and Introduction to the Study of Mammals Living and Extinct and Introduction to the Study of Mammals and Introduction to the Study of Mammals Living and Extinct by William Henry Flower C.B., F.R.S., D.C.L., Doctor of Laws, P.Z.S., F.L.S., F.G.S., and C. Director of the Natural History Departments, British Museum, and Richard Lydecker B.A., F.G.S., F.C.S., and C. The Woolly Opossum, London, Adam and Charles Black, M.D. CCCXCI. Preface. One of the greatest difficulties experienced by all who undertake a work of this nature, not professing to be an exhaustive treatise on the subject with which it deals, is to determine the amount of detail desirable to be introduced to meet the requirements of the ordinary student, without rendering it too bulky or costly for general use. The experience of those who endeavor to profit by the book can alone decide how far the authors have succeeded in this respect. It will be observed that in many instances certain better-known or more interesting members of the class have been described at considerable length, while it has been necessary to treat others with much greater brevity. With regard to the references to the literature of the various groups treated of, it has been the endeavor of the authors to make a selection of such memoirs and works as are likely to prove most valuable to the student for the amount of original information which they contain, and more especially of those giving full bibliographical data up to the time of their publication, the repetition of which has been considered unnecessary. In a few instances new generic terms have been introduced to replace some which were already occupied. These have been proposed by Mr. Lydecker, and should be quoted as his. The work is based largely upon the article Mammalia, together with 40 shorter articles, written by the senior of the two authors for the 9th edition of the Encyclopaedia Britannica. The account of the orders Rodentia, Insectivora, and Chiroptera contributed to the article Mammalia by Dr. G. E. Dobson, F.R.S., as well as the articles Mole, Shrew, and Vampire, by the same writer, the articles Marmot, Mouse, Opossum, Phalanger, Rat, Squirrel, Stoat, Vole, and others, by Mr. Oldfield Thomas, and likewise the article Ape, by Dr. St. G. Mivart, F.R.S., have also been made use of to a greater or less extent. The best thanks of the authors are due to these three gentlemen for freely permitting the incorporation of their own work in the present volume. Mr. Lydecker undertook the task of arranging the various articles in their proper sequence, selecting from these such portions as seemed suitable, filling up the gaps, and adding new matter where necessary, a large amount of this new matter treating of the extinct forms, and also of the group Artiodactyla. The subsequent revision, both before being sent to the printers, and also when passing through the press, has been made by both authors, who are thus jointly responsible for the whole work. The illustrations are to a great extent those prepared for the various articles in the encyclopedia, but many have been added, some drawn expressly for the work, and some borrowed from other publications. For most of the latter the authors take this opportunity of expressing their thanks to the Publication Committee of the Zoological Society of London, as well as to the individual writers in whose works they first appeared. The authors have further much pleasure in acknowledging the ready and obliging way in which Mr. Oldfield Thomas has, throughout the progress of the work, placed his extensive knowledge of the group of animals of which it treats at their disposal. London, March 1891. Corrigenda. Page 280, for Chiropsis red Coeropsis. Page 292, for Chiropotamidae and Chiropotamus red Coeropotamidae and Coeropotamus. Page 590, for Poecilogale red Poecilogale. Transcriber's note, the corrections have been applied. Contents page Chapter 1 Introductory remarks 1 Use of term mammals, 1. Characters of mammals, 2. Development of young, 3. Size of mammals, 4. Uses and products of mammals, 4. Chapter 2 General anatomical characters 7. Tegumentary structures 7. Hair, 7. Color, 8. Scales, etc. 11. Nails, claws, and hoofs, 12. Odor-secreting glands, 12. 2. Dental system 13. Teeth, 13. Structure of teeth, 13. Development of teeth, 15. Forms of teeth, 17. Succession of teeth, 19. Arrangement, homologies, and notation of teeth, 21. Dental formulae, 25. Modifications of teeth in relation to function, 28. Taxonomy, 30. Trituberculism, 30. 3. The skeleton 33. Definition, 33. Axial skeleton, 34. Skull, 34. Vertebral column, 39. cervical vertebrae, 41, dorsal vertebrae, 42, lumbar vertebrae, 42, sacral vertebrae, 43, caudal vertebrae, 43, sternum, 44, ribs, 44, appendicular skeleton, 46, anterior limb, 46, shoulder girdle, 46, brachium and antebrachium, 47, manus, 48, carpus, 48, metacarpus and phalanges, 49, posterior limb, 50, pelvic girdle, 50, thigh and leg, 51, PES, 52. 4. The digestive system. 53 general considerations, 53, mouth, 54, salivary glands, 55, stomach, 57, intestinal canal, 59, liver, 60. The circulatory, absorbent, respiratory, and urinary systems. 63 blood, 63, heart, 63, lymphatic vessels, 65, ductless glands, 65, nostrils, 66, trachea, 67, larynx, 67, diaphragm, 67, lungs, 68, air sacs, 68, urinary organs, 69, bladder, 69. 6. Nervous system and organs of sense. 69 brain, 69, nerves, 71, sense of touch, 72, taste and smell, 72, sight, 72, hearing, 73. 7. Reproductive organs. 74 testes, 74, penis, 74, ovaries and oviduct, 75, mammary glands, 75, secondary sexual characters, 76, placenta, 76. Chapter 3 Origin and Classification of the Mammalia. 82 Origin, 82, Classification, 84, Table of Orders and Families, 88. Chapter 4 Geographical and Geological Distribution. 93 Geographical Distribution. 93 Zoological Regions, 96, Palearctic Region, 97, Ethiopian Region, 98, Oriental Region, 100, Celebes, 102, Nearctic Region, 102, Neotropical Region, 103, Aquatic Mammals, 104. 2. Geological Distribution. 107 Sequence of strata, 107, Mesozoic Mammals, 109, Multituberculata, 109, Polyprotodont types, 113, Tertiary Mammals, 115. Chapter 5 The subclass Prototheria or Ornithodelphia. 117 General characters, 117. Family Ornithorhynchidae, 119, Ornithorhynchus, 119. Family Echidnidae, 124, Echidna, 125, Proechidna, 126, Fossil species, 127. Chapter 6 The subclass Metatheria or Didelphia. 128 General characters, 128, Distribution, 131, Classification, 131. Suborder Polyprotodontia. 133 Family Didelphidae, 133, Chironectes, 134, Didelphes, 135. Family Dasyuridae, 136, Subfamily Dasyurinae, 136, Thylacynus, 136, Sarcophilus, 137, Dasyurus, 138, Phascologale, 139, Sminthopsis, 139, Antechinamys, 139, Subfamily Myrmecobiinae, 140, Myrmecobius, 140. Family Paramelidae, 141, Parameles, 142, Paragale, 143, Coeripus, 143. Suborder Diprotodontia. 144 Family Phascolomyidae, 144, Phascolomys, 145, Phascolinus, 146. Family Phalangeridae, 147, Subfamily Tarsipedinae, 148, Tarcypes, 148, Subfamily Phalangerinae, 149, Phalanger, 149, Trichosurus, 150, Pseudochirus, 151, Pteroids, 152, Dactylopsila, 152, Ptoris, 153, Gymnobolidius, 154, Dermitia, 154, Distoechurus, 155, Acrobats, 155, subfamily Phascolarctinae, 155, Phascolarctus, 156. Extinct phalangeroids, 157, Thylacoleo, 157. Family Macropodidae, 158, subfamily Hypsipyrmnidontinae, 162, Hypsipyrmnidon, 162, Trichlus, 162, subfamily Podaroinae, 162, Podarus, 163, Betungia, 163, Caloprimnus, 164, Epiprimnus, 164, subfamily Macropodinae, 164, Lagostrophus, 165, Dendrolagus, 165, Dorcopsis, 166, Lagerkests, 166, Onychogale, 166, Petrogale, 167, Macropus, 167, extinct genera, 170. Extinct families, 171, Diprotodon, 171, Nototherium, 171. Chapter 7 The subclass Eutheria and the order Edentata 173 General characters and classification of Eutheria, 173. Order Edentata 176 Family Bradipodidae, 179, Bradipus, 181, Colepus, 182, Nothropus, 183. Family Megatheridae, 183, Megatherium, 185, Celidotherium and Mylodon, 188, Promegatherium, 189. Family Myrmecophagidae, 190, Myrmecophaga, 190, Tamandua, 192, Cycloturus, 193. Family Dasypodidae, 194, subfamily Chlamydophorinae, 196, Chlamydophorus, 196, subfamily Dasypodinae, 197, Dasypus, 197, Xenurus, 198, Priodon, 198, Taloputes, 199, subfamily Tatusianae, 200, Tatusia, 200, extinct genera, 201. Family Glyptodontidae, 202. Family Manidae, 204, Manus, 204, Paleomonas, 208. Family Oricteropodidae, 208, Oricterapus, 208. Bibliography, 211. Chapter 8 The Orders Sirenia and Cetacea 212 Order Sirenia 212 Family Monadidae, 215, Monadus, 215. Family Halichoridae, 220, Halichor, 220. Family Rhytinidae, 221, Rhytina, 221. Extinct Sirenians, 222, Halotherium, 222, Other forms, 223. Bibliography, 224. Order Cetacea 225 Suborder Mysticosidae 234 Family Balenidae, 234, Balena, 236, Neobalena, 241, Rachionectes, 241, Megaptera, 241, Balanoptera, 242, extinct genera, 245. Suborder Archaeocidae 246 Family Zeuglodontidae, 246, Zeuglodon, 246. Suborder Odontocidae 247 Family Physeteridae, 247, subfamily Physeterinae, 248, Physeter, 248, Kogia, 250, extinct Physeteroids, 251, subfamily Zaphini, 251, Hyperoodon, 252, Xiphias, 254, Mesoplodon, 254, Berardius, 256, Conaziphius, 257. Family Squalodontidae, 257, Squalodon, 257. Family Platanistidae, 257, Platanista, 258, Enea, 259, Pontoporia, 259, Fossil forms, 259. Family Delphinidae, 260, Monodon, 260, Delphinapterus, 262, Phocina, 263, Cephalorhynchus, 266, Orcella, 267, Orca, 267, Sidorca, 268, Globicephalus, 268, Grampus, 270, Pharesia, 270, Laginarhynchus, 270, Delphinus, 271, Tursiops, 271, Perdelphinus, 271, Steno, 271, Sotalia, 272. Bibliography, 272. Chapter 9 The Order Ungulata 273 Ungulata Vera 275 Suborder Artiodactyla 275 Suena, 278. Family Hippopotamidae, 278, Hippopotamus, 278. Family Suidae, 281, Sus, 281, Babirusa, 287, Phacochirus, 288. Family Dicotylidae, 289, Dicotyls, 289, Hyotherium, etc., 291. Extinct transitional artiodactyls, 292, Choeropotamidae, 292, Anthracotheriidae, 292, Maricopotamus, 293, Caudilopidae, 293, Anoplotheriidae, 293, Cenotheriidae, 294, Dicodontidae, 294. Tylopoda, 295. Family Camelidae, 295, Camelus, 296, Achinia, 298, Extinct cameloids, 303. Tragulina, 305. Family Tragulidae, 305, Tragulus, 305, Dorcatherium, 306, Extinct traguloids, 306. Pecora, 307, Antlers, 308, Horns, 310, Teeth, 310, Stomach, 312. Family Cervidae, 313, Subfamily Muscini, 314, Moscus, 314, Subfamily Cervini, 316, Plesiometacarpalia, 316, Cervulus, 316, Elaphidus, 318, Cervus, 319, Telemetacarpalia, 323, Rangifer, 324, Alces, 326, Cervulses, 327, Capreolus, 327, Hydropotes, 328, Cariacus, 329, Pugua, 330, Extinct genera, 330. Family Giraffidae, 330, Giraffa, 331, Allied extinct types, 332. Family Antilocapridae, 333, Antilocapra, 333. Family Bovidae, 334, Alcelaphus, 334, Conchoites, 336, Cephalophus, 338, Tetraceros, 338, Neotragus, 338, Nanotragus, 339, Peli, 339, Cobus, 339, Cervicapra, 340, Antelope, 340, Epiceros, 341, Saiga, 341, Panthalops, 341, Gazella, 341, Hippotragus, 343, Oryx, 343, Adax, 345, Bocelaphus, 345, Trigelaphus, 346, Strepsiceros, 347, Ureas, 348, Extinct types, 348, Rupicapra, 349, Nemoritus, 350, Haploceros, 351, Budorcas, 351, Capra, 352, Ovis, 354, Ovibos, 357, Bos, 360. Suborder Perissodactyla 368 Family Tapiridae, 370, Tapirus, 370, Paleodopirus, 373. Family Lophiodontidae, 373. Family Paleotheriidae, 375. Family Equidae, 376, Protohippus, 380, Hipparion, 380, Equus, 381. Family Rhinocerotidae, 402, Rhinoceros, 402, Extinct types, 411. Families Lambdotheridiidae, Calicotheridae, and Titanotheridae, 412. Family Macroceniidae, 414. Family Proterotheriidae, 414. Subungulata 414. Suborder Hyracoidea 415. Family Hyracidae, 415. Hyrax, 417. Dendrohyrax, 418. Suborder Proboscidea 418. Family Elephantidae, 423. Elephas, 424. Mastodon, 431. Family Dinotheriidea, 435. Dinotherium, 435. Suborder Amblypoda 436. Uintatherium, 436. Coryphodon, 437. Suborder Condylarthra 438. Suborder Toxodontia 439. Nesidon, 439. Toxodon, 439. Typotherium, 440. Group Tilodontia 441. Bibliography of ungulates 442. Chapter 10. The order Rodentia 443. Suborder Simplicidentida 448. Section Sciuromorpha, 448. Family Anomaluridae, 449. Anomalurus, 449. Family Sciuridae, 450. Sciurus, 450. Rhythrosciurus, 452. Xeris, 452. Tamias, 452. Pteromes and Sciuropterus, 453. Eupatorus, 454. Extinct genera, 454. Arctomys, 454. Cinemes, 455. Spermophilus, 456. Extinct genera, 457. Family Haplodontidae, 457. Haplodon, 457. Family Castoridae, 457. Castor, 457. Section Myomorpha, 459. Family Myoxidae, 459. Myoxus, 459. Aliomes, 459. Graphiurus, 459. Clavigulus, 460. Muscardinus, 460. Family Lophiomyidae, 460. Lophiomes, 460. Family Muridae, 461. Hydromes, 461. Xeromes, 461. Platacanthomes, 462. Gerbilis, 462. Pachyuromes, 462. Mistromes, 462. Automes and Dacomes, 462. Malacomes, 462. Phloemes, 462. Dendromes, 463. Chrysetus, 463. Holoculus, 464. Sigmodon, 464. Rhythrodon and Achetodon, 464. Neotoma, 464. Hypogeomes, 465. Nesomes, 465. Brachytarsomes, 465. Halomes, 465. Eleurus, 465. Phenacomes, 466. Arvicola, 466. Synaptomes, 467. Myodes, 467. Cuniculus, 470. Fiber, 470. Neofiber, 472. Alobius, 472. Siphoneus, 472. Diomes, 473. Muse, 473. Nisotia, 475. Galunda, 476. Euromes, 476. Chirorames, 476. Haplodotus, 476. Mastocomes, 476. Acanthomes, 476. Echinothrix, 477. Typhlomes, 477. Chrysetomes and Sacostomus, 477. Pithecarus, 477. Family Spalacidae, 477. Spalax, 477. Rhizomes, 477. Bathyergus, 478. Georchus and Myoscalops, 478. Heterocephalus, 478. Family Geomyidae, 478. Geomes, 478. Thalamomes, 478. Dipotomes, 479. Parognathus and Heteromes, 479. Family Dipodidae, 479, Smynthus, 479, Zapus, 480, Dipus, 480, Alactiga, 480, Platycercomes, 480, Pedites, 480. Section Hystercomorpha, 480. Family Octodontidae, 480. Pterodactylus, 481, Pectinator, 481, Octodon, 481, Habercoma, 482, Schizodon, 482, Tenemes, 482, Spalacopus, 482, Petromes, 482, Myopotamus, 482, Capromes, 482, Olacotus, 483, Plagiodon, 483, Launchers and Echinomes, 483, Mesomes, 483, Dactylomes, 483, Circomes, 483, Carcharodon, 484, Fossil forms, 484. Family Theridomyidae, 484. Family Hystricidae, 484, Erethosin, 484, Cynotheres, 485, Chietomes, 486, Hystrix, 486, Atharura, 487, Trichis, 487. Family Chinchillidae, 487, Chinchilla, 487, Legidium and Legostomus, 488, extinct genera, 488. Family Castaroididae, 488, Castoroids, 488. Family Dasyproctidae, 488, Dasyprocta, 488, Caelogenes, 489. Family Dinomyidae, 489, Dynames, 489. Family Cavidae, 489, Cavia, 489, Dolichotis, 490, Hydrochirus, 490, extinct genera, 491. Suborder Duplicidentata 491. Family Lagomyidae, 491, Lagames, 491. Family Leporidae, 492, Lepus, 492. Chapter 11 The Order Carnivora 496 Suborder Carnivora Vera 497 Section Eluroidea, 501. Family Felidae, 502, Felis, 502, Cynaelurus, 523, extinct genera, 523. Family Viveridae, 525, Cryptoprocta, 525, Vivera, 526, Fossa, 527, Genetta, 528, Prianodon, 530, Poiana, 531, Paradoxurus, 532, Arctigale, 533, Hemigale, 533, Arctic Tis, 534, Nandinia, 534, Cynogale, 534, Herpes tes, 535, Heligale, 537, Diogale, 537, Synectis, 537, Rhinogale, 537, Crossarchus, 537, Suricata, 538, Dalidictus, Dalidea, and Hemigalidia, 538, Euplories, 538, extinct genera, 539. Family Proteliidae, 539, Protels, 539. Family Hyenidae, 540, Hyena, 540. Section Cynoidea, 544. Family Canidae, 544, Canis, 546, Lycaon, 553, Ictisian, 553, Otosion, 554, extinct genera, 555. Section Arctoidea, 556. Family Ursidae, 557, Ursus, 557, Malursus, 560, Eluripus, 560, extinct genera, 561. Family Procyonidae, 562, Elurus, 562, Persian, 564, Bacerus, 566, Bassarician, 566, Nasua, 566, Circoleptes, 567. Family Mustelidae, 567, Lutra, 567, extinct otters, 570, Latex, 570, Mephitis, 572, Conepidus, 574, Arctonix, 574, Midas, 575, Meles, 575, Taxidea, 576, Mellivora, 576, Halictus, 578, Ictinix, 579, Galictus, 579, Mustela, 579, extinct mustelines, 590, Poecilogale, 590, Lyncodon, 590, Gullo, 591. Suborder Pinnipedia 592 Family Otoridae, 593, Otaria, 593. Family Trichechidae, 596, Trichicus, 597. Family Phocidae, 600, Halicoiris, 601, Phoca, 601, Monachus, 604, Ogmarinus, 605, Lobodon, 605, Poecilophica, 605, Omatophica, 605, Cystophora, 605, Macrorhinus, 606, extinct seals, 606. Suborder Creodonta 606 Hyanodontidae, 608, Proviviridae, 608, Arctocyonidae and Mesonychidae, 609. Chapter 12 The Order Insectivorous 610 Suborder Dermopterus 614 Family Galeopithecidae, 614, Galeopithecus, 614. Suborder Insectivora Verus 616 Family Tupaiidae, 617, Tupaia, 617, Tillicircus, 618, extinct genera, 618. Family Macrocelididae, 618, Macrocelides, 618, Rhynchocyon, 618. Family Aranaceidae, 619, Gymnura, 619, Arenaceous, 620, extinct genera, 621, Family Cericidae, 621, Sorex, 622, Soriculus, 624, Notiosorex, 624, Blarina, 624, Crossopus, 625, Myosorex, 625, Crocidura, 626, Diplomesodon, 626, Anurosorex, 626, Chimeragale, 626, Nectogale, 627, Fossil Cericidae, 627. Family Talpidae, 628, Myogale, 628, Eurotrachus, 629, Europsilus, 629, Scallops, 630, Scapinus, 630, Condylura, 630, Scaptonix, 630, Talpa, 630, extinct genera, 634. Family Adipocericidae, 634. Family Potamegalidae, 634, Potamogale, 635, Geogale, 635. Family Solenodontidae, 635, Solenodon, 636, Centites, 637, Hemicentites, 637, Auriculus, 638, Microgale, 638, Orozorix, 638, Chrysochloris, 639. Extinct types, 640. Bibliography, 640. Chapter 13 The Order Chiropterus 641 Suborder Megachiropterus 650 Family Pteropodidae, 650, Epimaphorus, 650, Pteropus, 651, Xantharpia, 652, Bontia, 653, Synopterus, 653, Harpia, 653, Cephalotes, 653, Pteralopex, 654, Notopterus, 654, Eonycterus, 654, Carponicterus and Melanicterus, 654, Nesonycterus, 655, Calonicterus, 655, Trigonicterus, 655. Suborder Microchiropterus 655 Section Vespertilianina, 655. Family Rhinolophidae, 656, Rhinolophus, 656, Hipposiderus, 657, Anthops, 657, Rhinonycterus and Trionops, 658, Coelops, 658, Megaderma, 658. Family Vespertilionidae, 660, Placotis, 660, Cenotus, 661, Odonicterus, 661, Nyctophilus, 661, Antrosus, 661, Vesperugo, 661, Calanolabus, 662, Scytophilus, 662, Nyctocegus, 663, Atalapha, 663, Harpiocephalus, 663, Vespertilio, 663, Ceravola, 664, Nautilus, 664, Miniopterus, 664, Thyroptera, 665, Mixopoda, 665, Fossil Vespertilionidae, 665. Section Imballinurina, 666. Family Imballinuridae, 666, Furypterus and Antorphocolis, 666, Emballinura, 667, Calura, 667, Rhynchonicterus, 667, Sacopteryx, 667, Taphazos, 667, Diclydurus, 668, Noctilio, 668, Rhinopoma, 669, Chiromeles, 669, Molossus, 670, Nyctinomus, 670, Mysticops, 671. Family Philostomatidae, 672, Chilonycterus, 672, Mormops, 672, Loncarina, Otopterus and Dolichophyllum, 673, Vampyrus, etc., 673, Desmodus, 677, Diphylla, 678. Chapter 14 The Order Primates 680 Suborder Lemuroideus 682 Family Lemuridae, 683, Indres, 684, Propithecus, 684, Avahis, 686, Lemur, 687, Hippolymer, 689, Lepidolemur, 689, Chirogalius, 689, Galago, 690, Nycticebus, 691, Loris, 692, Paradicticus, 693. Family Tarsidae, 694, Tarsius, 694. Family Chiromyidae, 694, Chiromes, 695. Extinct Lemuroids, 696. Suborder Anthropoideus 699 Family Hippalidae, 709, Hapale, 710, Midas, 710. Family Cebidae, 711, Mycetes, 711, Pithecia, 712, Eukarya, 712, Calothrix, 713, Chrysothrix, 714, Nyctopithecus, 714, Atlas, 715, Ariodes, 715, Lagathrix, 716, Cebus, 717. Family Cercopithecidae, 718, Cynocephaly, 719, Therapithecus, 722, Cynopithecus, 722, Macacus, 722, Cercocebus, 723, Cercopithecus, 724, Nasalis, 725, Semnopithecus, 726, Colobus, 727, extinct genera, 727. Family Simiidae, 728, Hylobates, 728, Simia, 731, Gorilla, 734, Anthropopithecus, 736. Family Hominidae, 739, Homo, 740. Classification of the varieties of man, 743. And Introduction to the Study of Mammals Living and Extinct Chapter 1 Introductory Remarks Mammalia, French, Mammifères, German, Saugetiere, is the name invented by Linnaeus, from the Latin mamma, and now commonly used by zoologists, for one of the 5 great classes of vertebrate animals, which, though the best known and undoubtedly the most important group of the animal kingdom, has never received any generally accepted vernacular designation in our language. The unity of structure of the animals composing this class, and their definite demarcation from other vertebrates, were not recognized until comparatively modern times, and hence no word was thought of to designate what zoologists now term a mammal. The nearest equivalents in common use are beast and quadruped, both of which, however, cover a different ground, since they are often used to include the larger four-footed reptiles, and to exclude certain undoubted mammals, as man, bats, and whales. The limits of the class as now understood by zoologists are perfectly well defined, and, although certain forms still existing on the earth, but not those mentioned above as excluded by the popular idea, are of exceedingly aberrant structure, and exhibit several well-marked characters connecting them with the lower vertebrate groups, common consent retains them in the class with which the great proportion of their characters ally them, and hitherto no traces of any species showing still more divergent or transitional characters have been discovered. There is thus an interval, not bridged over by any known forms, between mammals and other vertebrates, although recent discoveries have shown evidence of a more or less marked affinity between the most generalized mammals and a peculiar group of extinct reptiles known as the Animodontia, or Theromera, which are themselves nearly related to the equally extinct labyrinthodont amphibians of the Paleozoic and Mesozoic epochs. In the gradual order of evolution of living beings, mammals, taken all together, are certainly the highest in organization, as, with the possible exception of birds, they were the last to appear on the Earth's surface. But, as in speaking of all other large and greatly differentiated groups, this expression must not be understood in too limited a sense. The tendency to gradual perfection for their particular station in life, which all groups manifest, leads to various lines of specialization, or divergence from the common or general type, which may or may not take the direction of elevation. A too complex and sensitive condition of organization may in some circumstances of life be disadvantageous, and modification may then take place in a retrograde direction. Thus in mammals, as in other classes, there are low as well as high forms, but by any tests that can be applied, especially those based on the state of development of the central nervous system, it will be seen that the average exceeds that of any other class, that the class contains many species far excelling those of any other in perfection of structure, and especially one form which is unquestionably the culminating point yet arrived at amongst organized beings. With regard to the time of the first appearance of mammals upon the earth, the geological record is provokingly imperfect. At the commencement of the Tertiary period they were abundant, and already modified into most of the leading types at present existing. It was at one time thought that they first came into being at this date, but the discovery of more or less fragmentary remains of numerous and generally small species has revealed the existence of some forms of the class at various periods throughout almost the whole of the age of the deposition of the secondary or Mesozoic rocks. This subject will be reverted to later on. It hardly need be said that mammals are vertebrate animals, and possess all the characteristics common to the members of that division of the animal kingdom. They are separated from the Ichthyopsida, fishes and amphibians, and agree with the Sauropsida, reptiles and birds, in the possession during their development of an amnion and allantois, and in never having external bronchi or gills. They differ from reptiles and resemble birds in being warm-blooded, and having a heart with 4 cavities and a complete double circulation. They differ from both birds and reptiles in the red corpuscles of the blood being non-nucleated and, with very few exceptions, circular in outline, in the lungs being freely suspended in a thoracic cavity, separated from the abdomen by a complete muscular partition, the diaphragm, which is the principal agent in inflating the lungs in respiration, in having but one aortic arch, which curves over the left bronchus, in the skin being more or less clothed with hair, in the greater perfection of the commissural system of the cerebral hemispheres, which has either a complete corpus callosum, or an incomplete one associated with a very large anterior commissure, in having no syrinx or inferior vocal organ, but a complete larynx at the upper end of the trachea, in having a mandible of which each ramus, except in very early developmental conditions, consists of a single bone on each side, articulating to the squamosal without the intervention of a quadrate bone, in having a pair of laterally placed occipital condyles instead of one median one, and in the very obvious character of the female being provided with mammary glands, by the secretion of which the young, usually produced alive, although in the lowest forms by means of externally hatched eggs, are nourished for some time after birth. In common with all vertebrate animals, mammals never have more than 2 pairs of limbs, as the larger number live ordinarily on the surface of the earth. In the great majority of the class, both pairs are well developed and functional, and adapted for terrestrial progression. Mammals are, however, by no means limited to this situation. Thus some species spend the greater part of their lives beneath the surface, their 4 limbs being specially modified for burrowing. Others, again, are habitually arboreal, their limbs being fitted for climbing or hanging to boughs of trees. Some are as aerial as birds, the 4 limbs being developed into wings of a special character, while in others, which are as aquatic as fishes, the limbs assume the form of fins or paddles. In many of the latter, the hinder extremities are either completely suppressed, or present only in a rudimentary state. In no known mammal are the 4 limbs absent. The hinder extremity of the axis of the body is usually prolonged into a tail, which may be a mere pendant appendage, or may be modified to perform various functions, as grasping boughs and climbing, or even gathering food, in the case of the prehensile-tailed monkeys and possums, swimming in the cetacea, and acting as a flap to drive away troublesome insects from the skin in the ungulata. The state of development of the young at the time of birth varies greatly in the different groups. Thus, among the marsupials, where there is no connection during intrauterine life between the circulatory systems of the parent and the fetus, the young are born in an exceedingly imperfectly developed condition. For their protection, the mother, in a large number of cases, has a special pouch enclosing the mammae, into which the young are transferred at birth, and in which they remain till they are well developed. Among the higher, or placental types, however, where a connection exists between the maternal and fetal circulations previous to birth, the young are always born in a much more highly developed state than among the marsupials, although we meet with great variations in this respect. In those forms which habitually live in holes, like many rodents, the young are always very helpless at birth, and the same is also true of many of the carnivora, which are well able to defend their young from attack. In the great order of ungulate, or hoofed mammals, where in the majority of cases defense from foes depends upon fleetness of foot, or upon huge corporeal bulk, the young are born in a very highly developed condition, and are able almost at once to run by the side of the parent. This state of relative maturity at birth reaches its highest development in the cetacea, where it is evidently associated with the peculiar conditions under which these animals pass their existence. In the primates, however, we again find the young produced in a more or less helpless condition, and requiring a long period before they attain their full development, this being more especially the case with those higher forms which approximate in structure to man. In point of size, mammals vary to a greater extent than the existing members of any one class of animals, and include the largest living inhabitants of the earth. The extremes of size are marked on the one hand by the whale known as Sibbald's rorqual, which attains a length of 80 feet and a weight of nearly as many tons, and on the other by the pygmy shrew and the minute harvest mouse, which can climb a stem of wheat. Of all the living creatures inhabiting our globe, mammals are by far the most important in their economic uses, since, in addition to being the only animals capable of labor for human benefit, they furnish the greater portion of the animal food of many races of man, and likewise a large amount of their clothing. In these respects, the ungulates hold the first place. As regards employment for labor, with the exception of the dogs used for sleighing by the Eskimo, and those which among some European nations draw light carts, all the mammals in general use are ungulates. Of the first importance are the horses and asses, which are employed as beasts of draught or burden over nearly the whole globe. Among many nations, however, cattle, as represented by the true oxen, the buffaloes, and the yaks of Tibet, occupy a still more important position, while in the highlands of Tibet, sheep are largely used for carrying burdens. In other regions, again, the place of the horse and the ass is taken by the camels, which are peculiarly fitted for traversing parched and arid deserts, while in the Andes we find the llamas serving the same office. In Lapland and other parts of the northern regions, the reindeer is the main agent employed in draught. Lastly, we must not omit to mention the Indian elephant, which, from its vast strength, is so useful in transport through the wilder parts of its native country. As regards food, we again find the ungulates, and more especially the artiodactyl division, taking the foremost place, and in this connection we have only to mention, among animals kept in a domestic condition, swine, cattle, sheep, and goats, the three latter affording not only their flesh, but also milk and its resulting cheese and butter. To many races, however, maras and camels are the chief milk producers, while the Lapps make use of the milk of the reindeer. The rodents, as represented by hares and rabbits, occupy a minor position as furnishers of food. In relation to clothing, the ungulates are likewise of paramount importance, as exemplified by the wool of the sheep, which is so valuable on account of its peculiar property of felting. Furs, however, are mostly yielded by mammals of other orders, among which the fur seals are perhaps the most important at the present day. Many other carnivores yield valuable furs, among which may be mentioned bears, foxes, raccoons, skunks, minks, otters, and ermines. Of less importance are certain rodents, such as the squirrels, rabbits, hares, etc., while the hair of the beaver was formerly much sought after for the manufacture of hats. Returning to the ungulates, we may notice the importance of horsehair, the employment of camel's hair for brushes, and the many uses of the bristles of the pig. Some of the monkeys yield fur which has been extensively used. Leather, again, is almost exclusively supplied by mammals, and mainly by the ungulates. Three other important products, namely horn, buck's horn, and ivory, are likewise obtained solely from the same great order. Horn, as we shall notice in the sequel, is the sheath covering the bony horncores of the oxen, while buck's horn is the commercial term applied to the antlers of the deer, which are largely used for knife handles and other purposes. True ivory is the product of the two species of elephant, but other kinds of ivory are obtained from the teeth of the sperm whale and the tusks of the walrus and hippopotamus, the latter kind having been extensively employed some years ago for artificial teeth. For many purposes the place of ivory is taken by bone, this being mostly obtained from ungulates. The bones of camels are of an especially firm texture and good color, and are largely employed in India for inlaying. Other important uses of bones are in the form of bone dust as manure, and also as a source of phosphoric acid. The horns of the African rhinoceros and the hide of the hippopotamus are occasionally manufactured into small canes or whips. Horns and hoofs are also largely employed in the manufacture of glue. Formerly the so-called whalebone, or more properly baleen, was much used, especially to form the ribs of umbrellas and in stiffening ladies' apparel, but the gradual destruction of the right whales, its only source of supply, has largely restricted its use of late years. The cetacea are also of great economical importance from the abundance of oil yielded by the thick layer of blubber underlying the skin. Large quantities of valuable oil are also furnished by the walrus and the seals. Spermaceti, which was at one time extensively used in the manufacture of candles, is obtained from a large cavity in the head of the sperm whale or cachalot, and also from the hyperidon or bottlenose whale. The nature of ambergris, a peculiar substance found floating on the surface of the sea and employed in perfumery, was long a matter of controversy, but it appears to be an intestinal concretion of the sperm whale. Other substances of more importance to the perfumer are musk, the product of the musk deer of the Himalaya, and civet, which is obtained from the so-called civet cat and other allied carnivores. A secretion of the beaver has also been used in perfumery and in medicine. Chapter 2 General Anatomical Characters I. Tegumentary structures haired. The external surface of the greater number of members of the class is thickly clothed with a peculiarly modified form of epidermis, commonly called hair. This consists of hard, elongated, slender, cylindrical or tapering, filiform, unbranched masses of epidermic material, growing from a short papilla sunk at the bottom of a follicle in the derm or true skin. Such hairs upon different parts of the same animal, or upon different animals, assume various forms, and are of various sizes and degrees of rigidity, as seen in the delicate soft velvety fur of the mole, the stiff bristles of the pig, and the spines of the hedgehog and porcupine, all modifications of the same structures. Each hair is composed usually of a cellular pithy internal portion, containing much air, and a denser or more horny cortical part. In some animals, as deer, the substance of the hair is almost entirely composed of the medullary or cellular substance, and it is consequently very easily broken. In others the horny part prevails almost exclusively, as in the bristles of the wild boar. In the three-toed sloth, Bradipus, the hairs have a central horny axis and a pithy exterior. Though generally nearly smooth, or but slightly scaly, the surface of some hairs is strongly imbricated, notably so in some bats, while in the two-toed sloth, Colepus, the hairs are longitudinally grooved or fluted. Though usually more or less cylindrical or circular in section, hairs are often elliptical or flattened, as in the curly-haired races of men, the terminal portion of the hair of moles and shrews, and conspicuously in the spines of the rodents Xeris and Platycanthames. Hair having a property of mutual cohesion or felting, which depends upon a rough and scaly surface and a tendency to curl, as in domestic sheep, in which animal this property has been especially cultivated by selective breeding, is called wool. In a large number of mammals hairs of one kind only are scattered pretty evenly over the surface, but in many there are two kinds, one longer, stiffer, and alone appearing on the surface, and the other shorter, finer, and softer, constituting the underfur, analogous to the down of birds. This underfur, or pasham as it is called by the natives of Kashmir, is especially abundant in the mammals inhabiting the cold plateau of Tibet and the adjacent regions. In many cases hairs of a different character from those of the general surface grow in special regions, forming ridges or tufts on the median dorsal or ventral surface or elsewhere. The tail is very often completed in this way by variously disposed elongated hairs. The margins of the eyelids are almost always furnished with a special row of stiffish hairs, called cilia or eyelashes, and in most mammals specially modified hairs, constituting the vibrissae or whiskers, and endowed, through the abundant nerve supply of their basal papillae, with special tactile powers, grow from the lips and cheeks. In some mammals the hairy covering is partial and limited to particular regions, in others, as the hippopotamus and the sirenia, though scattered over the whole surface, it is extremely short and scanty, but in none is it reduced to so great an extent as in the cetacea, in which it is limited to a few small bristles confined to the neighborhood of the lips and nostrils, and often only present in the young or even fetal condition. Some kinds of hairs, as those of the mane and tail of the horse, appear to persist throughout the lifetime of the animal, but more generally, as in the case of the body hair of the same animal, they are shed and renewed periodically, generally annually. Many mammals have a longer hairy coat in winter, which is shed as summer comes on, and some few, which inhabit countries covered in winter with snow, as the Arctic fox, variable hair, and ermine, undergo a complete change of color in the two seasons, being white in winter, and gray or brown in summer. The several species of Cape mole, Chrysochloris, the desmans or water moles, Myogale, and Potamogale velox, are remarkable as being the only mammals whose hair reflects those iridescent tints so common in the feathers of tropical birds. The principal and most obvious purpose of the hairy covering is to protect the skin against external influences, especially cold and damp. Its function in the hairless cetacea is supplied by the specially modified and thickened layer of adipose tissue beneath the skin, called blubber. Color. From the consideration of hair we are easily led to that of color. As a general rule, bright and primary colors are absent in the class, but among the baboons we find brilliant patches of scarlet or blue on some of the bare portions of the body, and one of the South American monkeys, Brachyurus, has its whole face of a bright crimson. The most general colors are various shades of gray, brown, and tawny, with a frequent tendency to whiteness of the ventral surface of the body, but among the squirrels, and more especially those provided with a parachute for flying, we find brilliant russets, passing into orange and red. Dark brown or black is also not very uncommon, as in the bears and the sable antelope of South Africa. Entirely white mammals are rare, and mostly characteristic of the polar regions, or of countries having a long and snowy winter. An entirely white bat, Diclydurus albus, occurs, however, in South America. In the large majority of mammals that exhibit a varied coloration, the upper and most exposed parts of the surface present the richest and darkest colors, the underparts being pale or often quite white. The radals, gluttons, elurus, hamsters, and some others are exceptions to this rule. A large number of mammals having a ground color of gray, tawny, or dun are marked by stripes or spots, which are generally of a darker hue than the ground color, as in many carnivora, but more rarely are lighter, as in the fallow and axis deer and several species of antelope. These stripes very generally run transversely to the axis of the body, as in the Tasmanian thylacine, the tiger, and the zebra, but they may be longitudinal, as in several of the civet family. There has been considerable discussion as to whether the striped or the spotted is the more primitive type of coloration, but no very conclusive arguments have been brought forward in favor of either view. It is, however, manifest that in several groups of mammals there is a tendency to lose the spots, and more rarely the stripes, and to assume a uniform color. Thus the young of nearly all the species of deer are spotted, whereas the adults of only the fallow and axis deer are so marked. The same is true of most of the pigs, and the young of the Malayan and American tapirs are marked by light-colored stripes and spots on a dark ground. In like manner the young of the lion and the puma exhibit distinct spots which disappear with advancing age. In most of our domestic horses of various shades of bay and brown we may detect dappling on the under hair when the outer coat has been removed, which is not apparent on the surface of the latter. Many varieties of the ass and the horse also exhibit a tendency to the presence of stripes on the legs, which would seem to indicate a descent from a striped zebra-like type. A peculiar feature, which is, however, common to many other groups of animals, is the tendency to what is known as melanism, or the production of black or dark individuals or races of particular species, due to an excess of pigment in the skin and hair. Thus we may have black leopards and jaguars, black wolves, and black rabbits. The opposite to melanism, and of more frequent occurrence, is albinism, a condition in which the pigment or coloring matter usually present in the tissues constituting the external coverings of the body, and which gives them their characteristic hue, is absent. When it occurs the hair is of an opaque white, the claws, hoofs, etc., of a pale horn color, and the skin and eyes pink, in consequence of the color of the blood which circulates through them being no longer concealed by the stronger hues of the pigments. An animal in this condition is called an albino. In complete albinism there is a total absence of pigment throughout the system. This condition occurs occasionally as an individual peculiarity among wild animals of many kinds, but it has never been perpetuated among them in distinct races or species. The disadvantage of absence of pigment in the eye, causing a certain amount of intolerance of light, is probably sufficient to account for this. Several races of true albinos, as white ferrets, rabbits, rats, and mice, have, however, been established under the protection of man, and in them this abnormal condition is propagated from generation to generation. Partial albinism, a condition in which the absence of pigment is limited to portions of the surface, or, at all events, does not extend to the eyes, is much more common as an individual variation both in domestic and in wild animals. It is possible that the artificial conditions incident to domestication increase the tendency to its occurrence, but, whether this be so or not, it certainly becomes perpetuated more frequently among domesticated than among wild animals. This may be accounted for partly by its proving of no disadvantage to them, and partly by the frequent selection by man of animals of such color in preference to others. The result is that there is no completely domestic animal of which white races do not exist. On the other hand, to most wild animals even partial albinism seems to be a disadvantage in the struggle for existence, since, except in the case of species inhabiting lands continually covered with snow, it renders them more conspicuous objects both to their enemies and their prey, and hence it is rarely perpetuated. In northern regions, however, a large proportion of species are regularly and normally of a white color, either, as the polar bear, all the year through, or, as the ermine or stoat, Arctic fox, and alpine hare, during the winter season. The coloration in these cases is obviously protective, as it is also to a great extent in many other instances throughout the class. Among conspicuously colored mammals, it has been observed that the vertical black and tawny stripes of the tiger harmonize so well with the brown and green grasses of its native jungle as to render the animal almost invisible when lying among them, while the dappled hide of the giraffe is said to agree equally well with the checkered splashes of light and shade in the clumps of tall mimosas among which it feeds. The uniformly tawny hue of the lion accords well with the prevailing tint of its native desert, and anyone who has seen an elephant or buffalo in the deep shades of an Indian forest will realize how perfectly adapted is their dull, slaty color to concealment in such a spot. The dun color of the wild ass of India is equally well suited to the sandy deserts of Kutch, It is also stated that the brilliant stripes of the zebras of Africa are arranged in such proportion as exactly to match the pale tint which arid ground possesses when seen by moonlight. 1. The most remarkable instance of protective coloration is, however, to be found in the sloths of South America, in which the coarse gray hairs so closely resemble a mass of lichenous growth that it is almost impossible to distinguish these animals when at rest from the gnarled and lichen-clad boughs from which they suspend themselves. This resemblance is increased by the fact that the hairs actually develop a growth of lichens upon themselves. That the somber coloration of these animals has been produced to harmonize with their present surroundings seems to be evident by the circumstance that when the long hair is plucked off the under fur is seen to present a bold alternation of black and yellow stripes, which may probably be regarded as the original primitive coloration of this group. Scales, etc., true scales, or flat imbricated plates of horny material, covering the greater part of the body, so frequently occurring in reptiles, are found only in one family of mammals, the Manatee or pangolins, but these are also associated with hairs growing from the intervals between the scales, or on the parts of the skin not covered by them. Similarly, imbricated epidermic productions form the covering of the undersurface of the tail of the flying rodents of the genus Anomalurus, and flat scuts, with the edges in apposition, and not overlaid, clothe both surfaces of the tail of the beaver, rats, and others of the same order, and also of some insectivores and marsupials. The armadillos alone have an ossified exoskeleton, composed of plates of true bony tissue, developed in the derm or corium, and covered with scuts of horny epidermis. Other epidermic appendages are the horns of ruminants and rhinoceroses, the former being elongated, tapering, hollow caps of hardened epidermis of fibrillated structure, fitting on and growing from conical projections of the frontal bone, and always arranged in pairs, while the latter are of similar structure, but solid and without any internal bony support, and, in all existing species, situated in the median line. Callosities, or bare patches covered with hardened and thickened epidermis, are found covering the pads under the soles of the feet and undersurfaces of the toes of nearly all mammals, upon the ischial tuberosities of many apes, the sternum of camels, on the inner side of the limbs of the equidae, the grasping undersurface of the tail of the prehensile-tailed monkeys, etc. The greater part of the skin of both species of one-horned Asiatic rhinoceros is immensely thickened and stiffened by increase of the tissue both of the derm and epiderm, constituting the well-known jointed armor-plated hide of those animals. Nails, claws, and hoofs. With very few exceptions, the terminal extremities of the digits of both limbs are more or less protected or armed by epidermic plates or sheaths, constituting the various forms of nails, claws, or hoofs. These are wanting in the cetacea alone. A perforated spur, with a special secreting gland in connection with it, is found attached to the hind leg of the males of the three genera of Monotremata, Ornithorhynchus, Perwechidna, and Echidna. Odor-secreting glands. Besides the universally distributed sebaceous glands connected with the pilose system, most mammals have special glands situated in modified portions of the integument, often involuted to form a shallow recess or a deep sac with a narrow opening, situated in various parts of the surface of the body, and secreting odorous substances, by the aid of which individuals appear to recognize one another, and probably affording the principal means by which wild animals are able to become aware of the presence of other members of the species, even at great distances. Although the commencement of the modifications of portions of the external covering for the formation of special secretions may be at present difficult to understand, the principle of natural selection will readily explain how such organs become fixed and gradually increase in development in any species, especially as there would probably be a corresponding modification and increased sensibility of the olfactory organs. Such individuals as by the intensity and peculiarity of their scent had greater power of attracting the opposite sex would certainly be those most likely to leave descendants to inherit and in their turn propagate the modification. To this group of structures belong the suborbital gland or crumen of antelopes and deer, the frontal gland of the mudjack and of bats of the genus Hippocyterus, the submental gland of the chevrotains and of Taphazos and some other bats, the post-auditory follicle of the chamois, the temporal gland of the elephant, the lateral glands of the musk shrew, the dorsal gland of the peccary, the inguinal glands of antelopes, the preputial glands of the musk deer and beaver, already alluded to in connection with the use made of their powerfully odorous secretion in medicine and perfumery, and also of the swine and hare, the anal glands of carnivora, the perineal gland of the civet, also of commercial value, the caudal glands of the fox and goat, the gland on the humeral membrane of bats of the genus Secopteryx, the postdigital gland of the rhinoceros, the interdigital glands of the sheep and many ruminants, and numerous others. In some of these cases the glands are peculiar to, or more largely developed in, the male, in others they are found equally developed in both sexes. 2. Dental system. The dental system of mammals may be considered rather more in detail than space permits for some other portions of their structure, not only on account of the important part it plays in the economy of the animals of this class, but also for its interest to zoologists as an aid in the classification and identification of species. Owing to the imperishable nature of their tissues, teeth are preserved for an indefinite time, and in the case of extinct species frequently offer the only indications available from which to derive an idea of the characters, affinities, and habits of the animals to which they once belonged. Hence even their smallest modifications have received great attention from comparative anatomists, and they have formed the subject of many special monographs. 2. Teeth are present in nearly all mammals, and are applied to various purposes. They are, however, mainly subservient to the function of alimentation, being used either in procuring food, by seizing and killing living prey or gathering and biting off portions of vegetable material, and more indirectly in tearing or cutting through the hard protective coverings of food substances, as the husks and shells of nuts, or in pounding, crushing, or otherwise mechanically dividing the solid materials before swallowing, so as to prepare them for digestion in the stomach. Certain teeth are also in many animals most efficient weapons of offense and defense, and for this purpose alone, quite irrespective of subserviency to the digestive process, are they developed in the male sex of many herbivorous animals, in the females of which they are absent or rudimentary. Teeth belong essentially to the tegumentary or dermal system of organs, and, as is well seen in the lower vertebrates, pass by almost insensible gradations into the hardened spines and scuts formed upon the integument covering the outer surface of the body, but in mammals they are more specialized in structure and limited in locality. In this class they are developed only in the gums or fibromucous membrane covering the alveolar borders of the upper and lower jaws, or, in other words, the premaxillary and maxillary bones and the mandible. In the process of development, for the purpose of giving them that support which is needful for the performance of their functions, they almost always become implanted in the bone, the osseous tissue growing up and molding itself around the lengthening root of the tooth, so that ultimately they become apparently parts of the skeleton. In no mammal, however, does ankylosis or bony union between the tooth and jaw normally take place, as in many fishes and reptiles, a vascular layer of connective tissue, the alveolo-dental membrane, always intervening. 3. The presence of 2 or more roots, frequently met within the cheek teeth of mammals, implanted in corresponding distinct sockets of the jaw, is now peculiar to animals of this class. 4. Structure. The greater number of mammalian teeth when fully formed are not simple and homogeneous in structure, but are composed of several distinct tissues, which are enumerated below. The pulp, a soft substance, consisting of a very delicate gelatinous connective tissue, in which numerous cells are embedded, and abundantly supplied with blood vessels and nerves, constitutes the central axis of all the basal part of the tooth, and affords the means by which the vitality of the whole is preserved. The nerves which pass into the pulp and endow the tooth with sensibility are branches of the fifth pair of cranial nerves. The pulp occupies a larger relative space, and performs a more important purpose, in the young growing tooth than afterwards, as by the calcification and conversion of its outer layers the principal hard constituent of the tooth, the dentine, is formed. In teeth which have ceased to grow the pulp occupies a comparatively small space, which in the dried tooth is called the pulp cavity. This communicates with the external surface of the tooth by a small aperture at the apex of the root, through which the branches of the blood vessels and nerves, by which the tooth receives its nutrition and sensitiveness, pass in to be distributed in the pulp. In growing teeth the pulp cavity is widely open, while in advanced age it often becomes obliterated, and the pulp itself entirely converted into bone-like material. The dentine or ivory forms the principal constituent of the greater number of teeth. When developed in its most characteristic form, it is a very hard but elastic substance, white, with a yellowish tinge, and slightly translucent. It consists of an organic matrix, something like, but not identical with, that of bone, richly impregnated with calcareous salts, chiefly calcium phosphate, these constituting in a fresh human tooth 72% of its weight. When subjected to microscopical examination, it is seen to be everywhere permeated by nearly parallel branching tubes which run, in a slightly curving or wavy manner, in a general direction from the center towards the free surface of the tooth. These tubes communicate by open mouths with the pulp cavity, and usually terminate near the periphery of the dentine by closed ends or loops, though in marsupials and certain other mammals they penetrate into the enamel. They are occupied in the living tooth by soft gelatinous fibrils connected with the cells of the pulp. A variety of dentine, permeated by canals containing blood vessels, met with commonly in fishes and in some few mammals, as the megatherium, is called vasodentine. Other modifications of this tissue occasionally met with are called osteodentine and secondary dentine, the latter being a dentine of irregular structure which often fills up the pulp cavity of old animals. The enamel constitutes a thin investing layer, complete or partial, of the outer or exposed and working surface of the dentine of the crown of the teeth of most mammals. This is the hardest tissue met within the animal body, containing from 95 to 97% of mineral substances, chiefly calcium phosphate and some carbonate, with traces of fluoride. Its ultimate structure consists of prismatic fibers, placed generally with their long axes at right angles to the free surface of the tooth. Enamel is easily distinguished from dentine with the naked eye by its clear, bluish-white, translucent appearance. The cement or crust of petrosa is always the most externally placed of the hard tissues of which teeth are composed, as will be understood when the mode of development of these organs is considered. It is often only found as a thin layer upon the surface of the root, but sometimes, as in the complex crowned molar teeth of the horse and elephant, it is a structure which plays a very important part, covering and filling in the interstices between the folds of the enamel. In appearance, histological structure, and chemical composition it is closely allied to osseous tissue, containing lacunae and canaliculi, though only when it is of considerable thickness are haversian canals present in it. Development. The two principal constituents of the teeth, the dentine and the enamel, are developed from the two layers of the mucous membrane of the jaw, the dentine from the deeper or vascular, the enamel from the superficial or epithelial layer. The latter dips down into the substance of the gum, and forms the enamel organ or germ, the first rudiment of the future tooth, which is constantly present even in those animals in which the enamel is not found as a constituent of the perfectly formed tooth. Below the mass of epithelial cells thus embedded in the substance of the gum, and remaining connected by a narrow neck of similar structure with the epithelium of the surface, a portion of the vascular areolar tissue becomes gradually separated and defined from that which surrounds it, and assumes a distinct form, which is that of the crown of the future tooth, a single cone in the case of simple teeth, or with two or more eminences in the complex forms. This is called the dental papilla or dentine germ, and by the gradual conversion of its tissue into dentine the bulk of the future tooth is formed, the uncalcified central portion remaining as the pulp. The conversion of the papilla into hard tissue commences at the outer surface of the apex, and gradually proceeds downwards and inwards, so that the form of the papilla exactly determines the form of the future dentine, and no alteration either in shape or size of this portion of the tooth, when once calcified, can take place by addition to its outer surface. In the meanwhile, calcification of a portion of the cells of the enamel organ, which adapts itself like a cap round the top of the dentinal papilla, and has assumed a somewhat complex structure, results in the formation of the enamel coating of the crown of the tooth. While these changes are taking place, the tissues immediately surrounding the tooth germ become condensed and differentiated into a capsule, which appears to grow up from the base of the dental papilla, and encloses both this and the enamel germ, constituting the follicle or tooth sac. By the ossification of the inner layer of this follicle the cement is formed. This substance, therefore, unlike the dentine, increases from within outwards, and its growth may accordingly be the cause of considerable modification of form and enlargement, especially of the roots, of certain teeth, as those of seals and some cetacea. The delicate homogeneous layer coating the enamel surface of newly formed teeth, in which cement is not found in the adult state, and known as Naismith's membrane, is considered by Tomes as probably a film of this substance, too thin to exhibit its characteristic structure, though by others it is believed to be derived from the external layer of the enamel organ. The homology of the teeth with the dermal appendages, hairs, scales, and claws, has already been alluded to, and it will now be seen that in both cases two of the primary embryonic layers are concerned in their development, the mesoblast and epiblast, although in very different proportions respectively. Thus in the hair or nail the part derived from the epiblast forms the principal bulk of the organ, the mesoblast only constituting the papilla or matrix. But in the tooth the epiblastic portion is limited to the enamel, and is always of relatively small bulk and often absent, while the dentine, the principal constituent of the tooth, and the cement are formed from the mesoblast. When more than one set of teeth occur in mammals, those of the second set are developed in a precisely similar manner to the first, but the enamel germ, instead of being derived directly from an independent part of the oral epithelium, is formed from a budding out of the neck of the germ of the tooth succeeded. In the case of the true molars, which have no predecessors, the germ of the first has an independent origin, but that of the others is derived from the neck of the germ of the tooth preceding it in the series. The foundations of the permanent teeth are thus laid as it were almost simultaneously with those of their predecessors, although they remain in many cases for years before they are developed into functional activity. Although the commencement of their formation takes place at an early period of embryonic life, teeth are in nearly all mammals still concealed beneath the gum at the time of birth. The period of eruption, or cutting of the teeth as it is called, that is, their piercing through and rising above the surface of the mucous membrane, varies much in different species. In some, as seals, the whole series of teeth appears almost simultaneously, but more often there are considerable intervals between the appearance of the individual teeth, the front ones usually coming into place first, and those at the back of the mouth at a later period. Forms of teeth. The simplest form of tooth may be exemplified on a large scale by the tusk of the elephant, Figure 1 and I. It is a hard mass almost entirely composed of dentine, of a conical shape at first, but during growth becoming more and more cylindrical or uniform in width. The enamel covering, present on the apex in its earliest condition, soon disappears, but a thin layer of cement covers the circumference of the tooth throughout life. In section it will be seen that the basal portion is hollow, and contains a large conical pulp, as broad at the base as the tooth itself, and deeply embedded in the bottom of a recess, or socket, in the maxillary bone. This pulp continues to grow during the lifetime of the animal, and at the same time is converted at its surface into dentine. The tooth therefore continually elongates, but the use to which the animal subjects it in its natural state causes the apex to wear away, at a rate generally proportionate to the growth at the base, otherwise it would become of inconvenient length and weight. Such teeth of indefinite growth are said to be rootless, or to have persistent pulps. Figure 1. Diagrammatic sections of various forms of teeth. I. Incisor or tusk of elephant, with pulp cavity persistently open at base. 2. Human incisor during development, with root imperfectly formed, and pulp cavity widely open at base. 3. Completely formed human incisor, with pulp cavity contracted to a small aperture at the end of the root. 4. Human molar, with broad crown and 2 roots. The molar of the ox, with the enamel covering the crown deeply folded, and the depressions filled up with cement. The surface is worn by use, otherwise the enamel coating would be continuous at the top of the ridges. In all the figures the enamel is black, the pulp white, the dentine represented by horizontal lines, and the cement by dots. One of the corresponding front teeth of man, Figure 2, 2 and 3, may be taken as an example of a very different condition. After its crown is fully formed by calcification of the germ, the pulp, though continuing to elongate, begins to contract in diameter, a neck or slight constriction is formed, and the remainder of the pulp is converted into the root, often, but incorrectly, called fong, a tapering conical process embedded in the alveolar cavity of the bone, and having at its extremity a minute perforation, through which the vessels and nerves required to maintain the vitality of the tooth enter the pulp cavity, which is very different from the widely open cavity at the base of the growing tooth. When the crown of the tooth is broad and complex in character, instead of having a single root, it may be supported by 2 or more roots, each of which is implanted in a distinct alveolar recess or socket, and to the apex of which a branch of the common pulp cavity is continued, Figure 1, 4. Such teeth are called rooted teeth. When they have once attained their position in the jaw, with the neck a little way above the level of the free margin of the alveolus, and embraced by the gum or tough fibrovascular membrane covering the alveolar border, and having the root fully formed, they can never increase in length or alter their position, if they appear to do so in old age, it being only in consequence of absorption and retrocession of the surrounding alveolar margins. If, as often happens, their surface wears away in mastication, it is never renewed. The open cavity at the base of the imperfectly developed tooth, Figure 1.2, causes it to resemble the persistent condition of the rootless tooth. The latter is therefore a more primitive condition, the formation of the root being a completion of the process of tooth development. Functionally it is, however, difficult to say that the one is a higher form than the other, since they both serve important and different purposes in the animal economy. As is almost always the case in nature, intermediate conditions between these two forms of teeth are met with. Thus some teeth, as the molars of the horse, and of many rodents, are for a time rootless, and have growing pulps producing very long crowns with parallel sides, the summits of which may be in use and beginning to wear away while the bases are still growing, but ultimately the pulp contracts, forms a neck and distinct roots, and ceases to grow. The canine tusks of the musk deer and of the walrus have persistent pulps, and are open at their base until the animal is of advanced age, when they close, and the pulp ceases to be renewed. The same sometimes happens in the tusks of very old boars. The simplest form of the crown of a tooth is that of a cone, but this may be variously modified. Thus it may be flattened, with its edges sharp and cutting, and pointed at the apex, as in the laterally compressed premolars of most carnivora, or it may be chisel or awl-shaped, with a straight truncated edge, as in the human incisors, or it may be broad, with a flat or rounded upper surface. Very often there is a more or less prominent ridge encircling the whole or part of the base of the crown just above the neck, called the cingulum, which serves as a protection to the edge of the gum in masticating, and is most developed in flesh-eating and insectivorous animals, in which the gums are liable to be injured by splinters of bone or other hard fragments of their food. The form of the crown is frequently rendered complex by the development upon its surface of elevations or tubercules called cusps or cones, or by ridges usually transverse, but sometimes variously curved or folded. When the crown is broad and the ridges are greatly developed, as in the molars of the elephant, horse, and ox, Figure 1 and V, the interspaces between them are filled with cement, which supports them and makes a solid compact mass of the whole tooth. When such a tooth wears away at the surface by friction against the opposed tooth of the other jaw, the different density of the layers of the substances of which it is composed, enamel, dentine, and cement, arranged in characteristic patterns, causes them to wear unequally, the hard enamel ridges projecting beyond the others, and thus giving rise to a grinding surface of great mechanical advantage. Succession. The dentition of all mammals consists of a definite set of teeth, almost always of constant and determinate number, form, and situation, and, with few exceptions, persisting in a functional condition throughout the natural term of the animal's life. In many species these are the only teeth which the animal ever possesses, the set which is first formed being permanent, or, if accidentally lost, or decaying in extreme old age, not being replaced by others. These animals are called monophyodont. But in the larger number of mammals, certain of the teeth are preceded by others, which may be only of a very transient, rudimentary, and functionless character, being in the seals, for example, shed either before or within a few days after birth, or may be considerably developed, and functionally occupy the place of the permanent teeth for a somewhat lengthened period, during the growth and development of the latter and of the jaws. In all cases these teeth disappear, by the absorption of their roots and shedding of the crowns, before the frame of the animal has acquired complete maturity, as evidenced by the coalescence of the epiphyses of the osseous system. As these teeth are, as a general rule, present during the period in which the animal is nourished by the milk of the mother, the name of milk teeth, French dents de lait, German Milchzahn, has been commonly accorded to them, although it must be understood that the epoch of their presence is by no means necessarily synchronous with that of lactation. Animals possessing such teeth are called diphyodont. No mammal is known to have more than two sets of teeth, and the definite and orderly replacement of certain members of the series is a process of quite a different nature from the indefinite succession which takes place in all the teeth continuously throughout the lifetime of the lower vertebrates. When the milk teeth are well developed, and continue in place during the greater part of the animal's growth, as is especially the case with the ungulata, and, though to a less degree, with the primates and carnivora, their use is obvious, since taken all together they form structurally a complete epitome on a small scale of the more numerous and larger permanent set, see Figure 3, and, consequently, are able to perform the same functions, while time is allowed for the gradual maturation of the latter, and especially while the jaws of the growing animal are acquiring the size and strength sufficient to support the permanent teeth. Those animals, therefore, that have a well-developed and tolerably persistent set of milk teeth may be considered to be in a higher state of development, as regards their dentition, than those that have the milk teeth absent or rudimentary. It is a very general rule that individual teeth of the milk and permanent set have a close relationship to one another, being originally formed, as mentioned above, in exceedingly near proximity, and with, at all events so far as the enamel germ is concerned, a direct connection. Moreover, since the latter ultimately come to occupy the position in the alveolar border temporarily held by the former, they are spoken of respectively as the predecessors or successors of each other. But it must be understood that milk teeth may be present which have no successors in the permanent series, and, what is far more general, permanent teeth may have no predecessors in the milk series. The complete series of permanent teeth of most mammals forms a complex machine, with its several parts adapted for different functions, the most obvious structural modification for this purpose being an increased complexity of the individual components of the series from the anterior towards the posterior extremity of such series. Since, as has just been said, the complete series of the milk teeth often presents structurally and functionally a similar machine, but composed of fewer individual members, and the anterior of which are as simple, and the posterior as complex as those occupying corresponding positions in the permanent series, and since the milk teeth are only developed in relation to the anterior or lateral, never to the most posterior of the permanent series, it follows that the hinder milk teeth are usually more complex than the teeth of which they are the predecessors in the permanent series, and represent functionally, not their immediate successors, but those more posterior permanent teeth which have no direct predecessors. This character is clearly seen in those animals in which the various members of the molar series are well differentiated from each other in form, as the carnivora, and also in man. In animals which have two sets of teeth, the number of those of the permanent series which are preceded by milk teeth varies greatly, being sometimes, as in marsupials and some rodents, as few as one on each side of each jaw, and sometimes including the larger portion of the series. Although there are difficulties in some cases in arriving at a satisfactory solution of the question, it is, on the whole, safest to assume that when only one set of teeth is present, this corresponds to the permanent teeth of the diffeodonts. When this one set is completely developed, and remains in use throughout the animal's life, there can be no question on this subject. When, on the other hand, the teeth are rudimentary and transient, as in the whalebone whales, it is possible to consider them as representing the milk series, but there are weighty reasons in favor of the opposite conclusion. 5. Arrangement, homologies, and notation of teeth. The teeth of the two sides of the jaws are always alike in number and character, except in cases of accidental or abnormal variation, and in the one remarkable instance of constant deviation from bilateral symmetry among mammals, the tusks of the narwhal, monodon, in which the left is of immense size, and the right rudimentary. In certain mammals, such as the dolphins and some armadillos, which have a very large series of similar teeth, not always constant in number in different individuals, there may be differences in the two sides, but, apart from these, in describing the dentition of any mammal, it is quite sufficient to give the number and characters of the teeth of one side only. Since the teeth of the upper and the lower jaws work against each other in masticating, there is a general correspondence or harmony between them, the projections of one series, when the mouth is closed, fitting into corresponding depressions of the other. There is also a general resemblance in the number, characters, and mode of succession of both series, so that, although individual teeth of the upper and lower jaws may not be in any strict sense of the term homologous parts, there is a great convenience in applying the same descriptive terms to the one as are used for the other. Figure 2. Upper and lower teeth of one side of the mouth of a dolphin, Lagenorhynchus, as an example of the homodont type of dentition. The bone covering the outer side of the roots of the teeth has been removed to show their simple character. The simplest dentition as a whole is that of many species of dolphin, Figure 2, in which the crowns are single-pointed, slightly curved cones, and the roots also single and tapering, and all alike in form from the anterior to the posterior end of the series, though it may be with some slight difference in size, those at the two extremities of the series being rather smaller than the others. Such a dentition is called homodont, and in the case cited, as the teeth are never changed, it is also monophyodont. Such teeth are adapted only for catching slippery living prey, as fish. In a very large number of mammals, the teeth of different parts of the series are more or less differentiated in character, and have different functions to perform. The front teeth are simple and one-rooted, and are adapted for cutting and seizing. They are called incisors. The back or cheek teeth have broader and more complex crowns, tuberculated or ridged, and are supported on two or more roots. They crush or grind the food, and are hence called molars. Many animals have, between these two sets, a tooth at each corner of the mouth, longer and more pointed than the others, adapted for tearing or stabbing, or for fixing struggling prey. From the conspicuous development of such teeth in the carnivora, especially the dogs, they have received the name of canines. A dentition with its component parts so differently formed that these distinctive terms are applicable to them is called heterodont. In most cases, though by no means invariably, animals with heterodont dentition are also diphyodont. This general arrangement is extremely obvious in a considerable number of mammals, and closer examination shows that, under very great modification and detail, there is a remarkable uniformity of essential characters in the dentition of a large number of members of the class belonging to different orders and not otherwise closely allied, so much so indeed that it has been possible, chiefly through the researches of Sir Richard Owen, to formulate a common plan of dentition from which the others have been derived by the alteration of some and suppression of other members of the series, and occasionally, but very rarely, by addition. The records of paleontology fully confirm this view, as by tracing back many groups now widely separated in dental characters we find a gradual approximation to a common type. In this generalized form of mammalian dentition, which is best exemplified in the genera Anoplotherium and Homolodontotherium, the entire number of teeth present is 44, or 11 above and 11 below on each side. Those of each jaw are placed in continuous series without intervals between them, and, although the anterior teeth are simple and single-rooted, and the posterior teeth complex and with several roots, the transition between the two kinds is gradual. In dividing and grouping such teeth for the purpose of description and comparison, more definite characters are required than those derived merely from form or function. The first step towards a classification has been made by the observation that the upper jaw is composed of two bones, the premaxilla and the maxilla, and that the suture between these bones separates the three anterior teeth from the others. These three teeth, then, which are implanted by their roots in the premaxilla, form a distinct group, to which the name of incisor is applied. This distinction is, however, not so important as it appears at first sight, for, as mentioned when speaking of the development of the teeth, their connection with the bone is only of a secondary nature, and, although it happens conveniently for our purpose that in the great majority of cases the segmentation of the bone coincides with the interspace between the third and fourth tooth of the series, still, when it does not happen to do so, as in the case of the mole, we must not give too much weight to this fact, if it contravenes other reasons for determining the homologies of the teeth. The 8 remaining teeth of the upper jaw offer a natural division, inasmuch as the posterior 3 never have milk predecessors, and, although some of the anterior teeth may be in the same case, the particular one preceding these 3 always has such a predecessor. These 3 then are grouped apart as the molars, or, since some of the teeth in front of them often have a molariform character, true molars. Of the 5 teeth between the incisors and molars, the most anterior, or that which is usually situated close behind the premaxillary suture, almost always, as soon as any departure takes place from the simplest and most homogeneous type, assumes a lengthened and pointed form, and is the tooth so developed as to constitute the canine or laniary tooth of the carnivora, the tusk of the boar, etc. It is customary therefore to call this tooth, whatever its size or form, the canine. The remaining 4 are the premolars or false molars. This system of nomenclature has been objected to as being artificial, and in many cases not descriptive, the distinction between premolars and canine especially being sometimes not obvious, but the terms are now in such general use, and are so practically convenient, especially if, as it is best to do in all such cases, we forget their original signification and treat them as arbitrary signs, that it is not likely they will be superseded by any that have been proposed as substitutes for them. With regard to the lower teeth, the difficulties are greater, owing to the absence of any suture corresponding to that which defines the incisors above, but since the number of the teeth is the same, the corresponding teeth are preceded by milk teeth, and in the large majority of cases it is the 4th tooth of the series which is modified in the same way as the canine, or 4th tooth, of the upper jaw. It is quite reasonable to adopt the same divisions as with the upper series, and to call the first 3, which are implanted in the part of the mandible opposite to the premaxilla, the incisors, the next the canine, the next 4 the premolars, and the last 3 the molars. It may be observed that when the mouth is closed, especially when the opposed surfaces of the teeth present an irregular outline, the corresponding upper and lower teeth are not exactly opposite, otherwise the 2 series could not fit into one another, but as a rule the points of the lower teeth shut into the interspaces in front of the corresponding teeth of the upper jaw. This is seen very distinctly in the canine teeth of the carnivora, and is a useful guide in determining the homologies of the teeth of the 2 jaws. Objections have certainly been made to this view, because, in certain rare cases, the tooth which, according to it, would be called the lower canine has the form and function of an incisor, as in ruminants and lemurs, and on the other hand, as in cautelops, an extinct ungulate from North America, the tooth that would thus be determined as the first premolar has the form of a canine, but it should not be forgotten that, as in all such cases, definitions derived from form and function alone are quite as open to objection as those derived from position and relation to surrounding parts, or still more so. Dental formulae. For the sake of brevity, the complete dentition, arranged according to these principles, is often described by the following formula: the numbers above the line representing the teeth of the upper, those below the line those of the lower jaw, incisors superscript 3 superscript 3/33, canines superscript 1 superscript 1 slash, premolars slash 44. Molars superscript 3 superscript 3/33 equals superscript 1 superscript 1 superscript 1 superscript 1 slash, total 44. Since, however, initial letters may be substituted for the names of each group, and it is quite unnecessary to give more than the numbers of the teeth on one side of the mouth, the formula may be conveniently abbreviated into I superscript 3/3, C superscript 1 slash, P slash 4, M superscript 3/3 equals superscript 1 superscript 1 slash, total 44. The individual teeth of each group are always enumerated from before backwards, and by such a formula as the following: I1, I2, I3, C, P1, P2, P3, P4, M1, M2, M3 I1, I2, I3, C, P1, P2, P3, P4, M1, M2, M3 or more briefly, I1, 2, 3 C1 P1 2, 3 for M1 2, 3. 1 2 3, 1, 1 2 3 4, 1 2 3. A special numerical designation is thus given by which each one can be indicated. In mentioning any single tooth, such a sign as M superscript 1 slash will mean the first upper molar, slash M the first lower molar, and so on. The use of such signs saves much time and space in description. 6. It was part of the view of the founder of this system of dental notation that, at least throughout the group of mammals whose dentition is derived from this general type, each tooth has its strict homologue in all species, and that in those cases in which fewer than the typical number are present, as in all existing mammals except the genera Sus, Gymnura, Talpa, and Myogale, the teeth that are missing can be accurately defined. According to this view, when the number of incisors falls short of 3, it is assumed that the absent ones are missing from the outer and posterior end of the series. Thus, when there is but one incisor present, it is I1, when 2, they are I1 and I2. Furthermore, when the premolars and the molars are below their typical number, the absent teeth are missing from the fore part of the premolar series, and from the back part of the molar series. If this were invariably so, the labors of those who describe teeth would be greatly simplified, but there are so many exceptions that a close scrutiny into the situation, relations, and development of a tooth is required before its nature can be determined, and in some cases the evidence at our disposal is scarcely sufficient for the purpose. In other instances, however, as among the polyprotodont marsupials, we have decisive evidence to show that the missing premolar teeth are not those at the extremity of the series. Figure 3. Milk and permanent dentition of upper, I, and lower, 2. Jaw of the dog, Canis familiaris, with the symbols by which the different teeth are commonly designated. The third upper molar, M.3, is the only tooth wanting in this animal to complete the typical heterodont mammalian dentition. The milk dentition is expressed by a similar formula, D for deciduous or M for milk being commonly prefixed to the letter expressive of the nature of the tooth. Since the three molars, and almost invariably the first premolar of the permanent series, have no predecessors, the typical milk dentition would be expressed as follows: D superscript 3/3, DC superscript 1/ DM superscript 3/3 equals /7, total 28. In a few ungulates, however, such as the hyrax and tapir, and in some instances the rhinoceros and the extinct Paleotherium, the whole of the four premolars are preceded by milk teeth, when we have the fullest development of cheek teeth in the whole of the Eutheria. The teeth which precede the premolars of the permanent series are all called molars in the milk dentition, although as a general rule, in form and function they represent in a condensed form the whole premolar and molar series of the adult. When there is a marked difference between the premolars and molars of the permanent dentition, the first milk molar resembles a premolar, while the last has the characters of the posterior true molar. The dentition of all the members of the orders Primates, Carnivora, Insectivora, Chiroptera, and Ungulata can clearly be derived from the above-described generalized type. The same may be said of the rodents, and even the Proboscidea, though at least in the existing members of the order with greater modification. It is also apparent in certain extinct Cetacea, as Zeuglodon and Squalodon, but it is difficult to find any traces of it in existing Cetacea, Sirenia, or any of the so-called Edentata. All the marsupials, different as they are in their general structure and mode of life, and variously modified as is their dentition, present in this system of organs some deep-lying common characters which show their unity of origin. The generalized type to which their dentition can be reduced presents considerable resemblance to that of the placental mammals, yet differing in details. It is markedly heterodont, and susceptible of division into incisors, canines, premolars, and molars upon the same principles. The whole number is, however, not limited to 44. The incisors may be as numerous as 5 on each side above, and they are almost always different in number in the upper and the lower jaw. The premolars and molars are commonly 7, as in the placental mammals, but their arrangement is reversed, as there are 4 true molars and 3 premolars. The larger number of incisive and molar teeth among the marsupials suggests that their additional teeth have disappeared in the Eutheria, 7, and Mr. O. Thomas has endeavored to construct a generalized dental formula from which both the marsupial and Eutherian modifications may have been derived by the suppression of particular teeth. Thus the hypothetical formula I superscript 1 superscript 2 superscript 3/2 3 4 5 C superscript 1/ P superscript 1 superscript 2 superscript 3/2 3 4 M superscript 1 superscript 2 superscript 3/2 3 4 5 by the loss of the fifth lower incisor, and of the second premolars, which we know to be those which disappear in the marsupials, and the fifth molars, will give I superscript 1 superscript 2 superscript 3/2 3 4 C superscript 1/ P superscript 1 superscript 3/3 4 M superscript 1 superscript 2 superscript 3/2 3 4, or the formula of the opossum, Didelphys, usually written I/4, C superscript 1/ P superscript 3/3 M/4. Again, in the same formula the loss of the fourth and fifth incisors in both jaws, and also of the fourth molars, gives us I superscript 1 superscript 2 superscript 3/2 3 C superscript 1/ P superscript 1 superscript 2 superscript 3/2 3 4 M superscript 1 superscript 2 superscript 3/2 3, or the formula of a typical eutherian, like the pig, which we generally write as I superscript 3/3, C superscript 1/P/4, M superscript 3/3. Such a generalized formula will admit of modification into that of all existing, and a large number of fossil marsupials, but it is possible that some of the Mesozoic types may have had more than 4 premolars, although there is no absolutely decisive evidence that such was the case. The presence of 7 or 8 true molars in some Mesozoic forms merely entails the addition of 2 or 3 additional figures to the ideal generalized formula. The milk dentition of all known marsupials, existing or extinct, is, if not entirely absent, limited to a single tooth on either side of each jaw, this being the predecessor of the last permanent premolar. And if the view that the milk dentition is an additional series grafted upon the original permanent series be correct, it is evident that we have in this single replacement the first stage of this additional development. In very few mammals are teeth entirely absent. Even in the whalebone whales their germs are formed in the same manner and at the same period of life as in other mammals, and even become partially calcified, but they never rise above the gums, and completely disappear before the birth of the animal. In some species of the order Edentata, the true anteaters and the pangolins, no traces of teeth have been found at any age. The adult Monotremata are likewise devoid of teeth of the same structure as those of ordinary mammals, but well-developed molars occur in the young Ornithorhynchus, although no traces of teeth have hitherto been detected in Echidna. Modifications of the teeth in relation to their functions. The principal functional modifications noticed in the dentition of Mammalia may be roughly grouped as piscivorous, carnivorous, insectivorous, omnivorous, and herbivorous, each having, of course, numerous variations and transitional conditions. The essential characters of a piscivorous dentition are best exemplified in the dolphins, and also, as modifications of the carnivorous type, in the seals. This type consists of an elongated, rather narrow mouth, wide gape, with numerous subequal, conical, sharp-pointed, recurved teeth, adapted simply to rapidly seize, but not to divide or masticate, active, slippery, but not powerful prey. All animals which feed on fish as a rule swallow and digest them entire, a process which the structure of prey of this nature, especially the intimate interblending of delicate, sharp-pointed bones with the muscles, renders very advantageous, and for which the above-described type of dentition is best adapted. The carnivorous type of dentition is shown in its most specialized development among existing mammals in the Felidae. The function being here to seize and kill struggling animals, often of large size and great muscular power, the canines are immensely developed, trenchant, and piercing, and are situated wide apart, so as to give the firmest hold when fixed in the victim's body. The jaws are as short as is consistent with the free action of the canines, so that no power may be lost. The incisors are very small, so as not to interfere with the penetrating action of the canines, and the crowns of the molar series are reduced to scissor-like blades, with which to pare off the soft tissues from the large bones, or to divide into small pieces the less dense portions of the bones for the sake of nutriment afforded by the blood and marrow they contain. The gradual modification between this and the 2 following types will be noticed in their appropriate places. In the most typical insectivorous animals, as the hedgehogs and shrews, the central incisors are elongated, pointed, and project forwards, those of the upper and lower jaw meeting like the blades of a pair of forceps, so as readily to secure small active prey, quick to elude capture, but powerless to resist when once seized. The crowns of the molars are covered with numerous sharp edges and points, which, working against each other, rapidly cut up the hard-cased insects into little pieces fit for swallowing and digestion. The omnivorous type, especially that adapted for the consumption of soft vegetable substances, such as fruits of various kinds, may be exemplified in the dentition of man, of most monkeys, and of the less modified pigs. The incisors are moderate, subequal, and cutting. If the canines are enlarged, it is usually for other purposes than those connected with food, and only in the male sex. The molars have their crowns broad, flattened, and elevated into rounded tubercles. The name bunodont, or hillock-toothed, has been proposed for molars of this type, and will frequently be found convenient. In the most typically herbivorous forms of dentition, as seen in the horse and kangaroo, the incisors are well developed, trenchant, and adapted for cutting off the herbage on which the animals feed. The canines are rudimentary or suppressed. The molars are large, with broad crowns, which in the simplest forms have strong transverse ridges, but may become variously complicated in the higher degrees of modification which this type of tooth assumes. Various forms of teeth of this type will be noticed among the ungulates and rodents. The natural groups of mammals, or those which in our present state of knowledge we have reason to believe are truly related to each other, may each contain examples of more than one of these modifications. Thus the primates have both omnivorous and insectivorous forms. The carnivora show piscivorous, carnivorous, insectivorous, and omnivorous modifications of their common type of dentition. The ungulata and the rodentia have among them the omnivorous and various modifications, both simple and complex, of the herbivorous type. The marsupialia exhibit examples of all forms, except the purely piscivorous. Other orders, more restricted in number or in habits, as the Proboscidea and Cetacea, naturally do not show so great a variety in the dental structure of their members. Taxonomy. In considering the taxonomic value to be assigned to the modifications of teeth of mammals, two principles, often opposed to each other, which have been at work in producing these modifications, must be held in view. 1. The type, or ancestral form, as we generally now call it, characteristic of each group, which in most mammals is itself derived from the still more generalized type described above, and 2. Variations which have taken place from this type, generally in accordance with special functions which the teeth are called upon to fulfill in particular cases. These variations are sometimes so great as completely to mask the primitive type, and in this way the dentition of many animals of widely different origin has come to present a remarkable superficial resemblance, as in the case of the wombat, a marsupial, the aye, a lemur, and the rodents, or as in the case of the thylacine and the dog. In all these examples indications may generally be found of the true nature of the case by examining the earlier conditions of dentition, for the characters of the milk teeth or the presence of rudimentary or deciduous members of the permanent set will generally indicate the route by which the specialized dentition of the adult has been derived. It is perhaps owing to the importance of the dental armature to the well-being of the animal in procuring its sustenance, and preserving its life from the attacks of enemies, that great changes appear to have taken place so readily, and with such comparative rapidity, in the forms of these organs, changes often accompanied with but little modification in the general structure of the animal. Of this proposition the Chiromes among lemurs, the walrus among seals, and the narwhal among dolphins form striking examples, since in all these forms the superficial characters of their dentition would entirely separate them from the animals with which all other evidence, even including the mode of development of their teeth, proves their close affinity. Figure 4. Molar teeth of Mesozoic mammals, enlarged. Triconodont type, 1. Dromatherium, 2. Microconodon, 3. Amphilests, 4. Phascalotherium, 5. Triconodon. Tritubercular type, 6, 7. Spalacotherium, 10. Asthenodon. Tubercular sectorial type, 8. Amphitherium, 9. Paramus, 11-13. Amblytherium, 14. Amblytherium. Protocone, high, hypocone, paracone, metacone, in the upper teeth, and protoconid, hypoconid, paraconid, and metaconid in the lower. 6 and 15 are upper molars, and the rest lower molars. After Osborn. Trituberculism. Recent researches, and more especially those of Professors Cope and Osborn, tend to show that almost all of the extremely different forms of tooth structure found among mammals may be traced to one common type, in which the crown of each tooth carried 3 cusps, and hence termed the tritubercular type, these 3 cusps being arranged in a triangle, with the apex directed inwardly in the upper teeth, figure 4, 6, and outwardly in the lower ones, figure 4, 7. It is further probable that this tritubercular type was itself derived from a type of dentition in which the teeth were in the form of almost a quite simple cone, such a presumably primitive type of dentition, being apparently retained among some existing edentates, like the armadillos, while it is possible that we should regard the dentition of the existing cetacea, figure 2, as a reversion to the same primitive type. None of the Mesozoic mammals at present known exhibit this simple conical type of teeth, although we have an approximation to it in the extremely generalized genus Dromatherium. Starting then from this presumed simple cone, it appears that the teeth of Dromatherium, figure 4, present the first stage towards trituberculism, the crown of each tooth having one main cone, with minute lateral cusps, and the root being grooved. In the next or true triconodont stage, figure 4.3.5, the crown has become elongated anteroposteriorly, and consists of one central and two lateral cones or cusps, while the root is divided. From this the transition is easy to the tritubercular type, in which the three cusps, instead of being placed in a line, are arranged in a triangle, the upper teeth, figure 4.6, having one inner and two outer cusps, while the reverse condition obtains in those of the lower jaw, figure 4.7. These three cusps of the simple tritubercular tooth are collectively designated as the primitive triangle. In the upper tooth the inner cusp is termed the protocone, the anteroexternal one the paracone, and the posteroexternal the metacone, the corresponding cusps of the lower tooth being named protoconid, paraconid, and metaconid, the protoconid being here on the outer side of the crown. It is thus apparent that in the first, or haplodont type, as well as in the triconodont type, the upper and lower molars are alike, while in the simple tritubercular type they have a similar pattern, but with the arrangement of the cusps reversed. This simple tritubercular type occurs in the Mesozoic genus Spalacotherium, figure 4.6 and 7, and apparently in the existing Chrysochloris, but in the majority of tritubercular forms, while this primitive triangle forms the main portion of the crown, other secondary cusps are added, the homologies of which in the upper and lower teeth are somewhat doubtful. At the same time that we have the addition of these secondary cusps, we also find trituberculism differentiating into a secodont and a bunodont series, according as to whether the dentition becomes of a cutting or a crushing type. Thus in the lower molars, figure 4.8 and 9, we very frequently find the three cusps of the primitive triangle elevated and connected by cross crests, while there is an additional low posterior heel or talon, which may be termed the hypoconid. This tubercular sectorial subtype, as it is termed, is found in the lower molars of many polyprotodont marsupials and insectivores, and it also occurs in the lower carnassial teeth of the true carnivora. The presence of two cusps, inner and outer, to the talon converts this modification into a quinquatubercular form, while, by the suppression of one of the three primitive cusps, it develops into the quadratubercular type of the bunodont series. Figure 5. Diagram of two upper and two lower left quadratubercular molars in mutual apposition. The cusps and ridges of the upper molars in double lines, and those of the lower in black lines. The lower molars are looked at from below, as if transparent. Protocone, hypocone, paracone, metacone, protoconal, metaconal, protoconid, hypoconid, paraconid, metaconid, and entoconid. After Osborn. In the upper molars the primitive triangle in the secodont series may remain purely tricuspid, but the addition of intermediate cusps, both in the secodont and bunodont series, may give rise to a quinquatubercular type, these intermediate cusps being respectively designated as the protoconal and metaconal, figure 5, PL. Finally, in the bunodont series, the addition of a posterointernal cusp, figure 5, termed the hypocone, forms the sextubercular molar. The following table exhibits, in a collective form, the names and relations of all the above-mentioned cusps, and the letters by which they are indicated in the figures, upper molars. Anterointernal cusp equals protocone equals PR postero or sixth cusp equals hypocone equals high. Anteroexternal cusp equals paracone equals pa postero equals metacone equals me. Anterior intermediate cusp equals protoconal equals milliliter posterior equals metaconal equals PL lower molars. Anteroexternal cusp equals protoconid equals PRD. Postero equals hypoconid equals height anterointernal or fifth cusp equals paraconid equals pad. Intermediate, or in quadratubercular molars anterointernal, cusp equals metaconid equals med posterointernal cusp equals entaconid equals end. The common occurrence of trituberculism in the mammals of the earlier geological epochs is, as remarked by Osborn, very significant of the uniformity of molar origin. Thus, among the Mesozoic mammals, with the exception of the group known as multituberculata, in which the molars are constructed on a different type, trituberculism occurs in the great majority of the genera, while out of 82 species, belonging to 5 different suborders from the lowest or Puerco-Eocene of the United States, all but 4 exhibit this feature, and the same holds good for the mammals of the corresponding European horizon. At the present day, trituberculism persists in the Lemuroidea, Insectivora, Carnivora, and Marsupialia. In the carnivora there is a tendency to lose the metaconid, while in the bunodont molars of the ungulata it is the paraconid that disappears. 3. The skeleton. Definition. The skeleton is a system of hard parts, forming a framework which supports and protects the softer organs and tissues of the body. It consists of dense fibrous and cartilaginous tissues, portions of which remain through life in this state, but the greater part is transformed during the growth of the animal into bone or osseous tissue. This is characterized by a peculiar histological structure and chemical composition, being formed mainly of a gelatinous basis, strongly impregnated with salts of calcium, chiefly phosphate, and disposed in a definite manner, containing numerous minute nucleated spaces or cavities called lacunae, connected together by delicate channels or canaliculi, which radiate in all directions from the sides of the lacunae. Parts composed of bone are, next to the teeth, the most imperishable of all the organs of the body, often retaining their exact form and internal structure for ages after every trace of all other portions of the organization has completely disappeared, and thus, in the case of extinct animals, affording the only means of attaining a knowledge of their characters and affinities. 8. In the armadillos and their extinct allies alone is there an ossified exoskeleton, or bony covering developed in the skin. In all other mammals the skeleton is completely internal. It may be described as consisting of an axial portion belonging to the head and trunk, and an appendicular portion belonging to the limbs. There are also certain bones called splanchnic, being developed within the substance of some of the viscera. Such are the os cordis and os penis found in some mammals. It is characteristic of all the larger bones of the mammalia that their ossification takes its origin from several distinct centers. One near the middle of the bone, and spreading throughout its greater portion, constitutes the diaphysis, or shaft, in the case of the long bones. Others near the extremities, or in projecting parts, form the epiphyses, which remain distinct during growth, but ultimately coalesce with the rest of the bone. Axial skeleton. The axial skeleton consists of the skull, the vertebral column, prolonged at the posterior extremity into the tail, the sternum, and the ribs. Skull. In the skull of adult mammals, all the bones, except the lower jaw, the auditory ossicles, and the bones of the hyoid arch, are immovably articulated together, their edges being in close contact, and often interlocking by means of fine denticulations projecting from one bone and fitting into corresponding depressions of the other. They are also held together by the investing periosteum, or fibrous membrane, which passes directly from one to the other, and permits no motion, beyond perhaps a slight yielding to external pressure. In old animals there is a great tendency for the different bones to become actually united by the extension of ossification from one to the other, with consequent obliteration of the sutures. The cranium, thus formed of numerous originally independent ossifications, which may retain throughout life more or less of their individuality, or be all fused together, according to the species, the age, or even individual peculiarity, consists of a brain case, or bony capsule for enclosing and protecting the brain, and a face for the support of the organs of sight, smell, and taste, and of those concerned in seizing and masticating the food. The brain case articulates directly with the anterior cervical vertebra, by means of a pair of oval eminences, called condyles, placed on each side of the large median foramen which transmits the spinal cord. It consists of a basal axis, continuous serially with the axes or centra of the vertebrae, and of an arch above, roofing over and enclosing the cavity which contains the cephalic portion of the central nervous system, see Figure 6. The base with its arch is composed of 3 segments placed one before the other, each of which is comparable to a vertebra with a greatly expanded neural arch. The hinder or occipital segment consists of the basioccipital, exoccipital, and supraoccipital bones, the middle segment of the basisphenoid, alisphenoid, and parietal bones, and the anterior segment of the presphenoid, orbitosphenoid, and frontal bones. The axis is continued forwards into the mesethmoid, or septum of the nose, around which the bones of the face are arranged in a manner so extremely modified for their special purposes that anatomists who have attempted to trace their serial homologies with the more simple portions of the axial skeleton have arrived at very diverse interpretations. The characteristic form and structure of the face of mammals is mainly dependent upon the size and shape of 1. The orbits, a pair of cup-shaped cavities for containing the eyeball and its muscles, which may be directed forwards or laterally, placed near together or wide apart, and may be completely or only partially encircled by bone. 2. The nasal fossae, or cavities on each side of the median nasal septum, forming the passage for the air to pass between the external and the internal nares, and containing in their upper part the organ of smell. 3. The zygomatic arch, a bridge of bone for the purpose of muscular attachment, which extends from the side of the face to the skull, overarching the temporal fossa. 4. The roof of the mouth, with its alveolar margin for the implantation of the upper teeth. The face is completed by the mandible, or lower jaw, consisting of 2 lateral rami, articulated by a hinge joint with the squamosal, a cranial bone interposed between the posterior and penultimate segment of the brain case, where also the bony capsule of the organ of hearing is placed, each being composed of a single solid piece of bone, and the 2 united together in the middle line in front, at the symphysis, which union may be permanently ligamentous or become completely ossified. Into the upper border of the mandibular rami the lower teeth are implanted. Figure 6. Longitudinal and vertical section of the skull of a dog, Canis familiaris, with mandible and hyoid arch in, anterior narial aperture, MT, maxilloturbinal bone, AT, ethmoturbinal, nasal, ossified portion of the mesethmoid, CE, cribriform plate of the ethmoturbinal, FR, frontal, parietal, IP, interparietal, supraoccipital, exoccipital, BO, basioccipital, periodic, BS, basisphenoid, point, pterygoid, AS, allospheноid, OS, orbitosphenoid, PS, presphenoid, PI. Palatine, VO, vomer, MX, maxilla, PMX, premaxilla, SH, stylohyle, epihyal, CH, ceratohyal, BH, basohyal, TH, thyrohyal, S, symphysis of mandible, CP, coronoid process, CD, condyle, A, angle, ID, inferior dental canal. The mandible is displaced downwards, to show its entire form. The asterisk indicates the part of the cranium to which the condyle is articulated. 9. In addition to the bones already mentioned as entering into the formation of the cranium, there are many others, the most important of which may be briefly noticed. The anterior extremity of the skull is formed by the premaxilli, figures 6 and 7 PMX, which carry the incisors. Behind them are the maxilli, in which all the remaining upper teeth are implanted. Both the premaxilli and maxilli meet in a median suture on the palate, where they form a floor to the nasal passage, this floor being continued backwards by the plate-like palatines, at the hinder extremity of which the posterior nares are usually situated. In a few instances, however, as in certain edentates and cetaceans, the small pair of bones forming the posterior continuation of the lateral borders of the palatines, and known as the pterygoids, figure 6, point, likewise meet in the middle line below the nasal passage, and thus cause the aperture of the posterior nares to be situated near the occiput. On the upper, or frontal aspect of the cranium, the paired nasals roof over the nasal passage and fill the interval left between the premaxilla and maxilla of either side. Behind the nasals and maxilli, the anterior part of the brain case is formed by the large paired frontals, figures 6 and 7 FR, behind which are the parietals, which may be of still larger size, and form the greater part of the brain case. A median interparietal ossification, figure 6, IP, may divide the parietals posteriorly, and is itself articulated with the supraoccipital, to the lateral borders of which the parietals are also joined. The squamosal, figure 7, SQ, forms the lateral wall of the hinder part of the brain case, and articulates superiorly with the parietal, and posteriorly with the exoccipital. The glenoid cavity, figure 8, for the reception of the articular condyle of the mandible, is formed by the inferior portion of the squamosal, at the point where it gives off the zygomatic process to form the hinder portion of the zygomatic arch. The middle portion of that arch is formed by the jugal, or malar bone, figure 7, which articulates posteriorly with the zygomatic process of the squamosal, and anteriorly with the maxilla. The jugal, as in Figure 7, may also articulate with a small bone situated on the anterior border of the orbit known as the lacrimal. It is important to observe that the zygomatic or temporal arch is a squamosomaxillary one, and that an arcade thus composed is found elsewhere only among the extinct anomodont reptiles, which have already been mentioned as showing signs of mammalian affinity. The relative position occupied by the orbido and allospheноid is sufficiently indicated in Figure 7. Figure 7. Side view of skull of Cape jumping hare, Pedic's caféer. Times 3/5 pmx, premaxilla, mx, maxilla, ma, jugal or malar, fr, frontal, l, lacrimal, pa, parietal, na, nasal, sq, squamosal, tie, tympanic, exoccipital, as, allospheноid, os, orbitosphenoid, por, mastoid bulla. Wedged in between the squamosal and the bones of the occipital and basisphenoidal region are the bones connected with the organ of hearing, known as the periotic and tympanic. The position of the periotic, which encloses the labyrinth or essential organ of hearing, is shown in Figure 6. The periotic is divided into a very dense anterointernal moiety known as the petrosal, and a posteroexternal or mastoid portion, Figure 8, which appears on the outer wall of the brain case. The tympanic is produced horizontally outwards to form the external auditory meatus or tube of the ear, while the inner and under surface is frequently dilated into a shell-like auditory bulla, Figure 8. The small bones of the internal ear known as the malleus, incus, and stapes are contained in the membranous tympanic cavity, which is situated in a space left among this group of bones. Further mention of these bones is made below under the head of the sense organs. In the carnivora and some other groups, the foramina on the base of the skull for the passage of blood vessels and nerves are of considerable taxonomic importance. The position of the more important of these foramina is indicated in Figure 8, but for details the reader may refer to the work on the osteology of the mammalia already mentioned. Attention may, however, be particularly directed to the so-called allospheноid canal, the position of which is shown in Figure 8, since this is a feature of some importance in the classification of the carnivora. This canal is a short channel running horizontally forward from near the foramen ovale through the allospheноid, and opening anteriorly with the foramen rotundum. It is traversed by the external carotid artery. Figure 8. The right half of the hinder part of the base of the cranium of the wolf, Canis lupus. C. Condyloid foramen, L. Foramen lacerum posticum, car. Carotid canal, E. Eustachian canal, O. Foramen ovale, A. Posterior, and A. Anterior aperture of allospheноid canal, P. Paroccipital process of exoccipital, M. Mastoid process of periotic, M. External auditory meatus, G. Glenoid foramen, below which is the glenoid cavity for the condyle of the mandible. Flower, Proc. Zoll SOC, 1869, page 25. Only in those species, as man and the smaller kinds of the primates and some other orders, in which the brain holds a large relative proportion to the rest of the body, does the external form of the skull receive much impress from the real shape of the cavity containing the brain. The size and form of the mouth, and the modifications of the jaws for the support of teeth of various shape and number, the ridges and crests on the cranium for the attachment of the muscles necessary to put this apparatus in motion, and outgrowths of bone for the enlargement of the external surface required for the support of sense organs or of weapons, such as horns or antlers, which outgrowths, to prevent undue increase of weight, are filled with cells containing air, cause the principal variations in the general configuration of the skull. These variations are, however, only characteristically developed in perfectly adult animals, and are in many cases more strongly marked in the male than the female sex. Throughout all the later stages of growth up to maturity, the size and form of the brain case remain comparatively stationary, while the accessory parts of the skull rapidly increase and assume their distinctive development characteristic of the species. The hyoidean apparatus in mammals, Figure 6, supports the tongue and larynx, and consists of an inferior median portion termed the basohele, from which two pairs of half-arches, or cornua, extend upwards and outwards. The anterior is the more important, being connected with the periotic bone of the cranium. It may be almost entirely ligamentous, but more often has several ossifications, the largest of which is usually the stylohyle. The posterior cornu, thyrohyle, is united at its extremity with the thyroid cartilage of the larynx, which it suspends in position. The median portion, or basihyle, is sometimes, as in the howling monkeys, enormously enlarged and hollowed, admitting into its cavity an air sac connected with the organ of voice. Figure 9. Anterior surface of human thoracic vertebra, 4th. C. Body or centrum, NC. Neural canal, P. Pedicle, and L. Lamina of the arch, T. Transverse process, AZ. Anterior zygapophysis. Vertebral column. The vertebral column consists of a series of distinct bones called vertebrae, arranged in close connection with each other along the dorsal side of the neck and trunk, and in the median line. 10. It is generally prolonged posteriorly beyond the trunk, to form the axial support of the appendage called the tail. Anteriorly it is articulated with the occipital region of the skull. The number of distinct bones composing the vertebral column varies greatly among the mammalia, the main variation being due to the degree of elongation of the tail. Apart from this, in most mammals the number is not far from 30, though it may fall as low as 26, as in some bats, or rise as high as 40, Hyrax and Colepus. The different vertebrae, with some exceptions, remain through life quite distinct from each other, though closely connected by means of fibrous structures which allow of a certain, but limited, amount of motion between them. The exceptions are the following: 1. Near the posterior part of the trunk, in nearly all mammals which possess completely developed hinder limbs, 2 or more vertebrae become ankylosed together to form the sacrum, or portion of the vertebral column to which the pelvic girdle is attached. 2. In some species of whales and armadillos there are constant ossific unions of certain vertebrae of the cervical region. Figure 10. Side view of the first lumbar vertebra of a dog, Canis familiaris. S. Spinous process, AZ. Anterior zygapophysis, PZ. Posterior zygapophysis, M. Metapophysis, A. Anapophysis, T. Transverse process. Although the vertebrae of different regions of the column of the same animal or of different animals present great diversities of form, yet there is a certain general resemblance among them, or a common plan on which they are constructed, which is more or less modified by alteration of form or proportions, or by the addition or suppression of parts to fit them to fulfill their special purpose in the economy. An ordinary or typical vertebra consists, in the first place, of a solid piece of bone, termed the body or centrum, figure 9, c, of the form of a disc or short cylinder. The bodies of contiguous vertebrae are connected together by a very dense, tough, and elastic material called the intervertebral substance, of peculiar and complex arrangement. This substance forms the main, and in some cases the only, union between the vertebrae. Its elasticity provides for the vertebrae always returning to their normal relation to each other and to the column generally, when they have been disturbed therefrom by muscular action. A process, P, arises on each side from the dorsal surface of the body. These processes, meeting in the middle line above, form an arch, surmounting a space or short canal, and C. Since it contains the posterior prolongation of the great cerebrospinal nervous axis, or spinal cord, this space is called the neural canal, and the arch the neural arch, in contradistinction to another arch on the ventral surface of the body of the vertebrae, called the haemal arch. The latter is, however, never formed in mammals by any part of the vertebra itself, but by certain distinct bones placed more or less in apposition to it, namely the ribs in the thoracic, and the chevron bones in the caudal region. In most cases the arch of one vertebra is articulated with that of the next by distinct surfaces with synovial joints, placed one on each side, called zygapophyses, AZ, PZ, but these are often entirely wanting when flexibility is more needed than strength, as in the greater part of the caudal region of long-tailed animals. In addition to the body and the arch, there are certain projecting parts called processes, chiefly serving for the attachment of the numerous muscles which move the vertebral column. Of these two are single and median, viz. the spinous process, neural spine, or neuropophysis, S, arising from the middle of the upper part of the arch, and the hypopophysis from the under surface of the body. The latter, however, is as frequently absent as the former is constant. The other processes are paired and lateral. They are the transverse processes, T, of which there may be two, an upper and a lower, in which case the former is called, in the language of Owen, to whom we are indebted for the terminology of the parts of vertebrae in common use, diapophysis, and the latter parapophysis. Other processes less constantly present are called respectively metapophyses, M, and anapophyses, A. The vertebral column is divided for convenience of description into 5 regions: the cervical, thoracic or dorsal, lumbar, sacral, and caudal. This division is useful, especially as it is not entirely arbitrary, and in most cases is capable of ready definition, but at the contiguous extremities of the regions the characters of the vertebrae of one are apt to blend into those of the next region, either normally or as peculiarities of individual skeletons. Figure 11. Anterior surface of 6th cervical vertebra of dog. S. Spinous process, AZ, anterior zygapophysis, V. Vertebro-arterial canal, T. Transverse process, T. Its inferior lamella. Cervical vertebrae. The cervical region constitutes the most anterior portion of the column, or that which joins the cranium. The vertebrae which belong to it are either entirely destitute of movable ribs, or if they have any these are small, and do not join the sternum. As a general rule they have a considerable perforation through the base of the transverse process, the vertebro-arterial canal, figure 11, V, or, as it is sometimes described, they have 2 transverse processes, superior and inferior, which meet at their extremities to enclose a canal. This, however, rarely applies to the last vertebra of the region, in which only the upper transverse process is usually developed. The transverse process, moreover, very often sends down near its extremity a more or less compressed plate, inferior lamella, which, being considered serially homologous with the ribs of the thoracic vertebrae, though not developed autogenously, is often called the costal or pluripophyseal plate. This is usually largest on the 6th, and altogether wanting on the 7th vertebra. The 1st and 2nd cervical vertebrae, called respectively atlas and axis, are specially modified for the function of supporting and permitting the free movements of the head. They are not united together by the intervertebral substance, but connected only by ordinary ligaments and synovial joints. The cervical region in mammals presents the remarkable peculiarity that, whatever the length or flexibility of the neck, the number of vertebrae is the same, viz. 7, with the exception of the manatee and Hoffmann's 2-toed sloth, Colepus hoffmanni, which both have but 6, and the 3-toed sloth, Bradypus tridactylus, which has 9, though in this case the last 2 usually support movable ribs, which are not sufficiently developed to reach the sternum. According to Parker there may occasionally be 8 cervicals in the pangolins, Manus. Dorsal vertebrae. The dorsal, or, as it would be more correctly termed, thoracic, region consists of the vertebrae succeeding those of the neck, which have ribs movably articulated to them. These ribs arch round the thorax, the anterior one, and usually the greater number of those that follow, being attached below to the sternum. Lumbar vertebrae. The lumbar region consists of those vertebrae of the trunk in front of the sacrum which bear no movable ribs. It may happen that, as the ribs decrease in size posteriorly, the last being sometimes more or less rudimentary, the step from the thoracic to the lumbar region may be gradual and rather undetermined in a given species, but most commonly this is not the case, and the distinction is as well defined here as in any other region. As a general rule there is a certain relation between the number of the thoracic and lumbar vertebrae, the whole number being tolerably constant in a given group of animals, and any increase of the one being at the expense of the other. Thus in all known Artiodactyl ungulata there are 19 dorsal lumbar vertebrae, but these may consist of 12 dorsal and 7 lumbar vertebrae, or 13 dorsal and 6 lumbar, or 14 dorsal and 5 lumbar. The smallest number of dorsal lumbar vertebrae in mammals occurs in some armadillos, which have but 14. The number found in man, the higher apes, and most bats, viz. 17, is exceptionally low. 19 prevails in the Artiodactyla, nearly all marsupials, and very many rodents, 20 or 21 in carnivora and most insectivora, and 23 in Perissodactyla. The highest and quite exceptional numbers are in the 2-toed sloth, Colepus, 27, and the Hyrax 30. The prevailing number of rib-bearing vertebrae is 12 or 13, any variation being generally in excess of these numbers. Sacral vertebrate. The sacral region offers more difficulties of definition. Taking the human os sacrum as a guide for comparison, it is generally defined as consisting of those vertebrae between the lumbar and caudal regions which are ankylosed together to form a single bone. It happens, however, that the number of such vertebrae varies in different individuals of the same or nearly allied species, especially as age advances, when a certain number of the tail vertebrae generally become incorporated with the true sacrum. Other suggested tests, as those vertebrae which have a distinct additional, pluripophyseal, center of ossification between the body and the ilium, those to which the ilium is directly articulated, or those in front of the insertion of the ischiosacral ligaments, being equally unsatisfactory or unpractical, the old one of ankylosis, as it is found to prevail in the average condition of adults in each species, is used in the enumeration of the vertebrae in the following pages. The cetacea, having no iliac bones, have no part of the vertebral column modified into a sacrum. Figure 12. Anterior surface of fourth caudal vertebrae of Porpoise, Phocina communis. S. Spinous process, M. Metapophysis, T. Transverse process, H. Chevron bone. Caudal vertebrae. The caudal vertebrae are those placed behind the sacrum, and terminating the vertebral column. They vary in number greatly, being reduced to 5, 4, or even 3, in a most rudimentary condition, in man and in some apes and bats, and being numerous and powerfully developed, with strong and complex processes, in many mammals, especially among the edentata, cetacea, and marsupialia. The highest known number, 46, is possessed by the African long-tailed pangolin. Connected with the undersurface of the caudal vertebrae of many mammals which have the tail well developed are certain bones formed more or less like an inverted arch, called chevron bones, or by the French osnv. These are always situated nearly opposite to an intervertebral space, and are generally articulated both to the vertebra in front and the vertebra behind, but sometimes chiefly or entirely either to one or the other. In some of the anomodont reptiles and labyrinthodont amphibians these chevrons are attached to the intercentra, or imperfect discs alternating with the true centra, which suggests that they are primarily intercentral elements which have been transferred to the edges of the centra by the disappearance of the intercentra. Sternum. The sternum of mammals is a bone, or generally a series of bones, placed longitudinally in the mesial line, on the inferior or ventral aspect of the thorax, and connected on each side with the vertebral column by a series of more or less ossified bars called ribs. It is present in all mammals, but varies much in character in the different groups. It usually consists of a series of distinct segments placed one before the other, the anterior being called the presternum or manubrium sterni of human anatomy, and the posterior the xiphosternum, or xiphoid or ensiform process, while the intermediate segments, whatever their number, constitute the mesosternum or body. In the whalebone whales the presternum alone is developed, and but a single pair of ribs is attached to it. Figure 13. Human sternum and sternal ribs. PS, presternum, MS, mesosternum, XS, xiphosternum, C, point of attachment of clavicle, 1 to 10, the cartilaginous sternal ribs. Ribs. The ribs form a series of long, narrow, and more or less flattened bones, extending laterally from the sides of the vertebral column, curving downwards towards the median line of the body below, and mostly joining the sides of the sternum. The posterior ribs, however, do not directly articulate with that bone, but are either attached by their extremities to the edges of each rib in front of them, and thus only indirectly join the sternum, or else they are quite free below, meeting no part of the skeleton. These differences have given rise to the division into true and false ribs, by no means good expressions, signifying those that join the sternum directly and those that do not, and of the latter, those that are free below, are called floating ribs. The portion of each rib nearest the vertebral column and that nearest the sternum differ in their characters, the latter being usually but imperfectly ossified, or remaining permanently cartilaginous. These are called costal cartilages, or when ossified sternal ribs. Figure 14. Sternum and strongly ossified sternal ribs of great armadillo, Priodon gigas. PS, presternum, XS, xiphosternum. In the anterior part of the thorax the vertebral extremity of each rib is divided into two parts, head or capitulum, and tubercle. The former is attached to the side of the body of the vertebra, the latter to its transverse process. The former attachment corresponds to the interspace between the vertebrae, the head of the rib commonly articulating partly with the hinder edge of the body of the vertebra antecedent to that which bears its tubercle. Hence the body of the last cervical vertebra usually supports part of the head of the first rib. In the posterior part of the series, the capitular and tubercular attachments commonly coalesce, and the rib is attached solely to its corresponding vertebra. The number of pairs of ribs is of course the same as that of the thoracic vertebrae. The circumstance that in some of the anomodont reptiles and labyrinthodonts the capitula of the ribs articulate with the intercentral elements of the vertebral column has suggested, as in the instance of the chevron bones, that the intercentral capitular articulation of the ribs of mammals is a feature directly inherited from those extinct types by the gradual disappearance of the intercentra. Appendicular skeleton. The appendicular portion of the framework consists, when completely developed, of two pairs of limbs, anterior and posterior, Figure 15. Figure 15. Skeleton of lion, Felis leo. CD, caudal vertebrae, CP, carpus, CR, coracoid process of scapula, CV, cervical vertebrae, D, dorsal vertebrae, FB, fibula, FM, femur, H, humerus, IL, ilium, ischium, L, lumbar vertebrae, M, metatarsus, MC, metacarpus, P, patella, PB, pubis, PH, phalanges, PV, pelvis, R, radius, S, sacral vertebrae, SC, scapula, SK, skull, TB, tibia, TS, tarsus, U, ulna, ZY, zygomatic arch anterior limb. The anterior limb is present and fully developed in all mammals, being composed of a shoulder girdle and three segments belonging to the limb proper, viz. the upper arm or brachium, the forearm or antebrachium, and the hand or manus. Shoulder girdle. The shoulder or pectoral girdle in the large majority of mammals is in a rudimentary or rather modified condition, compared with that in which it exists in other vertebrates. In the monotremata, Ornithorhynchus and Echidna, alone is the ventral portion, or coracoid, complete and articulated with the sternum below, as in the Sauropsida, and in this group alone do we find an anterior ventral element, apparently corresponding with the precoracoid of the anomodont reptiles, although generally known as the apicoracoid. In all other mammals the coracoid, though ossified from a distinct center, forms only a process, sometimes a scarcely distinct tubercle, projecting from the anterior border of the glenoid cavity of the scapula. The last-named cavity, which in the monotremes is formed jointly by the scapula and coracoid, receives the head of the humerus, or arm bone. The scapula is always well developed, and generally broad and flat, whence its vernacular name blade bone, with a ridge called the spine on its outer surface, which usually ends in a free curved process, the acromion. As the scapula affords attachment to many of the muscles which act upon the anterior limb, its form and the development of its processes are greatly modified according to the uses to which the member is put. Thus it is most reduced and simple in character in those animals whose limbs are mere organs of support, as the ungulates, and most complex when the limbs are also used for grasping, climbing, or digging. The development or absence of the clavicle or collarbone, an accessory bar which connects the sternum with the scapula and steadies the shoulder joint, has a somewhat similar relation, though its complete absence in the bears shows that this is not an invariable rule. A complete clavicle is found in man and all the primates, in Chiroptera, all insectivora, except Potamogale, in many rodents, in most edentates, and in all marsupials except Parameles. More or less rudimentary clavicles, generally suspended freely in the muscles, are found in the cat, dog, and most carnivora, Myrmecophaga, and some rodents. Clavicles are altogether absent in most of the Ursidae, all the Pinnipedia, Manus among edentates, the Cetacea, Sirenia, ungulates, and some rodents. The monotremes are peculiar in possessing a T-shaped interclavicle like that of many reptiles, lying upon the sternum, and articulating superiorly with the clavicles. Brachium and antebrachium. The proximal segment of the anterior or pectoral limb proper contains a single bone, the humerus, and the second segment two bones, the radius and the ulna, placed side by side, and articulating with the humerus at their proximal, and with the carpus at their distal extremity, Figure 15. In their primitive and unmodified condition these bones may be considered as placed one on each border of the limb, the radius being preaxial or anterior, and the ulna postaxial or posterior, when the distal or free end of the limb is directed outwards, or away from the trunk. This is their position in the earliest embryonic condition, and is best illustrated among adult mammals in the cetacea, where the two bones are fixed side by side and parallel to each other. In the greater number of mammals, the bones assume a very modified and adaptive position, usually crossing each other in the forearm, the radius in front of the ulna, so that the preaxial bone, radius, though external, in the ordinary position of the limb at the upper end, is internal at the lower end, and the hand, being mainly fixed to the radius, also has its preaxial border internal. In the large majority of mammals the bones are fixed in this position, but in some few, as in man, a free movement of crossing and uncrossing, or pronation and supination, as it is termed, is allowed between them, so that they can be placed in their primitive parallel condition, when the hand, which moves with the radius, is said to be supine, or they may be crossed, when the hand is said to be prone. The humerus frequently has a foramen piercing the inner border of the distal extremity, known as the antepicondylar foramen, which corresponds with a similar one found in the anomodont reptiles. The hollow in the head of the ulna for the reception of the head of the humerus is known as the greater sigmoid cavity, and that for the head of the radius as the lesser sigmoid cavity, figure 16. The term olecranon is applied to that process of the ulna which forms the prominence of the elbow. Figure 16. The outer aspect of the proximal extremity of the right ulna of a bear, Ursus. A. Anterior tubercle, OL, olecranon, B. Greater sigmoid cavity, C. Lesser dew. In most mammals walking on four limbs, in which the hand is permanently prone, the ulna is much reduced in size, and the radius increased, especially at the upper end, so that the articular surface of the latter, instead of being confined to the external side of the trochlea of the humerus, extends all across its anterior surface, and the two bones, instead of being external and internal, are anterior and posterior. In many hoofed or ungulate mammals, and in bats, the ulna is reduced to little more than its upper articular extremity, and firmly ankylosed to the radius, stability of these parts being more essential than mobility. Manus. The terminal segment of the anterior limb is the hand or manus. Its skeleton consists of three divisions. 1. The carpus, a group of small, more or less rounded or angular bones with flattened surfaces applied to one another, and, though articulating by synovial joints, having scarcely any motion between them. 2. The metacarpus, a series of elongated bones placed side by side, with their proximal ends articulating by almost immovable joints with the carpus. 3. The phalanges or bones of the digits, usually 3 in number to each, articulating to one another by freely movable hinge joints, the first being connected in like manner to the distal end of the metacarpal bone to which it corresponds. Figure 17. Dorsal surface of the right manus of a water tortoise, Calydra serpentina. After Gagenbohr. U. Ulna, R. Radius, U. Ulnar, I. Intermedium, R. Radial, C. Central, 1 to 5, the 5 bones of the distal row of the carpus, M superscript 1M, the 5 metacarpals. Carpus. To understand thoroughly the arrangement of the bones of the carpus in mammals, it is necessary to study their condition in some of the lower vertebrates. Figure 17 represents the manus in one of its fullest and at the same time most generalized forms, as seen in one of the water tortoises, Calydra serpentina. The carpus consists of 2 principal rows of bones. The upper or proximal row contains 3 bones, to which Gagenbohr has applied the terms radial, R, intermedium, I, and ulnar, U, the first being on the radial or preaxial side of the limb. 11. The lower or distal row contains 5 bones, called carpale 1, 2, 3, 4, and 5 respectively, commencing on the radial side. Between these 2 rows, in the middle of the carpus, is a single bone, the central, C. In this very symmetrical carpus it will be observed that the radial supports on its distal side 2 bones, carpale 1 and 2, the intermedium is in a line with the central and carpale 3, which together form a median axis of the hand, while the ulnar has also 2 bones articulating with its distal end, viz. Carpale 4 and 5. Each of the carpals of the distal row supports a metacarpal. In the carpus of the mammalia there are usually 2 additional bones developed in the tendons of the flexor muscles, one on each side of the carpus, which may be called the radial and ulnar sesamoid bones. The latter, which is the more constant and generally larger, is commonly known as the pisiform bone. The fourth and fifth carpals of the distal row are always united into a single bone, and the central is very often absent. As a general rule, all the other bones are present and distinct, though it not unfrequently happens that two may have coalesced to form a single bone, or one or more may be altogether suppressed. The following table shows the principal names in use for the various carpal bones, those in the second column being the terms generally employed by English anatomists. Radial equals scaphoid equals navicular. Intermedium equals lunar equals semilunar, lunatum. Ulnar equals cuneiform equals triquetrum, pyramidal. Central equals intermedium, Cuvier. Carpal 1 equals trapezium equals multangulum majus. Carpal 2 equals trapezoid equals multangulum minus. Carpal 3 equals magnum equals capitatum. Carpal 4 equals uniform equals hamidum uncinnatum. Carpal 5, the radial and ulnar sesamoids are regarded by Bartleben, 12, as the rudiments of a prepollex and a post minimus digit, the primitive number of digits being thus supposed to have been 7. These bones have been observed in all orders of mammals having 5 complete digits. Occasionally, as in Pedic's Caffaire, the so-called prepollex consists of 2 bones, of which the distal one bears a distinct nail-like horny covering. In Bathyergus maritimus the pisiform, or post minimus, is likewise double, the 2 elements being regarded by their describer as representing the carpal and metacarpal of the presumed 7th digit. Similarly in the posterior limb the tibial sesamoid, and a fibular ossification corresponding to the pisiform, are regarded as representing a prehallux and a post minimus. Metacarpus and phalanges, the metacarpal bones, with the digits which they support, are never more than 5 in number, and are described numerically, first, second, etc., counting from the radial towards the ulnar side. The digits are also sometimes named, 1, the pollex, 2, index, 3, medius, 4, annularis, 5, minimus. One or more may be in a rudimentary condition, or altogether suppressed. If one is absent, it is most commonly the first. Excepting the Cetacea, no mammals have more than 3 phalanges to each digit, but they may occasionally have fewer by suppression or ankylosis. The first or radial digit is an exception to the usual rule, one of its parts being constantly absent, since, while each of the other digits has commonly a metacarpal and 3 phalanges, it has only 3 bones altogether. Whether the missing one is a metacarpal or one of the phalanges is a subject which has occasioned much discussion, and has not yet been satisfactorily decided. The terminal phalanges of the digits are usually specially modified to support the nail, claw, or hoof, and are called ungual phalanges. In walking, some mammals, as the bears, apply the whole of the lower surface of the carpus, metacarpus, and phalanges to the ground. To these the term plantigrade is applied. Many others, as nearly all the existing ungulata, only rest on the last 1 or 2 phalanges of the toes, the first phalanx and the metacarpals being vertical and in a line with the forearm. These are called digitigrade. Intermediate conditions exist between these 2 forms, to which the terms phalangigrade, as the camel, and subplantigrade, as in most carnivora, are applied. When the weight is borne entirely on the distal surface of the ungual phalanx, and the horny structures growing around it, as in the horse, the mode of progression is called unguligrade. In the Chiroptera the digits are enormously elongated, and support a cutaneous expansion constituting the organ of flight. In the Cetacea the manus is formed into a paddle, being covered by continuous integument, which conceals all trace of division into separate digits, and shows no sign of nails or claws. In the sloths the manus is long and very narrow, habitually curved, and terminating in 2 or 3 pointed curved claws in close apposition with each other, and incapable, in fact, of being divaricated, so that it is reduced to the condition of a hook, by which the animal suspends itself to the boughs of the trees among which it lives. These are only examples of the endless modifications to which the distal extremity of the limb is subjected in adaptation to the various purposes to which it is applied. Posterior limb. The posterior limb is constructed upon a plan very similar to that of the anterior extremity. It consists of a pelvic girdle and 3 segments belonging to the limb proper, viz. the thigh, the leg, and the foot or PES, figure 15. Pelvic girdle. The pelvic girdle is present in some form in all mammals, though in the Cetacea and the Sirenia it is in an exceedingly rudimentary condition. In all mammals except those belonging to the two orders just named, each lateral half of the pelvic girdle consists essentially, like the corresponding part of the anterior limb, of a flattened rod of bone crossing the long axis of the trunk, having an upper or dorsal and a lower or ventral end. The upper end diverges from that of the opposite side, but the lower end approaches, and, in most cases, meets it, forming a symphysis, without the intervention of any bone corresponding to the sternum. The pelvic girdle differs from the shoulder girdle in being firmly articulated to the vertebral column, thus giving greater power to the hinder limb in its function of supporting and propelling the body. Like the shoulder girdle, it bears on its outer side, near the middle, a cup-shaped articular cavity, acetabulum, into which the proximal end of the first bone of the limb proper is received. Each lateral half of the girdle is called the os innominatum, or innominate bone, and consists originally of 3 bones which unite at the acetabulum. The ilium or upper bone is that which articulates with the sacral vertebrae. Of the 2 lower bones the anterior or pubis unites with its fellow of the other side at the symphysis, the posterior is the ischium. These lower elements form 2 bars of bone, united above and below, but leaving a space between them in the middle, filled only by membrane, and called the thyroid or obturator foramen. The whole circle of bone formed by the 2 innominate bones and the sacrum is called the pelvis. In the monotremata and marsupialia, a pair of thin, flat, elongated ossifications called epipubic or marsupial bones are attached to the forepart of the pubis, and project forward into the muscular wall of the abdomen. Thigh and leg. The first segment of the limb proper has 1 bone, the femur, corresponding with the humerus of the anterior limb. The second segment has 2 bones, the tibia and fibula, corresponding with the radius and ulna. These bones always lie in their primitive unmodified position, parallel to each other, the tibia on the preaxial and the fibula on the postaxial side, and are never either permanently crossed or capable of any considerable amount of rotation, as in the corresponding bones of the forelimb. In the ordinary walking position the tibia is internal, and the fibula external. In many mammals the fibula is in a more or less rudimentary condition, and it often ankyloses with the tibia at one or both extremities. The patella or kneecap, which is found in an ossified condition in all mammals, with the exception of some of the marsupialia, is a large sesamoid bone developed in the tendon of the extensor muscles of the thigh, where the tendon passes over the front of the knee joint, to which it serves as a protection. There are frequently smaller ossicles, 1 or 2 in number, situated behind the femoral condyles, called fabellae. The processes for the attachment of muscles near the upper end of the femur are termed trochanters, and the third trochanter, found on the hinder aspect of the shaft of this bone in many forms, is of considerable taxonomic importance. PES. The terminal segment of the hind limb is the foot or PES. Its skeleton presents in many particulars a close resemblance to that of the manus, being divisible into 3 parts: 1. A group of short, more or less rounded or square bones, constituting the tarsus; 2. A series of long bones placed side by side, forming the metatarsus; and 3. The phalanges of the digits or toes. The bones of the tarsus of many of the lower vertebrata closely resemble both in number and arrangement those of the carpus, as shown in figure 17. They have been described in their most generalized condition by Gagenbohr under the names expressed in the first column of the following table. The names in the second column are those by which they are generally known to English anatomists, while in the third column some synonyms occasionally employed are added. Tibial equals astragalus, 13 equals talus. Intermedium, fibular equals calcaneum equals os calces. Central equals navicular equals scaphoideum. Tarsale 1 equals internal cuneiform equals entocuneiform. Tarsale 2 equals middle cuneiform equals mesocuneiform. Tarsale 3 equals external cuneiform equals ectocuneiform. Tarsale 4 equals cuboid. Tarsale 5, the bones of the tarsus of mammals present fewer diversities of number and arrangement than those of the carpus. The proximal row, see figure 18, always consists of 2 bones, namely the astragalus, A, which probably represents the coalesced scaphoid and lunar of the hand, and the calcaneum, c. The former is placed more to the dorsal side of the foot than the latter, and almost exclusively furnishes the tarsal part of the tibiotarsal or ankle joint. The calcaneum, placed more to the ventral or plantar side of the foot, is elongated backwards to form a more or less prominent tuberosity, the tuber calces, to which the tendon of the great extensor muscles of the foot is attached. The navicular bone, N, is interposed between the proximal and distal row on the inner or tibial side of the foot, but on the outer side the bones of the two rows come into contact. The distal row, when complete, consists of 4 bones, which, beginning on the inner side, are the 3 cuneiform bones, internal, C superscript 1, middle, C superscript 2, and external, C superscript 3, articulated to the distal surface of the navicular, and the cuboid, CB, articulated with the calcaneum. Of these the middle cuneiform is usually the smallest in animals in which all 5 digits are developed, but when the hallux is wanting the internal cuneiform may be rudimentary or altogether absent. The 3 cuneiform bones support respectively the first, second, and third metatarsals, and the cuboid supports the fourth and fifth. They thus exactly correspond with the 4 bones of the distal row of the carpus. Figure 18. Bones of the right human foot. T. Tarsus, M. Metatarsus, ph. Phalanges, C. Calcaneum, A. Astragalus, CB. Cuboid, N. Navicular, C superscript 1. Internal cuneiform, C superscript 2. Middle cuneiform, C superscript 3. External cuneiform. The digits are indicated by Roman numerals, counting from the tibial to the fibular side. In addition to these constant tarsal bones, there may be supplemental or sesamoid bones, one situated near the middle of the tibial side of the tarsus, largely developed in many carnivora and rodentia, another, less frequent, on the fibular side, and a third, often developed in the tendons of the plantar surface of the tarsus, is especially large in armadillos. There is also usually a pair of sesamoid bones on the plantar aspect of each metatarsophalangeal articulation. In the young of the carnivorous genus Critoprocta there may be a second central, which usually coalesces with the ectocuneiform. The metatarsal bones never exceed 5 in number, and the phalanges follow the same numerical rule as in the manus, never exceeding 3 in each digit. Moreover, the first digit, counting from the tibial side, or hallux, resembles the pollex of the hand in always having one segment less than the other digits. As the function of the hind foot is more restricted than that of the hand, the modifications of its structure are less striking. In the Cetacea and the Sirenia it is entirely wanting, though in some existing members of the first named order rudiments of the bones of both the first and second segments of the limb have been detected, and a femur is present in the Miocene Sirenian Halotherium. 4. The digestive system. General considerations. The search after the purpose which every modification of structure subserves in the economy is always full of interest, and, if conducted with due caution and sufficient knowledge of all the attendant circumstances, may lead to important generalizations. It must always be borne in mind, however, that adaptation to its special function is not the only cause of the particular form or structure of an organ, but that this form, having in all probability been arrived at by the successive and gradual modification of some other different form from which it is now to a greater or less degree removed, has other factors besides use to be taken into account. In no case is this principle so well seen as in that of the organs of digestion. These may be considered as machines which have to operate upon elementary substances in very different conditions of mechanical and chemical combination, and to reduce them in every case to the same or precisely similar materials, and we might well imagine that the apparatus required to produce flesh and blood out of coarse fibrous vegetable substances would be different from that which had to produce exactly the same results out of ready-made flesh or blood, and in a very broad sense we find that this is so. Thus, if we take a large number of carnivorous animals, belonging to different fundamental types, and a large number of herbivorous animals, and strike a kind of average of each, we shall find that there is, pervading the first group, a general style, if we may use the expression, of the alimentary organs, different from that of the others. That is to say, there is a specially carnivorous and a specially herbivorous modification of these parts. But, if function were the only element which has guided such modification, it might be inferred that, as one form must be supposed to be best adapted in its relation to a particular kind of diet, that form would be found in all the animals consuming such diet. But this is far from being the case. Thus the horse and the ox, for instance, two animals whose food in the natural state is precisely similar, are most different as regards the structure of their alimentary canal, and the processes involved in the preparation of that food. Again, the seal and the porpoise, both purely fish-eaters, which seize, swallow, and digest precisely the same kind of prey, in precisely the same manner, have a totally different arrangement of the alimentary canal. If the seal's stomach is adapted in the best conceivable manner for the purpose it has to fulfill, why is not the porpoise's stomach an exact facsimile of it, and vice versa? We can only answer that the seal and porpoise belong to different natural groups of animals, formed either on different primitive types, or descended from differently constructed ancestors. On this principle only can we account for the fact that, whereas, owing to the comparatively small variety of the different alimentary substances met with in nature, few modifications would appear necessary in the organs of digestion, there is really endless variety in the parts devoted to this purpose. Mouth, the digestive apparatus of mammals, as in other vertebrates, consists mainly of a tube with an aperture placed at or near either extremity of the body, the oral and the anal orifice, and furnished with muscular walls, the fibers of which are so arranged as by their regular alternate contraction and relaxation to drive onwards the contents of the tube from the first to the second of these apertures. The anterior or commencing portion of this tube and the parts around it are greatly and variously modified in relation to the functions assigned to them of selecting and seizing the food, and preparing it by various mechanical and chemical processes for the true digestion which it has afterwards to undergo before it can be assimilated into the system. For this end the tube is dilated into a chamber or cavity called the mouth, bordered externally by the lips, which are usually muscular and prehensile, and supported by a movable framework carrying the teeth, the structure and modifications of which have been already described. The roof of the mouth is formed by the palate, terminating behind by a muscular, contractile arch, having in man and some few other species a median projection called the uvula, beneath which the mouth communicates with the pharynx. The anterior part of the palate is composed of mucous membrane tightly stretched over the flat or slightly concave bony lamina separating the mouth from the nasal passages, and is generally raised into a series of transverse ridges, which sometimes, as in ruminants, attain a considerable development. In the floor of the mouth, between the rami of the mandible, and supported behind by the hyoidean apparatus, lies the tongue, an organ the free surface of which, especially in its posterior part, is devoted to the sense of taste, but which also, by its great mobility, being composed almost entirely of muscular fibers, performs important mechanical functions connected with masticating and procuring food. Its modifications of form in different mammals are very numerous. Between the long, extensile, vermiform tongue of the anteaters, which is essential to the peculiar mode of feeding of those animals, and the short, sessile, and almost functionless tongue of the porpoise, every intermediate condition is found. Whatever the form, the upper surface is always covered with numerous fine papillae, in which the terminal filaments of the gustatory nerve are distributed. Salivary glands. The fluid known as the saliva is secreted by an extensive and complex system of glands discharging into the cavity of the mouth, buccal cavity, the position and relation of some of which are exhibited in the woodcut on the next page, Figure 19. Figure 19. Salivary glands of the genit. A. Right side of the head dissected. P. Parotid gland. D. Stenos duct. SM. Submaxillary gland, traversed by the jugular veins. JV. O. Aperture of stenos duct. B. Part of the head with the lip drawn up to show. STD. Aperture of stenos duct. Z.GL. Zygomatic gland. O. Aperture of dew. Z. Zygomatic arch. Mivart. Proc. Zoll. SOC 1882, page 504. This apparatus consists of small glands embedded in the mucous membrane or submucous tissue lining the cavity of the mouth, which are of two kinds, the follicular and the racemose, and of others in which the secreting structure is aggregated in distinct masses removed some distance from the cavity, other tissues besides the lining membrane being usually interposed, and pouring their secretion into the cavity by a distinct tube or duct, which traverses the mucous membrane. To the latter alone the name of salivary glands is ordinarily appropriated, although the distinction between them and the smaller racemose glands is only one of convenience for descriptive purposes, their structure being more or less nearly identical, and, since the fluids secreted by all become mixed in the month, their functions are, at all events in great part, common. Under the name of salivary glands are commonly included, 1. The parotid, p, situated very superficially on the side of the head, below or around the cartilaginous external auditory meatus, and the secretion of which enters the mouth by a duct, often called stenos or stensons, which crosses the masseter muscle and opens into the upper and back part of the cheek, figure 19, and, 2. The submaxillary, sm, situated in the neck, near or below the angle of the mandible, and sending a long duct. Whartons, forwards to open on the forepart of the floor of the cavity of the mouth, below the apex of the tongue. These are the most largely developed and constant of the salivary glands, being met with in various degrees of development in almost all animals of the class. Next in constancy are, 3. The sublingual, closely associated with the last named, at all events in the locality in which the secretion is poured out, and, 4. The zygomatic, Z.gl, found only in some animals in the cheek, just under cover of the anterior part of the zygomatic arch, its duct entering the buccal cavity near that of the parotid. The most obvious function common to the secretion of these various glands, and to that of the smaller ones placed in the mucous membrane of the lips, the cheeks, the tongue, the palate, and fauces, is the mechanical one of moistening and softening the food, to enable it the more readily to be tasted, masticated, and swallowed, though each kind of gland may contribute in different manner and different degree to perform this function. The saliva is, moreover, of the greatest importance in the first stage or introduction to the digestive process, as it dissolves or makes a watery extract of all soluble substances in the food, and so prepares them to be further acted on by the more potent digestive fluids met with subsequently in their progress through the alimentary canal. In addition to these functions, it seems now well established by experiment that saliva serves in man and many animals to aid directly in the digestive process, particularly by its power of inducing the saccharine transformation of amylaceous substances. As a general rule, in mammals the parotid saliva is more watery in its composition, while that of the submaxillaries, and still more the sublingual, contains more solid elements and is more viscid, so much so that some anatomists consider the latter, together with the small racemose glands of the cheeks, lips, and tongue, as mucous glands, retaining the name of salivary only for the parotid. These peculiar properties are sometimes illustrated in a remarkable degree, as, for example, the great secretion of excessively viscid saliva which lubricates the tongue of the anteaters and armadillos, associated with enormously developed submaxillary glands, while, on the other hand, the parotids are of great size in those animals which habitually masticate dry and fibrous food. Stomach. After the preparation which the aliment has undergone in the mouth, the extent of which varies immensely in different forms, being reduced almost to nothing in such animals as the seals and cetaceans, which, to use the familiar expression, bolt their food entire, and most fully carried out in the ruminants, which chew the cud, it is swallowed, and carried along the esophagus by the action of its muscular coats into the stomach. In the greater number of mammals this organ is a simple saccular dilatation of the alimentary canal, as in figures 20 and 21, but in others it undergoes remarkable modifications and complexities. The lining of the stomach is thickly beset with tubular glands, which are generally considered to belong to two different forms, recognizable by their structure, and different in their function, the most numerous and important secreting the gastric juice, the active agent in stomachic digestion, and hence called peptic glands, while the others are concerned only in the elaboration of mucus. The relative distribution of these glands in different regions of the walls of the stomach varies greatly in different animals, and in many species there are large tracts of the mucous membrane which do not secrete a fluid having the properties of gastric juice, but often constitute more or less distinct cavities devoted to storing and perhaps softening or otherwise preparing the food for digestion. Sometimes there is a great aggregation of glands forming distinct thickened patches of the stomach wall, as in the beaver and koala, or even collected in piriform pouches with a common narrow opening into the cavity, as in the manatee and the curious African rodent Lophiomys. The action of the gastric fluid is mainly exerted upon the nitrogenous elements of the food, which it dissolves and modifies so as to render them capable of undergoing absorption, affected partly by the blood vessels of the stomach, although the greater part passes through the pylorus, an aperture surrounded by a circular muscular valve, into the intestinal canal. Here it comes in contact with the secretion of a vast number of small glands called the crypts of Lieberkühn, somewhat similar to those of the stomach, and also of several special glands of a different character, namely, the small racemose, duodenal, or Brunner's glands, the pancreas, and the liver, the position of the ducts of the two latter organs being indicated in Figure 20. Figure 20. Stomach and pancreas of the genit. Posterior or dorsal surface, OE, esophagus, S, pancreas, PD, pancreatic duct, BD, biliary duct from the liver. From Mavart, Proc. Zoll. SOC 1882, page 305. Intestinal canal. The intestinal canal varies greatly in relative length and capacity in different animals, and it also offers manifold peculiarities of form, being sometimes a simple cylindrical tube of nearly uniform caliber throughout, but more often subject to alterations of form and capacity in different portions of its course, the most characteristic and constant being the division into an upper and narrower, and lower and wider portion, called respectively the small and the large intestine, the former being divided quite arbitrarily and artificially into duodenum, jejunum, and ileum, and the latter into colon and rectum. One of the most striking peculiarities of this part of the alimentary canal is the frequent presence of a diverticulum or blind pouch, the caput cecum coli, as it was first called, a name generally abbreviated into cecum, situated at the junction of the large and the small intestine, a structure presenting an immense variety of development, from the smallest bulging of a portion of the side wall of the tube to a huge and complex sac, greatly exceeding in capacity the whole of the remainder of the alimentary canal. It is only in herbivorous animals that the cecum is developed to this great extent, and among these there is a curious complementary relationship between the size and complexity of this organ and that of the stomach. Where the latter is simple, the cecum is generally the largest, and vice versa. Both the cecum and colon are often sacculated, a disposition caused by the arrangement of the longitudinal bands of muscular tissue in their walls, but the small intestine is always smooth and simple-walled externally, though its lining membrane often exhibits various contrivances for increasing the absorbing surface without adding to the general bulk of the organ, such as the numerous small villi by which it is everywhere beset, and the more obvious transverse, longitudinal, or reticulating folds projecting into the interior, met with in many animals, of which the valvuli conniventes of man form well-known examples. Figure 21. Diagrammatic plan of the general arrangement of the alimentary canal in a typical mammal. O. Esophagus, St. Stomach, P. Pylorus, S. Small intestine, abbreviated, C. Cecum, L. Large intestine or colon, ending in R, the rectum. Besides the crypts of Lieberkühn found throughout the intestinal canal, and the glands of Brunner confined to the duodenum, there are other structures in the mucous membrane, about the nature of which there is still much uncertainty, called solitary and agminated glands, the latter being more commonly known by the name of Peyer's patches. These were formerly supposed to be secretory organs, which discharged some kind of fluid into the intestine, but are now more generally considered to belong to that group of structures of somewhat mysterious function of which the lymphatic and lacteal glands are members. The solitary glands are found scattered irregularly throughout the whole intestinal tract. The agminated, on the other hand, are always confined to the small intestine, and are most abundant in its lower part. They are subject to great variation in number and in size, and even in different individuals of the same species, and also differ in character at different periods of life, becoming atrophied in old age. Liver. The distinct glands situated outside the walls of the intestinal canal, but which pour their secretion into it, are the pancreas and the liver. The latter is the more important on account of its size, if not on account of the direct action of its secretion in the digestive process. This large gland, so complex in structure and function, is well developed in all mammals, and its secreting tube, the bile duct, always opens into the duodenum, or that portion of the canal which immediately succeeds the stomach. It is situated on the right side of the abdomen in contact with the diaphragm and the stomach, but varies greatly in relative size, and also in form, in different groups of mammals. In most mammals a gallbladder, consisting of a piriform diverticulum from the bile duct, is present, but in many this appendage is wanting, and it is difficult to find the rationale of its presence or absence in relation to use or any other circumstance in the animal economy. The descriptions of the livers of various animals to be met with in treatises or memoirs on comparative anatomy are very difficult to understand for want of a uniform system of nomenclature. The difficulty usually met with arises from the circumstance that this organ is divided sometimes, as in man, ruminants, and the cetacea, into two main lobes, which have been always called respectively right and left, and in other cases, as in the lower monkeys, carnivora, insectivora, and several other orders, into a larger number of lobes. Among the latter the primary division usually appears at first sight tripartite, the whole organ consisting of a middle, called cystic or suspensory lobe, and two lateral lobes, called respectively right and left lobes. This introduces confusion in describing livers by the same terms throughout the whole series of mammals, since the right and left lobes of the monkey or dog, for instance, do not correspond with parts designated by the same names in man and the sheep. There are, moreover, conditions where neither the bipartite nor the tripartite system of nomenclature will answer, so that we should have considerable difficulty in describing them without some more general system. In order to arrive at such a system it appears desirable to consider the liver in all cases as primarily divided by the umbilical vein, see figure 22, U, into two segments, right and left. This corresponds with its development and with the condition characteristic of the organ in the inferior classes of vertebrates. The situation of this division can almost always be recognized in adult animals by the persistence of some traces of the umbilical vein in the form of the round ligament, and by the position of the suspensory ligament. Figure 22. Diagrammatic plan of the inferior surface of a multilobed liver of a mammal. The posterior or attached border is uppermost. U. Umbilical vein of the fetus, represented by the round ligament in the adult, lying in the umbilical fissure, DV, the ductus venosus, VC, the inferior vena cava, P, the vena porti entering the transverse fissure, LLF, the left lateral fissure, RLF, the right lateral fissure, CF, the cystic fissure, LL, the left lateral lobe, LC, the left central lobe, RC, the right central lobe, RL, the right lateral lobe, S, the spigelian lobe, C, the caudate lobe, G, the gallbladder. When the two main parts into which the liver is thus divided are entire, as in man, the ruminants, and cetacea, they may be spoken of as the right and left lobes, when fissured, as the right and left segments of the liver, reserving the term lobe for the subdivisions. This will involve no ambiguity, for the terms right and left lobe will no longer be used for divisions of the more complex form of liver. In the large majority of mammals each segment is further divided by a fissure, more or less deep, extending from the free towards the attached border, which are called right and left lateral fissures, figure 22, RLF and LLF. When these are more deeply cut than the umbilical fissure, U, the organ has that tripartite or trefoil-like form just spoken of, but it is easily seen that it is really divided into four regions or lobes, those included between the lateral fissures being the right and left central, RC and LC, separated by the umbilical fissure, and those beyond the lateral fissures on each side being the right and left lateral lobes, RL and LL. The essentially bipartite character of the organ and its uniformity of construction throughout the class are thus not lost sight of, even in the most complex forms. The left segment of the liver is rarely complicated to any further extent, except in some cases by minor or secondary fissures marking off small lobules, generally inconstant and irregular, and never worthy of any special designation. On the other hand, the right segment is usually more complex. The gallbladder, when present, is always attached to the undersurface of the right central lobe, sometimes merely applied to it, in other cases deeply embedded in its substance. In many instances the fossa in which it is sunk is continued to the free margin of the liver as an indent, or even a tolerably deep fissure, cf. The portal fissure, P, through which the portal vein and hepatic artery enter and the bile duct emerges from the liver, crosses the right central lobe transversely, near the attached border of the liver. The right lateral lobe always has the great vena cava, VC, either grooving its surface or tunneling through its substance near the inner or left end of its attached border, and a prolongation of this lobe to the left, between the vein and the portal fissure, sometimes forming a mere flat track of hepatic substance, but more often a prominent tongue-shaped process, is the so-called Spigelian lobe, S. From the undersurface of the right lateral lobe a portion is generally partially detached by a fissure, and called the caudate lobe, C. In man this lobe is almost obsolete, but in most mammals it is of considerable magnitude, and has very constant and characteristic relations. It is connected by an isthmus at the left, narrowest or attached, end to the Spigelian lobe, behind which isthmus the vena cava is always in relation to it, channeling through or grooving its surface. It generally has a pointed apex, and is deeply hollowed to receive the right kidney, to the upper and inner side of which it is applied. Considerations derived from the comparatively small and simple condition of the liver of the ungulata, compared with its large size and complex form in the carnivora, have led to the perhaps too hasty generalization that the first type is related to a herbivorous and the latter to a carnivorous diet. The exceptions to such a proposition are very numerous. The fact of the great difference between the liver of the cetacea and that of the seals cannot be accounted for by difference of habits of life, though it perhaps may be by difference of origin. 14. V. Circulatory, absorbent, respiratory, and urinary systems. Blood. The blood of mammals is always red, and during the life of the animal hot, having a nearly uniform temperature, varying within a few degrees on each side of 100 degrees FAHR. The corpuscles are, as usual in the vertebrates, of two kinds: 1. Colorless, spheroidal, nucleated, and exhibiting amoeboid movements, while 2. The more numerous, on which depends the characteristic hue of the fluid in which they are suspended, are colored, non-nucleated, flattened, slightly biconcave discs, with circular outline in all known species except the camels and llamas, where they have the elliptical form characteristic of the red corpuscles of nearly all the other vertebrates, though adhering to the mammalian type in the absence of nucleus and relatively small size. As a rule they are smaller as well as more numerous than in other classes, but vary considerably in size in different species, and not always in relation to the magnitude of the animal, a mouse, for instance, having as large corpuscles as a horse. Within the limits of any natural group there is, however, very often some such relation, the largest corpuscles being found among the large species and the smallest corpuscles among the small species of the group, but even to this generalization there are many exceptions. The transverse diameter of the red corpuscles in man averages superscript 1/32 of an inch, which is exceptionally large, and only exceeded by the elephant, superscript 1/2745, and by some cetacea and edentata. They are also generally large in apes, rodents, and the monotremata, and small in the artiodactyls, least of all in the chevrotanes, tragulus, being in T. javanicus and mamina not more than superscript 1/2325. 15. Heart. The heart of mammals consists of 4 distinct cavities, 2 auricles and 2 ventricles. Usually the ventricular portion is externally of conical form, with a simple apex, but in the Sirenia it is broad and flattened, and a deep notch separates the apical portion of each ventricle. A tendency to this form is seen in the cetacea and the seals. It is characteristic of mammals alone among vertebrates that the right auriculoventricular valve is tendinous like the left, consisting of flaps held in their place by fibrous ends, chordae tendinii, and arising from projections of the muscular walls of the ventricular cavity, musculi papillaires. In the monotremata a transition between this condition and the simple muscular flap of the sauropsida is observed. In most of the larger ungulates a distinct but rather irregular ossification, os cordis, is developed in the central tendinous portion of the base of the heart. Blood vessels. The orifices of the aorta and pulmonary artery are each guarded by 3 semilunar valves. The aorta is single, and arches over the left bronchial tube. After supplying the tissues of the heart itself with blood by means of the coronary arteries, it gives off large vessels, carotid, to the head and, brachial, to the anterior extremities. The mode in which these vessels arise from the aorta varies much in different mammals, and the study of their disposition affords some guide to classification. In nearly all cases the right brachial and carotid have a common origin, called the innominate artery in anthropotomy. The other two vessels may come off from this, as is the rule in ungulates, the common trunk constituting the anterior aorta of veterinary anatomy, or they may be detached in various degrees, both arising separately from the aorta, as in man, or the left carotid from the innominate and the left brachial from the aorta, a very common arrangement, or the last two from a common second or left innominate, as in some bats and insectivores. The aorta, after giving off the intercostal arteries, passes through the diaphragm into the abdomen, and, after supplying the viscera of that cavity by means of the gastric, hepatic, splenic, mesenteric, renal, and spermatic vessels, gives off in the lumbar region a large branch, iliac, to each of the hinder extremities, which also supplies the pelvic viscera, and is continued onwards in the middle line, greatly diminished in size, along the undersurface of the tail as the caudal artery. In certain mammals, arterial plexuses, called rhetia mirabilia, formed by the breaking up of the vessel into an immense number of small trunks, which may run in a straight course parallel to one another, as in the limbs of sloths and slow lemurs, or form a closely packed network, as in the intracranial plexuses of ruminants, or a sponge-like mass of convoluted vessels, as in the intercostals of cetaceans, are peculiarities of the vascular system the meaning of which is not in all cases clearly understood. In the cetacea they are obviously receptacles for containing a large quantity of oxygenated blood available during the prolonged immersion, with consequent absence of respiration, to which these animals are subject. The vessels returning the blood to the heart from the head and upper extremities usually unite, as in man, to form the single vena cava superior or precaval vein, but in some insectivores, chiroptera, and rodents, in the elephant, and all marsupials and monotremes, the two superior caval veins enter the right auricle without uniting, as in birds. In seals and some other diving mammals there is a large venous sinus or dilatation of the inferior vena cava immediately below the diaphragm. In the cetacea the purpose of this is supplied by the immense abdominal venous plexuses. As a rule the veins of mammals are furnished with valves, but these are said to be altogether wanting in the cetacea, and in the superior and inferior cava, subclavian and iliac veins, the veins of the liver, both portal and hepatic, heart, lungs, kidneys, brain, and spinal cord of other mammals. Many of the veins within the cranium are included in spaces formed by the separation of the laminae of the dura mater, and do not admit of being dilated beyond a certain size. These are termed sinuses. The portal circulation in mammals is limited to the liver, the portal vein being formed by the superior and inferior mesenteric, the splenic, the gastroepiploic, and the pancreatic veins. The kidney is supplied solely by arterial blood, and its veins empty their contents only into the inferior cava. Lymphatic vessels. The absorbent or lymphatic system of vessels is very fully developed in the mammalia. Its ramifications extend through all the soft tissues of the body, and convey a colorless fluid called lymph, containing nucleated corpuscles, and also, during the process of digestion, the chyle, a milky fluid taken up by the lymphatics, here called lacteals, of the small intestine, and pour them into the general vascular system, where they mix with the venous blood. The lymphatic vessels of the hinder extremities, as well as those from the intestinal canal, unite in the abdomen to form the thoracic duct, the hinder end or commencement of which has a dilatation called the receptaculum chyli. This duct, which is of irregular size and sometimes double, often dividing and uniting again in its course, or even becoming plexiform, passes forwards close to the bodies of the thoracic vertebrae, and empties itself, by an orifice guarded by a valve, into the great left brachiocephalic vein, having previously received the lymphatics from the thorax and the left side of the head and left anterior extremity. The lymphatics from the right side of the head and right anterior limb usually enter by a small distinct trunk into the corresponding part of the right brachiocephalic vein. The duct, and also the principal lymphatic vessels, are provided with valves. Lymphatic glands, rarely met within the Sauropsida, are usually present in mammals, both in the general and in the lacteal system, the latter being called mesenteric glands. They are round or oval masses, situated upon the course of the vessels, which break up in them and assume a plexiform arrangement, and then reunite as they emerge. No structures corresponding to the pulsating lymphatic hearts of the lower vertebrates have been met within mammals. Ductless glands. Associated with the vascular and lymphatic systems are certain bodies, the functions of which are not properly understood, usually, on account of their general appearance, grouped together under the name of ductless glands. The largest of these is the spleen, which is single, and always placed in mammals in relation to the fundus or left end of the stomach, to which it is attached by a fold of peritoneum. It is dark-colored and spongy in substance, and has a depression or halus on one side, into which the splenic artery, a branch of the celiac axis of the abdominal aorta, enters, and from which the vein joining the portal system emerges. The spleen varies much in size and form in different mammals, being relatively very small in the cetacea. It is sometimes almost spherical, but more often flattened, oval, triangular, or elongated, and occasionally, as in monotremes and most marsupials, triradiate. The suprarenal bodies or adrenals are 2 in number, each situated either in contact with, or at a short distance in front of the anterior extremity of the kidney. They are abundantly supplied with nerves, and are much larger relatively in early than in adult life. The thyroid bodies, of which there are generally 2, though in man and some other species they are connected by an isthmus passing across the middle line, are constant in mammals, though only met with in a rudimentary condition, if at all, in other vertebrates. They are situated in the neck, in contact with the sides of the anterior extremity of the trachea. The thymus lies in the anterior part of the thorax, between the sternum and the great vessels at the base of the heart, and differs from the thyroid in being median and single, and having a central cavity. It attains its greatest development during the period in which the animal is nourished by its mother's milk, and then it diminishes, and generally disappears before full growth is attained. Nostrils. Mammals breathe occasionally through the mouth, but usually, and in many cases exclusively, through the nostrils or nares. Those are apertures, always paired, except in the toothed cetacea, where they unite to form a single external opening, and situated at the fore part of the face, generally at or beneath the end of the muzzle, a median prominence above the mouth. This is sometimes elongated to form a proboscis, to the extremity of which the nostrils are carried, and which attains its maximum of development in the elephant. In the cetacea the nostrils are situated at a considerable distance behind the anterior end of the face, upon the highest part of the head, and are called blowholes, from the peculiar mode of respiration of those animals. The nostrils are kept open by means of cartilages surrounding their aperture, which many animals have the power of moving so as to cause partial dilatation or contraction. In diving animals, as seals and cetacea, they can be completely closed at will so as to prevent the entrance of water when beneath the surface. The passage to which the nostrils lead is in most mammals filled by a more or less complex sieve-like apparatus, formed of the convoluted turbinal bones and cartilages, over which a moist, vascular, ciliated mucous membrane is spread, which intercepts particles of dust, and also aids in warming the inspired air before it reaches the lungs. In the proboscidea, in which these functions are performed by the walls of the long tubular proboscis, this apparatus is entirely wanting. Tracheid. The narial passages have the organ of smell situated in their upper part, and communicate posteriorly with the pharynx, and through the glottis with the trachea or windpipe, a tube by which the air is conveyed to and from the lungs. The permanent patency of the trachea during the varied movements of the neck is provided for by its walls being stiffened by a series of cartilaginous rings or hoops, which in most mammals are incomplete behind. Having entered the thorax, the trachea bifurcates into the 2 bronchi, one of which enters, and, dividing dichotomously, ramifies through each lung. In some of the cetacea and artiodactyla a 3rd bronchus is given off from the lower part of the trachea, above its bifurcation and enters the right lung. Larynx. The upper end of the trachea is modified into the organ of voice or larynx, the air passing through which to and from the lungs is made use of to set the edges of the vocal cords, or fibrous bands stretched one on each side of the tube, into vibration. The larynx is composed of several cartilages, such as the thyroid, the cricoid, and the arytenoid, which are moved upon one another by muscles, and suspended from the hyoidean arch. By alteration of the relative position of these cartilages the cords can be tightened or relaxed, approximated or divaricated, as required to modulate the tone and volume of the voice. A median tongue-shaped fibrocartilage at the top of the larynx, the epiglottis, protects the glottis, or aperture by which the larynx communicates with the pharynx, from the entry of particles of food during deglutition. The form of the larynx and development of the vocal cords present many variations in different members of the class, the greatest modification from the ordinary type being met within the cetacea, where the arytenoid cartilages and epiglottis are united in a tubular manner, so as to project into the nasal passage, and, being grasped by the muscular posterior margin of the palate, provide a direct channel of communication from the lungs to the external surface. An approach to this condition is met within the hippopotamus and some other ungulates. It is indeed so general as an abnormality that House suggests that an internarial epiglottis may have been a primitive feature common throughout the class. Nearly all mammals have a voice, although sometimes it is only exercised at seasons of sexual excitement. Some marsupials and edentates appear to be quite mute. In no mammal is there an inferior larynx, or syrinx, as in birds. Diaphragm. The thoracic cavity of mammals differs from that of the Sauropsida in being completely separated from the abdomen by a muscular partition, the diaphragm, attached to the vertebral column, the ribs, and the sternum. This is much arched, with the convexity towards the thorax, so that when its fibers contract and it is flattened the cavity of the thorax is increased, and when they are relaxed the cavity is diminished. Lungs. The lungs are suspended freely in the thorax, one on each side of the heart, being attached only by the root, which consists of the bronchus or air tube and pulmonary arteries and veins by which the blood is passed backwards and forwards between the heart and the lungs. The remaining part of the surface of each lung is covered by serous membrane, the pleura, and whatever the state of distension or contraction of the chest wall, is accurately in contact with it. Inspiration is effected by the contraction of the diaphragm and by the intercostal and other muscles elevating or bringing forward the ribs, and thus throwing the sternum farther away from the vertebral column. As the surface of the lung must follow the chest wall, the organ itself is expanded, and air rushes in through the trachea to fill all the minute cells in which the ultimate ramifications of the bronchi terminate. In ordinary expiration very little muscular power is expended, the elasticity of the lungs and surrounding parts being sufficient to cause a state of contraction and thus drive out at least a portion of the air contained in the cells, when the muscular stimulus is withdrawn. The lungs are sometimes simple externally, as in the Sirenia, where they are greatly elongated, and the Cetacea, but are more often divided by deep fissures into one or more lobes. The right lung is usually larger and more subdivided than the left. It often has a small distinct lobe behind, wanting on the left side, and hence called lobulus azygos. Air sacs. Most mammals have in connection with the air passages certain diverticuli or pouches containing air, the use of which is not always easy to divine. The numerous air sinuses situated between the outer and inner tables of the bones of the head, represented in man by the antrum of Highmore and the frontal and sphenoidal sinuses, and attaining their maximum of development in the Indian elephant, are obviously for the mechanical purpose of allowing expansion of the osseous surface without increase of weight. They are connected with the nasal passages. The eustachian tubes pass from the back of the pharynx to the cavity of the tympanum, into which and the mastoid cells they allow air to pass. In the equidae there are large postpharyngeal air sacs in connection with them. The dolphins have an exceedingly complicated system of air sacs in connection with the nasal passages just within the nostrils, and the tapirs, rhinoceroses, and horses have blind sacs in the same situation. In the males of some seals, Cystophora and Macrorhinus, large pouches, which the animal can inflate with air, and which are not developed in the young animal or the female, arise from the upper part of the nasal passages, and lie immediately under the skin of the face. These appear analogous, although not in the same situation, to the gular pouch of the male bustard. The larynx frequently has membranous pouches in connection with it, into which air passes. These may be lateral and opening just above the vocal cords, when they constitute the saculi laryngis, found in a rudimentary state in man, and attaining an enormous development, so as to reach to the shoulders and axillae, in some of the anthropoid apes, or they may be median, opening in front either above or below the thyroid and cricoid cartilages, as in the howling and other monkeys, and also in the whalebone whales and great anteater. Urinary organs. The kidneys of mammals are more compact and definite in form than in other vertebrates, being usually more or less oval, with an indent on the side turned towards the middle line, from and into which the vessels and ducts pass. They are distinctly divided into a cortical secretory portion, composed mainly of convoluted tubes, and containing the so-called Malpighian bodies, and a medullary excreting portion, formed of straight tubes converging towards a papilla, embraced by the commencement of the ureter or duct of the organ. The kidneys of some mammals, as most monkeys, carnivores, rodents, etc., are simple, with a single papilla into which all the renal tubuli enter. In others, as man, there are many pyramids of the medullary portion, each with its papilla, opening into a division, calyx, of the upper end of the ureter. Such kidneys, either in the embryonic condition only, or throughout life, are lobulated on the surface. In some cases, as in bears, seals, and especially the cetacea, the lobulation is carried further, the whole organ being composed of a mass of ranules, loosely united by connective tissue, and with separate ducts, which soon join to form the common ureter. Bladder. In all mammals except the monotremes, the ureters terminate by slit-like valvular openings in the urinary bladder. This receptacle, when filled, discharges its contents through the single median urethra, which in the male is almost invariably included in the penis, and in the females of some species of rodents, insectivores, and lemurs has a similar relation to the clitoris. In the monotremes, though the bladder is present, the ureters do not enter into it, but join the urinogenital canal some distance below it, with the orifice of the genital duct intervening. 6. Nervous system and organs of sense. Brain. The brain of mammals shows a higher condition of organization than that of other vertebrates. The cerebral hemispheres have a greater preponderance compared with other parts, especially to the so-called optic lobes, or corpora quadrigemina, which are completely concealed by them. The commissural system of the hemispheres is much more complex, both fornix and corpus callosum being present in some form, and when the latter is rudimentary, as in marsupials and monotremes, its deficiency is made up for by the great size of the anterior commissure. The lateral lobes of the cerebellum, wanting in lower vertebrates, are well developed and connected by a transverse commissure, the pons verolii. The whole brain, owing especially to the size of the cerebral hemispheres, is considerably larger relatively to the bulk of the animal than in other classes, but it must be recollected that the size of its brain depends upon many circumstances besides the degree of intelligence which an animal possesses, although this is certainly one. Man's brain is many times larger than that of all other known mammals of equal bulk, and even 3 times as large as that of the most nearly allied ape. Equal bulk of body is here mentioned, because, in drawing any conclusions from the size of the brain compared with that of the entire animal, it is always necessary to take into consideration the fact that in every natural group of closely allied animals the larger species have much smaller brains relatively to their general size than the smaller species, so that, in making any effective comparison among animals belonging to different groups, species of the same size must be selected. It may be true that the brain of a mouse is, as compared with the size of its body, larger than that of a man, but, if it were possible to reduce an animal having the general organization of a man to the size of a mouse, its brain would doubtless be very many times larger, and conversely, as shown by the rapid diminution of the relative size of the brain in all the large members of the rodent order, a mouse magnified to the size of a man would, if the general rule were observed, have a brain exceedingly inferior in volume. Although the brain of the large species of whales is, as commonly stated, the smallest in proportion to the bulk of the animal of any mammal, this does not invalidate the general proposition that the cetacea have very large brains compared with terrestrial mammals, like the ungulata, or even the aquatic sirenia, as may be proved by placing the brain of a dolphin by the side of that of a sheep, a pig, or a manatee of equal general weight. It is only because the universally observed difference between the slough our ratio of increase of the brain compared with that of the body becomes so enormous in these immense creatures that they are accredited with small brains. The presence or absence of sulci or fissures on the surface of the hemisphere, dividing it into convolutions or gyri, and thus increasing the superficies of the cortical gray matter, as well as allowing the pia mater with its nutrient blood vessels to penetrate into the cerebral substance, follow somewhat similar rules. The sulci are related partly to the high or low condition of organization of the species, but also in a great degree to the size of the cerebral hemispheres. In very small species of all groups, even the primates, they are absent, and in the largest species of groups so low in the scale as the marsupials and edentates they are found. They reach their maximum of development in the cetacea. The accompanying woodcut, figure 23, shows the principal parts of a mammalian brain, as seen from the superior, lateral, and inner surfaces. The Sylvian fissure, SF, is one of the most constant of the sulci found in the hemispheres. Figure 23. Brain of the genet, Genetta tigrina. A. From above, B. From the right side, C. Inner surface of right hemisphere, CC. Corpus callosum, CMS, colloso-marginal sulcus, C. Notch representing central sulcus of other forms, D. Depression on superior lateral gyrus of hemisphere, HG. Hippocampal gyrus, I. Inferior lateral gyrus of hemisphere, M. Middle lateral gyrus of Dew, S. Superior lateral gyrus of Dew. OS. Supraorbital sulcus of Dew, SF. Sylvian fissure of Dew, OL. Olfactory lobes. The deeply convoluted part behind the cerebral hemisphere is the cerebellum, below which lies the medulla oblongata, or commencement of the spinal cord. Mavart, Proc. Zoll. SOC 1882, page 516. The researches of paleontologists, founded upon studies of casts of the interior of the cranial cavity of extinct forms, have shown that, in many natural groups of mammals, if not in all, the brain has increased in size, and also in complexity of surface foldings, with the advance of time, indicating in this, as in so many other respects, a gradual progress from a lower to a higher type of development. Nerves. The 12 pairs of cranial nerves generally recognized in vertebrates are usually all found in mammals, though the olfactory nerves are excessively rudimentary, if not altogether absent, in the toothed whales. The spinal cord, or continuation of the central nervous axis, lies in the canal formed by the neural arches of the vertebrae, and gives off the compound double-rooted nerves of the trunk and the extremities, corresponding in number to the vertebrae, through the interspaces between which they pass out to their destination. The cord is somewhat enlarged at the 2 points where it gives off the great nerves to the anterior and the posterior extremities, which, from their interlacements soon after their origin, are called respectively the brachial and lumbar plexuses. The ganglionic or sympathetic portion of the nervous system is well developed, and presents few modifications. Sense of touch. The sense of touch is situated in the skin generally, but is most acute in certain regions more or less specialized for the purpose by the presence of tactile papillae, such as portions of the face, especially the lips and end of the snout, and the extremities of the limbs when these are used for other purposes than mere progression, and the under surface of the end of the tail in some monkeys. The vibrissae or long stiff bristles situated on the face of many mammals are rendered extremely sensitive to touch by the abundant supply of branches from the fifth nerve to their basal papillae. In bats the extended wing membranes, and probably also the large ears and the folds and prominences of skin about the face of some species, are so sensitive as to receive impressions even from the different degrees of resistance of the air, and so enable the animals to avoid coming in contact with obstacles to their nocturnal flight. Taste and smell. The organs of the other special senses are confined to the head. Taste is situated in the papillae scattered on the dorsal surface of the tongue. The organ of smell is present in all mammals except the toothed whales. It consists of a ramification of the olfactory nerves over a plicated, moist, mucous membrane, supported by folded plates of bone, placed on each side of the septum nasi in the roof, or often in a partially distinct upper chamber, of the nasal passage, so arranged that, of the air passing into the lungs in inspiration, some comes in contact with it, causing the perception of any odorous particles with which it may be charged. Many mammals possess intense powers of smelling certain odors which others are quite unable to appreciate, and the influence which this sense exercises over the well-being of many species is very great, especially in indicating the proximity of others of the same kind, and giving warning of the approach of enemies. The development and modification of the sense of smell is probably associated with that of the odorous secretion of the cutaneous glands. Sight. The organ of sight is quite rudimentary, and even concealed beneath the integument, in some burrowing rodents and insectivores, and is most imperfectly developed in the platanista, or freshwater dolphin of the rivers of India. In all other mammals the eyeball has the structure characteristic of the organ in the higher vertebrata, consisting of parts through which the rays of light are admitted, regulated, and concentrated upon the sensitive expansion of the optic nerve lining the posterior part of the ball. A portion of the fibrovascular and highly pigmented layer, the choroid, which is interposed between the retina and the outer sclerotic coat, is in many mammals modified into a brilliantly colored light-reflecting surface, the tapetum lucidum. There is never a pecten or marsupium like that of the Sauropsida, nor is the sclerotic ever supported by a ring of flattened ossicles, as is so frequently the case in the lower vertebrate classes. The eyeball is moved in various directions by a series of muscles, the 4 straight, 2 oblique, and, except in the higher primates, a posterior retractor muscle called conoid. The superior oblique muscle passes through a tendinous pulley fastened to the roof of the orbit, which is a feature not found beyond the limits of the mammalian class. The eye is protected by the lids, generally distinctly separated into an upper and a lower movable flap, which, when closed, meet over the front of the eye in a more or less nearly horizontal line, but sometimes, as in the Sirenia, the lids are not distinct, and the aperture is circular, closing to a point. In almost all mammals below the primates, except the Cetacea, a nictitating membrane or third eyelid is placed at the inner corner of the eyeball, and works horizontally across the front of the ball within the true lids. Its action is instantaneous, being apparently for the purpose of cleaning the front of the transparent cornea, a function unnecessary in animals whose eyes are habitually bathed in water, and which in man and his nearest allies is performed by winking the true eyelids. Except in Cetacea, the surface of the eye is kept moist by the secretion of the lacrimal gland, placed under the upper lid at its outer side, and the lids are lubricated by the Harterian and Meibournian glands, the former being situated at the inner side of the orbit, and especially related to the nictitating membrane, the latter in the lining membrane of the lids. Hearing. The organ of hearing is enclosed in a bony capsule, periodic, situated in the side of the head, intercalated between the posterior, occipital, and the penultimate, parietal, segment of the skull. It has, in common with other vertebrates, 3 semicircular canals and a vestibule, but the cochlea is more fully developed than in the Sauropsida, and, except in the monotremes, spirally convoluted. The tympanic cavity is often dilated below, forming a smooth rounded prominence on the base of the skull, the auditory bulla, figure 8. The 3 principal ossicles, the malleus, incus, and stapes, are always present, but variable in characters. In the Sirenia, Cetacea, and seals they are massive in form, being in the first named order of larger size than in any other mammals. In the Cetacea the malleus is ankylosed to the tympanic, but in other mammals it is connected only with the membrana tympani. The stapes in the lower orders, edentates, marsupials, and monotremes, has a great tendency to assume the columnar form of the corresponding bone in Sauropsida, its 2 rami entirely or partially coalescing. 16. The tympanic membrane, drum of the ear, forms the outer wall of the cavity. In the fetal state it is level with the external surface of the skull, and remains so permanently in a few mammals as the American monkeys, but commonly, by the growth of the squamosal bone, it becomes deeply buried at the bottom of a bony tube, meatus auditoris externus, which is continued to the surface of the skin in a fibrous or fibrocartilaginous form. In whales, owing to the thickness of the subcutaneous adipose tissue, this meatus is of great length, and is also extremely narrow. In most aquatic and burrowing animals it opens upon the surface by a simple aperture, but in the large majority of the class there is a projecting fold of skin, strengthened by fibrocartilages, called the pinna, auricle, or external ear, of very variable size and shape, generally movably articulated on the skull, and provided with muscles to vary its position, this pinna helping to collect and direct the vibrations of sound into the meatus. 7. Reproductive organs. Testes. In the male the testes retain nearly their primitive or internal position throughout life in the monotremata, Sirenia, Cetacea, most Edentata, Hyracoidea, Proboscidea, and seals, but, in other groups they either periodically, as in Rodentia, Insectivora, and Chiroptera, or permanently pass out of the abdominal cavity through the inguinal canal, forming a projection beneath the skin of the perineum, or becoming suspended in a distinct pouch of integument called the scrotum. All the marsupials have a pedunculated scrotum, the position of which differs from that of other mammals, being in front of, instead of behind, the preputial orifice. As regards the presence, absence, or comparative size and number of the accessory generative glands, prostate, vesicular, and Cooper's glands, as they are called, there is much variation in different groups of mammals. Penis. The penis is almost always completely developed, consisting of two corpora cavernosa attached to the ischial bones, and of a median corpus spongiosum enclosing the urethra, and forming the glands at the distal portion of the organ. In marsupials, monotremes, and the sloths and anteaters, the corpora cavernosa are not attached directly to the ischia, and in the last named the penis is otherwise of a very rudimentary character, the corpus spongiosum not being present. In many marsupials the glans penis is bifurcated. In most primates, carnivora, rodentia, insectivora, and chiroptera, but in no other orders, an os penis is present. Ovaries and oviduct. In the female, the ovaries permanently retain their original abdominal position, or only descend a short distance into the pelvis. They are of comparatively smaller size than in other vertebrates, have a definite flattened oval form, and are enclosed in a more or less firm tunica albuginea. The oviduct has a trumpet-like, and usually fimbriated abdominal aperture, and is more or less differentiated into three portions: 1. A contracted upper part, called in man and the higher mammals the fallopian tube; 2. An expanded part with muscular walls, in which the ovum undergoes the changes by which it is developed into the fetus, called the uterus; 3. A canal, the vagina, separated from the last by a valvular aperture, and terminating in the urinogenital canal, or common urinal and genital passage, which in higher mammals is so short as scarcely to be distinct from the vagina. The complete distinction of the oviducts of the two sides throughout their whole length, found in all lower vertebrates, only occurs in this class in monotremes, a prevailing mammalian characteristic being their more or less perfect coalescence in the middle line to form a single median canal. In the marsupials this union only includes the lower part of the vagina, but in most placentals it extends to the whole vagina and a certain portion of the uterus, which cavity is then described as bicornuate. In the higher mammals, as in man, and also in some of the edentates, the whole of the uterus is single, the contracted upper portion of the oviducts or fallopian tubes, as they are then called, entering its upper lateral angles by small apertures. In certain lower forms the urinogenital canal opens with the termination of the rectum into a common cloaca, as in other vertebrates, but it is characteristic of the majority of the class that the two orifices are more or less distinct externally. Mammary glands. Mammary glands secreting the milk by which the young are nourished during the first portion of their existence after birth, are present in both sexes in all mammals, though usually only functional in the female. In the monotremes alone their orifices are mere scattered pores in the skin, but in all other forms they are situated upon the end of conical elevations, called mammae, or teats, which, taken into the mouth of the young animal, facilitate the process of sucking. These are always placed in pairs upon some part of the ventral surface of the body, but vary greatly in number and position in different groups. In the cetacea, where the prolonged action of sucking would be incompatible with their subaqueous life, the ducts of the glands are dilated into large reservoirs from which the contents are injected into the mouth of the young animal by the action of a compressor muscle. Secondary sexual characters. Secondary sexual characters, or modifications of structure peculiar to one sex, but not directly related to the reproductive function, are very general in mammals. They almost always consist of the acquisition or perfection of some character by the male as it attains maturity, which is not found in the female or the young in either sex. In a large number of cases these clearly relate to the combats in which the males of many species engage for the possession of the females during the breeding season, others are apparently ornamental, and of many it is still difficult to apprehend the meaning. Many suggestions on this subject will, however, be found in the chapters devoted to it in Darwin's work on the descent of man and selection in relation to sex, where most of the best-known instances are collected. Superiority of size and strength in the male of many species is a well-marked secondary sexual character related to the purpose indicated above, being probably perpetuated by the survivors or victors in combats transmitting to their descendants those qualities which gave them advantages over others of their kind. To the same category belong the great development of the canine teeth of the males of many species which do not use these organs in procuring their food, as the apes, swine, musk and some other deer, the tusk of the male narwhal, the antlers of deer, which are present in most cases only in the males, and the usual superiority in size and strength of the horns of the bovidae. Other secondary sexual characters, the use of which is not so obvious, or which may only relate to ornament, are the presence of masses or tufts of long hair on different parts of the body, as the mane of the male lion and bison, the beards of some ruminants and bats, as Taphazos melanopagon, monkeys, and of man, and all the variations of coloration in the sexes, in which, as a general rule, the adult male is darker and more vividly colored than the female. Here may also be mentioned the presence or the greater development of odoriferous glands in the male, as in the musk deer, and the remarkable perforated spur with its glands and duct, so like the poison tooth of the venomous serpents, found in the males of both Ornithorhynchus and Echidna, the use of which is at present unknown. Placenta. The development of the mammalian ovum, and the changes which the various tissues and organs of the body undergo in the process of growth, are too intricate subjects to be explained without entering into details incompatible with the limits of this work, especially as they scarcely differ, excepting in their later stages, from those of other vertebrates, upon which, owing to the greater facilities these present for examination and study, the subject has been more fully worked out. There are, however, some points which require notice, as peculiar to the mammalian class, and as affording at least some hints upon the difficult subject of the affinities and classification of the members of the group. The nourishment of the fetus during intrauterine life takes place through the medium of certain structures, partly belonging to the fetus itself and partly belonging to the inner parietes of the uterus of the parent. These in their complete form constitute the complex organ called the placenta, serving as the medium of communication between the mother and fetus, and in which the physiological processes that are concerned in the nutrition of the latter take place, but as we shall see, though a placenta, in the usual acceptation of the term, is peculiar to the mammalian class, it is not in all of its members that one is developed. The structures to which we shall have especially to refer are the outer tunic of the ovum, to which, however formed, the term chorion is commonly applied, and two sac-like organs connected with the body cavity of the embryo, both formed from the splanchnic mesoblast, lined by a layer of the hypoblast. These are the umbilical vesicle or yolk sac and the allantois. The umbilical vesicle is a thin membrane enclosing the yolk, which by the doubling in of the ventral walls of the embryo becomes gradually formed into a distinct sac external to the body, with a pedicle, the omphalloenteric duct, by which for a time a communication is maintained between its cavity and the intestinal canal. In the walls of this sac blood vessels, omphallomesoreic or vitelline, are developed in connection with the vascular system of the embryo, through which, either by their contact with the outer surface of the walls of the ovum, or by the absorption through them of the contents of the yolk sac, the nutrition of the embryo in the lower vertebrates chiefly takes place. In mammals, the umbilical vesicle plays a comparatively subordinate part in the nourishment of the fetus, its function being generally superseded by the allantois. The last-named sac commences at a very early period as a diverticulum from the hinder end of the alimentary tract of the embryo. Its proximal portion afterwards becomes the urinary bladder, the contracted part between this and the cavity of the allantois proper constituting the uricus, which passes out of the body of the fetus at the umbilicus together with the vitelline duct. The mesoblastic tissue of the walls of the allantois soon becomes vascular, its arteries are supplied with fetal blood by the two hypogastric branches of the iliacs, or main divisions of the abdominal aorta, and the blood is returned by venous trunks uniting to form the single umbilical vein which runs to the under surface of the liver, where, part of it joining the portal vein and part entering the vena cava directly, it is brought to the heart. These are the vessels which, with their surrounding membranes, constitute the umbilical cord, the medium of communication between the fetus and the placenta, when that organ is fully developed. The egg membranes of the monotremes present many points of agreement with those of the ovum of the marsupials, 17, and differ from those of the placental types. Thus monotremes and marsupials agree in having a vitelline membrane, which appears between the young ovum and the follicular epithelium, persisting in the one case until the time of hatching, and in the other till a late uterine stage. There are also several other common features fully described in Mr. Caldwell's memoir, but which cannot be detailed in this work. In the Marsupialia, the observations made many years ago by Sir R. Owen upon the development of the kangaroo have been confirmed by those of Dr. H. C. Chapman, 18, while Dr. Salenka, 19, and Professor H. F. Osborne, 20, have contributed important evidence as to the structure and relations of the fetal membranes of the possums and others. It thus appears that up to the period of the very premature birth of these animals the outer covering of the ovum, or false chorion, is free from persistent villi, and not adherent to the epithelium of the uterine walls, for, although fitting into the folds of the latter, it is perfectly and readily separable in its entire extent from them. The umbilical vesicle or yolk sac is large, vascular, and adherent to a considerable portion of the false chorion or subzonal membrane, while the allantois is relatively small, and although the usual blood vessels can be traced into it, it does not appear to contract any connection with the false chorion, and, therefore, much less with the walls of the uterus, of such a nature as to constitute a placenta. In some forms, however, such as the possums, the umbilical vesicle or yolk sac develops temporary villi, which unite with the subzonal membrane, or false chorion, to form a disc-like area closely attached to the cells covering the utricular glands of the uterine epithelium, and thus forming a so-called yolk sac placenta. The function of this organ is considered to be the transmission of the secretions of the utricular glands to the embryo by means of the umbilical vesicle, the function of the allantois being either respiratory or the absorption of the fluid secreted in the uterine cavity by the utricular glands. While in the uterus the nourishment of the fetus seems, therefore, to be derived from the umbilical vesicle, as in reptiles and birds, rather than from the uterine walls by means of the allantoic vessels, as in the higher mammals. The latter vessels, in fact, play even a much less important part in the development of these animals, not only than in the placental mammals, but even than in the Sauropsida, for they can scarcely have the respiratory function assigned to them in that group, pulmonary respiration and the lacteal secretion of the mother very early superseding all other methods of providing the due supply, both of oxygen and of food required for the development and growth of the young animal. In this sense the marsupials may be looked upon as the most typically mammalian of the whole class. In no other group do the milk-secreting glands play such an important part in providing for the continuity of the race. In the third primary division of the mammalia, the so-called placentalia, the umbilical vesicle generally does not quite unite with the chorion, and disappears as development proceeds, so that no trace of it can be seen in the membranes of an advanced embryo, but it may persist until the end of the intrauterine life as a distinct sac in the umbilical cord, or lying between the allantois and amnion. The disappearance or persistence of the umbilical vesicle does not, according to our present knowledge, appear to be correlated with a higher or lower general grade of development, as might be presupposed. It is stated to have been found in man even up to the end of intrauterine life, and also in the carnivora, while in the ungulata and cetacea it disappears at an earlier age. In many, if not all, of the rodentia, insectivora, and chiroptera, it plays a more important part, becoming adherent to a considerable part of the inner surface of the chorion, to which it conveys blood vessels, although villi do not appear to be developed from the surface of this part, as they are on the portion of the chorion supplied by the allantoic vessels. These orders thus present to a certain extent a transitional condition from the marsupials, although essentially different, in possessing the structures next to be described. The special characteristic of the whole of the placental mammals constituting the majority of the class, is that the allantois and its vessels become intimately blended with a smaller or greater part of the parietes of the ovum, forming a structure on the outer surface of which villi are developed, and which, penetrating into corresponding cavities of the decidua, or soft, vascular, hypertrophied lining membrane of the uterus, constitutes the placenta. This organ may be regarded, as Sir William Turner says, both in its function and in the relative arrangement of its constituent textures, as a specially modified secreting gland, the ducts of which are represented by the extremities of the blood vessels of the fetal system. The passage of material from the maternal to the fetal system of vessels is not a simple percolation or diffusion through their walls, but is occasioned by the action of a layer of cells derived from the maternal or uterine structures, and interposed between the blood vessels of the maternal part of the placenta and those of the villi covering the chorion, in which the embryonic vessels ramify. The numerous modifications in the details of the structure of this organ relate to augmenting the absorbing capacity of the vessels of the chorion, and are brought about either by increasing the complexity of the fetal villi and maternal crypts over a limited area, or by increasing the area of the part of the chorion covered by the placental villi, or by various combinations of the two methods. The first class of variations has given rise to a distinction into two principal kinds of placenta: 1. Simple or non-deciduate, and 2. Deciduate. In the former, the fetal villi are received into corresponding depressions of the maternal surface, from which at the period of parturition they are simply withdrawn. In the second, or more complex form, the relation is more intimate, a layer of greater or less thickness of the lining membrane of the uterus, called decidua, becoming so intimately blended with the chorion as to form part of the placenta proper, or that structure which is cast off as a solid body at parturition. In other words, in the one case the line of separation between the placenta and uterus at birth takes place at the junction of the fetal and maternal structures, in the other through the latter, so that a portion of them, often of considerable thickness, and containing highly organized structures, is cast off with the former. It was once thought that the distinction between these two forms of placentation is so important as to constitute a sufficiently valid basis for a primary division of the placental mammals into two groups. It has, however, been shown that the distinction is one rather of degree than of kind, as intermediate conditions may exist, and it is probable that in different primary groups the simpler, non-deciduate form may have become developed independently into one or other of the more complex kinds. Apart from its intimate structure, the placenta may be met with a very general form. It may consist of villi scattered more or less regularly over the greater part of the surface of the chorion, the two extremities or poles being usually more or less bare. This form is called the diffused placenta. It is probably a primitive condition, from which most of the others are derived, although its existence must presuppose the absence of the umbilical vesicle as a constituent of the chorionic wall. It is found at present in the manus among edentates, the cetacea, the perissodactyle ungulates, and the camels, pigs, and chevrotains among the artiodactyls. Such placentae are always non-deciduate. Recent observations by Sir W. Turner on the placentation of the dugong show that the Sirenia present the peculiarity of having a zonary placenta, which is either entirely or in great part non-deciduate, and is, therefore, transitional between the diffused and the true zonary type. In the true ruminants or pecora, among the artiodactyl ungulates, the villi are aggregated in masses called cotyledons, with bare spaces between. Such a placentation is called polycotyledonary. In another modification, the villi are collected in a more or less broad band encircling the chorion, leaving a very large portion of the two poles bare, constituting the zonary placenta, characteristic of the carnivora, and also occurring in the elephant, hyrax, and Oricterapus. The fact of the form of the placenta of these three last-named animals agreeing together, and with that of the carnivora, does not, however, necessitate the ascription of zoological affinities, as the same ultimate form may have been attained by different processes of development. In another form, one pole only of the chorion is non-vascular, the placenta assuming a dome or bell shape, as in the lemurs and the sloths. The transition from this, by the gradual restriction of the vascular area, is easy to the oval or discoidal form of placenta of the anteaters, armadillos, and higher primates. The discoidal placenta of the rodents, insectivores, and chiroptera, though showing so much superficial resemblance to that of the last-named order as to have led to the inclusion of all these forms in one primary group, is now known to be developed in another manner, not by the concentration of villi from a diffused to a limited area, but by retaining the area to which it was originally restricted in consequence of the large surface of the chorion occupied, as before mentioned, by the umbilical vesicle. To compensate for the smallness of area, the complex or deciduate structure has been developed. Among some rodents there is evidence to show that the discoidal placenta has been derived from a zonary one, of which distinct vestiges have been detected in the mouse. We may conclude that, although the characters and arrangement of the fetal structures may not have that extreme importance which has been attributed to them by some zoologists, they will form, especially when more completely understood, valuable aids in the study of the natural affinities and evolution of the Mammalia. 21. Chapter 3: Origin and Classification of the Mammalia. Origin. Although, as stated in the first chapter, the mammalian class, as at present known either by existing or extinct forms, is completely isolated from all other groups of the animal kingdom, yet it is impossible to refrain from speculating as to its origin and nearest affinities. In arranging the classes of vertebrates in a linear series, it is customary to place them in the following order: Pisces, Amphibia, Reptilia, Aves, Mammalia, an order which probably indicates the relative degree of elevation to which the most highly developed members of each class has attained. Such an arrangement appears to express the true relationship of the first four classes to one another, but it is quite clear that the Mammalia have no sort of affinity with the Aves. Writing in 1879, Professor Huxley, 22, came to the conclusion that, in looking among vertebrates for the progenitors of the Mammalia, we must pass over all known forms of birds and reptiles, and go straight down to the Amphibia. In addition to the characters derived from the conformation of the pelvis upon which the argument was primarily based, the following reasons were given for this conclusion. The Amphibia are the only air-breathing vertebrata which, like mammals, have a dicondylian skull. It is only in them that the articular element of the mandibular arch remains cartilaginous, while the quadrate ossification is small, and the squamosal extends down over it to the osseous elements of the mandible, thus affording an easy transition to the mammalian condition of those parts. The pectoral arch, girdle, of the monotremes is as much amphibian as it is sauropsidian. The carpus and the tarsus of all sauropsida, except the chelonia, are modified away from the urodele type, while those of the mammal are directly reducible to it. Finally, the fact that in all sauropsida it is a right aortic arch which is the main conduit of arterial blood leaving the heart, while in mammals it is a left aortic arch which performs this office, is a great stumbling block in the way of the derivation of the Mammalia from any of the sauropsida. But, if we suppose the earliest forms of both the Mammalia and the Sauropsida to have had a common amphibian origin, there is no difficulty in the supposition that, from the first, it was a left aortic arch in the one series, and the corresponding right aortic arch in the other, which became the predominant feeder of the arterial system. Subsequently, Professor E. D. Cope, 23, in a suggestive paper called attention to the remarkable resemblances to the monotremes presented by the skeleton of that group of early secondary reptiles which he then designated the Theromorpha, but which may be included in the Animodontia of Sir R. Owen, and came to the conclusion that in that group we have the true ancestors of the Mammalia. This conclusion was, however, disputed by Dr. Bauer, 24, who considered that the Animodontia were too specialized to have been the actual progenitors of the Mammalia, and that they should rather be regarded as a divergent branch of the stem which had given origin to the Mammalia. Since that date, observations made on the structure of the South African anomodonts have shown such an intimate connection between that group and the labyrinthodont amphibians, that there can be no hesitation in regarding the one as the direct descendant of the other, and we may probably regard the Mammalia as having originated from the same ancestral stock at the time the amphibian type was passing into the reptilian. From this point of view, some of the mammalian features found in the more specialized anomodonts may probably be regarded as having been acquired during a parallel line of development. Both the Animodontia and the Mammalia differ from the amphibians in the loss of the splint-like parasphenoid which underlies the basisphenoid axis of the skull, and by the ossification of that axis, but while the former have become monocondylic by the participation of the basioccipital in the support of the cranium, the latter retain the amphibian dicondylic plan. The skull of the anomodonts presents mammalian resemblances not found in any other reptiles, this being especially noticeable in the region of the squamosal, and it is only in this group in mammals that the temporal or zygomatic arch is a squamosomaxillary one, see page 37. The resemblance between the pectoral and pelvic girdles of the anomodonts and those of the monotreme mammals is noticed under the head of the latter, where reference is also made to the similarity in the structure of the humerus in the two groups. The PES of the Amphibia and Animodontia agree in having a distinct intermedium, tibial, fibulare, and central, whereas in other reptiles these bones are not generally distinct. In mammals the intermedium, fibulare, and central are distinct, and according to Cope's interpretation there may be a distinct tibial. Classification. In the present condition of the world, mammals have become so broken up into distinct groups by the extinction of intermediate forms, that a systematic classification is perfectly practicable. Most of the associations of species, which we call orders, and even the suborders and families, are natural groups. In isolating, defining, and naming them, we are really dealing with facts of nature of a totally different order from the artificial and fanciful divisions formed in the infancy of zoological science. When, however, we pass to the extinct world, all is changed. In many cases the boundaries of our groups become enlarged until they touch those of others. New forms are discovered which cannot be placed within any of the existing divisions. As the horizon of our vision is thus expanded, the principles upon which a scheme of classification is constructed must be altogether changed. Our present divisions and terminology are no longer sufficient for the purpose, and some other method will have to be invented to show the complex relationships existing between different animal forms when viewed as a whole. The present time, preeminently distinguished by the rapidly changing and advancing knowledge of extinct forms, is scarcely one in which this can be done with any satisfactory result, so that all attempts to form a classification embracing even the already known extinct species must be only of a provisional and temporary nature. In systematic descriptions in books, in lists, and catalogues, and in arranging collections, the objects dealt with must be placed in a single linear series. But by no means whatever can such a series be made to coincide with natural affinities. The artificial character of such an arrangement, the constant violation of all true relationships, are the more painfully evident the greater the knowledge of the real structure and affinities. But the necessity is obvious, and all that can be done is to make such an arrangement as little as possible discordant with facts. The following table contains a list of the orders, suborders, and families of existing mammals as recognized by the authors, and placed in the order in which they will be treated of in this work. The more important of the groups containing only extinct forms are added in a different type, being interpolated, as near as may be, among those that appear to be their existing relatives. A few explanatory remarks upon the mutual relations of some of the principal groups mentioned in the table may be useful here, but the subject will be more fully developed in treating separately of each division. One of the most certain and fundamental points in the classification of the Mammalia is that all the animals now composing the class can be grouped primarily into three natural divisions, which, presenting very marked differential characters, and having no existing, or yet certainly demonstrated extinct, intermediate, or transitional forms, may be considered as subclasses of equal value, taxonomically speaking, though very different in the numbers and importance of the animals at present composing them. These three groups are often called by the names originally proposed for them by Blainville: 1. Ornithodelphia, 2. Didelphia, 3. Monodelphia, the first being equivalent to the order Monotremata, the second to the Marsupialia, and the third including all the remaining members of the class. Although actual paleontological proof is wanting, there is much reason to believe that each of these, as now existing, are survivors of distinct branches to which the earliest forms of mammals have successively given rise, and for which hypothetical branches Professor Huxley has proposed the names of Prototheria, Metatheria, and Eutheria, names which, being far less open to objection than those of Blainville, are here used as equivalents of the latter. The only known existing Prototheria, although agreeing in many important characters, evidently represent two very divergent stocks, perhaps as far removed as are the members of some of the accepted orders of the Eutheria. It would, however, be merely encumbering zoological science with new names to give them any other than the ordinarily known family designations of Ornithorhynchidae and Echidnae. Similarly with regard to the Metatheria, although the great diversity in external form, in anatomical characters, and in mode of life of the various animals of this section might lead to their division into groups equivalent to the orders of the Eutheria, we do not think it advisable to depart from the usual custom of treating them all as forming one order, called Marsupialia, the limits of which are equivalent to those of the subclass. The characters of the 6 families which compose the group are extremely well marked and easily defined, and since they form a regular gradation between two extreme types, they can be satisfactorily arranged in a serial order. A marked distinction in the dentition enables us to divide them into primary groups or suborders. The remaining mammals are included in the Eutheria, Placentalia, or Monodelphia. Their affinities with one another are so complex that it is impossible to arrange them serially with any regard to natural affinities. Indeed, each order is now so isolated that it is almost impossible to say what its affinities are, and none of the hitherto proposed associations of the orders into larger groups stand the test of critical investigation. All serial arrangements of the orders are therefore perfectly arbitrary, and although it would be a very great convenience for reference in books and museums if some general sequence, such as that here proposed, were generally adopted, such a result can scarcely be expected, since equally good reasons might be given for almost any other combination of the various elements of which the series is composed. In fact, we have already seen reason to depart in some respects from that used in the encyclopedia. The Edentata, Sirenia, and Cetacea stand apart from all the rest in the fact that their dentition does not conform to the general heterodont, diffeodont type to which that of all other Eutheria can be reduced, and which is such a close bond of union between them. In all three orders, however, some indications may be traced of relationship, however distant, with the general type. With regard to the Edentata, reasons will be given for believing that both the sloths and anteaters are nearly related, and that the armadillos, though much modified, belong to the same stock, but that the pangolins and the aardvarks represent very isolated forms. There is no difficulty about the limits of the order Sirenia, comprising aquatic, vegetable-eating animals, with complete absence of hind limbs, and low cerebral organization, represented in our present state of knowledge only by two existing genera, Halicore and Monatus, and a few extinct forms, which, though approaching a more generalized mammalian type, show no special characters allying them to any of the other orders. The few facts as yet collected relating to the former history of the Sirenia leave us as much in the dark as to the origin and affinities of this peculiar group of animals as we were when we only knew the living members. They lend no countenance to their association with the Cetacea, and, on the other hand, their supposed affinity with the Ungulata receives no very material support from them. Another equally well-marked and equally isolated, though far more numerously represented and diversified order, is that of the Cetacea, placed simply for convenience next to the Sirenia, with which, except in their fish-like adaptation to aquatic life, they have little in common. The old association of these orders in one group can only be maintained either in ignorance of their structure or in an avowedly artificial system. Among the existing members of the order, there are two very distinct types, the toothed whales or Odontoceti, and the baleen whales or Mysticoceti, which present as many marked distinguishing structural characters as are found between many other divisions of the Mammalia usually reckoned as orders. Since the extinct Zeuglodonts, so far as their characters are known, do not fall into either of these groups, but are in some respects annectant forms, we have placed them provisionally, at least, in a third group by themselves, named Archaeoceti. There is nothing known at present to connect the Cetacea with any other order of mammals, but it is quite as likely that they are offsets of a primitive ungulate as of a carnivorous type, or perhaps of a still more generalized mammalian stock. The remaining Eutherian mammals are clearly united by the characters of their teeth, being all heterodont and diffeodont, with their dental system reducible to a common formula. Although older views of the relationship of ungulate mammals expressed by the terms pachydermata, ruminantia, and so forth, still linger in some corners of zoological literature, no single point in zoological classification can be considered so firmly established as the distinction between the perissodactyle and artiodactyl ungulates, both being in the existing fauna of the world perfectly natural and distinctly circumscribed groups. The breaking up of the latter into four equivalent sections, the Pecora, Tylopoda, Trigulina, and Suena, is equally in accordance with all known facts. Less certain, however, is the association of the Proboscidea and the Hyracoidea with the true ungulates. By many zoologists they are each, although containing so very few existing species, made into distinct orders, and much is to be said in favor of this view. The discovery, however, of a vast number of extinct species of ungulates which cannot be brought under the definition of either Perissodactyla or Artiodactyla, and yet are evidently allied to both, and to a certain extent bridge over the interval between them and the isolated groups just mentioned, make it necessary either to introduce a number of new and ill-defined ordinal divisions, or so to widen the scope of the original order as to embrace them all, considering the elephants and the high races as representing suborders equivalent to the great perissodactyle and artiodactyl groups. It is the latter alternative that we have adopted. The Rodentia, although generally presenting a low grade of development, are a very specialized and distinct group. The position here assigned to them would accord with apparent relationships with the ungulates, through the elephant on the one hand and the extinct Typotherium on the other. In the present state of the fauna of the Earth, the carnivora form a very distinct order, though naturally subdivided into two groups, the members of the one being more typical, while those of the other, the Pinnipedia, are aberrant, having the whole of their organization specially modified for living habitually in the water. The insectivora comprise various lowly organized and generalized forms, exhibiting considerable divergence of character, and apparently connected through transitional extinct species with the carnivora. As no other order can claim the family Galeopithecidae, it is placed here, but rather for convenience than for any other consideration, since it has but little if any relationship with any of the other members. Its isolated position is indicated by assigning it a distinct subordinal rank. The Chiroptera have always been placed near the Insectivora, but they are really a highly specialized group, as much isolated from all other mammals by the modification of their anterior limbs in adaptation to aerial locomotion, as the Cetacea and the Sirenia, by the absence of hind limbs, are specially adapted for an aquatic life. Lastly, the primates, which in any natural system must be placed at the head of the series, are divisible into two very distinct groups, one containing the various forms of lemurs, Lemuroidea, and the other the monkeys and man, Anthropoidea. Whether the Lemuroidea should form part of the primates, according to the traditional view, or a distinct order altogether removed from it, is as yet an undetermined question, for both sides of which there is much to be said. There can, however, be no doubt that the Anthropoidea form a perfectly natural group, presenting a series of tolerably regular gradations from the marmosets, Hapale, to man. Certain breaks in the series, however, enable us to divide it into 5 distinct families: Hapalidae or marmosets, Cebidae or American monkeys, with 3 premolar teeth on each side of each jaw, Cercopithecidae, containing the majority of Old World monkeys, Simiidae, consisting of the genera Hylobates, Simia, Gorilla, and Anthropopithecus, the true man-like apes, and, lastly, Hominidae, containing the genus Homo alone. Subclass I. Prototheria. Order I. Monotremata, monotremes. Fam. 1. Ornithorhynchidae, duckbill. 2. Echidnidae, spiny anteater. Group. Multituberculata, 25, Fam. 1. Plagiaulacidae, Plagiaulax. 2. Polymastodontidae, Polymastodon. 3. Tritylodontidae, Tritylodon. Subclass 2. Metatheria. Order 2. Marsupialia, marsupials. Suborder 1. Polyprotodontia, polyprotodonts. Fam. 1. Dromaeotheridae, Dromaeotherium. 2. Amphitheoridae, Amphitherium, etc. 3. Spalacotheridae, Spalacotherium. 4. Tritylodontidae, Tritylodon. 5. Didelphidae, possums. 6. Dasyuridae, thylacine and dasyurs. 7. Paramelidae, bandicoots. Suborder 2. Diprotodontia, diprotodonts. Fam. 8. Phascolomyidae, wombats. 9. Phalangeridae, phalangers. 10. Diprotodontidae, diprotodon. 11. Nototheridae, notothere. 12. Macropodidae, kangaroos. Subclass 3. Eutheria. Order 3. Edentata, edentates. Fam. 1. Bradipodidae, sloths. 2. Megatheridae, ground sloths. 3. Myrmecophagidae, anteaters. 4. Dasypodidae, armadillos. 5. Glyptodontidae, glyptodonts. 6. Manidae, pangolins. 7. Orctopodidae, aardvarks. Order 4. Sirenia, sirenians. Fam. 1. Manatidae, manatees. 2. Rhytinidae, rhytina. 3. Halichoridae, dugongs. 4. Halotheridae, halothere. Order versus Cetacea, cetaceans. Suborder 1. Mysticosidae, baleen whales. Fam. 1. Balenidae, Greenland whale, etc. Suborder 2. Archaeocidae. Fam. 2. Zeuglodontidae, zeuglodonts. Suborder 3. Odontocidae, toothed whales. Fam. 3. Physeteridae, sperm whale. 4. Platanistidae, freshwater dolphins. 5. Delphinidae, dolphins, porpoises, etc. Order 6. Ungulata, hoofed mammals. Suborder 1. Artiodactyla, artiodactyls. Section A. Suina, pig-like artiodactyls. Fam. 1. Hippopotamidae, hippopotamus. 2. Suidae, pigs and peccaries. Annectant types. 3. Choeropotamidae, choeropotamus. 4. Anthracotheriidae, anthracothere. 5. Mericopotamidae, mericopotamus. 6. Caudilopidae, oreodonts. 7. Anoplotheridae, anoplothere. 8. Dichodontidae, dicodon. Section B. Tragulina, chevrotains. 9. Tragulidae, chevrotains. Section C. Tylopoda, camels. 10. Camelidae, camels and llamas. 11. Poabrotheridae, Poabrotherium. Section D. Pecora, true ruminants. 12. Cervidae, deer. 13. Giraffidae, giraffe. 14. Antilocapridae, prongbuck. 15. Bovidae, sheep, cattle, etc. Suborder 2. Perissodactyla, perissodactyls. Fam. 16. Tapiridae, tapirs. 17. Lophiodontidae, lophiodonts. 18. Paleotheridae, paleotheres. 19. Equidae, horses. 20. Rhinocerotidae, rhinoceroses. 21. Lambdotheridiidae, paleocyaps. 22. Calicotheridae, calicothere. 23. Titanotheridae, titanothere. 24. Macroceniidae, macrocenia. Suborder 3. Toxodontia, toxodonts. Fam. 25. Toxodontidae, toxodon. 26. Typotheridae, typothere. Suborder 4. Condylarthra. Fam. 27. Paraptychidae, Pariptychus. 28. Phenacodontidae, Phenacodus. 29. Meniscotheridae, Meniscothere. Suborder 5. Hyracoidea, hyraces. Fam. 30. Hyracidae, hyrax. Suborder 6. Amblypoda. Fam. 31. Pantolambdidae, pantolambda. 32. Corphodontidae, coryphodon. 33. Uintotheridae, uintothere. Suborder 7. Proboscidea, proboscideans. Fam. 34. Dinotheridea, dinothere. 35. Elephantidae, elephants. Group. Tilodontia, tilodonts. Fam. Anchipodontidae, Ancipodus. Calamodontidae, calamodon. Order 7. Rodentia, rodents. Suborder 1. Simplicidentata. Fam. 1. Anomaluridae, Anomalurus. 2. Sciuridae, squirrels and marmots. 3. Haplodontidae, Haplodon. 4. Ischiromyidae, Ischiromys. 5. Castoridae, beavers. 6. Myoxidae, dormice. 7. Lophiomyidae, Lophiomys. 8. Muridae, rats, mice, and voles. 9. Spalacidae, mole rats. 10. Geomyidae, pouched rats. 11. Dipotidae, jerboas. 12. Theridomyidae, theridomys. 13. Octodontidae, spiny mice. 14. Castoroididae, castoroids. 15. Hystricidae, porcupines. 16. Chinchillidae, chinchillas. 17. Dinomyidae, dinomys. 18. Cavidae, cavies. 19. Dasyproctidae, agudas. Suborder 2. Duplicidentata. Fam. 20. Lagomyidae, picas. 21. Leporidae, hares and rabbits. Order 8. Carnivora, carnivores. Suborder 1. Carnivora vera, Fisipedes. Fam. 1. Felidae, cats. 2. Hyenidae, hyenas. 3. Protoliidae, earthwolf. 4. Viveridae, civets and ichneumons. 5. Canidae, wolves and foxes. 6. Ursidae, bears. 7. Mustelidae, weasels and otters. 8. Procyonidae, raccoons and cat bear. Suborder 2. Pinnipedia, pinnipedes. Fam. 9. Otaridae, eared seals. 10. Trichechidae, walrus. 11. Phocidae, seals. Suborder 3. Creodonta, creodonts. Fam. 12. Hyenodontidae, hyenodon. 13. Provivoridae, provivora. 14. Arctocyonidae, arctocyon. 15. Mesonychidae, mesonyx. Order 9. Insectivora, insectivores. Suborder 1. Insectivora vera. Fam. 1. Tupaidae, tupaeas. 2. Macrocelididae, elephant shrews. 3. Aranaceidae, hedgehogs. 4. Cericidae, shrews. 5. Talpidae, moles. 6. Potamegalidae, potamegale. 7. Solenodontidae, solenodon. 8. Centetidae, centetes. 9. Chrysochloриdae, golden moles. Suborder 2. Dermoptera. Fam. 10. Galeopithecidae, Galeopithecus. Order X. Chiroptera, bats. Suborder 1. Megachiroptera, frugivorous bats. Fam. 1. Pteropodidae, flying foxes. Suborder 2. Microchiroptera, insectivorous bats. Fam. 2. Vespertilionidae, common bats. 3. Nycteridae, nycterus. 4. Rhinolophidae, leaf-nosed bats. 5. Emballonuridae, emballonura. 6. Philostomatidae, vampires. Order 11. Primates. Suborder 1. Lemuroidea, lemuroids. Fam. 1. Hyopsodontidae, hyopsodus. 2. Chiromyidae, IA. 3. Tarsidae, tarsia. 4. Lemuridae, lemurs. Suborder 2. Anthropoidea, anthropoids. Fam. 5. Hapalidae, marmosets. 6. Cebidae, American monkeys. 7. Cercopithecidae, Old World monkeys. 8. Simiidae, gibbons and man-like apes. 9. Hominidae, man. The distinctive character of these subclasses and orders, with an account of their subdivisions and the principal forms contained in each, will be given in subsequent chapters. Chapter 4 Geographical and Geological Distribution. Geographical Distribution. 26. In considering the present distribution of mammals over the globe, we may, in the first place, direct our attention to terrestrial or land types, reserving the consideration of aerial types, like the bats, and aquatic forms, as exemplified by the cetaceans, sirenians, and seals, to separate sections. Among terrestrial forms, each species has a certain definite area of distribution in space, which may be of very wide extent, or may be confined to a restricted region. This distributional area is, however, always connected, or continuous, that is to say, that although we may have a single species inhabiting two continents, like the lion in Asia and Africa, or dwelling both on a continent and adjacent continental islands, like the Javan rhinoceros of India, Java, and Borneo, yet we shall always find that such areas, if not still connected, show evident signs of having been so connected in comparatively late geological epochs, and we never find instances of the same species inhabiting totally disconnected areas, such as India and South America. As examples of mammals with a wide distribution, we may mention the lion and the leopard, which are now found throughout Africa, and also occur in India, as well as in the intervening areas of Arabia and Persia. In the case of the former species, paleontology further teaches us that its distribution in the last geological epoch was even more extensive, since we have good evidence to show that it formerly ranged over the greater part of Europe, including the British Isles. The jackal affords another well-known instance of a species common to India and Africa. The American puma, again, may be cited as an example of a mammal having a very wide range in latitude, since it is found from Patagonia in the south to Canada in the north. As instances of wide range in the opposite direction, we have only to mention the reindeer and the elk or moose, found in the northern regions of both the Old and New Worlds, which are only separated from one another by the narrow channel of Bering Strait. Of mammals with extremely restricted distributional areas, we may mention many of the insectivora, such as the desman of the Pyrenees, and some of the Madagascar types of this order, the lemurs from the same island, some of the species of marmots, the remarkable bear-like Eleuropus of eastern Tibet, one species of zebra, and other ungulates from Africa. The distribution of a genus, except of course when the genus is represented only by a single form, is very generally more extensive than that of a species, and this may be markedly the case when there are only some 2 or 3 species in a genus. In genera, moreover, we meet with what is known as discontinuous distribution, that is, where the distributional area of one or more species is totally separated from that of others. The best instance of this occurs in the case of the tapirs, where we find one species inhabiting the Malayan Peninsula, and no others anywhere in the world, with the exception of South America. The explanation of such an apparently anomalous feature in distribution is to be found in the past history of the globe, which shows us that tapirs once existed in China, Europe, and North America, and, therefore, indicates that the existing isolated species are the sole survivors of a group once spread over a large portion of the Earth's surface. In regard to generic distribution, it must, however, be mentioned that this depends to a great extent on the limits which we are disposed to assign to genera themselves. As the distributional area of a genus generally exceeds that of a species, so that of a family, or group of genera, is larger than that of a single genus, and similarly the distribution of an order, or assemblage of families, usually occupies a larger area than that of a single family. Thus, for instance, the genus Thylacynus, represented only by the so-called Tasmanian wolf or thylacine, is now entirely restricted to Tasmania, but the family Dasyuridae, to which that genus belongs, ranges all over Australia, while the order Marsupialia, which includes the Dasyuridae, is found both in Australia and America, and in past epochs was probably spread over the entire globe. A remarkable feature in connection with the distribution of the terrestrial mammalia is the circumstance that, with the exception of certain species introduced by human agency, and small forms which can easily have been transported on floating timber or other similar means, they are totally absent from what are known as oceanic islands, that is, islands arising from great depths in the ocean, mainly composed of coral or volcanic rocks, and showing no signs of having ever been connected with the existing continents, or the larger and so-called continental islands. The obvious explanation of this feature is that from their total isolation these islands have never been able to receive a mammalian fauna from the great continental areas on which mammalian life was probably first developed. As an intermediate step between these islands which are practically void of mammalian life and the continents which teem with such a variety of forms, are certain larger islands and portions of continents containing a mammalian fauna more or less markedly distinct from that of the whole of the other regions of the globe. The best instance of this is Australia, which, with the exception of one dog, the dingo, and certain muridian bats, has no mammals except monotremes and marsupials. The latter are, moreover, perfectly distinct from those of America, which, if we exclude the islands in the neighborhood of Australia, is the only other region which now possesses any marsupials at all. Here also we have a ready and full explanation which accords with all the facts, since it is evident that Australia has been isolated from the Asiatic continent from some very remote geological epoch, at which period it is probable that monotremes and marsupials were the dominant if not the sole representatives of the mammalia then existing. Consequently, Australia has never been able to receive an influx of the eutherian orders, which have probably swept away all the marsupials except the small American possums from the rest of the globe. Again, the large island of Madagascar, which has a fauna of an African type, but still very markedly different from that of the mainland, may be considered to have been connected with the latter at a time when the eutheria had become the dominant forms, but has been separated for a sufficiently long period to have enabled a large number of its species and genera to have become distinct from those of the adjacent continent. Similarly, there is evidence to show that South America was probably cut off for a considerable period from the northern half of the American continent, in consequence of which its lowly organized fauna of edentates were enabled to attain such a remarkable development in the later geological periods. In contrast to the mammalian fauna of islands of the preceding type is, or rather was, that of the British Islands, which in the early historic and prehistoric periods was identical with that of the continent. This leads to the inference that at a comparatively late epoch there was a direct land communication between Britain and the continent, which is shown by geological evidence to have actually been the case. The above instances are sufficient to show what an important influence the date of separation of islands from the adjacent continents has had upon their existing mammalian fauna, and how largely the present distribution of mammalian life is bound up with the past history of our globe. We must, however, not omit to mention another very important agency of past times which has likewise had great influence on the present distribution of the various faunas of the Northern Hemisphere. This is the so-called glacial epoch, which took place immediately before the establishment of the present condition of things, and appears to have been the cause of the extinction of many of the larger mammalian types which formerly inhabited Europe, and whose retreat to the warmer regions of the south was apparently cut off by the Mediterranean. Zoological regions. Zoologists are now generally agreed in dividing the land surfaces of the globe into a number of zoological regions or provinces, characterized by a more or less distinctly marked general facies of their fauna as a whole. Some of these regions are much more distinctly defined than the others, and in the majority of cases there is a kind of neutral ground or no man's land at the junction between any two of these regions. It must also be remembered that in the Old World proper, as we go back in time, we find a gradual assimilation in the mammalian faunas of the different regions, indicating that originally there was one large fauna of a generally similar type occupying the greater portion of this area. Thus we find that hippopotami, giraffes, kudus, elands, and other types of antelopes now restricted to Africa, formerly extended to Europe and India, while there is also evidence to show that the group of large anthropoid apes, now found only in Africa and the Bornean region, were likewise spread over a large part of the southwestern half of the Old World. Moreover, while at the present day there is a marked connection between the mammals of the northern regions of both the Old and New Worlds, in the Tertiary period it appears that the fauna of the whole of North America was much more nearly allied to that of the central regions of the Old World than is now the case. Thus in the Tertiary rocks of America we meet with remains of what we are accustomed to regard as such essentially Old World genera as horses and rhinoceroses. On the other hand, there are no traces in America of the existence at any period of apes, giraffes, hippopotami, or hyenas, while that continent has yielded evidence of groups of ungulates totally unrepresented in the Eastern Hemisphere. The chief zoological regions of the globe, proposed by Mr. Sclater in 1857, and now recognized by the majority of authorities, are 6 in number, and are named as follows. Firstly, the Palearctic region, embracing the whole of Europe, Persia, northern Arabia, and all of Asia northward of the line of the Himalaya proper, Japan, that part of Africa lying northward of the Sahara Desert, and the oceanic islands of the North Atlantic. Secondly, the Ethiopian region, which comprises all Africa lying to the south of the Sahara, the southern part of Arabia, Madagascar, and the Mascarene Islands. Thirdly, the Oriental or Indian region, which is taken to include India south of the Himalaya, and to the northwest as far as Baluchistan, the Malay Peninsula, southern China, Sumatra, Java, Borneo, and the Philippines. Fourthly, the Australasian region, which is usually defined as being bounded to the northwest by the deep sea channel lying between Borneo and Celebes known as Wallace's Line, and is taken to include Celebes, Lombok, New Guinea, Australia, Tasmania, New Zealand, and the host of oceanic islands in the South Pacific. Several writers, however, prefer to regard Celebes and some of the adjacent islands as representing a transitional Austromalayan region. Fifthly, the Nearctic region, comprising Greenland and North America as far south as the north of Mexico. And sixthly, the Neotropical region, which embraces the remaining portion of the American continent and the West Indies. Various minor modifications of this scheme have been proposed. Thus some writers are disposed to raise India to the rank of a distinct primary region, while others propose the same for New Zealand. The Palearctic and Nearctic regions have a large number of common types, more especially among the mammals, and Dr. A. Heilprin, 27, has expressed his opinion that they should be regarded as a single primary region under the name of the Holarctic. The same writer would also separate the South Pacific Islands as constituting a Polynesian region. Minor divisions or subregions have also been marked out, but it will be unnecessary to indicate their limits in the present work. We may, however, mention the Mediterranean subregion of the Palearctic, which includes the peninsular portion of southern Europe, North Africa, Asia Minor, Persia, Afghanistan, Baluchistan, and northern Arabia, as a good instance of the transition from one region to another, since its fauna has a mingling of Palearctic, Ethiopian, and Oriental types, the former being, however, the predominant ones. Of the chief mammalian types characteristic of these various regions, only a brief sketch can be given in this work. Palearctic region. The Palearctic region is of enormous extent, and includes countries varying greatly in their flora, climate, and elevation. Thus it embraces the Arctic plains of Siberia, the warm regions of Italy, southern France, and northern Africa, the forest-clad slopes of the outer Himalaya, and the lofty arid plains of Turkestan and Tibet, scorched by a burning sun in summer and chilled by a still more terrible cold in winter. Its extreme limits in the west are marked by the Canaries and Azores, and in the east by distant Japan, and yet throughout this vast expanse we find a great uniformity of life, as exemplified by the large number of British genera which occur also in Japan. The mammals which are on the whole the most characteristic of this region are the sheep and goats, forming a section of the great family of Bovidae, nearly all the species of which are Palearctic, although we meet with one goat, Capra, in the Nilgiris of southern India, and a sheep, Ovis, in the Nearctic region. The musk ox, Ovibos, is characteristic of the Palearctic and Nearctic regions. At least one species of camel is characteristic of this region, and it is not improbable that the second may also have originated in it. There are a few characteristic types of antelopes, such as the alpine chamois, Rupicapra, the saiga of Tartary, and the Kairu, Panthalops, of Tibet, each of which is represented by only a single species, and we miss the host of antelopes so characteristic of the Ethiopian region. Deer, Cervus, are abundant, although by no means confined to this region, and the musk deer, Moscus, the sole representative of the subfamily Muscini, is exclusively Palearctic. Monkeys, as a rule, are absent, although we meet with one species of Macacus in northern Africa and at Gibraltar, and some other types on the southern border of Tibet. The moles, Talpa, are mainly Palearctic, although one species enters northern India, while the desmans, Myogale, of the Pyrenees and southern Russia are unknown beyond the limits of this region. The water shrew, Nectigale, is likewise a peculiar eastern Palearctic type. Among the rodents, the pikas or tailless hares, Lagamies, and the dormice, Myoxus, are essentially Palearctic forms, only one species of each being found beyond the limits of the region, and the one extra Palearctic species of Lagamies occurring in the cognate Nearctic region. The mice and rats are represented by the typical genus Mus and other types, and hares, Lepus, and one species of squirrel, Sciurus, are common. The carnivora include two species of bears, Ursus, wolves and foxes, Canis, a lynx and a few species of cats, Felis, as well as numerous weasels, Mustela, and some other types. Ethiopian region. The Ethiopian region is of great interest to the student of mammals, since it is inhabited by a number of forms remarkable for their large size. A considerable portion of the area consists of desert, especially in the north, but there is also a wide extent of grassy plains, veldt, as well as vast tracts of equatorial forests of great density. Perhaps the most striking feature in the Ethiopian fauna is the number of ungulates, both of the artiodactyl and perissodactyl sections. In the former section we have the giraffes, Giraffa, represented by one species, which is the type of a family, and is unknown elsewhere. Equally characteristic are the hippopotami, which likewise form the type of a family, while the pigs are represented by the warthogs, Phacocheirus, and the river hogs, forming an aberrant group of the genus Sus. The oxen, bos, are represented by buffaloes, but there are no species of true oxen or bison. The antelopes attain an extraordinary development, the number of species being estimated at from 80 to 90, which are referred to a large number of genera, although several of these are more or less ill-defined. Most of these genera are peculiar to this region, but the gazelles, gazella, are also found in the desert regions of other parts of the Old World, and oryx ranges into Arabia and Persia. In contrast to this abundance of antelopes is the total absence of the deer family, or cervidae, which are so characteristic of the Palearctic and Oriental regions. The chevretains or tragulidae are, however, represented by Dorcitherium. 28. In the perissodactyle section we may notice the presence of two species of rhinoceros, both furnished with two horns, and distinguished from those of the Oriental region by the absence of incisor and canine teeth. The horse family, Equidae, is also represented by several species, and includes the peculiar group of zebras, characterized by their beautifully striped skins. Of other ungulates the elephants, which, like the rhinoceroses, are now peculiar to the Ethiopian and Oriental regions, have one species, which is widely different from its Indian congener. The hyraces are mainly characteristic of this region, although one species occurs in Syria and Palestine. The carnivora include some forms like the lion, leopard, and jackal, common to the Oriental region, but likewise include certain peculiar types like the earthwolf, Pertels, which may be regarded as the type of a distinct family, and two species hyenas, which are referred by some authorities to a distinct genus, Crocuta. There is also the hunting dog, Lycaon, and the peculiar group of foxes known as the phoenix, together with Otocion. Bears, wolves, and true foxes are absent, but civets, etc., are abundant, although not characteristic of the region. The primates yield several very characteristic types, such as the gorilla and the chimpanzee, Anthropopithecus, among the Simiidae, which, with the exception of the orangs of Borneo, are the only existing large man-like apes, and the group of dog-faced baboons, Cynocephali, in the Cercopithecidae. The genus Colobus is also a group of the latter family, absolutely characteristic of the region. Lemurs, again, occur on the continent of Africa, but the great development of this group is in the adjacent island of Madagascar, where several peculiar genera occur, and where the larger carnivora and ungulata are absent. These peculiarities of the fauna of Madagascar apparently point, as previously mentioned, to its separation from the mainland before the latter was overrun by the larger types, and at a time when its chief mammals were lemurs and insectivores. There are two genera of edentates, the pangolins, Manus, and the aardvark, or Pteropus, the latter being peculiar. Although the foregoing groups of mammals are now so characteristic of the Ethiopian region, it cannot be too strongly insisted that their restriction to this region is, so to speak, merely a feature of the present day, and that at a late geological epoch nearly all the peculiar genera were represented in India, and many of them also in Europe. Oriental region. The third or Oriental region is likewise of very considerable extent, and is the only one, in addition to the Ethiopian, which is the home of huge ungulates, like elephants and rhinoceroses, and the large man-like apes. A large proportion of this extensive area is occupied by tropical and subtropical forests and swamps, these being especially abundant in Burma, southern China, Siam, and the southern ridges of the Himalaya, collectively constituting the Indochinese subregion, and also in the Indo-Malayan subregion of the Malay Peninsula and adjacent islands. In the third or Indian subregion, comprising peninsular India, with the exception of the Carnatic, there are large tracts of open country, including some of the hottest regions in the world, parts of which form plains more or less covered with vegetation during the cooler and rainy seasons, while others are barren rocky tablelands, as in the Deccan, or arid deserts like those of parts of the Punjab and Sindh. Finally, in the fourth or Sinhalese subregion, represented by the Carnatic and the island of Ceylon, we find vast areas of luxuriant forest and jungle. In the northwestern desert area of the Indian subregion, the fauna includes a mixture of Palearctic and Ethiopian forms, with those characteristic of the Oriental region. Among the chief features of the mammalian fauna of this region we may notice the absence of hippopotami and giraffes, the greatly diminished number of antelopes, as compared with those of Africa, and the abundance of deer and true pigs. The antelopes comprise the two peculiar genera Bucelophus, Nilgai, and the typical antelope, blackbuck, each of which is represented by only a single species, while the deer belong to the so-called racine group, which is markedly different from that to which the Palearctic red deer belongs. True chevrotains, tragulus, are peculiar to this region. The oxen include the true buffalo, differing in many respects from the African species of the same group, and also certain species of true oxen, such as the Gower and Banting, belonging to the Bibavine group, which is confined to this region. In the Perissodactyla horses, equus, are represented only by a single species in the desert area of the Indian subregion, while the two species of rhinoceros differ from those of Africa in being furnished with canines and incisors. The Malayan tapir is the only Old World species of its genus. The Indian elephant differs, moreover, so markedly from its African ally that some writers regard the two as types of distinct genera. The carnivora include the lion, leopard, jackal, and hunting leopard, which are common to Africa, but the tiger is very characteristic of this region, although extending northwards into the Palearctic. Civets are abundant, comprising some peculiar genera, of which it will suffice to mention the well-known Paradoxurus. Wolves closely allied to the Palearctic species occur in northern India, and there are also foxes related to the typical species. The dog-like animals which hunt in packs, and are separated by some writers from Canis under the name of scion, occur in the present and the Palearctic region. The striped hyena is the Indian representative of its genus. Radals are common to this and the Ethiopian region, and constitute the genus Mellivora. The most striking feature in the carnivorous fauna of this region, as distinguished from the Ethiopian, is, however, the presence of bears, some of which belong to the typical genus Ursus, while one species is usually generically separated under the name of Melursus. Among the rodents we may especially notice the abundance of the Muridae and Sciuridae. In the former family we have numbers of true mice, mews, and also the peculiar genus Nisotia, bandicoot rat, while in the latter both the true squirrels, Sciurus, and the flying squirrels, Pteromes, attain great development. The genus, Pteromes, is, indeed, mainly characteristic of this region, although in Kashmir and Japan it enters the Palearctic. The bats are very numerous, being represented by all the families, with the exception of the Philostomatidae, or vampires, of South America. Among the insectivora the genera Tupaia and Galeopithecus, flying lemur, are peculiar to this region, although not found in India. Finally, in the primates we have the genera Macacus and Semnopithecus very abundantly represented, although both also enter the Palearctic region, but the anthropoid types are confined to the southeastern half of the region, and include the orangs, Simia, of Borneo, and the smaller long-armed gibbons, Hylobates, which are abundant in the Malay Peninsula, both genera not being found beyond this region. The lemurs are much less abundant than in the Ethiopian region, but they include the peculiar tarsia of Sumatra, Borneo, and Celebes, Austromalayan region, which differs so markedly in dentition and structure of the feet from all other forms that it has been made the type of a separate family. The edentates, so poorly represented in the Old World, include only pangolins, manus, which, as we have already seen, also occur in the Ethiopian region. Australasian region. With the fourth or Australasian region we come to a mammalian fauna so peculiar that we have no difficulty whatever in defining it from all the other regions of the globe, although it should be observed that in the Austromalayan Islands we have a partial mingling of the Australasian and Malayan faunas. If we exclude Celebes from this region we find that, with the exception of a pig in New Guinea, of the dingo in Australia, of numerous mice and rats, Muridae, and bats, there are no eutherian mammals throughout the area. The mammals of this region are restricted to the Australian mainland, the island of Tasmania, New Guinea, and the Aru Islands, the whole area of New Zealand having been totally devoid of mammalian life until introduced by man. The whole of the Monotremata, constituting the subclass Prototheria, and all the marsupials, exclusive of the few outlying forms ranging into the transitional Austromalayan area, and with the exception of the American family of the possums, Didelphidae, are absolutely confined to this region. Celebes. The mammals of Celebes, the typical representative of the Austromalayan transitional region or subregion, include the peculiar ape known as Sinopithecus, Tarsius, also oriental, the Anoa, and the single species of Babirusa. Several other types of placental mammals are found in this transitional area, while the marsupials are represented by phalanger and petaurus. Nearctic region. The two remaining regions we have to consider are comprised in the New World. The first of these is the Nearctic, which, as already mentioned, has a fauna showing such a strongly marked relationship to that of the Palearctic region, that it has been proposed to unite the two regions. Among types common to these two regions we may mention closely allied species of true deer, cervus, as exemplified by the red deer and the wapiti, the allied bisons of the two regions, the reindeer and elk common to both, as well as nearly related, and in some cases identical, species of cats, lynxes, bears, wolves, foxes, beavers, squirrels, marmots, and hares. The glutton or wolverine, and the musk ox is also common to the Arctic portions of the two regions. The ungulates are very poorly represented, but we have, in addition to the forms already mentioned, one species of the Palearctic genus Ovis, namely the bighorn, and the prongbuck, Antilocapra, which is quite peculiar. There are, however, no perissodactyla. The raccoons and coatis, Procyon, constitute a family represented out of the New World only by the aberrant cat bear, Elurus, of Nepal. The characteristic American feline known as the puma extends over this region, but there are no edentates, and the marsupials are represented only by a single species of opossum. Rodents are extremely numerous, and comprise several characteristic types, which alone would tell us what part of the globe we were visiting. The most distinctive are the pouched rats, Geomyidae, and the beaver-like rodents known as the Haplodontidae. True rats and mice, mews, which are represented throughout the Old World, are totally wanting in the New, where they are replaced by the vesper mice, which may be included in the European genus Chrysetis, although often separated as Hesperomys. This feature alone would seem to justify the distinction of the Nearctic from the Palearctic region. The musquash, Fiber, is a genus of Nearctic rodents unknown in the Old World. Among other characteristic genera we may mention, in the carnivora, the skunk, Mephitis, and the American badger, Taxidea. Primates are absent from the entire region. Neotropical region. The last of the six main regions is the Neotropical, including Mexico, South America, and the West Indies. A very large extent of this area is occupied by forests, which are described as being denser and more luxuriant than those of any other part of the globe. Alternating with these forest areas are the vast grassy plains known in different regions as llanos, savannas, and pampas. The backbone of the region is formed by the Great Chain of the Andes. Next to the Australasian, this region is perhaps better characterized by its mammalian fauna than any of the others. Commencing with the ungulates, we find a total absence of antelopes, sheep, and oxen, and also of all perissodactyls except tapirs. Deer are, however, represented, although by peculiar forms, Cariacus, unknown beyond the New World. The peccaries, dicotyls, which are often made the type of a distinct family, take the place of the Old World pigs, while the llamas and alpacas, Achinia, are the substitutes for the Palearctic camels. The carnivora include several cats, Felis, among which the puma and the jaguar are the most noticeable, and there are also raccoons, coatis, foxes, and one species of bear. Insectivora are totally wanting, but the bats are characterized by the presence of the vampires, Philostomatidae, which are almost restricted to this region. The rodents likewise include three families unknown elsewhere, namely the chinchillas and Viscacha, Chinchillidae, the agoutis, Dasyproctidae, and the cavies, Cavidae, while a large number of the Octodontidae are neotropical, all the other forms being Ethiopian. In the primates, again, we have all the forms quite peculiar to this region, and constituting two families, viz. the Cebidae or prehensile-tailed monkeys, and the Hopalidae, or marmosets, both of which differ decidedly in their dentition, as well as in other features, from the Old World monkeys. Lemuroids are unknown. Perhaps, however, the mammals which may be considered as most characteristic of the Nearctic region are the numerous edentates, which form three families, mostly confined to it. These comprise the Bradypodidae or sloths, which solely inhabit the forest region, the Myrmecophagidae or anteaters, and the Dasypodidae or armadillos, of which one species has crept northward as far as Texas. Almost equally characteristic are the numerous possums, the majority of which belong to the genus Didelphys. Finally, it should be observed that the West Indies are distinguished from the rest of the region by the absence of primates, carnivora, and edentates. Aquatic mammals. Many mammals grouped for the present purpose as terrestrial pass a great portion of their lives in brooks, lakes, or rivers, and, being dependent upon such waters for obtaining their subsistence, are necessarily confined to their vicinity, but the truly aquatic mammals, or those living constantly in the water, and unable to move their quarters from place to place by land, are the orders Cetacea and Sirenia, with which may also be grouped the seals, forming the pinniped division of the order Carnivora. For the marine Cetacea, animals mostly of large size and endowed with powers of rapid locomotion, there are obviously no barriers to universal distribution over the surface of the earth covered by sea, except such as are interposed by uncongenial temperature or absence of suitable food. Nevertheless, it was thought some years ago that the fact of a whale or a dolphin occurring in a sea distant from that in which it had usually been found was sufficient justification for considering it as a distinct species and imposing a new name upon it. There are now, however, so many cases known in which cetaceans from the northern and southern seas, from the Atlantic and Pacific Oceans, present absolutely no distinguishing external or anatomical characters upon which specific determination can be based that the opposite view is gaining ground, and, since some species are undoubtedly very widely distributed, being in fact almost cosmopolitan, there seems little reason why many others should not be included in the same category. The evidence is satisfactory enough in those instances in which the intermediate regions are inhabited by the same forms, the cases of continuous areas of distribution. In those in which the areas of distribution are apparently discontinuous, there may be more room for doubt, but it must not be forgotten that the negative evidence is here of much less value than in the case of land animals, since the existence of cetaceans in any particular part of the ocean may be easily overlooked. The great sperm whale, Physeter macrocephalus, is known to be almost cosmopolitan, inhabiting or passing through all the tropical and temperate seas, although not found near either pole. At least 3 of the well-known species of rorqual, Balænoptera, of the British coasts are represented in the North Pacific, on the South American shores, and near New Zealand, by species so closely allied that it is difficult to point out any valid distinctive characters, though it may perhaps be desirable to wait for a more exhaustive examination of a large series of individuals before absolutely pronouncing them to be specifically identical. There is nothing yet known by which we can separate the humpback whales, Megaptera, of Greenland, the Cape of Good Hope, and Japan. The same may be said of the common dolphin of the European seas, Delphinus delphis, and the so-called D. bairdi of the North Pacific and D. fursteri of the Australian seas. The pilot whale, Globicephalus malas, and the Sudorca of the North Atlantic and of New Zealand are also, so far as present knowledge enables us to judge, respectively alike. Many other similar cases might be given. Captain Maury collected much valuable evidence about the distribution of the larger cetacea, and, finding right whales, Balena, common in both northern and southern temperate seas, and absent in the intermediate region, laid down the axiom that the torrid zone is to the right whale as a sea of fire, through which he cannot pass. Hence all cetologists have assumed that the right whale of the North Atlantic, B. biscayensis, that of the South Seas, B. australis, and that of the North Pacific, B. japonica, are necessarily distinct species. The anatomical structure and external appearance of all are, however, so far as yet known, marvelously alike, and, unless some distinguishing characters can be pointed out, it seems scarcely justifiable to separate them from geographical position alone, as, though the tropical seas may be usually avoided by them, it does not seem impossible, or even improbable, that some individuals of animals of such size and rapid powers of swimming may have at some time traversed so small a space of ocean as that which divides the present habitual localities of these supposed distinct species. If identity or diversity of structural characters is not to be allowed as a test of species in these cases, as it is usually admitted to be in others, the study of their geographical distribution becomes an impossibility. Although many species are thus apparently of such wide distribution, others are certainly restricted. Thus the Arctic right whale, Balena mysticetus, has been conclusively shown to be limited in its range to the region of the northern circumpolar ice, and no corresponding species has been met within the southern hemisphere. In this case, not only temperature, but also the peculiarity of its mode of feeding, may be the cause. The narwhal and the beluga have a very similar distribution, though the latter occasionally ranges farther south. The common hyperoodon is restricted to the North Atlantic, never entering, so far as is yet known, the tropical seas. Other species are exclusively tropical or austral in their range. One of the true whalebone whales, Neoballina marginata, has only been met with hitherto in the seas round Australia and New Zealand, and a large ziphioid, Berardius arnu, only near the last-named islands. The cetacea are not limited to the ocean, or even to salt water, some entering large rivers for considerable distances, and others being exclusively fluviatile. One species of Platanista is extensively distributed throughout nearly the whole of the river systems of the Ganges, Brahmaputra, and Indus, ascending as high as there is water enough to swim in, but apparently never passing out to sea. The individuals inhabiting the Indus and the Ganges must therefore have been for long ages isolated without developing any definite distinguishing anatomical characters, for those by which the supposed P. indi was formerly separated from P. gangetica have been shown by Anderson to be of no constant value. Orcella fluminalis appears to be limited to the Irrawaddy River, and at least 2 distinct species of dolphin belonging to different genera are found in the waters of the upper Amazon. A Neomeris has been found in the Great Chinese River, the Yangtze-Kiang, nearly 1,000 miles from the sea. It is remarkable, however, that none of the Great Lakes or inland seas of the world are, according to our present knowledge, inhabited by cetaceans. A regular seasonal migration has been observed in many of the oceanic cetacea, especially those inhabiting the North Atlantic, but further observations upon this subject are still much needed. The great difference in the manner of life of the Sirenia, as compared with that of the cetacea, causes a corresponding difference in their geographical distribution. Slow in their movements, and feeding exclusively upon vegetable substances, watergrasses, or fuci, the Sirenia are confined to rivers, estuaries, or coasts where these grow, and are not denizens of the open sea, although of course there is a possibility of accidental transport by the assistance of oceanic currents across considerable distances. Of the 3 genera existing within historic times, 1, Monatus, is exclusively confined to the shores of the tropical Atlantic and the rivers entering into it, individuals scarcely specifically distinguishable being found both on the American and the African side of the ocean. The dugong, Halicore, is distributed in different colonies, at present isolated, throughout the Indian Ocean from Arabia to North Australia. The Rhytina or northern sea cow was, for some time before its extinction, limited to a single island in the extreme north of the Pacific Ocean. The pinnipeds, although capable of traversing long reaches of ocean, are less truly aquatic than the last 2 groups, always resorting to the land or to extensive ice floes for the purpose of breeding. The geographical range of the various species is generally more or less restricted, usually according to climate, as they are mostly inhabitants either of the Arctic or Antarctic seas and adjacent temperate regions, very few being found within the tropics. For this reason the northern and the southern species are for the most part quite distinct. In fact, the only known exception is the case of a colony of the sea elephant, Macrorhinus leoninus, the general range of which is in the southern hemisphere, inhabiting the coast of California. Even in this case a different specific name has been given to the northern form, but the characters by which it is distinguished are not of great importance, and probably, except for the abnormal geographical distribution, would never have been noticed. The most remarkable circumstance connected with the distribution of the pinnipeds is the presence of members of the suborder in the 3 isolated Great Lakes or inland seas of Central Asia, the Caspian, Aral, and Baikal. These forms, notwithstanding their long isolation, having varied but slightly from species now inhabiting the polar seas. 2. Geological distribution. Geological sequence. In order to understand the geological distribution, or in other words the distribution in time of mammals, it is necessary to be acquainted with the chief divisions, or time periods, of the strata constituting the crust of the globe. These are shown in the following table, which commences with the uppermost or most recent beds and ends with the lowest and oldest. I. Cainozoic or Tertiary, 1. Pleistocene, river alluvia, etc. 2. Pliocene, Suffolk Crag. 3. Miocene, Hempstead beds of Hampshire. 4. Eocene, Paris gypsum and London clay. 2. Mesozoic or secondary, 1. Cretaceous, chalk, greensands, etc. 2. Jurassic, oolites and lias. 3. Triassic, red marls, dolomites, etc. 3. Paleozoic or primary, 1. Permian, beds overlying the coal. 2. Carboniferous, coal measures, etc. 3. Devonian, old red sandstone. 4. Silurian, Wenlock limestone, etc. 5. Cambrian, Llanberis slate, etc. 6. Archean, gneiss and other schists. The names in the first column indicate the primary divisions or life periods, while those in the second column are the great systems, each of which is again divided into minor groups, the popular names of a few of these minor groups being given in the third column. There are at present no means of arriving at any satisfactory conclusion as to the absolute length of time indicated by either the primary or secondary divisions, but there is little doubt that the whole of the tertiary period is only equal to a fraction of the Mesozoic as regards its duration, while it is probable that the duration of the Mesozoic epoch was largely exceeded by that of the Paleozoic. Mesozoic mammals. The earliest date at which mammals are at present known is in the upper part of the Triassic period, which forms the base of the Great Mesozoic epoch, and from this date they are represented more or less abundantly in various horizons of the Jurassic and Cretaceous. The very rapid advances in our knowledge of these forms which have been made in the last few years, especially in consequence of the explorations of rich fossiliferous beds in North America, have not only completely changed the present aspect of the science, but give such promise for the future, that any sketch which we may now attempt of this branch of the subject can only be regarded as representing a transient phase of knowledge. It will be well, however, to gather together in this place the leading facts now ascertained with regard to the most ancient forms, as, owing to the uncertainty of their relationship with any of the existing orders, they will be most conveniently treated of separately, while the ascertained facts relating to the geological history of the forms more nearly allied to those now living will be more appropriately described under the account of the different groups into which the class may now be divided. The remains of mammals which existed anterior to the tertiary period hitherto discovered nearly all belong to creatures of very small size, many of the largest scarcely exceeding the common polecat or squirrel. Some are known only by a few isolated teeth, others by nearly complete sets of these organs, and the majority by more or less nearly perfect specimens of the rami of the lower jaw. It is a very curious circumstance that this part of the skeleton alone has been preserved in such a large number of instances. Only very rarely has a nearly complete cranium been found, and there is no satisfactory evidence of the structure of the vertebral column of any single individual, and only one known case of a complete limb, 29. The species already described from European strata are numerous, although the number of genera and species has lately been reduced. Of these by far the greater number have been found at a single spot near Swanage in Dorsetshire, in a bed of calcareous mud only 40 feet long, 10 feet wide, and averaging 5 inches in depth. The marvelous results obtained by the exploration by Mr. S. H. Beckles of this small fragment of the Earth's surface show by what accidents, as it were, our knowledge of the past history of life has been gained, and what may still remain in store where little thought of at present. A bed, apparently equally rich, has been discovered in the Jurassic of Wyoming, North America, the contents of which have been made known by Professor Marsh, while another fertile source of these remains occurs in the Laramie beds of the Upper Cretaceous of the United States. 30. The whole of the Mesozoic mammals at present known may be divided into two great groups. The one characterized by a type of dentition more or less clearly resembling that found among the existing polyprotodont marsupials, while the other presents an altogether peculiar modification, recalling in some respects that of the diprotodont marsupials, although differing so decidedly as to show that the owners of this form of dentition cannot be included in that group. Figure 24. Frontal and oral aspects of the cranium of Tritylodon longivus, from the Karoo system of Basutoland, South Africa. 2/3 natural size. After Owen. Multituberculata. The name Multituberculata has been proposed for the group exhibiting the type of dentition last mentioned, and is generally adopted, although the term Allotheria has been also suggested. The essential characteristic of the dentition of this group is the presence of a single scalpiform incisor on each side of the lower jaw, figure 25, and of one larger incisor, and in some instances of one or two smaller ones in each premaxilla, figure 24. These incisors are separated by an interval or diastema from the first of the premolars. The true molars, and in some instances the premolars, figure 24, are characterized by having longitudinal rows of tubercles separated by one or more grooves, there being either 2 or 3 of these rows in the upper molars of those forms in which these teeth are known, while there are, at least usually, only 2 in those of the lower jaw. In other cases the premolars are of a secant type, with a highly convex cutting edge, and usually either serrated or obliquely grooved, figures 25, 26. From a certain resemblance between these secant premolars and those of some of the smaller macropodidae, it was at one time considered that we had in these mammals representatives of diprotodont marsupials. The great difference in the structure of the molar teeth of these forms, coupled with the circumstance that when the number of upper incisors is reduced below 3 it is the second in place of the first which becomes enlarged and opposed to the incisor of the lower jaw, seems to prevent the acceptation of this view. Moreover, in their peculiar structure the molars seem, on the whole, to make a nearer approximation to the teeth of Ornithorhynchus than to any other known mammal, and it has accordingly been suggested that the Multituberculata may really represent an order of Prototheria. Some support is afforded to this suggestion by certain fragmentary bones from the Cretaceous of the United States, which are regarded by Marsh as parts of a coracoid and interclavicle. The peculiar character of the whole dentition of these forms indicates that if they are really Prototherians they cannot be regarded as primitive and ancestral types. Figure 25. The right ramus of the mandible of Plagiolax becklesi, from the purbeck of Swanage. Twice natural size. I. Incisor, M. Molar, B. Coronoid process, C. Condyle. After Owen. It would be beyond the scope of the present work to describe in detail, or even to mention the names of all the members of this group, and it will therefore suffice to refer to a few of the principal types. Of the forms with tubercular premolars the best known is the genus Tritylodon, figure 24, which occurs typically in beds of lower Mesozoic in South Africa, but is also known from the Trias of Stuttgart. In the Stonesfield Slate, near Oxford, which belongs to the lower part of the Jurassic system, and is separated from the Trias by the intervening lias, a fragmentary jaw with 3 teeth, figure 27, appears to indicate an allied type, the teeth having 3 longitudinal ridges separated by grooves. In the Purbeck beds of Dorsetshire, forming the top of the Jurassic system, we find another member of this group, which has been described as Bolodon, closely allied to which is Alodon of the Upper Jurassic of the United States. Figure 26. The imperfect right ramus of the mandible of Plagiolax minor, from Swanage. 4 times natural size. P. Premolars, M. Molars. After Lyell. The first discovery of the remains of Mesozoic mammals was made in the Kuper or Upper Trias of the Rhetian Alps in Bavaria. In 1847 Professor Pleininger of Stuttgart, while sifting some sand from the Kuper of Diegerlach and Steinenbronn, found, among an immense mass of teeth, scales, and unrecognizable fragments of skeletons of fish and saurians, 2-minute teeth, each with well-defined, enameled, tuberculated crowns and distinct roots, plainly showing their mammalian character. These were considered by their discoverer to indicate a predaceous and carnivorous animal of very small size, to which he gave the name of Microlestes antiquus. Subsequently Mr. C. Moore discovered in a bone bed of Redick, topmost Trias, age, filling a fissure in the mountain limestone at Holwell, near Frome in Somersetshire, various isolated teeth with their crowns much worn, but apparently including both upper and lower molars and a canine, which are assigned by Sir R. Owen to Pleininger's genus Microlestes, and described specifically as M. Moore. Under the name of Hypsopermnopsis rheticus, Professor Boyd Dawkins described a single tooth with 2 roots discovered in the Redick marlstone at Watchet in Somersetshire. Sir R. Owen referred the latter tooth to Microlestes, and if its describer is right in regarding it as a much worn premolar of the type of those of Plagiolax, figure 25, there would be evidence that Microlestes was closely allied to the latter, from the molars of which those of Microlestes are scarcely distinguishable. Figure 27. Stereognathus oolithicus. Fragment of jaw with 3 teeth, A, B, C, in matrix, from the Stonesfield slate. Natural size. After Owen. Plagiolax, of the Dorsetshire Purbeck, figures 24, 25, is at once distinguished from Tritylodon by its secant premolars, which, as already mentioned, recall those of some of the Macropodidae, although readily distinguished by the convexity of the cutting edge and their oblique grooving. This remarkable and highly specialized type has been the occasion of one of the most interesting discussions on the inferences which may be drawn as to the affinities and habits of an otherwise unknown animal from the structure of a small portion of its organization which occurs in the annals of natural history, a discussion carried on with great ability, ingenuity, and wealth of illustration on both sides. Dr. Falconer maintained that it was more nearly allied to the rat kangaroo, Podurus or Hypsiprymnus, than to any other existing form, and that, as it is known that these animals feed upon grass and roots, it may be inferred of Plagiolax that the species were herbivorous or frugivorous. I can see nothing in the character of their teeth, he adds, to indicate that they were either insectivorous or omnivorous. Sir R. Owen, on the other hand, from the same materials came to the conclusion that the physiological deductions from the above-described characteristics of the lower jaw and teeth of Plagiolax are that it was a carnivorous marsupial. It probably found its prey in the contemporary small insectivorous mammals and lizards, supposing no herbivorous form like Stereognathus to have coexisted during the Upper Oolitic period. It is impossible here to give at any length the arguments by which these opposing views are respectively supported, but it may be indicated that the first mentioned is strongly countenanced by the consideration of the following facts. 1. All existing marsupials may be divided, so far as their dentition is concerned, into two groups, a. Those which have a pair of large more or less procumbent incisors close to the symphysis of the lower jaw, and rudimentary or no canines, diprotodont dentition. And, b. Those which have numerous small incisors and large pointed canines, polyprotodont dentition. 2. The vast majority of the former group are purely vegetable feeders, and almost all of the latter are carnivorous or insectivorous. And, 3. Plagiolax, so far as its structure is known, shows an analogy with the former group, and, as we have no sure basis for inferences as to the habits of an unknown animal, but the knowledge of the habits of such as are known, we have no grounds for supposing that its habits differed from those forms having an analogous type of dental structure. 31. Allied types, such as Tenacodon, are also met within the Upper Jurassic of North America, and the Plagiolacity also persisted into the lower part of the Eocene division of the Tertiary period, Neoplagiolax being a tertiary form common to Europe and the United States, while Lyotomus and Tilodus are at present known only from the latter country. The present group is also represented in the Upper Cretaceous of the United States by Selenacodon, Meniscoesis in part, Simoleames, etc. Polymastodon, of the lowest or Puerco-Eocene of New Mexico, is the largest known form, and is characterized by the presence of only one premolar and the elongated molars. The angle of the mandible is inflected after the marsupial fashion. Polyprotodont type sta. The second type of mammalian dentition found in the Mesozoic period resembles that occurring among recent polyprotodont marsupials, that is to say there are at least 3 lower incisors, the canines are well developed, and the premolars and molars are cuspidate, the number of the latter reaching in some cases to 7 or 8. There has been much discussion as to the taxonomic position of these forms, and while the majority of writers admit the marsupial affinities of at least a moiety, it has been contended that others indicate distinct ordinal groups more or less closely allied to the insectivora. At present, however, there is no decisive evidence to support such a view. Important proof of the marsupial affinity of one of these forms is afforded by the replacement of the teeth, which appears to be of the same nature as in the existing marsupials, that is to say, the last premolar alone is preceded by a milk tooth. The most generalized forms appear to be Dromatherium and Microconodon, from lower Mesozoic beds in the United States, of which enlarged views of the teeth are given in Figure 4.1.2, page 31. Professor Osborne points out the extremely simple character of these teeth, and it is quite possible that these forms may prove to be Prototheria. There are 3 premolars and 7 molars in the lower jaw of Dromatherium. Figure 28. Reversed view of the left ramus of the mandible of Triconodon mordax, from the Purbeck of Swanage. Natural size. After Owen. A common form in the purbeck of Dorsetshire is Triconodon, Triacanthodon, in which the formula of the lower teeth is I3, C1, P4, M3-4. A lower jaw is shown in Figure 28, and an enlarged view of a molar tooth in Figure 4, 5. The molar teeth consist of 3 flattened cones placed in the same anteroposterior line, those of the upper and lower jaw being alike. Priacodon, of the Jurassic of the United States, is probably inseparable from Triconodon. In the genus Phascalotherium, Figure 29, of the Lower Jurassic Stonesfield slate, the lower teeth may be classified as I4, C1, P3, M4, the premolars and molars being much alike. The molars approximate to the type of those of Triconodon, but the anterior and posterior cones are relatively smaller. Like that of the last-named genus, the mandible of Phascalotherium is remarkable for the extremely low position of its articular condyle. In Amphilests, Figure 30, of the Stonesfield slate the molars appear to be of the same general type as those of Phascalotherium, but are more numerous, although their exact number cannot be determined. A somewhat different type of lower molar is displayed by the genus Amblytherium, of the Dorsetshire purbeck, to which Amphitherium of the Stonesfield slate was probably allied. This type of tooth is shown in Figure 4, 8, 9, 12, page 31, and, as there stated, represents that modification of the tritubercular type known as the tubercular sectorial. The 3 primitive tritubercular cusps form what is known as the blade of the tooth, behind which there is the talon or hypocone. A similar form of molar occurs in the existing possums and bandicoots. The number of lower teeth in Amblytherium is I4, C1, P4, M7-8. Numerous allied types, such as Achirodon and Dryalests, occur in the Upper Jurassic of Europe or the United States, while from only one side of the jaw being exposed. In each case so-called genera like Stylodon and Stylocodon have been formed upon specimens showing the opposite side to that which is exposed in the types of Amblytherium and Amphitherium. The only parallel among existing forms to the excessive number of molar teeth found in these Mesozoic genera occurs in the marsupial genus Myrmecobius, of which a description is given in a succeeding chapter. Jaws more or less closely resembling those described under the names mentioned above are also found in the uppermost Cretaceous of the United States. A feature common to these Mesozoic mammals and Myrmecobius and some other existing forms is the presence of a narrow channel on the inner side of the mandibular ramus known as the mylohyoid groove, Figure 29. Figure 29. Inner view of the right ramus of the mandible of Phascalotherium bucklandi, from the Stonesfield slate. The outline shows the natural size. I. Incisors, 1 missing, C. Canine, P. Premolars, M. Molars. The mylohyoid groove is seen near the lower border. After Owen. Figure 30. Reversed inner view of the left ramus of the mandible of Amphilests broderipi, from the Stonesfield slate. Twice natural size. The restoration of the anterior teeth is conjectural, and the condyle is placed too high. After Owen. The last type of molar dentition occurring among the Mesozoic mammalia is that found in the lower jaws, Figure 31, upon which the genus Spalacotherium was established, the upper jaws, described as parallests, being apparently referable to the same animal. Upper and lower teeth of this form are represented in Figure 4, 6, 7, page 31, where they are described as typical examples of the tritubercular type of molars, the upper teeth having 1 inner and 2 outer cusps, and the reverse condition obtaining in the lower ones. This type of molar presents a marked resemblance to that found in the existing insectivorous genus Chrysochloris. The number of lower teeth in Spalacotherium is, however, I3, C1, P plus M10, by which it is widely distinguished from all the insectivora. Monacodon, of the Upper Jurassic of the United States, appears to be allied to Spalacotherium. Figure 31. Part of the left ramus of the mandible, viewed from the outer side, of Spalacotherium tricuspidans, from the purbeck of Swanage. Twice natural size. After Owen. Tertiary mammals. The more important types of tertiary mammals will, as already mentioned, be noticed under the heads of the groups to which they are severally allied, but a few general remarks on this subject may be advantageously recorded in this chapter. In the first place, it may be observed that the comparatively scanty evidence of mammalian life hitherto yielded by the Cretaceous, coupled with the number and variety of forms approximating to the existing groups found even in the lowest tertiary, indicates a great imperfection of the geological record. At present, indeed, we have no decisive evidence of the existence of any members of the Eutherian subclass previously to the tertiary, but it can hardly be doubted that in some part of the world they had made their appearance before that epoch. The Eutherian mammals of the lowest Eocene, both in Europe and the United States, are of an extremely generalized type, and although many of them approximate to existing groups, they show such a combination of characters, now restricted to individual groups, as to indicate that several of the various orders into which the subclass is now divided were at that period very intimately connected. A marked feature of these early Eutherians is the prevalency of trituberculism in the dentition, not less noteworthy being the frequent occurrence of pentadactylism in the feet, while many of the individual bones were devoid of the grooves and ridges found in those of later types. By the time that we reach the upper division of the Eocene period, such as the horizon of the well-known gypsum of the Paris Basin, nearly all the chief groups of mammals had become clearly differentiated from one another, although their representatives were usually more generalized than their existing allies. From this date to the later geological periods there is a gradual approximation to the types of mammalian life existing at the present day. In addition to the features of trituberculism and pentadactylism so characteristic of the oldest known Eutherians, we may notice some other points in connection with the earlier types. Thus the older tertiary mammals, as we have already stated, had relatively smaller and simpler brains than the later types, so that a gradual evolution in this respect may be traced from the Eocene to the Pleistocene. Again, there is a great tendency among the Eocene forms to a retention of the typical Eutherian dental formula noticed on page 25, and also to the absence of an interval, or diastema, in the dental series. Concomitantly with this feature we may notice the short crowns and simpler structure of the molar teeth of the earlier ungulates as compared with those of today, of which details will be given in a later chapter. Another instance of the more generalized characters of the earlier mammals is afforded by the absence or slight development of horns, antlers, and tusks among the ungulata. Thus the earlier rhinoceroses were hornless, and the deer either without antlers or with antlers of a very simple kind, while the male swine were not furnished with the formidable tusks of the existing wild boars. Finally, all, or nearly all of the mammals, from the lowest Eocene of Reims present the peculiarity of having a vertical perforation in the astragalus. The intimate connection existing during the Middle Tertiary between many families of mammals now widely distinguished from one another may be more conveniently noted when we come to the consideration of the families in question. Chapter 5 The subclass Prototheria or Ornithodlphia General Characters. The characters of the Prototheria can at present only be deduced from the two existing families, since hitherto no extinct animals which can be referred with certainty to other divisions of this remarkable and well-characterized group have been discovered. These two isolated forms, in many respects widely dissimilar, yet having numerous common characters which unite them together and distinguish them from the rest of the Mammalia, are the Ornithorhynchidae and the Echidnae, both restricted in their geographical range to the Australian region of the globe. Taken all together they represent the lowest type of evolution of the mammalian class, and most of the characters in which they differ from the other two subclasses tend to connect them with the inferior vertebrates, the Sauropsida and Amphibia, for, though the name Ornithodelphia owes its origin to the resemblance of the structure of the female reproductive organs to those of birds, there is nothing especially bird-like about them. Their principal distinctive characters are these. The brain has a very large anterior commissure, and a very small corpus callosum, agreeing exactly in this respect with the marsupials. The cerebral hemispheres, in Echidna at least, are well developed and convoluted on the surface. The auditory ossicles present a low grade of development, the malleus being very large, the incus small, and the stapes columeliform. The coracoid bone is complete, and articulates with the sternum, and there is a precoracoid, epicoracoid, in advance of the coracoid, while there is also a large interclavicle or episternum in front of the sternum, and connecting it with the clavicles. There are also epipubic bones. The oviducts, not differentiated into uterine and fallopian portions, are completely distinct, and open, as in oviparous vertebrates, separately into a cloacal chamber, and there is no distinct vagina. The testes of the male are abdominal in position throughout life, and the vasa deferentia open into the cloaca, not into a distinct urethral passage. The penis, attached to the ventral wall of the cloaca, is perforated by a canal in the greater part of its length, and not merely grooved, as in reptiles and those birds which have such an organ. The canal is open at the base and brought only temporarily in contact with the termination of the vasa deferentia, so as to form a seminal urethra when required, but it never transmits the urinary secretion. This condition is a distinct advance on that of the Sauropsida in the direction of the more complex development of these parts in most of the other mammalia. The ureters do not open into the bladder, but behind it into the dorsal wall of the genitourinary passage. The mammary glands have no distinct nipple, but pour out their secretion through numerous apertures situated in a cup-shaped depression of the abdominal skin, forming a mammary marsupium, especially developed in the females during lactation. It should be mentioned that, according to the observations of Professor Gagenbohr, the mammary glands of the monotremes are the simplest found in the entire class. The region of the glands is, indeed, distinguished from the rest of the abdomen merely by its thicker layers of muscles. The glands themselves are closely connected with the hair follicles, and belong to the sudoriparous type, whereas the glands of all other mammals are of sebaceous origin. The young are produced from eggs laid by the female parent, which are meriblastic, like those of birds, that is to say only a portion of the yolk segments and forms the embryo, the remainder serving for the nourishment of the latter. The above are the principal distinguishing characters of the group, and apply not only to the subclass, but of course equally to the one-order Monotremata, in which the two existing genera are included. In addition to these more important characters, the following minor features may also be mentioned. The scapula differs from that of all other mammals in that the ridge corresponding to the spine of other forms is situated on the anterior border instead of in the middle of the outer or dorsal surface. The humerus is much expanded at its two extremities, and has a very prominent deltoid crest, and a well-marked antepicondylar foramen. The dorsothoracic vertebrae are 19 in number, and have no terminal epiphyses to their bodies. The transverse processes of the cervical vertebrae are of autogenous formation, and remain suturally connected with the remainder of the vertebra until the animal is full-grown. Though in this respect they present an approximation to the Sauropsida, reptiles and birds, they differ from these classes, inasmuch as there is not a gradual transition from these autogenous transverse processes of the neck, or cervical ribs, as they may be considered, into the thoracic ribs, for in the seventh vertebra the costal element is much smaller than in the others, indicative of a very marked separation of neck from thorax, not seen in the existing Sauropsida. The upper ends of the ribs are attached to the sides of the bodies of the dorsal vertebrae only, and not to the transverse processes. The sternal ribs are well ossified, and there are distinct partly ossified intermediate ribs. The cerebral cavity, unlike that of the lower marsupials or the reptiles, is large and hemispherical, flattened below and arched above, and about as broad as long. The cribriform plate of the ethmoid is nearly horizontal. The cranial walls are very thin, and smoothly rounded externally, and the sutures become completely obliterated in adult skulls, as in birds. The broad occipital region slopes upwards and forwards, and the face is produced into a long and depressed rostrum. The bony palate is prolonged backwards, so that the posterior nares are nearly on a level with the glenoid fossae. The mandible is without distinct ascending ramus, the coronoid process and angle are rudimentary, and the two halves are loosely connected at the symphysis. The fibula has a broad, flattened process, projecting upwards from its upper extremity above the articulation, like an olecranon. In the male there is an additional, flat, curved ossicle on the hinder and tibial side of the plantar aspect of the tarsus, articulating chiefly to the tibia, which supports in the adult a sharp-pointed perforated horny spur, with which is connected the duct of a gland situated beneath the skin of the back of the thigh, the function of which is not yet clearly understood. A rudimentary spur is found in the young female Ornithorhynchus, but this disappears when the animal becomes adult. The stomach is subglobular and simple. The alimentary canal has no ileocecal valve, or marked distinction between large and small intestine, but has a small, slender vermiform cecum with glandular walls. The liver is divided into the usual number of lobes characteristic of the mammalia, and is provided with a gallbladder. In the presence of three distinct bones developed from cartilage in the shoulder girdle, viz. Scapula, coracoid, and pre- or apicoracoid, the monotremes agree with the anomodont reptiles, see page 83, and with no other representatives of that class. The precoracoid of the anomodonts is, however, distinguished by extending upwards to articulate with the acromial process of the scapula. The monotreme humerus is, moreover, strikingly like the corresponding bone of many of the anomodonts and of some of the allied labyrinthodont amphibians. Family Ornithorhynchidae. Ornithorhynchus, 32, cerebral hemisphere smooth. Premaxilla and mandible expanded anteriorly and supporting a horny beak something like that of a duck, bordered by a naked and very sensitive membranous expansion. The place of teeth in the adult is supplied functionally by horny structures, elongated, narrow, and sharp-edged, along the anterior part of the sides of the mouth, and broad, flat-topped or molariform behind. Functional molar teeth present in the young and adolescent condition. Legs short, fitted for swimming, feet webbed, each with 5 well-developed toes armed with large claws, beyond which in the 4 feet the interdigital membrane is extended. Vertebrae, C7, D17, L2, S2, Ca21. Acetabulum not perforated. Tongue not extensile. Mucous membrane of small intestine covered with delicate, close-set transverse folds or ridges. Tail rather short, broad, and depressed. Eyes very small. Fur close and soft. The duck-billed platypus, Platypus anatinus, was the name assigned to one of the most remarkable of known animals by Shaw, who had the good fortune to introduce it to the notice of the scientific world in the Naturalist's Miscellany, Volume 10, 1799. In the following year it was independently described by Blumenbach, Boyd's Magazine, 2. Page 205, under the name of Ornithorhynchus paradoxus. Shaw's generic name, although having priority to that of Blumenbach, could not be retained, as it had been used at a still earlier time, 1793, by Herbst for a genus of Coleoptera. Ornithorhynchus is therefore now universally adopted as the scientific designation, although duck-billed platypus or duckbill may be conveniently retained as a vernacular appellation. By the colonists it is called water mole, but it need scarcely be said, its affinities with the true moles are of the slightest and most superficial description. Until the last few years the early stages of the development of the young were not fully known. It had, indeed, been repeatedly affirmed, in some cases by persons who have had actual opportunities of observation, that the platypus lays eggs, but these statements were generally received with skepticism and even denial. This much vexed question was, however, settled by the researches of Mr. W. H. Caldwell in 1884, who found that these animals, although undoubtedly mammals throughout the greater part of their structure, are oviparous, laying eggs, which in the manner of their development bear a close resemblance to the development of those of the reptilia. 2 eggs are produced at a time, each measuring about 3/4 of an inch in its long, and half an inch in its short, axis, and enclosed in a strong, flexible, white shell. The platypus is pretty generally distributed in situations suitable to its aquatic habits throughout the island of Tasmania and the southern and eastern portions of Australia. Slight variations in the coloring and size of different individuals have given rise to the idea that more than one species may exist, but all naturalists who have had the opportunity of investigating this question by the aid of a good series of specimens have come to the conclusion that there is but one, and no traces of any extinct allied forms have yet been discovered. Figure 32. Platypus or duckbill, Ornithorhynchus anatinus. From Gould's Mammals of Australia. The length of the animal when full grown is from 18 to 20 inches from the extremity of the beak to the end of the tail, the male being slightly larger than the female. The fur is short, dense, and rather soft to the touch, and composed of an extremely fine and close underfur, and of longer hairs projecting beyond this, each of which is very slender at the base, and expanded, flattened, and glossy towards the free end. The general color is deep brown, but paler on the underparts. The tail is short, broad, and depressed, and covered with coarse hairs, which in old animals generally become worn off from the undersurface. The eyes are small and brown. There is no projecting pinna or ear conch. The mouth, as is well known, bears a striking resemblance to the bill of a duck. It is covered with a naked skin, a strong fold of which projects outwards around its base. The nostrils are situated near the extremity of the upper surface. There are no true teeth in the adult, but their purposes are served by horny prominences, or cornules, 2 on either side of each jaw, those in the front, narrow, longitudinal, sharp-edged ridges, and those behind broad, flattened, and molariform. The upper surface of the lateral edges of the mandible has also a number of parallel fine transverse ridges, like those on the bill of a duck. Until 1888 it was thought that true teeth were totally wanting throughout the life of this animal, but in the spring of that year Mr. E. B. Poulton, 33, announced the discovery in an embryo of teeth which were regarded as quite functionless. In the following year, however, Mr. O. Thomas, 34, was fortunate enough to find some young skulls with functional teeth in situ, and was thus enabled to give a detailed account of their structure and of their relations to the cornules. From those specimens it appears that the teeth are functional for a considerable part of the life of the animal, cutting the gum in the usual manner, and, after being worn down by friction with food and sand, are shed from the mouth in the same manner as are the milk teeth of other mammals. The cornules are developed from the epithelium of the mouth under and around the teeth, and the hollows found in the middle of them are the vestiges of the alveoli from which the teeth have been shed. One of the skulls showed on either side, both above and below, 2 completely calcified teeth, but in another example there were 3 teeth on either side of the lower jaw. According to Mr. Thomas's account, the teeth themselves are broad, flat, and low-crowned. The upper ones have each 2 high, conical, internal cusps, from which minute ridges run downwards and outwards to the outer borders of the crowns, where the edge is peculiarly crenulate rather than cuspidate, in the ordinary sense of the word. On the whole, the anterior and posterior upper teeth are essentially similar to one another, except that the former are narrower, and their outer edges are less markedly crenulated. In the lower jaw there is a greater difference between the two. The anterior is triangular in outline, its longest side is placed antero-externally, and its anterior and postero-external angles have each a high-pointed cusp, ridged on its internal aspect, while the posterior and internal borders are indistinctly crenulated. The posterior tooth is broadly quadrangular in outline, with a projecting antero-internal angle. As in the corresponding tooth above, there are 2 cusps on one side, and a series of crenulations on the other, but they are of course reversed, the cusps being external and the crenulations internal. The cusps are high, and connected with transverse ridges running across towards the internal border. In trying to find any teeth like those of the duckbill among other known mammals, Mr. Thomas considers, as was first suggested by Professor Cope, that those of the Mesozoic multituberculata, page 109, make the nearest approximation. He adds, however, that it must be insisted that the resemblance between the multituberculate and the ornithorhynchus teeth is of the most general character, and that the two are certainly widely separated generically, even if we do admit that they appear to possess a relationship nearer to each other than to any other known groups of mammals. Reverting to the description of the duckbill, we find that in the cheeks are tolerably capacious pouches, which appear to be used as receptacles for food. The limbs are strong and very short, each with 5 well-developed toes provided with strong claws. In the 4 feet the web not only fills the interspaces between the toes, but extends considerably beyond the ends of the long, broad, and somewhat flattened nails, giving great expanse to the foot when used for swimming, though capable of being folded back on the palm when the animal is burrowing or walking on the land. On the hind foot the nails are long, curved, and pointed, and the web extends only to their base. On the heel of the male is a strong, curved, sharply pointed, movable horny spur, directed upwards and backwards, attached by its expanded base to the accessory bone of the tarsus. This spur, which attains the length of nearly an inch, is traversed by a minute canal, terminating in a fine longitudinal slit near the point, and connected at its base with the duct of a large gland situated at the back part of the thigh. The whole apparatus is so exactly similar in structure to the poison gland and tooth of a venomous snake as to suggest a similar function, but evidence that the platypus ever employs its spur as an offensive weapon has, at all events until lately, been wanting. A case is, however, related by Mr. Spicer in the Proceedings of the Royal Society of Tasmania for 1876, page 162, of a captured platypus inflicting a severe wound by a powerful lateral and inward movement of the hind legs, which wound was followed by symptoms of active local poisoning. It is not improbable that both the inclination to use the weapon and the activity of the secretion of the gland may be limited to the breeding season, and that their purpose may be, like that of the antlers of deer and many similar organs, for combat among the males. In the young female the spur is present in a rudimentary condition, but it disappears in the adult of that sex. The platypus is aquatic in its habits, passing most of its time in the water or close to the margin of lakes and streams, swimming and diving with the greatest ease, and forming for the purpose of sleeping and breeding deep burrows in the banks, which generally have two orifices, one just above the water level, concealed among long grasses and leaves, and the other below the surface. The passage at first runs obliquely upwards in the bank, sometimes to a distance of as much as 50 feet, and expands at its termination into a cavity, the floor of which is lined with dried grass and leaves, and in which the eggs are laid and the young brought up. The food consists of aquatic insects, small crustaceans, and worms, which are caught under water, the sand and small stones at the bottom being turned over with the bill. The creatures appear at first to deposit what they have thus collected in their cheek pouches, and when these are filled they rise to the surface and quietly triturate their meal with the horny plates before swallowing it. Swimming is effected chiefly by the action of the broad forepaws, the hind feet and tail taking little share in locomotion in the water. When asleep they roll themselves into a ball, as shown in the figure. In their native haunts they are extremely timid and wary, and very difficult to approach, being rarely seen out of their burrows in the daytime. Mr. A. B. Crowther, who has supplemented the often quoted observations of Dr. Bennett upon the habits of these animals in confinement, says, "They soon become very tame in captivity. In a few days the young ones appeared to recognize a call, swimming rapidly to the hand paddling the water, and it is curious to see their attempts to procure a worm enclosed in the hand, which they greedily take when offered to them. I have noticed that they appear to be able to smell whether or not a worm is contained in the closed hand to which they swim, for they desisted from their efforts if an empty fist was offered. When irritated they utter a soft low growl, resembling that of a puppy." Family Echidnae. Cerebral hemispheres larger and well convoluted. Facial portion of skull produced into a long, tapering, tubular rostrum, at the end of which the anterior nares are situated. Rami of mandible slender, styliform. Opening of mouth small, and placed below the extremity of the rostrum. No teeth or laterally placed horny plates, though the palate and tongue are furnished with spines. Tongue very long, vermiform, slender, and protractile. Lining membrane of small intestine villus, but without transverse folds. Feet not webbed, but with long strong claws fitted for scratching and burrowing. The hinder feet with the ends of the toes turned outwards and backwards in the ordinary position of the animal when on the ground. Tail very short. Acetabulum with a large perforation, as in birds. Calcaneal spur and gland of the male much smaller than in Ornithorhynchus. Fur intermixed with strong, sharp-pointed spines. Terrestrial and fossorial in habits, feeding exclusively on ants, and recalling in the structure of the mouth and various other parts, relating to their peculiar mode of life the true anteaters of the order Edentata. The echidnas or spiny anteaters constitute a family which appears in some respects to be less specialized than the Ornithorhynchidae. According to Mr. O. Thomas, all the living forms may be included in two species, which, with some hesitation, are referred to two genera, Echidna and Proechidna, Acanthoglossus. Echidna, 35. In Echidna there are 5 toes, all of which are provided with claws, those of the forefoot being broad, slightly curved, and directed forwards, while the posterior ones are slender, more curved, and inclined outwardly. The beak is about as long as the rest of the head, and either nearly straight, or slightly curved upwards, while the palate is comparatively wide, and but slightly vaulted. The number of the vertebrae is C7, D16, L3, S3, Ca12. The one existing representative of the genus, E. aculeata, occurs in New Guinea, Tasmania, and Australia. So much variation is displayed by this animal, that it has been divided into several species, but the latest researches tend to show that these variations cannot be regarded as indicating more than races, of which there are 3 well-marked types. The first race, or variety, has been termed the Port Moresby echidna, and is only known from that Papuan locality. It is distinguished from the typical form by its smaller size, by the shorter spines on the back, which admit of the fur being seen, and by the more spinous covering of the head, belly, and limbs, as well as by the lighter skull and relatively larger beak. The typical variety is confined to the Australian mainland, and is of medium size. The spines of the back are very long and stout, often reaching a length of 2 inches, and almost completely concealing the hair. The color of these spines varies from yellow at the roots to black at the tips, but some may be altogether yellow. The hair of the back is black or dark brown in color, but it may be occasionally absent, or in the region of the loins may exceed the spines in length. The limbs and undersurface of the body are covered with dark brown hair, thinly interspersed with short spines, and the hair of the face is of the same general hue as that of the body. The skull has a slender rostrum and a flat and narrow braincase. In the third or Tasmanian race, which is confined to Tasmania, the average size is somewhat larger than in the typical form. The most characteristic feature is, however, the shortness of the spines of the back, which in the greater part of that region are almost or quite concealed by the hairs. The hairs of the back are dark brown, those of the undersurface and sides of the head being generally rather paler. There is often a white spot on the chest. Very frequently there is a difference in the proportionate lengths of the hinder claws from those of the typical race. In the skull the beak is comparatively short and stout, and the braincase large and wide. Echidnas are usually found in rocky districts, and more especially in the mountains. In a wild state they live mainly on ants. Specimens have been brought to this country and kept in the Zoological Society's gardens, and in captivity they will readily eat eggs, and bread and milk. They are able, however, to endure long fasts, an individual having been known to go without food for upwards of a month. These animals seem to be mainly of nocturnal habits, and if brought out during the daytime appear to be sluggish and stupid, crouching to the ground with the head between the legs, and thus presenting a mass of spines to an enemy. They burrow rapidly in soft ground, sinking directly downwards, and not going head forwards. A specimen placed on a large chest of earth containing plants reached the bottom in less than 2 minutes, and it is said that the muzzle assists in the work of burrowing. Figure 33. The three-toed echidna, Proechidna berejnii. From Gervais. Proechidna, 36, the one known representative of the genus Proechidna, figure 33, attains dimensions about equal to those of the largest race of Echidna aculeata. The skull is less depressed than in the latter, with the anterior portion of the palate very concave, and the deflected beak nearly twice the length of the remainder of the skull. As a rule, there are only 3 claws to each foot, but the first and fifth digits are represented by several phalanges, and one instance is known where there are 5 complete claws on the anterior and 4 on the posterior feet. There are 2 more vertebrae in the dorsal and lumbar region than in echidna. The head and body are covered with a thick coat of hair, among which there are a number of short spines in the region of the back, which are much less numerous than in the typical race of the last species. The color of the fur is generally dark brown or black, but the head may be almost white, and the spines are usually entirely white, although in certain cases they may be brown at the root. This species is known only from New Guinea, the recorded specimens being from the northwestern regions of that country. It inhabits rocky ground, and dwells chiefly in the mountains, the specimens which were first described having been obtained at an elevation of about 3,500 feet above the sea level. The Papuans capture it by digging trenches in the ground to a depth of about a yard, by which means they generally come upon its runs. Fossil species. Remains of a species of echidna of very much larger size than the existing forms have been obtained from the cave deposits of New South Wales, which appear to be of Pleistocene age. This species was named Echidna owini by the late Mr. Krefft, but was subsequently called E. ramsayi by Sir R. Owen. In referring this species to the genus Echidna, that term must be regarded as including Proechidna. Chapter 6. The subclass Metatheria or Didelphia. General characters. The Metatheria or Didelphia are represented at present by numerous species, presenting great diversities of general appearance, structure, and habits, although all united by many essential anatomical and physiological characters, which, taken all together, give them an intermediate position between the prototheria and the eutheria. Although the striking differences in external form, in many anatomical characters, and in mode of life of various animals of this section might lead to their division into groups equivalent to the orders of the eutheria, it is more convenient on the whole to adhere to the usual custom of treating them all as forming one order called Marsupialia, 37, the limits of which are therefore equivalent to that of the subclass. The more essentially distinctive characters are as follows. In the structure of the brain and the presence of epipubic bones they agree with the prototheria, while in the structure of the ear bones and the shoulder girdle and the presence of teats on the mammary glands they resemble the eutheria, the reproductive organs belonging to neither one nor the other type, but having a special character representing an intermediate grade of development. The ureters open into the base of the bladder. The oviducts are differentiated into uterine and fallopian portions, and open into a long and distinct vagina, quite separate from the cystic urethra. The penis is large, but its crura are not directly attached to the ischia. The spongy body has a large bifurcated bulb. The young are born in an exceedingly rudimentary condition, and are never nourished by means of an allantoic placenta, but are transferred to the nipple of the mother, to which they remain firmly attached for a considerable time, nourished by the milk injected into the mouth by compression of the muscle covering the mammary gland. They are therefore the most typically mammalian of the whole class. The nipples are nearly always concealed in a fold of the abdominal integument or pouch, marsupium, which serves to support and protect the young in their early helpless condition. Entering more fully into the characters of the subclass, which are also those of the order Marsupialia, it may be observed that the brain is generally small in proportion to the size of the animal, and the surface folding of the cerebral hemispheres, though well marked in the larger species, is never very complex in character, and is absent in the medium-sized and smaller species. The arrangement of the folding of the inner wall of the cerebrum differs essentially from that of all known eutheria, the hippocampal fissure being continued forward above the corpus callosum, which is of very small size. The anterior commissure is, on the other hand, greatly developed. Figure 34. Teeth of upper jaw of opossum, Didelphys marsupialis, all of which are unchanged, except the last premolar, the place of which is occupied in the young animal by a molariform tooth, represented in the figure below the line of the other teeth. The teeth are always divisible, according to their position and form, into incisors, canines, premolars, and molars, but they vary much in number and character in the different families. Except in the genus Phascolemys, the number of incisors in the upper and lower jaws is never equal. The true molars are very generally 4 in number on either side of each jaw. The chief peculiarity in the dentition lies, however, in the mode of succession. Thus there is no vertical displacement and succession of the teeth, except in the case of a single tooth on either side of each jaw, which is always the hindermost of the premolar series, and is preceded by a tooth having more or less of the characters of a true molar, see figure 34, this deciduous tooth being the only one comparable to the milk teeth of the diffeodont eutheria. In some cases, as in Podarus, this tooth retains its place and function until the animal has nearly, if not quite, attained its full stature, and is not shed and replaced by its successor until after all the other teeth of the permanent series, including the posterior molars, are fully in place and use. In others, as the thylacine, it is very rudimentary in form and size, being shed or absorbed before any of the other teeth have cut the gum, and therefore quite functionless. It must further be noted that there are some marsupials, as the wombat, Myrmecobius, and the dasyures, in which no such milk tooth, even in a rudimentary state, has yet been discovered, possibly in some cases from want of materials for observation at the right stage of development. Epipubic or marsupial bones are present in both sexes of nearly all species. In one genus alone, Thylacinus, they are not ossified. The number of dorso-lumbar vertebrae is always 19, although there are some apparent exceptions caused by the last lumbar being modified into a sacral vertebra. The number of pairs of ribs is nearly always 13. The tympanic bone remains permanently distinct. The carotid canal perforates the basa sphenoid. The lacrimal foramen is situated upon or external to the anterior margin of the orbit, and there are generally large vacuities in the bony palate. The angle of the mandible is, except in tarsips, more or less inflected. The hyoid bones have always a peculiar form, consisting of a small, more or less lozenge-shaped basohyoid, broad ceratohyals, with the remainder of the anterior arch usually unossified, and stout, somewhat compressed thyrohyals. There are 2 anterior venae cavae, 38, into each of which a vena azagus enters. In the male the testes are always contained in a scrotum, which is suspended by a narrow pedicle to the abdomen in front of the penis. The vasa deferentia open into a complete and continuous urethra, which is also the passage by which the urine escapes from the bladder, and is perfectly distinct from the passage for the feces, although the anus and the termination of the urethrosexual canal are embraced by the same sphincter muscle. The glans is often bifurcated anteriorly. In the female the oviducts never unite to form a common cavity or uterus, but open separately into the vagina, which at least for part of its course is double. The mammae vary much in number, but are always abdominal in position, having long teats, and in most of the species are more or less enclosed in a fold of the integument forming a pouch or marsupium, though in some this is entirely wanting, and the newly born, blind, naked, and helpless young, attached by their mouths to the teat, are merely concealed and protected by the hairy covering of the mother's abdomen. In this stage of their existence they are fed by milk injected into their stomach by the contraction of the muscles covering the mammary gland, the respiratory organs being modified temporarily, much as they are permanently in the cetacea, the elongated upper part of the larynx projecting into the posterior nares, and so maintaining a free communication between the lungs and the external surface independently of the mouth and gullet, thus averting the danger of suffocation while the milk is passing down the latter passage. Figure 35. Front view of skull of Sarcophilus ursinus, showing polyprotodont and carnivorous dentition, Court. Journ. Geology, SOC Vol 24. Page 313. Distribution. The existing species of marsupials are, with the exception of one family, the Didelphidae, limited in geographical distribution to the Australasian region, 39, forming the chief mammalian fauna of Australia, New Guinea, and some of the adjacent islands. The Didelphidae are almost purely neotropical, 1 or 2 species ranging northwards into the Nearctic region. Fossil remains of members of this family have also been found in Europe and America in strata of the Eocene and early Miocene periods, and it is probable that at least many of the polyprotodont Mesozoic mammals noticed in Chapter 4 are referable to the Marsupialia. Figure 36. Front view of skull of koala, Phascolarctos cinereus, showing diprotodont and herbivorous dentition, Court. Journ. Geology, SOC Volume 24. Page 313. Classification. In dividing the marsupials into minor groups, it may be observed that one of the most obvious distinctive characters among them is derived from the form and arrangement of the teeth. In certain species, as the possums, dasyurs, and thylacine, the incisors are numerous, small, and subequal in size, and the canines large, as in the typical placental carnivores, Figure 35. To these the term polyprotodont is applied, and they are all more or less carnivorous in their habits. In others the central incisors are very prominent, and the lateral incisors and canines absent or subordinate in function, Figure 36. These are called diprotodont, and they are all wholly or in great part vegetable feeders. In one group of these, the wombats, there are but 2 incisors above and the same number below, but all the others, including the kangaroos, koalas, and phalangers, have 2 functional incisors below and as many as 6 above, 3 on each side, but of these the first or central pair is the most fully developed. Some hesitation has frequently been expressed as to whether the polyprotodont and diprotodont types are entitled to constitute distinct primary groups, owing to the presence of syndactylism among the paramelidae in the former, as well as in the latter, but if Mr. O. Thomas is right in regarding this feature as acquired independently in the 2 groups we may safely adopt such a division. Taking various combinations into consideration, the existing marsupials readily group themselves into 6 very natural families, the leading characters of which may be summarized as follows. Order Marsupialia. A. Polyprotodontia. Incisors numerous, small, subequal. Canines larger than the incisors. Molars with sharp cusps. Alpha, incisors /4. Hind feet with the 4 outer toes subequal, distinct, and a well-developed opposable hallux. Didelphidae. Beta incisors/3. Hind feet with 4 outer toes distinct. Hallux small or rudimentary, rarely opposable. Dasyuridae. Gamma incisors/3. Hind feet long and narrow. 4th toe larger than the others. Hallux rudimentary or absent. 2nd and 3rd toes very slender, and united in a common integument, syndactylous. Paramelidae. B. Diprotodontia. Incisors not exceeding superscript 3/3, usually superscript 3/ but occasionally superscript 1/. Central, first, upper and lower incisors large and cutting. Upper canines generally, and lower invariably, absent or small. Molars with bluntly tuberculated or transversely ridged crowns. Alpha, teeth with persistent pulps. Incisors superscript 1/, large, scalpiform, with enamel on the outer surface only. No canines. Hind feet with 4 subequal outer toes, partially syndactylous, and with rudimentary hallux. Phascolomyidae. Beta, teeth rooted. 3 upper incisors and a canine. Hind limbs not disproportionately large. Feet syndactylous, broad, with 4 subequal outer toes, and a large opposable hallux. Phalangeridae. Gamma, teeth rooted. 3 upper incisors, and frequently a canine. Hind limbs disproportionately large, with syndactylous feet as in Paramelidae. Macropodidae. Suborder Polyprotodontia. The leading characters of this group are given in the foregoing schedule. This group is the only one represented at the present day, and so far as we know also in past epochs, beyond the confines of the Australasian region and adjacent islands. Family Didelphidae. Dentition, I/4, C superscript 1/ P superscript 3/3, M/4, total 50. Incisors very small and pointed. Canines large. Premolars with compressed pointed crowns. Molars with numerous sharp cusps. The last premolar preceded by a deciduous multicuspidate milk molar, which remains in place until the animal is nearly adult, figure 34. Limbs of moderate development, each with 5 complete and distinct toes, all of which are provided with short, compressed, curved, sharp claws of nearly equal size, except the first toe of the hind foot or hallux, figure 37, which is large, widely separable from the others, to which it is opposed in climbing, and terminates in a dilated rounded extremity, without a nail. Tail generally long, partially naked and prehensile. Stomach simple. Cecum of small or moderate size. Pouch generally absent, sometimes represented by 2 lateral folds of the abdominal integument, partially covering the teats, rarely complete. Vertebrae, C7, D13, L6, S2, C19 to 35. Figure 37. Skeleton of the right hind foot of the Virginian opossum, Didelphys marsupialis. The Didelphidae, or true possums, differ from all other existing marsupials in their habitat, being peculiar to the American continent. They are mostly carnivorous or insectivorous in their diet, and arboreal in habits. Possums occur throughout the greater part of the American continent, ranging from the United States to Patagonia, the greater number of species being found in the warmer regions. In South America the possums take the place of the eutherian insectivora, and the sharp cusps on their teeth are admirably adapted for crushing the insects on which they mainly subsist. Chironectes, 40. The family comprises 2 genera only, namely Didelphys, containing all the species, with the exception of the curious upoc, which forms by itself the genus Chironectes and is distinguished from all other possums by its webbed feet, non-tuberculated sawls, and peculiar coloration. Its ground color is light gray, with 4 or 5 sharply contrasted brown bands passing across its head and back, and thus giving it a very peculiar mottled appearance. It is almost wholly aquatic in its habits, living on small fish, crustaceans, and water insects. Its range extends from Guatemala to southern Brazil. Didelphys, 41. The type genus Didelphys is a very large one, containing, according to Mr. O. Thomas, 23 existing species. It may be divided into 5 groups, or subgenera, all of which have received distinct names. The typical group is represented only by the common or Virginian opossum, D. marsupialis, of which the numerous varieties have received separate specific names. This species is of large size, with a long, scaly, prehensile tail, and long bristle-like hairs mingled with the fur. The pouch is complete. It ranges over all temperate North America, and is also found in Central and tropical South America, where it is commonly known as the crab-eating opossum. This animal is extremely common, being even found living in the towns, where it acts as a scavenger by night, retiring for shelter by day upon the roofs of the houses or into the sewers. The female produces in the spring from 6 to 16 young ones, which are placed in her pouch immediately after birth, and remain there until able to take care of themselves. The second or metachirene group includes 3 species found all over the tropical parts of the New World. They are of medium size, with short close fur, very long, scaly, and naked tails, and less developed ridges on their skulls than in the type species. As a rule, there is no pouch adapted to carry the young, which commonly ride on their mother's back, holding on by winding their prehensile tails round hers. The philandering group is closely allied to the preceding, but is readily distinguished by the woolly hair, and the brown streak down the middle of the face. The woolly opossum, D. lanigera, which is represented in the accompanying woodcut, figure 38, carrying its young in the fashion mentioned above, is one of the 2 species of this group. In the fourth or mycourine group, the numerous species are all smaller than in the preceding groups, and have short and close hair, and no dark streak down the face. The best-known species is the murine opossum, D. murina, little larger than a house mouse, and of a bright red color, which is found as far north as central Mexico, and extends thence right down to the south of Brazil. The last or paramine group contains several extremely shrew-like species, of very small size, with short, hairy, and usually non-prehensile tails, not half the length of the trunk, and with wholly unridged skulls. The most striking member of the group is the 3-striped opossum, D. americana, from Brazil, which is of a reddish-gray color, with 3 clearly defined deep black bands down its back, very much as in some of the striped mice of Africa. Figure 38. The woolly opossum, Didelphys lanigera. The numerous fossil species of opossum found in the Upper Eocene and Lower Miocene of Europe are of especial interest from a distributional point of view, since they indicate how the possums of America may have been connected with the Australian marsupials. These forms were originally referred to Didelphys, but have been subsequently described as Paratherium and Amphiprotherium. The characters of the molar teeth on which these genera are based do not appear to be sufficiently important to justify their separation from Didelphys. Allied forms occur in the tertiaries of North America, which were originally described under the name of Herpetotherium, but have been subsequently referred to Paratherium. Remains of many of the existing species of opossum are found in a fossil condition in the Pleistocene cave deposits of Brazil. Family Dasyuridae dentition, I/3, see superscript 1/P and M numerous, variable. Incisors small, canines well developed, molars with pointed cusps. Limbs equal. 4 feet with 5 subequal toes terminating in claws. Hind feet with the 4 outer toes well developed, and distinct from each other and bearing claws, the first, or hallux, clawless, generally rudimentary, sometimes entirely wanting. Stomach simple. No cecum. Predatory carnivorous or insectivorous animals, inhabitants of Australia, Tasmania, and the southern parts of New Guinea and some of the adjacent islands. The aberrant genus Myrmecobius, though clearly a member of this family, is so sharply distinguished from all the others as to render a division into 2 subfamilies necessary. Figure 39. The thylacine, Thylacinus cynocephaly. Subfamily Dasyurinidae. This comprises the more typical Dasyuridae, in which the premolars and molars never exceed the normal number of 7 on either side of each jaw, and in which the tongue is not specially extensile. Thylacinus, 42, dentition, I/3, see superscript 1/P superscript 3/3, M/4 equals 46. Incisors small, vertical, the outer one and the upper jaw larger than the others. Summits of the lower incisors, before they are worn, with a deep transverse groove dividing them into an anterior and a posterior cusp. Canines long, strong, and conical. Premolars separated from one another by intervals, with compressed crowns, increasing in size from before backwards. True molars in general characters resembling those of Dasyurus, but of more simple form, the cusps being not so distinct nor sharply pointed. Milk molar very small, and shed before the animal leaves the mother's pouch. Humerus with an antepicondylar foramen. General form very dog-like. Head elongated. Muzzle pointed. Ears moderate, erect, triangular. Fur short and closely applied to the skin. Tail of moderate length, thick at the base and tapering towards the apex, clothed with short hair. Hallux, including the metacarpal bone, wanting. Vertebrae, C7, D13, L6, S2, C23. Marsupial bones represented only by small unossified fibrocartilages. The only known existing species of this genus, T. cynocephaly, figure 39, though smaller than a common wolf, is the largest predaceous marsupial at present living. It is now entirely confined to the island of Tasmania, although fragments of bones and teeth found in caves afford evidence that a closely allied species once inhabited the Australian mainland. The general color of the thylacine is grayish-brown, but it has a series of transverse black bands on the hinder part of the back and loins, whence the name of tiger frequently applied to it by the colonists. It is also called wolf, and sometimes, though less appropriately, hyena. Owing to the havoc it commits among the sheepfolds, it has been nearly exterminated in all the more settled parts of Tasmania, but still finds shelter in the almost impenetrable rocky glens of the more mountainous regions of the island. The female produces 4 young at a time. The pouch opens backwardly, and there are 4 mammae. The figure of the skull exhibits the peculiar dog-like form so characteristic of the genus. Figure 40. Right lateral aspect of the skull of the thylacine. Sarcophilus, 43, dentition, I/3, C superscript 1/ P superscript 2/2, M/4. Upper incisors nearly equal, and placed vertically, the first not differentiated from the rest. Premolars rounded and closely crowded between the canine and molars, with broad crowns, molars broad and heavy, the last one without a distinct hind talon. Form thick and powerful, head disproportionately large for the body, muzzle short and broad, ears broad and rounded, tail of moderate length, and evenly hairy. Hallux wanting, soles of feet naked, without defined pads. Humerus with antepicondylar foramen. This genus is now represented only by a single species, S. ursinus, found in Tasmania, where, from its ferocious and destructive habits, it is commonly known under the name of the devil. A front view of the skull is shown in figure 35. The prevailing color of this animal is black, and the size about equal to that of an English badger. Its habits are fossorial, and it is very destructive to sheep. On account of the similarity in the number of its teeth, this genus has been generally included in the next one, but in the structure of the teeth it is much nearer to Thylacinus. An extinct species is found in the Pleistocene deposits of the mainland of Australia. It may be observed that the 2 premolars missing from the typical series of 4 in this and the next genus are the second and the fourth milk molar being likewise absent. In Thylacinus and other polyprotodonts with 3 premolars it is the second that is missing. Dasyurus, 44, dentition, I/3, C superscript 1/ P superscript 2/2, M/4, total 42. Upper incisors nearly equal, and placed vertically, first slightly longer, narrower, and separated from the rest. Lower incisors sloping forwards and upwards. Canines large and sharply pointed. Premolars with compressed and sharp-pointed crowns, and slightly developed anterior and posterior accessory basal cusps. True molars with numerous sharp-pointed cusps. In the upper jaw the first 3 with crowns having a triangular oral surface, the 4th small, simple, narrow, and placed transversely. In the lower jaw the molars more compressed, with longer cusps, the 4th not notably smaller than the others. Form bivalent. Ears long and narrow, prominent, and obtusely pointed. Hallux rudimentary, or absent, its metatarsal bone always present. Tail long and well clothed with hair. Humerus without an antepicondylar foramen. Vertebrae, C7, D13, L6, S2, C18 to 20. The dasyurs are small civet-like animals with a gray or brown pelage profusely spotted with white. They are mostly inhabitants of the Australian continent and Tasmania, where in the economy of nature they take the place of the smaller predaceous carnivora, the cats, civets, and weasels of other parts of the world. They hide themselves in the daytime in holes among rocks or in hollow trees, but prowl about at night in search of the small living mammals and birds which constitute their prey. The species are not numerous, and include D. maculatus, about the size of a common cat, inhabiting Tasmania and the southern part of Australia, D. vivarinus, Tasmania and Victoria, D. geoffroy, nearly all Australia, D. halicatus, North Australia, D. albopunctatus, New Guinea. Remains referred to D. vivarinus occur in the Australian Pleistocene deposits. Phascologale, 45. This genus comprises a considerable number of small marsupials, none of them exceeding a common rat in size, differing from the dasyurs in possessing an additional premolar, the dentition being I/3, C superscript 1/P superscript 3/3, M/4, total 46, and having the teeth generally developed upon an insectivorous rather than a carnivorous pattern, the upper middle incisors being larger and inclined forwards, the canines relatively smaller, and the molars with broad crowns, armed with prickly tubercles. The muzzle is pointed. Ears moderately rounded and nearly naked. Feet broad and short. 4 feet with 5 subequal toes, having compressed, slightly curved, pointed claws. Hind feet with the 4 outer toes subequal, having claws similar to those in the 4 feet, the hallux always distinct and partially opposable, though small and nailless. Tail long, very variable in its covering, being either bushy, crested, or nearly naked. Pouch represented merely by a few folds of skin. Mammae varying from 4 to 10 in number. The food of these animals is almost entirely insects, some species pursuing their prey among the branches of trees, while others are purely terrestrial. They are found throughout Australia, and also in New Guinea and the Aru and some of the adjacent islands. P. cristocaudata, a species with a thick compressed tail ornamented upon its apical half with a crest of black hair, differs from the others by the very reduced size of the 4th premolar in the upper, and its complete absence in the lower jaw, thus forming an interesting transition in dentition towards Dasyurus. It constitutes the genus Chaetocercus of Krefft, but is included by Mr. O. Thomas in Phascologale, the frequent absence of the 4th lower premolar in P. thorbeckiana indicating that the total absence of this tooth in the known specimens of this species cannot be regarded as of generic importance. All the members of this and the 2 following genera can be at once distinguished from Dasyurus by the absence of white spots on the fur. Sminthopsis, 46. The genus Sminthopsis includes several small species allied to Phascologale but characterized by the narrowness of the hind foot, and by the soles of the feet being either granulated or hairy, instead of naked. Antechinamys, 47. The last genus of the Dasyurinae is Antechinamys, represented only by A. loniger of Queensland and New South Wales. This elegant little mouse-like creature, which has large oval ears and a long tail with the terminal part bushy, is distinguished from Sminthopsis by the absence of the hallux and the great elongation of the limbs. The tympanic bullae of the skull are also unusually large, with the mastoid portion much swollen. A full account of the habits and anatomy of this animal, which appears to be of very rare occurrence, is given in the Proc. Zoll SOC 1880, page 454. Subfamily Myrmecobionidae. Molars and premolars exceeding the normal number of 7 on each side. Tongue, long cylindrical, and extensile. Figure 41. Myrmecobius fasciatus. From Gould. Myrmecobius, 48, dentition, I/3, C superscript 1/P superscript 3/3, M/5 or /6, total 52 or 56, being the largest number of teeth in any existing marsupial. The distinction between the molars and premolars is founded not on a knowledge of the succession of the teeth, but on their form. The teeth are all small and, except the 4 posterior inferior molars, separated from each other by an interval. Head elongated, but broad behind. Muzzle long and pointed. Ears of moderate size, ovate, and rather pointed. 4 feet with 5 toes, all having strong, pointed, compressed claws, the second, third, and fourth nearly equal, the fifth somewhat, and the first considerably shorter. Hind feet with no trace of hallux externally, but the metatarsal bone present. Tail long, clothed with long hairs. Fur rather harsh and bristly. Female without any pouch, the young when attached to the nipples being concealed only by the long hair of the abdomen. Vertebrae, C7, D13, L6, S3, C23. A gland on the undersurface of the body just in advance of the sternum. Of this singular genus but one species is known, M. fasciatus, figure 41, found in western and southern Australia. It is about the size of an English squirrel, to which animal its long bushy tail gives it some resemblance, but it lives entirely on the ground, especially in sterile, sandy districts, feeding on ants. Its prevailing color is chestnut red, but the hinder part of the back is elegantly marked with broad, white, transverse bands on a dark ground. The special interest of this form lies in its apparent relationship to those Mesozoic mammals which possess a large number of true molars, see page 114, and it is suggested by Thomas that it may eventually be found advisable to include some of the latter in the present subfamily. Family Paramelidae. Dentition, I/3, C superscript 1/P superscript 3/3, M/4, total 46 or 48. Upper incisors small, with short broad crowns. Lower incisors moderate, narrow, proclivus. Canines well developed. Premolars compressed, pointed. Molars with quadrate tuberculated crowns. Fourth premolar preceded by a small molariform tooth, which remains in place until the animal is nearly full grown. 4 feet with 2 or 3 of the middle toes of nearly equal size, and provided with strong, sharp, slightly curved claws, the other toes rudimentary. Hind feet long and narrow, the hallux rudimentary or absent, the second and third toes very slender, and united in a common integument, the fourth very large, with a stout elongated conical claw, the fifth smaller than the fourth, see figure 43. The ungual phalanges of the large toes of both feet cleft at their extremities, as in Manus among the Edentata, but in no other marsupials. Head elongated. Muzzle long, narrow, and pointed. Stomach simple. Cecum of moderate size. Pouch complete, opening backwards. Alone among marsupials they have no clavicles. The Paramelidae form a very distinct family, in some respects intermediate between the Sarcophagus dasyuridae and the Phytophagus macropodidae. In dentition they resemble the former, but they agree with the latter in the peculiar structure of the hind feet. In the construction of the 4 feet they differ from all other marsupials. The bandicoots, as these marsupials are popularly termed, are of fossorial habits, and subsist either on an insectivorous or omnivorous diet. It has been generally considered that their syndactylous feet indicate direct affinity with the diprotodonts, but owing to the essentially polyprotodont character of the organization, which extends even to their carpal and tarsal bones, Thomas dissents from this view, and concludes that their syndactylism is an independently acquired character, and that they are really a direct offshoot from the dasyuridae. Some individuals are remarkable for the presence of a longitudinal groove in the root of the canines, by which feature they approximate to some of the Mesozoic polyprotodont forms. They may be divided into 3 genera. Figure 42. Parameles gunni. From Gould. Parameles, 49, anterior and posterior extremities not differing greatly in development. 4 feet with the 3 middle toes well developed, the third slightly larger than the second, the fourth somewhat shorter, provided with long, strong, slightly curved, pointed claws. First and fifth toes very short and without claws. Hind feet with hallux of 1 or 2 phalanges, forming a distinct tubercle visible externally, the second and third toes very slender, of equal length, joined as far as the ungual phalanges, but with distinct claws, the fifth intermediate in length between these and the largely developed fourth toe. Ears of moderate or small size, ovate, pointed. Tail rather short, clothed with short adpressed hairs. Fur short and harsh. Vertebrae, C7, D13, L6, S1, C17. Skull long and narrow, with the bulla single, and its mastoid portion not inflated. The animals of this genus are all small, and live entirely on the ground, making nests composed of dried leaves, grass, and sticks in hollow places. They are rather mixed feeders, but insects, worms, roots, and bulbs constitute their ordinary diet. The various species are widely distributed over Australia, Tasmania, New Guinea, and several of the adjacent islands, as Aru, K, and New Ireland. The best known are P. gunny, Figure 42, Bougainvillei, Nasuta, Obesula, and Macrura from Australia, and P. doriana, Raffrayana, and Longicaudata from New Guinea. Remains apparently referable to existing species are found in the cave deposits of New South Wales. Paragale, 50, molar teeth curved, typically with longer crowns and shorter roots than in the last. Hinder extremities proportionally longer, and hallux without claw. Muzzle much elongated and narrow. Fur soft and silky. Ears very large, long, and pointed. Tail long, its apical half clothed on the dorsal surface with long hairs which form a crest. Vertebrae, C7, D13, L6, S2, C23. Skull distinguished from that of parameles by the large size and double structure of the auditory bulla, of which the mastoid portion is inflated. There is also an abrupt contraction of the muzzle at the third premolar. The type species of rabbit bandicoot, P. lagotis, as these animals are called, is found in Western Australia, and also occurs fossil in the cave deposits of New South Wales. It is the largest member of the family, being about the size of the common rabbit, to which animal it bears sufficient superficial resemblance to have acquired the name of native rabbit from the colonists. It burrows in the ground, but in other respects resembles the true bandicoots in its habits. The smaller P. leucura has short-crowned molars, with distinct cusps, which are almost obsolete in the type species. Figure 43. Skeleton of right hind foot of Coerpus castanotis. C. Calcaneum, A. Astragalus, CB, cuboid, N. Navicular, C. Superscript 3, ectocuneiform, 2 and 3, the conjoined second and third digits, 4, the large and only functional digit, B, the rudimentary fifth digit. Coerpus, 51, dentition generally resembling that of parameles, but the canines are less developed, and in the upper jaw two-rooted. Limbs very slender, posterior nearly twice the length of the anterior. 4 feet with the functional toes reduced to 2, the second and third, of equal length, with closely united metacarpals and short, sharp, slightly curved, compressed claws. First toe represented by a minute rudiment of a metacarpal bone, the fourth by a metacarpal and 2 small phalanges without a claw, and not reaching the middle of the metacarpal of the third, fifth entirely absent. Hind foot, Figure 43, long and narrow, mainly composed of the strongly developed fourth toe, terminating in a conical pointed nail, with a strong pad behind it, the hallux absent or represented by a rudimentary metatarsal, the remaining toes completely developed, and with claws, but exceedingly slender, the united second and third reaching a little way beyond the metatarsophalangeal articulation of the fourth, the fifth somewhat shorter. Tail not quite so long as the body, and covered with short hairs forming a slight crest. Ears large and pointed, and folded down when the animal is at rest. Fur soft and loose. Vertebrae, C7, D13, L6, S1, C20. Skull short and wide, with a small and single bulla, and a contraction of the muzzle at the third premolar. The only known species of this genus, Figure 44, chiefly remarkable for the singular construction of its limbs, is an animal about the size of a small rat, found in the interior of the Australian continent. Its general habits and food appear to resemble those of the other Paramelidae. It was first described as C. ecaudatus by Ogilby from a mutilated specimen, but the specific name was afterwards changed, as being inappropriate, by Gray to castanotis. Suborder Diprotodontia. For the leading characters of this group, see page 132. Family Phascolomyidae. Dentition, see superscript 1/I/P superscript 1/M/4 equals 24. All the teeth with persistent pulps. The incisors large, scalpiform, with enamel only on the front surface, as in the rodentia. The molars strongly curved, forming from the base to the summit about a quarter of a circle, the concavity being directed outwards in the upper and inwards in the lower teeth. The first of the series, or premolar, appears to have no milk predecessor, and is single-lobed, the other four composed of two lobes, each subtriangular in section. Limbs equal, stout, and short. 4 feet with 5 distinct toes, each furnished with a long, strong, and slightly curved nail, the first and fifth considerably shorter than the other 3. Hind feet with a very short nailless hallux, the second, third, and fourth toes partially united by integument, of nearly equal length, the fifth distinct and rather shorter, all 4 provided with long and curved nails. In the skeleton of the foot, the second and third toes are distinctly more slender than the fourth, showing a slight tendency towards the peculiar character so marked in the next 2 families. Tail rudimentary. Stomach simple, provided with a special gland situated near the cardiac orifice. Cecum very short, wide, and with a peculiar vermiform appendage. Pouch present. The auditory bullae of the skull are imperfect, open behind, with their anterior wall formed by a descending process of the squamosal, instead of the allospheноid. Masseteric fossa of mandible with a perforation and a deep pit. Figure 44. Coeripus castanotis. From Gould. Phascolemys, 52. The existing wombats, figure 45, comprise 3 species, all of which are included in the one genus Phascolemys, and all of which date from the Pleistocene. In the typical group we find the following characters. Fur rough and coarse. Ears short and rounded. Muffle naked. Postorbital process of the frontal bone obsolete. Ribs 15 pairs. Vertebrae, C7, D15, L4, S4, C10 to 12. The wombat of Tasmania and the islands of Bass's Straits, P. ursinus, and the closely similar but larger animal of the southern portion of the mainland of Australia, P. michelli, belong to this group. Figure 45. Common wombat, Phascolemys ursinus. In the second group the characters are as follows. Fur smooth and silky. Ears large and more pointed. Muffle hairy. Frontal region of skull broader than in the other group, with well-marked postorbital processes. Ribs 13. Vertebrae, C7, D13, L6, S4, C15 to 16. One species, P. latifrons, the hairy-nosed wombat of southern Australia. In their general form and actions the wombats resemble small bears, having a somewhat similar shuffling manner of walking, but they are still shorter in the legs, and have broader, flatter backs than bears. They live entirely on the ground, or in burrows or holes among rocks, never climbing trees, and feed entirely on grass, roots, and other vegetable substances. They sleep during the day, and wander forth at night in search of food, and are shy and gentle in their habits generally, though they can bite strongly when provoked. The only noise the common wombat makes is a low kind of hissing, but the hairy-nosed wombat is said to emit a short quick grunt when annoyed. The prevailing color of the last-named species, as well as of P. ursinus of Tasmania, is a brownish-gray. The large wombat of the mainland is very variable in color, some individuals being found of a pale yellowish-brown, others dark gray, and some quite black. The length of head and body is about 3 feet. It is noteworthy that P. michelli was first described from the evidence of fossil remains, the living form subsequently described as P. platyrhinus being found to be indistinguishable. Other extinct species occur in the Pleistocene of Australia. Phascolenus, 53, remains of a large extinct wombat, which must have nearly equaled the dimensions of a tapir, occur in the Pleistocene of Queensland, and have been described as Phascolenus. It is probable that the expanded and flattened upper incisors from the same deposits upon the evidence of which the presumed genus Supernodon was founded, are likewise referable to the same form. The characters of both the upper and lower incisors distinguish Phascolenus from Phascolemys. Family Phalangeridae. Dentition extremely variable, owing to the presence of minute rudimental teeth not constant in the same species, or even in the 2 sides of the jaws of the same individual, exclusive, however, of tarcypes, the formula I superscript 3/ C superscript 1/ P superscript 2 superscript 3/2, M superscript 3/34 represents fairly the general condition of the functional teeth. First incisors long and stout, the lower pair very large and pointed, but without the scissor-like action found in the existing Macropodidae. Second and third lower incisors minute and probably functionless. Fourth premolar generally secant, milk molar generally minute and deciduous at an early period. Molars either with sharp cutting crests or bluntly tuberculate, fourth sometimes absent. Mandible without pit, and at most a very minute perforation in the masseteric fossa. Limbs subequal. 4 feet with 5 distinct, subequal toes, furnished with claws. Hind feet short and broad, with 5 well-developed toes, the hallux large, nailless and opposable, the second and third slender, and united by a common integument as far as the claws. Tail generally long, and frequently more or less prehensile. Stomach simple. Cecum present, except in tarcypes, and usually large. Pouch complete. Animals of small or moderate size and arboreal habits, usually feeding on a vegetable or mixed diet, inhabiting Australia and the Papuan Islands. The homologies of the lower functionless teeth between the first incisor and fourth premolar are very difficult to determine, but it is probable that one represents a canine only when the largest known number is present, this tooth, according to Mr. Thomas, being the first to disappear. Phalangers are small woolly-coated animals, with long, powerful, and often prehensile tails, large claws, and, as in the American possums, with opposable nailless great toes. Their expression seems in the day to be dull and sleepy, but by night they appear to decidedly greater advantage. They live mostly upon fruit, leaves, and blossoms, although some few feed habitually upon insects, and all relish, when in confinement, an occasional bird or other small animal. Several of the phalangers possess flying membranes stretched between their fore and hind limbs, figure 48, by the help of which they can make long and sustained leaps through the air, like the flying squirrels, but it is interesting to notice that the possession of these flying membranes does not seem to be any indication of special affinity, the characters of the skull and teeth sharply dividing the flying forms, and uniting them with other species of the non-flying groups. Their skulls, figure 47, are as a rule broad and flattened, with the posterior part swollen out laterally, owing to the numerous air cells situated in the substance of the squamosal. The phalangers are interesting from an historical point of view, since the gray cuscus, Phalanger orientalis, was the first of the marsupials of the Eastern Hemisphere brought to the notice of Europeans, having been described in a work published at Leiden in 1611, from an account of a specimen seen at Amboina during the third expedition of Admiral van der Hagen. The present family corresponds to the Dasyuridae among the polyprotodonts as presenting, on the whole, the most generalized types of the suborder. The existing forms may be divided into 3 subfamilies. Subfamily Tarsipedinidae, cheek teeth almost rudimentary and variable in number. Tongue long, slender, pointed, and very extensile. Tail long. Cecum absent. Figure 46. Tarcypes rostratus. From Gould. Tarcypes, 54, so named from some supposed resemblance of its foot to that of the Lemurin genus Tarsius, but it must be remarked that it has none of the peculiar elongation of the calcaneum and navicular so characteristic of that genus. Head with elongated and slender muzzle. Mouth opening small. The 2 lower incisors are long, very slender, sharp-pointed, and horizontally placed. All the other teeth are simple, conical, minute, and placed at considerable and irregular intervals apart in the jaws, the number appearing to vary in different individuals and even on different sides of the same individual. The formula, in a specimen in the Museum of the Royal College of Surgeons, is I superscript 2/C superscript 1/P and M superscript 3/2 on one side, and /3 on the other, total 20. Rami of the mandible extremely slender, nearly straight, and without coronoid process or inflected angle. 4 feet with 5 well-developed toes, furnished with small, flat, scale-like nails, not reaching to the extremity of the digits. Hind feet rather long and slender compared with those of the Phalangerini, having a well-developed opposable and nailless hallux, second and third digits syndactylous, with sharp compressed curved claws, the fourth and fifth free, and with small flat nails. Ears of moderate size and rounded. Tail longer than the body and head, scantily clothed with short hairs, prehensile. Vertebrae, C7, D13, L5, S3, C24. Of this singular genus but one species, T. rostratus, figure 46, is known, about the size of a common mouse. It inhabits Western Australia, lives in trees and bushes, uses its tail in climbing, and feeds on honey, which it procures by inserting its long tongue into the blossoms of melaleuca, etc. One kept in confinement by Mr. Gould was also observed to eat flies. Subfamily Phalangerini. Teeth normal. One or more rudimentary teeth between the upper canine and fourth premolar, and between the first lower incisor and fourth premolar. Tongue of ordinary structure. No cheek pouches. Stomach and ascending colon simple. Cecum long, simple. Tail well developed, generally prehensile. A numerous group of animals, varying from the size of a mouse to that of a large cat, arboreal in their habits, and abundantly distributed throughout the Australian region. The members of this group are the typical representatives of the family, and are commonly known to the colonists as possums. Phalanger, 55. The typical genus Phalanger, cuscus, presents the following characters. No flying membrane, size large or medium, and build stout and clumsy, fur thick and woolly. Ears short or medium, hairy externally, and in some cases also internally. Toes of 4 feet subequal, their relative lengths in the order 4, 3, 5, 2, 1. Claws long, stout, and curved. Soles of feet naked and striated, with large ill-defined pads. Tail stout and markedly prehensile, with the proximal half furred like the body, and the terminal portion entirely naked. For mammy. Skull, figure 47, stout and strong, with large vacuities in the hinder half of the palate, and the auditory bully thick and inflated. Dentition usually I superscript 3/2, C superscript 1/P superscript 3/3, M/4. First upper incisor with nearly circular section, or only slightly flattened in front, canine more or less closely approximated to third incisor, which is very small, and situated partly in front of the suture between the premaxilla and maxilla. Fourth premolar large, secant, and placed obliquely to line of molars. Molars four-cusped, with the inner cusps of the upper ones crescentoid, and imperfect transverse ridges connecting each pair of cusps. Figure 47. Left lateral view of skull of gray cuscus, Phalanger orientalis. After Peters. The cuscus are curious sleepy-looking animals, inhabiting the various islands of the East Indian archipelago as far west as Celebes, and being the only marsupials found west of New Guinea. As already noted, it was a member of this genus, the gray cuscus, P. orientalis, a native of Amboina, Timor, and the neighboring islands, which was the first Australasian marsupial known to European naturalists. There are altogether 5 species known, all of about the size of a large cat. Their habits resemble those of other phalangers, except that they are said to be somewhat more carnivorous. Trichoceros, 56. The members of the genus Trichoceros are of relatively large size, and are distinguished from phalanger by the following characters. Ears more or less hairy behind. Relative lengths of toes of 4 feet in the order 4, 3, 2, 5, 1. Hair on the soles of the hind feet beneath the heel, but not elsewhere. Tail thick, not tapering, covered with bushy hair up to the extreme tip, which is naked, but with a naked strip on the inferior surface in the distal third or half. A gland on the chest. Dentition usually I superscript 3/2, C superscript 1/P superscript 2/2, M/4. Upper incisors of nearly uniform length, the first much flattened in front. Canine situated some distance behind the third upper incisor, which it scarcely exceeds in size. Last premolar and molars very similar to those of phalanger. The true phalangers comprise 2 species, of which the best known is the vulpine phalanger, T. vulpecula, so common in zoological gardens, where, however, it is seldom seen, owing to its nocturnal habits. It is of about the size and general build of a small fox, whence its name. In the typical variety the color is gray, with a yellowish-white belly, white ears, and a black tail. This variety is a native of the greater part of the continent of Australia, but is replaced in Tasmania by the closely allied brown phalanger, var. fuliginosa. Its habits are very similar to those of the yellow-bellied flying phalanger, Ptoris australis, described below, except that it is unable to take the flying leaps of that animal. Like all the other phalangers, its flesh is freely eaten both by the natives and the lower class of settlers. Pseudochirus, 57. The genus Pseudochirus agrees with the preceding in the absence of a flying membrane, and presents the following leading characters. Size large or medium. Fur comparatively short and woolly. Ears medium or short, hairy behind, although seldom closely furred over all this aspect. Claws medium. Fur toes subequal, the first two distinctly opposable to the other three. Soles of feet naked, with large, striated, round pads, and hair beneath the heels. Tail tapering, markedly prehensile, with its distal third and the whole of the undersurface short-haired, tip naked underneath for a short distance. For mammy. No gland on chest. Skull with larger nasals than in the preceding genera, the posterior part of the palate in most cases fully ossified, and the auditory bully generally somewhat inflated. Dentition, at most, I superscript 2 superscript 3/2, C superscript 1/P superscript 3/3, M/4. Upper teeth nearly uniform in length, but the first incisor distinctly longer than second. Upper premolars variable. Molars with both inner and outer cusps distinctly crescentoid, and recalling those of the solenodont artiodactyl ungulates. Range. Tasmania, Australia, and New Guinea. There are about 10 species of this genus known, of which the commonest is Cook's ring-tailed phalanger, Pseudochirus peregrinus, an animal discovered by Captain Cook during his first voyage, at Endeavour River, North Queensland. The complex and subsolenodont character of the molars of this and the following genus readily distinguish them from the more typical phalangers, and show an approximation to the type of dentition prevailing in Phascolarctos, according, however, to Mr. O. Thomas, a tendency towards the same structure is observable in unworn molars of young cuscus. The genus may be divided into 3 groups, of which the first, as typified by the common P. peregrinus, is restricted to Australia and Tasmania, while the third, as represented by P. canescens, is only found in New Guinea. P. albertesi may be taken as the type of the second group, which is represented by that species in New Guinea, and by P. archeri in Queensland. With the exception of P. peregrinus, the species have a more or less restricted range. Remains of Pseudochirus, probably referable to existing species, are found in the cave deposits of New South Wales. Pteroids, 58, with the genus Pteroids, containing only the single species P. volans, we come to the first of the flying phalangers, characterized by the possession of a living membrane along the flanks. The characters of this genus are as follows. Size large. Fur very long and silky. Ears large and oval, thickly furred on the back, but naked internally. Flying membrane reaching from wrist to ankle, but very narrow along the sides of the forearm and lower leg. Fur toes subequal, their relative lengths in the order 4, 3, 5, 2, 1. Claws long, curved, and sharp. Tail long, cylindrical, and bushy, except near its tip, where it is naked and prehensile. Skull short and broad, with the nasals short, and not extending nearly as far forwards as the premaxilla. Large vacuities in hinder part of palate. Auditory bully inflated and smooth. Dentition usually I superscript 3/2, C superscript 1/P superscript 2/2, M/4. General characters of teeth very similar to those of Pseudochirus, but the first upper incisor scarcely longer than the second. The single species is found in Australia, from Queensland to Victoria, and is commonly known as the Tagwin flying phalanger. The structure of the skull and teeth indicates close affinity with Pseudochirus, although the external form is widely different in the two genera. This phalanger seems, indeed, to be, so to speak, a very specialized Pseudochirus, in which the teeth have become somewhat further diminished and the flying membrane has been developed. Dactylopsila, 59. The genus Dactylopsila is one of the forms without any trace of a flying membrane, its characters being as follows. Size medium. Body striped black and white. Ears oval, nearly naked at the ends. For toes of very unequal length, the fourth being enormously elongated, fourth and fifth toes of PES also markedly elongated. Claws long, moderately curved. Tail long, cylindrical, and evenly bushy, with the extremity more or less naked below. Skull narrow, but with the zygomatic arches greatly expanded, palate fully ossified. Dentition, I superscript 3/3, C superscript 1/P superscript 3/2, M/4. Upper incisors very large, the third being directed horizontally forwards, canine small and approximated to the third incisor, which it resembles. The fourth premolar of moderate size, with its longer axis placed obliquely. First lower incisor longer than in any other genus. Molars oblong, with 4 cusps. The typical D. trivirgata, or striped phalanger, inhabits the Papuan and North Australian subregion, a second species, D. palpator, characterized by the still greater elongation of the fourth finger, occurring in South New Guinea. These animals are said to be of insectivorous habits, the elongated fourth finger, as in the analogous instance of the lemuroid genus Chiromes, being apparently specially adapted for extracting insects and larvae from their hiding places. Petaurus, 60, size medium or small. Fur very soft and silky. A broad flying membrane extending from the outer side of the fifth digit of the manus to the ankle. Fur toes usually increasing regularly in length from the first to the fifth, but in some of the smaller species the fourth is the longest. Claws strong, sharp, and much curved. Tail long, evenly bushy to the extremity. Glands on the chest and between the ears. Skull short and wide, with the nasals expanded posteriorly, and usually 2 small palatal vacuities near the second molars. Auditory bully inflated, and variable in size. Dentition, I superscript 3/2, C superscript 1/P superscript 3/3, M/4. First upper incisors very large, and taller than canine. Molars with square crowns rounded at the angles, and 4 cusps, except in the last, which is triangular. This genus, which ranges from New Ireland to South Australia, but is not found in Tasmania, contains 3 species, the largest of which is the yellow-bellied flying phalanger, P. australis, whose habits are recorded by Mr. Gould as follows. This animal is common in all the brushes of New South Wales, particularly those which stretch along the coast from Port Phillip to Moreton Bay. In these vast forests trees of one kind or another are perpetually flowering, and thus offer a never-failing supply of the blossoms upon which it feeds. The flowers of the various kinds of gums, some of which are of great magnitude, are the principal favorites. Like the rest of the genus, it is nocturnal in its habits, dwelling in holes and in the spouts of the larger branches during the day, and displaying the greatest activity at night while running over the small leafy branches, frequently even to their very extremities, in search of insects and the honey of the newly opened blossoms. Its structure being ill-adapted. For terrestrial habits, it seldom descends to the ground except for the purpose of passing to a tree too distant to be reached by flight. When chased, or forced to flight, it ascends to the highest branch and performs the most enormous leaps, sweeping from tree to tree with wonderful address. A slight elevation gives its body an impetus which, with the expansion of its membrane, enables it to pass to a considerable distance, always ascending a little at the extremity of the leap. By this ascent the animal is prevented from receiving the shock which it would otherwise sustain. A second species, P. sciureus, in some ways one of the most beautiful of all mammals, has been chosen for the accompanying woodcut. Gymnobolidius, 61, like Petaurus in every respect, but without any trace of a flying membrane, and with the fifth digit of the manus slightly shorter than the third. This genus is represented only by G. Leadbeaterii of Victoria, and according to Mr. Thomas, may be regarded as the primitive form from which the specialized Petaurus has been developed. Figure 48, Squirrel flying phalanger, Petaurus sciureus. Dermitia, 62, size small, and general appearance dormouse-like. Ears large and thin, almost naked, and without internal or basal tufts. No flying membrane. Digits of normal proportions, the relative lengths of those of the manus in the order 3, 4, 2, 5, 1, 4. Claws rudimentary, hind ones long and sharp. Tail mouse-like, cylindrical, furry at base, the remainder scaly, with fine hairs, except at the tip, which is naked and prehensile. Skull short and broad, with the hinder part of the palate incomplete, and the auditory bully large, much inflated, and transparent. Dentition, I superscript 3/2, C superscript 1/ P superscript 3/3, M superscript 3/3/4. First upper incisor spatulate, and much longer than either of the others. Canine large, placed at some distance behind the third incisor. Molars, except the last, with evenly rounded crowns, carrying 4 small smooth cusps. This genus, which occurs in New Guinea, Western Australia, and Tasmania, is represented by 4 species. It seems to be intermediate between Petaurus and acrobats, and it has apparently had to yield place to those more highly organized types in regions where they have come in contact with one another. Distoecurus, 63, size small. Ears rather short, thinly covered with hair, but with small tufts at the base. No flying membrane. Digits of normal proportions, without expanded terminal pads. Claws curved and sharp. Tail, skull, and dentition as in acrobats, with the exception that the 4th premolar is small in the upper, and absent in the lower jaw. The one species of feather-tailed phalanger, D. pinnatus, is found in New Guinea. Acrobats, 64, size very small. Ears moderate, thinly covered with hair, but with small tufts round the base and on the internal prominences. A narrow flying membrane, fringed with long hairs, running from the elbow to the flank, and from the latter to the knee. For mammy. Digits furnished with expanded and striated terminal pads, the relative length of those of the manus being in the order 4, 3, 5, 2, 1. Claws sharp, although somewhat concealed by the terminal pads. Tail short-haired above and below, with a broad fringe on either side. Skull short, wide, and depressed. Posterior portion of palate very imperfectly ossified, anterior palatal vacuities almost confined to the maxillae. Auditory bully low, rounded, and but slightly prominent. Dentition, I superscript 3/2, C superscript 1/ P superscript 3/3, M superscript 3/3. Teeth sharp, and of an insectivorous type. Upper canine long, and approximated to third incisor. The 3 upper premolars large, functional, and taller than the molars. Molars small and rounded, with smooth unridged cusps. There is only one species in this genus, the beautiful little pygmy flying phalanger, A. pygmaeus, not so big as a mouse, which is found in Queensland, New South Wales, and Victoria, and feeds on the honey it abstracts from flowers, and on insects. Its agility and powers of leaping are exceedingly great, and it is said by Mr. Gould to make a most charming little pet. Subfamily Phascolarctonidae. Teeth large, normal, no rudimentary premolars before the last upper premolar, or any teeth between the first lower incisor and 4th premolar. Tongue of ordinary structure. Distinct cheek pouches. Stomach with a special gland near the cardiac orifice. Cecum very long, and, with the upper portion of the colon, dilated and provided with numerous longitudinal folds of mucous membrane. In many anatomical characters, especially the possession of a special gastric gland, this group resembles the Phascolomyidae, 65, figure 49. Skeleton of right hind foot of koala, Phascolarctos cinereus, showing the stout opposable hallux, followed by 2 slender toes, which in the living animal are enclosed as far as the nails in a common integument. Phascolarctos, 66, dentition, I superscript 3/ C superscript 1/ P superscript 1/ M/4, total 30. Upper incisors crowded together, cylindroidal, the first much larger than the others, with a beveled cutting edge, figure 36. Canine very small, a considerable interval between it and the premolar, which is as long from before backwards but not so broad as the true molars, and has a cutting edge, with a smaller parallel inner ridge. The molars slightly diminishing in size from the first to the 4th, with square crowns, each bearing 4 pyramidal cusps, with curved ridges radiating from them, and having a structure very similar to these of Pseudochirus. The lower incisors are semiproclivus, compressed and tapering, beveled at the ends. Premolars and molars in continuous series, as in the upper jaw. Milktooth very minute, and almost functionless. 4 feet with the 2 inner toes slightly separated from and opposable to the remaining 3, all with strong, curved, and much compressed claws. Hind foot, figure 49, with the hallux placed very far back, large and broad, the second and third, united, toes considerably smaller than the other 2, the fourth the largest. No external tail. Fur dense and woolly. Ears of moderate size, thickly clothed with long hairs. Vertebrae, C7, D11, L8, S2, C8. Ribs 11 pairs, a rare exception to the usual number, 13, in the Marsupialia. There is but one species, the koala or native bear of the Australian colonists, P. cinereus, an animal of comparatively large size and heavy build, figure 50, found in the southeastern parts of the Australian continent. It is about 2 feet in length, and of an ash-gray color, an excellent climber, and residing generally in lofty eucalyptus trees, on the buds and tender shoots of which it feeds, though occasionally descending to the ground in the night. Extinct phalangeroids. Numerous imperfect remains recently described by Davis are regarded as indicating large extinct types of phalangeridae, but further evidence is required before all these determinations can be definitely accepted. Thus part of an upper jaw is provisionally referred to a large species of Pseudochirus, while part of a scapula is made the type of a genus Archazonuris which appears to be allied to the former. Another fragmentary scapula is considered to indicate a large phalanger. Finally, part of a fibula, described under the name of Koalamus, is regarded as affording evidence of the former existence of a large ancestral form allied to the koala, and it is suggested that an upper jaw with teeth may belong to the same or an allied type. Figure 50. The koala, Phascolarctos cinereus. From Sclater, Proc. Zoll. SOC 1880, page 355. Thylacoleo, 67, dentition of adult, I superscript 3/ C superscript 1/ P superscript 3/3, M superscript 1/2, total 28. First upper incisor much larger than the others, canine and first 2 premolars rudimentary. In the lower jaw the 2 small anterior premolars are functionless, and often deciduous, posterior premolars of both jaws formed on the same type as those of Podarus, but relatively much larger, true molars rudimentary, tubercular. One species, T. carnifex. This animal presents a most anomalous condition of dentition, the functional teeth being reduced to 1 pair of large cutting incisors situated close to the median line, and 1 great, trenchant, compressed premolar, on each side above and below. It was first described as a carnivorous marsupial, and named, in accordance with its presumed habits, as one of the fellest and most destructive of predatory beasts, but, as its affinities are certainly with the Phalangeridae and Macropodidae, and its dentition completely unlike that of any known predaceous animal, this view has been called in question. Figure 51. Front view of skull of Thylacoleo carnifex, restored. Superscript 1/3 natural size. From Quart. Journ. Geology, SOC Volume 24. Page 312. The dentition is nearer to that of the existing Phalangeridae than to that of the Macropodidae, and the genus may be provisionally regarded as the type of a distinct subfamily of the former. Family Macropodidae. Dentition I superscript 3/ C superscript 1/ P superscript 2/2, M/4. Incisors sharp in cutting, those of the lower jaw frequently having a scissor-like action against one another, upper canine, if present, small. Penultimate premolar shed with the 4th milk molar, which is molariform and long persistent. Molars wide, and either transversely ridged or bluntly tuberculate. Premolars and molars moving forwards in the skull as the age of the animal increases, this being most marked in the larger species. Masseteric fossa of mandible hollowed out below into a deep cavity walled in externally by a plate of bone, and communicating with the inferior dental canal by a large foramen. Hind limbs usually larger than the anterior ones, and progression generally saltatorial. 4 feet with 5 digits, hind feet syndactylous, the 4th digit being very large and strongly clawed, hallux usually absent. Tail generally long and hairy, occasionally prehensile, stomach sacculated. pouch large and opening forwards. Figure 52. Skeleton of right hind foot of kangaroo. The Macropodidae or kangaroos, taken as a whole, form a very well-marked family, easily distinguished from the other members of the suborder by their general conformation, and by peculiarities in the structure of their limbs, teeth, and other organs. They vary in size from that of a sheep down to a small rabbit. The head, especially in the larger species, is small, compared with the rest of the body, and tapers forward to the muzzle. The shoulders and fore limbs are feebly developed, and the hind limbs usually of disproportionate strength and magnitude, which gives them a peculiarly awkward appearance when moving about on all fours, as they occasionally do when feeding. Rapid progression is, however, performed only by the powerful hind limbs, the animal covering the ground by a series of immense bounds, during which the fore part of the body is inclined forwards, and balanced by the long, strong, and tapering tail, which is carried horizontally backwards. When not moving, they often assume a perfectly upright position, the tail aiding the two hind legs to form a sort of supporting tripod, and the front limbs dangling by the side of the chest. This position gives full scope for the senses of sight, hearing, and smell to warn of the approach of enemies, from which these animals save themselves by their bounding flight. The fore paws have lived distinct digits, each armed with a strong curved claw. The hind foot, figure 52, as being a typical example of the syndactylous modification, may be noticed in some detail. It is extremely long and narrow, and, with only one exception, without any hallux or great toe. It consists mainly of one very large and strong toe, corresponding to the fourth of the human or other typically developed foot, ending in a strong, curved, and pointed claw. Close to the outer side of this lies a smaller fifth digit, and to the inner side two excessively slender toes, the second and third, bound together almost to the extremity in a common integument. The two little claws of these toes, projecting together from the skin, may be of use in scratching and cleaning the fur of the animal, but the toes themselves must have quite lost all connection with the functions of support or progression. The dentition of the kangaroos, functionally considered, consists of sharp-edged incisors, most fully developed near the median line of the mouth, for the purpose of cropping the various kinds of herbage on which they feed, and ridged and tuberculated molars for crushing it, there being no tusks or canines for offensive or defensive purposes. The number of vertebrae is, in the cervical region 7, dorsal 13, lumbar 6, sacral 2, caudal varying according to the length of the tail, but generally from 21 to 25. In the forelimb, the clavicle and the radius and ulna are well developed, allowing of considerable freedom of motion of the hand. The pelvis has large epipubic or marsupial bones. The femur is short, and the tibia and fibula are of great length, as is the foot, the whole of which is applied to the ground when the animal is at rest in the upright position. Figure 53. The great gray kangaroo, Macropus giganteus. The stomach is of large size, and very complex, its walls being puckered up by longitudinal muscular bands into a great number of saculae, like those of the human colon. The alimentary canal is long, and the cecum well developed. All the species have a marsupium or pouch formed by a fold of the skin of the abdomen, covering the mammary glands with their fore nipples. In this pouch the young are placed as soon as they are born, there their growth and development proceeds, and to it they resort temporarily for the purpose of shelter, concealment, or transport, for some time after they are able to run and jump about the ground and feed upon the same herbage which forms the nourishment of the parent. During the early period of their sojourn in the pouch, the blind, naked, helpless young creatures, which in the great kangaroo, figure 53, scarcely exceed an inch in length, are attached by their mouths to the nipples of the mother, and are fed by milk injected into their stomach by the contraction of the muscle covering the mammary gland. The kangaroos are all vegetable feeders, browsing on grass and various kinds of herbage, the smaller species also eating roots. They are naturally timid, inoffensive creatures, but the larger ones when hard-pressed will turn and defend themselves, sometimes killing a dog by grasping it in their fore paws, and inflicting terrible wounds with the sharp claws of their powerful hind legs, sustaining themselves meanwhile upon the tail. A few aberrant forms are arboreal. The great majority are inhabitants of Australia and Tasmania, forming one of the most prominent and characteristic features of the fauna of these lands, and in the scenery of the country, as well as the economy of nature, performing the part of the deer and antelopes of other parts of the world, which are entirely wanting in Australia. Kangaroos were very important sources of food supply to the natives, and are hunted by the colonists, both for sport and with a view to their destruction, on account of the damage they naturally do in consuming the grass, now required for feeding cattle and sheep. Notwithstanding this, they have in some districts increased in numbers, owing to the suppression of their former enemies, the Aborigines and the dingo or native dog. A few species are found in New Guinea and the adjacent islands, which belong, in the zoological sense, to the Australian region. Before noticing the various generic types of the Macropodidae, a few words are necessary in respect of the tooth change, and we may here quote the observations of Mr. O. Thomas on this subject. The full dentition of the members of this family consists, in the upper jaw, first of 3 incisors, then of a small canine, often, however, suppressed, as in Figure 55, and then of 6 cheek teeth, of which the second in the series is the only one which has a milk or deciduous predecessor, and is therefore the one to be regarded as the last premolar of the typical mammalian dentition. The special characteristics that render the development and succession of the teeth in the Macropodidae, and especially in the genus Macropus, so puzzling to systematic zoologists, are, firstly, a general progression forwards in the jaw of the whole tooth row, comparable to that found elsewhere only in the elephants and some sirenians, and, secondly, the fact that before the tooth change the first tooth of the series, P3, and the single milk tooth, DM4, placed next to it, both of which fall out of the change, are respectively so very similar in shape and size to the first and second teeth of the permanent series, viz. the permanent premolar, P4, and the first molar, M1, as to be most naturally mistaken for, or compared with, them in specific descriptions. The necessary knowledge as to the stage of dentition in which any skull may be, can often be gained only by cutting open the bone either above and behind the first tooth of the series to see if the true permanent P4 be still buried there, in which case, of course, that first tooth is only P3, or behind the last visible molar to see if there be yet another tooth behind it, showing it to be M3 and not M4. The first plan is, as a rule, the better, since P4 is generally by far the most important tooth for diagnostic purposes, and its characters have, therefore, in any case to be taken into account. The Macropodidae are divided into 3 well-marked sections: 1. The true kangaroos, Macropodini; 2. A group consisting of smaller animals, commonly called rat kangaroos, or, improperly, kangaroo rats, or sometimes potaroos; and 3. The Hypsopremnodontini, now represented only by a single species. Subfamily Hypsopremnodontini. Size very small. Claw small, feeble, and subequal. Hind feet with an opposable hallux. Tail naked and scaly. The fourth premolar twisted obliquely outwards, as in Phalanger. Other teeth as in the Potaroini. This subfamily is now represented only by the genus Hypsopremnodon, 68, which is a form of great interest, as showing a structure of foot connecting that of the kangaroos with that of the phalangers. The single known species, H. moscatus, was described by Ramsay from specimens discovered in northeast Australia. It was described almost simultaneously by Owen under the name of Pleopus nudicaudatus. From the resemblance in the structure of the foot and the obliquity of the premolars to the phalangers, Mr. Thomas has some hesitation as to which family should receive this genus, but the macropine characters of the mandible preponderate in favor of the Macropodidae. Trichlus, 69, a lower jaw of a much larger form from the Pleistocene deposits of Australia apparently indicates another member of this subfamily, having the outwardly directed and grooved premolar characteristic of Hypsopremnodon. It differs, however, from that genus, and also from all other known Macropodidae, in having a small tooth between the incisor and fourth premolar, which apparently represents a canine, or perhaps an anterior premolar. This form indicates, therefore, a closer connection between the Phalangeridae and Macropodidae than any other. Subfamily Potaroinida. The second section or subfamily, the Potaroini, have the first upper incisor narrow, curved, and much exceeding the others in length, Figure 54. Upper canines always persistent, flattened, blunt, and slightly curved. Premolars of both jaws always having large, simple, compressed crowns, with a nearly straight or slightly concave free-cutting edge, both outer and inner surfaces usually marked by a series of parallel, vertical grooves and ridges, these teeth being either set in the same line with the molars, or slightly bent outwards. Molars with quadrate crowns, having a blunt, conical cusp at each corner, the fourth notably smaller than the third, sometimes rudimentary, and appearing early. 4 feet narrow, 3 middle toes considerably exceeding the first and fifth in length, their claws long, compressed, and but slightly curved. Hind feet as in Macropus. Tail long and hairy, sometimes partially prehensile, being used for carrying bundles of grass with which these animals build their nests. Figure 54. Skull and teeth of rat kangaroo, Bettungia leswieri. C. Upper canine. The other letters as in Figure 51. The potaroos or rat kangaroos are all small animals, none of them exceeding a common rabbit in size. They inhabit Australia and Tasmania, are nocturnal, and feed on the leaves of various kinds of grasses and other plants, as well as roots and bulbs, which they dig up with their 4 paws. 9 species are known, presenting a considerable range of diversity in minor characters, and admitting of being grouped in 4 principal sections, which may be allowed the rank of genera. These are, Podarus, 70, head long and slender. Auditory bully somewhat inflated. Ridges on premolars few and perpendicular. Large palatine foramina. Tarsus short. Muffle naked. 3 species, viz. P. tridactylus, P. gilberti, and P. platyops, the last 2 being confined to West Australia. Bettungia, 71, head comparatively short and broad. Ears short and rounded. Auditory bully generally much inflated. Large palatine foramina. Tarsus long. Ridges on premolars numerous and oblique. Tail more or less prehensile, thickly haired, and the hairs on the upper surface longer than those on the lower, and forming a crest. Muffle naked. 4 species, viz. B. peniculata, B. cuniculus, B. gaymardi, B. leswieri. Caloprimnus, 72, muffle naked, as in Bettungia, but the edge of the hairy part less emarginate backwards in the middle line. Ears short, rounded, and hairy. Auditory bully much inflated, and of large size. Nasals larger and wider behind than in the other genera. Very long anterior palatine foramina. Limbs as in Bettungia. Tail thin, cylindrical, evenly coated with short hair, without trace of a crest. Skull broad and flat, with a remarkably short and conical muzzle. The sole representative of this genus is C. campestris of South Australia, originally referred to Bettungia. Figure 55. Skull and teeth of the red-necked wallaby, Macropus ruficalis. I superscript 1, I superscript 2, I superscript 3, first, second, and third upper incisors, PM, fourth or posterior premolar, the penultimate or third having been already shed, M superscript 1, M superscript 2, M superscript 3, M, the 4 true molars. The last, not fully developed, is nearly concealed by the ascending ramus of the jaw. Epiprimnus, 73, head short and broad. Auditory bully not inflated. No palatine foramina. Tarsus long. Muffle partially hairy. Tail evenly hairy, not crested above. Molars oblong, less distinctly quadratubercular, and not decreasing so much in size posteriorly as in the other genera. Represented only by A. rufescens. Remains of A. rufescens occur in the Pleistocene cave deposits of New South Wales. Subfamily Macropodinida. This subfamily includes the largest forms. The cutting edges of the upper incisors are nearly level, or the first pair but slightly longer than the others, figure 55. The canines are rudimentary and often wanting. The premolars are usually not longer, from before backwards, than the true molars and less compressed than in the last subfamily. They are placed in precisely the same line with the molars. The crowns of the molars always have 2 prominent transverse ridges, and these teeth increase in size from before backwards, the 4th molar appearing very late. The 4 limbs are small, with subequal toes armed with strong, moderately long, curved claws. Hind limbs very long and strongly made. Head small, with more or less elongated muzzle. Ears generally rather long and ovate. Upwards of 44 existing species of this group have been described, and many attempts have been made to subdivide them into smaller groups or genera for the convenience of arrangement and description, but these have generally been based upon such trivial characters that it is preferable to speak of many of them as sections of the genus Macropus, reserving generic rank only to forms somewhat aberrant in structure. According to this arrangement, the genera will be as follows: Lagostrophus, 74, represented only by the banded wallaby, L. fasciatus, of Western Australia, which presents the following distinctive features. Size small. Muffle naked. Hind feet covered with long bristly hairs, concealing the claws. Lower part of back marked by dark crossbands. Skull with a narrow pointed muzzle and inflated auditory bully, symphysis of mandible firmly united. No canine. Upper incisive series meeting at a sharp angle, and diverging but slightly behind. First incisor smaller in section than either of the others and scarcely longer, bluntly pointed, second with a flattened oral surface, third smaller, similarly flattened, but with a groove on oral surface forming a notch at its postero-external angle. Fourth premolar short, with a distinct inner ledge. Molars as in Macropus. Dendrologus, 75, general proportions of limbs and body normal and unlike those of other members of the family. Muffle broad and only partly naked. Fur on nape, and sometimes on back, directed forwards. Fore limbs nearly as large as the hind feet with the syndactylous second and third digits relatively large, claws of fourth and fifth hind digits curved like those of the manus. Tail very long, and thickly furred. Skull stout, with a short and wide muzzle, the posterior part of the palate fully ossified, and the auditory bully not inflated. A small canine. Fourth premolar large, but much shorter anteroposteriorly than in the next genus, molars as in the latter. This genus includes 4 species of tree kangaroos, 3 of which occur in New Guinea, while D. lumholtzi is found in North Queensland. They differ greatly from all the other forms in being chiefly arboreal in their habits, climbing with facility among the branches of large trees, and feeding on the bark, leaves, and fruit. They are confined to the tropical forests of the regions mentioned, and it would appear that we must regard their resemblance in the proportions of the limbs and habits to the phalangers as having been independently acquired. Dorcopsis, 76, hind limbs relatively less large than in Macropus. Muffle large, broad, and naked. Ears small. Fur on nape directed wholly or partially forwards. Hind claws not concealed by hair. Tail with a nearly naked tip. Skull long and narrow, with the auditory bully not inflated. A well-developed canine. First upper incisor somewhat short, second and third nearly equal, notched externally. Fourth premolar greatly elongated anteroposteriorly, its length generally exceeding the united lengths of the first and second molars, a distinct inner ledge, and vertical grooves on both sides. Molars low and rounded, with the median longitudinal bridge between the ridges almost or quite aborted, and the talon in front of the first transverse ridge very narrow, and not extending to the inner side. The 2 series of cheek teeth parallel, or nearly so, instead of converging at the extremities. 3 species of this genus are known, all of which are from New Guinea, the type being D. muelleri. In the characters of the dentition, the forward inclination of the fur on the nape, and other points, this genus is allied to Dendrologus, but Dorcopsis macleae connects the other species with Macropus. Lagerkests, 77, muffle entirely or partially covered with hair. Fourth hind digit with a long claw, not concealed by hair. Tail rather short, evenly furred, without a spur. Skull with short muzzle and diastema, and inflated auditory bulla. Canine present, sometimes very small. Fourth premolar large, not constricted in the middle, with a continuous inner ledge. This genus includes the hare kangaroos, a group of small hare-like animals, great leapers and swift runners, which mostly affect the open grassy ridges, particularly those of a stony character, sleeping in forms or seats like the common hare. Their limbs are comparatively small, their claws sharp and slender, and their muffle is clothed with velvet-like hairs. 3 species, M. leperoides, M. hirsutus, M. conspiculatus. The range extends over the whole of Australia, but does not embrace Tasmania. Onychogale, 78, muffle hairy. Fourth hind claw long, narrow, compressed, and sharp. Tail long and tapering, covered with short hair, and furnished at the tip with a horny spur. Skull nearly as in Macropus, with the auditory bully more or less inflated. Canine small or wanting. Upper incisor small, decreasing in size from first to third. Fourth premolar small, hourglass-shaped, and without inner ledge. Molars as in Macropus. This genus contains 3 species, having the same distribution as lagercasts. Mr. O. Thomas observes, the spur-tailed wallabies form a natural little group, distinguished both by the shape of the incisors and the peculiar horny excrescence at the tip of the tail. The latter character is altogether unique among marsupials, and is only found among other mammals in the lion, which occasionally has a somewhat similar horny spur at the end of its tail. In the case of the wallabies, it is difficult to conceive what can be the use of this spur, and observations on the living animal are much needed with regard to this interesting point. Petrogale, 79, muffle naked. Fur of nape directed backwards. Claw of fourth hind digit very short. Tail long, cylindrical, thinner than in Macropus, and thickly haired and penciled at the extremity. Skull as in the smaller species of Macropus, with large posterior palatal vacuities, and the bully sometimes inflated. No canine. Upper incisor small, the third resembling that of Macropus. Fourth premolar large and stout, as in some of the wallabies, with a continuous inner ledge, and 2 or 3 indistinct vertical ridges externally. Molars as in the wallabies. This genus is represented by 6 species, of which P. peniculata is a well-known example, ranging over the whole of the mainland of Australia. The rock wallabies, as its members may be called, are very closely allied to some of the true wallabies, and some hesitation may be expressed as to the advisability of accepting their generic separation from Macropus. They inhabit rocky regions, making their retreats in caverns and crevices, leaping with surprising agility from one narrow ledge to another, and browsing upon the scanty herbage that the neighborhood of such situations affords. The species are P. xanthopus, P. peniculata, P. lateralis, P. consina, P. brachiotis, P. inornata. Remains of P. peniculata are found in a fossil state in the Pleistocene cave deposits of New South Wales. Macropus, 80, muffled generally completely naked. Ears large. Fur on nape, with an occasional exception in 2 species, directed backwards. Claw of fourth hind digit very long. Tail thick, tapering, and evenly furred. For mammy. Skull, figure 55, long, smooth, and rounded, the nasals expanded behind, generally large palatal vacuities, and the auditory bully not inflated. Canine minute, and shed at an early period. Incisor series forming an open curve, the first the tallest, and the third nearly always the longest antero-posteriorly, and generally with an enfolding of enamel near its postero-external angle. Fourth upper premolar with a secant edge, and an inner basal ledge or tubercle, corresponding lower tooth secant, both may be longer or shorter than first molar. Molars, except very occasionally, with a distinct longitudinal bridge connecting transverse ridges. Lower incisors long and scalpiform, with inner secant edges opposable, owing to the loose articulation of the mandibular symphysis. This genus includes the true kangaroos and wallabies, the size of the individual existing species varying from that of a rabbit to that of a man. There are no less than 23 existing species, which may be divided into 3 groups, as well as many extinct ones. The genus is found in Australia and New Guinea, as well as in the eastern half of the Austromalayan transitional region. The first group, or true kangaroos, comprises the largest existing forms, which are generally of a uniform and somber color. The skull is of a large and massive type, with the palate more or less well ossified posteriorly, while the molars frequently have a median longitudinal bridge connecting the first transverse ridge with the anterior talon, and no antero-external bridge between the same ridge and talon. The history of the discovery of the typical representative of this group, as being of considerable interest, may be given at some length. When Captain Cook, during his first memorable voyage of discovery, was detained for the purpose of refitting his ship at Endeavour River on the northeast coast of Australia. A strange-looking animal, entirely unknown to them, was frequently seen by the ship's company, and it is recorded in the annals of the voyage that, on the 14th of July, 1770, Mr. Gore, who went out this day with his gun, had the good fortune to kill one of the animals which had been so much the subject of our speculation, and which is called by the natives kangaroo, a name which, though it does not appear to be now known to any of the aboriginal tribes of the country, has been adopted for this animal in all European languages, with only slight modifications of spelling. With the exception of a passing glimpse in the beginning of the same century by the Dutch traveller Bruyn of some living examples of an allied species, this was the first introduction to the civilized world of any member of a group of animals now so familiar. The affinities of the species, skins of which were brought home by Captain Cook and subsequent voyagers, were recognized by Schreiber as nearer to the American possums than the only known marsupials, than to any other mammals with which zoologists were acquainted, and consequently it was placed by him, in his great work on the Mammalia, then in the course of publication, in the genus Didelphys, with Gigantea for a specific designation, the latter having been bestowed upon it by Zimmermann, under the impression that it was a huge species of jerboa. Soon afterwards, 1791, Dr. Shaw very properly formed a new genus for its reception, which he named Macropus, in allusion to the peculiar length of its hind foot. By the name thus formed, Macropus giganteus, this kind of kangaroo has ever since been known in zoological literature. It is the common grey kangaroo, called boomer, forester, or old man by the colonists, and frequents the open grassy plains of the greater part of eastern Australia and Tasmania, a figure being given in the woodcut on page 160. The muffle is partly covered with hair, and the fourth premolar very short. Several varieties are known. A subgroup, distinguished from the above by the naked muffle, includes some very large and handsome species, which principally dwell in rocky mountain ranges, as M. rufus, the great red kangaroo, M. antilopenus, and M. robustus. The fourth premolar is of large or medium size in these forms. Remains of M. giganteus occur fossil in the Pleistocene of Australia, where we also find the allied extinct M. titan, which attains somewhat larger dimensions. M. robustus also dates from the same geological epoch, where it was accompanied by two allied types known as M. altus and M. cooperi. The second group includes the larger wallabies, which are smaller than the true kangaroos, with a brighter and more variegated coloration. The palate is generally more incomplete than in the typical group, and in the molars the anterior talon is connected with the first transverse ridge by an external instead of a median longitudinal bridge. The members of this group are frequenters of forests and dense impenetrable brushes and scrubs, and hence are often called brush kangaroos, though a native name, wallaby, is now generally applied to them. There are several species, of which M. ruficalis, M. eualabatus, M. perrii, and M. agilis are the best known. M. eualabatus and M. perrii are found fossil in the Pleistocene deposits of Australia. In those beds we also meet with remains of several very large extinct species, which appear to be allied to those wallabies in which the fourth premolar is large and elongated, all of them agreeing with the wallabies in the absence of the median bridge between the first ridge and talon of the molars. These fossil forms comprise M. brihus, in which the skull was probably about 1 foot in length, and M. rochus, and M. manic, which were of somewhat inferior dimensions. In the last named species the length of the fourth upper premolar is equal to that of the first and half of the second molar, 81. The third and last group of the genus includes the small wallabies, which are small and lightly built animals, in some instances not larger than a rabbit. Their muffles are always naked, and in the skull the anterior palatine foramina are small and the posterior vacuities very large, while the posterior expansion of the nasals is very marked. The third upper incisor is smaller than in the last group. This group extends farther into the tropics than either of the others, being found in the New Britain and Aru Islands, as well as in New Guinea. M. brachyurus is remarkable for its comparatively short and slender tail and small ears. The earliest known species of kangaroo, referred to before, M. bruni, belongs to this section. Several examples were seen by Bruyn in 1711 living in captivity in the garden of the Dutch governor of Batavia, and described and figured in the account of his travels, risen over Muscovy, etc., under the name of Philander. It was quite lost sight of, and its name even transferred by S. Muller to another species, Dorcopsis muelleri, until rediscovered in 1865 by Rosenberg, who sent a series of specimens to the Leiden Museum from the islands of Aru and Great Key, thus determining its true habitat. M. thetatus is a well-known Australian representative of this group. Extinct genera. In addition to the fossil forms already mentioned which can be referred to existing genera, there are others from the Australian Pleistocene indicating extinct generic types of macropodidae, to which brief reference may now be made. The first of these is Sthenurus, 82, represented by a single large species, S. atlas, and characterized by the presence of a complete inner lobe to the fourth upper premolar, and of an outer one in the opposing lower tooth, so that these teeth present a flat and oval grinding surface when worn. The median longitudinal bridge connecting the transverse ridges of the molars is very imperfect, and in the upper molars there is no bridge between the first ridge and talon. In Procoptodon 83, the premolars resemble those of Sthenurus, but the molars are elongated, and usually have their enamel thrown into numerous vertical foldings. The most distinctive feature is, however, the complete ankylosis of the mandibular symphysis, the mandibular rami being deep, and the diastema in the dental series short. The lower incisors are nearly cylindrical, and the palate has large vacuities. 3 species are known. The largest representation of the whole family is the type of the genus Palercestes, 84, P. A. Zale, in which the length of the skull is estimated at 16 inches. It is distinguished from Procoptodon by the longer mandibular symphysis and diastema, and the spatulate lower incisors. The true molars have no distinct anterior talon, and are not grooved, while the palate was fully ossified. Extinct families. Here may be noticed 2 genera of extinct marsupials, the remains of which have been found in the Pleistocene deposits of Australia, which agree with the Macropodidae and the Phalangeridae in having superscript 3 incisors, those of the lower jaw being very large and proclivus. As the whole of their structure, especially that of the hind feet, is not yet known, their precise affinities cannot be determined. Diprotodon, 85, dentition, I superscript 3/C/P superscript 1/M/4, total 28. The first upper incisor very large and scalpiform, figure 56. True molars with prominent transverse ridges, as in Macropus, but wanting the longitudinal connecting bridge. Anterior and posterior limbs less disproportionate than in the kangaroos. Humerus elongated, and differing from that of nearly all marsupials in the absence of an entepicondylar foramen. The palate is fully ossified, and there is no pit or perforation in the masseteric fossa of the mandible. D. australis is the largest known marsupial, being fully equal in bulk to a rhinoceros. It may be regarded as the type of a family, Diprotodontidae, having affinity on the one hand with the phalangers and on the other with the kangaroos. Figure 56. Left lateral aspect of the skull of Diprotodon australis, from the Pleistocene of Australia. Natural size. I. Incisors, P. Premolar, M. Molars. After Owen. Nototherium, 86, represented by a species of somewhat smaller size than the type of Diprotodon, with a shorter skull, in which the zygomatic arches are very wide and the nasals curiously expanded at their extremities. The mandibular symphysis is ankylosed, and, as in Diprotodon, there appears to have been no tooth change. The humerus probably referable to Nototherium is of a short and widely expanded type, with a large entepicondylar foramen, and coming nearer to that of the wombat than to that of any other existing form. The Nototheridae may apparently be regarded as a distinct family connecting the Diprotodontidae with the Phascolomyidae and Phalangeridae. Bibliography of Marsupialia. G. R. Waterhouse, Nat. History of the Mammalia, Volume 1, Marsupiata, 1846, J. Gould, Mammals of Australia, 1863, R. Owen, Article Marsupialia, in Cyclop. Of Anatomy and Physiology, and various memoirs on extinct mammals of Australia in Philosophical Transactions, W. H. Flower, on the development and succession of the teeth in the Marsupialia, Phil. Trans 1867, O. Thomas, on the homologies and succession of the teeth in the Dasyuridae, Phil. Trans 1887, and Catalogue of Marsupialia and Monotremata in the British Museum, 1888. Chapter 7 The subclass Eutheria and the order Edentata. The whole of the remaining groups of mammals are included in a single subclass, known by the names Eutheria, Monodelphia, or Placentalia. 87. The one distinctive feature they have in common, from which the last mentioned name is derived, is the presence of an allantoic placenta by means of which the fetus is nourished within the uterus of the mother. Throughout the entire subclass, as a general rule, the urinogenital organs open quite independently of the rectum, the corpus callosum of the brain is well developed, the mandible does not show a marked inflection of its angle, and distinct epipubic bones are not attached to the anterior margin of the pubic symphysis. In those cases where there is a heterodont and diffeodont dentition, the dental formula can be reduced to some modification of the one given on page 25, there being only one known genus where 4 true molars occur, and even that not invariably. As in the Metatheria, the coracoid is reduced to a mere appendage of the scapula, and the acetabular cavity of the pelvis is imperforate. While the survivors of the other subclasses have probably been for a long time in a stationary condition, these have, as there is already good evidence to show throughout all the tertiary geological age, and by inference for some time before, been multiplying in numbers and variations of form, and attaining higher stages of development and specialization in various directions. They consequently exhibit far greater diversity of external or adaptive modification than is met within either of the other subclasses, some being fitted to live as exclusively in the water as fishes, and others to emulate the aerial flight of birds. To facilitate the study of the different component members of this large group, it is usual to separate them into certain divisions which are called orders. In the main, zoologists are now of accord as to the general number and limits of these divisions among the existing forms, but the affinities and relationships of the orders to one another are far from being understood, and there are very many extinct forms already discovered which do not fit at all satisfactorily into any of the orders as commonly defined. Commencing with the most easily distinguished, we may first separate a group called Edentata, composed of several very distinct forms, the sloths, anteaters, and armadillos, which under great modifications of characters of limbs and digestive organs, as well as habits of life, have just enough in common to make it probable that they are the very specialized survivors of an ancient group, most of the members of which are extinct, although the researches of paleontology have not yet revealed them to us. The characters of their cerebral, dental, and in many cases of their reproductive organs show an inferior grade of organization to that of the generality of the subclass. The next order, about the limits of which there is no difficulty, is the Sirenia, aquatic vegetable-eating animals, with complete absence of hind limbs, and low cerebral organization, represented in our present state of knowledge by but 2 existing genera, the dugongs and manatees, and by a few extinct forms, which, though approaching a more generalized mammalian type, show no special characters allying them to any of the other orders. Another equally well-marked and equally isolated, though far more numerously represented and diversified order, is that of the Cetacea, composed of the various forms of whales, dolphins, and porpoises. In aquatic habits, external fish-like form, and absence of hind limbs, they resemble the last, though in all other characters they are as widely removed as are any 2 orders among the Eutheria. All the remaining orders are more nearly allied together, the steps by which they have become modified from one general type being in most cases not difficult to realize. Their dentition especially, however diversified in detail, always responds to the formula already alluded to, and, although the existing forms are broken up into groups in most cases easy of definition, the discoveries already made in paleontology have in great measure filled up the gaps between them. Very isolated among existing Eutheria are the 2 species of elephant constituting the group called Proboscidea. These, however, are now known to be the survivors of a large series of similar animals, mammoths, mastodons, and dinotheres, which as we pass backwards in time gradually assume a more ordinary or generalized type, and the interval which was lately supposed to exist between even these and the rest of the class is partially bridged over by the discovery in American Eocene and early Miocene formations of the gigantic Dinocerata, evidently offshoots of the great group of hoofed animals, or Ungulata. represented in the actual fauna by the horses, rhinoceroses, tapirs, swine, and ruminants. Almost as isolated as the Proboscidea among existing mammals are the few small species constituting the family Hyracidae, and in their case paleontology affords no help at present, and therefore, pending further discoveries, it has been thought advisable in most recent systems to give them the honor of an order to themselves, under the name of Hyracoidea. But the number of extinct forms already known allied to the Ungulata, though not coming under the definition of either of the two groups, Artiodactyla and Perissodactyla, under which all existing species range themselves, is so great that either many new orders must be made for their reception or the definition of the old order Ungulata so far extended as to receive them all, in which case both Proboscidea and Hyracoidea may be included within it. Again, the rodentia or gnawing animals, rabbits, rats, squirrels, porcupines, beavers, etc., are, if we look only at the present state of the class, most isolated. No one can doubt what is meant by a rodent animal, or have any difficulty about defining it clearly, at least by its dental characters, yet our definitions break down before the extinct South American Typotherium, half rodent and half ungulate, which leads by an easy transition to the still more truly ungulate Toxodon, for the reception of which a distinct order, Toxodontia, has been proposed. It has also been suggested that the rodents are connected by some of the extinct Telodontia, or Taeniodontia, with the edentates. The insectivora and the carnivora again are at present quite distinct orders, but they merge into one another through fossil forms, and are especially connected by the large group of primitive carnivora, so abundantly represented in the Eocene deposits both of America and Europe, to which Cope has given the name of Creodonta. The carnivora also appear to have been closely connected with the primitive ungulates as represented by the extinct group called Condylarthra. In another direction the step from the insectivores to the lemurs is not great, and in past times the transition was probably complete. The bats or Chiroptera are allied to the insectivora in all characters except the extraordinary modification of their anterior extremities into wings, but this, like the want of the hind limbs in the Cetacea and Sirenia, makes such a clear distinction between them and all other mammals that, in the absence of any knowledge of any completely intermediate or transitional forms, they can be perfectly separated, and constitute as well-defined an order as any in the class. We have, however, an inkling of the mode in which the insectivora were modified into Chiroptera shown us by the so-called flying lemur, Galeopithecus. Finally, we have the important and well-characterized group called primates, including all the monkeys and man, and the question is not yet solved as to how and through what forms this is linked on to the other groups. It is commonly assumed that the lemurs are nothing more than inferior primates, but the interval between them in the actual fauna of the world is very great, and our knowledge of numerous extinct types recently discovered in America, said to be intermediate in characters, is not yet sufficient to enable us to form a definite opinion upon the subject. The Edentata may be taken first as standing in some respects apart from all the others, and the primates must be placed at the head of the series. The position of the others is quite arbitrary, as none of the hitherto proposed associations of the orders into larger groups stand the test of critical investigation, and paleontological researches have already gone far to show that they are all modifications of a common heterodont, diphyodont, pentadactylate form. Order Edentata. The name assigned to this group, which some zoologists think ought rather to be ranked as a subclass, 88, than an order, by Cuvier is often objected to as inappropriate, for although some of the members are edentulous, others have very numerous teeth, and the Linnaean name Brida is occasionally substituted. But that term is quite as objectionable, especially since the group to which Linnaeus applied it is by no means equivalent to the order as now understood, as the names of the genera contained in it, viz. Elephas, Trichicus, Bradypus, Myrmecophaga, Manus and Dasypus, indicate. It contained, in fact, all the animals then known which are comprised in the modern groups of Proboscidea, Sirenia and Edentata together with the walrus, one of the carnivora. If retained at all, it should rather belong to the Proboscidea, as Elephas stands first in the list of genera in the Systema Naturae. Cuvier's order included the Ornithorhynchus and Echidna, the structure of which was then imperfectly known, and which are now by common consent removed to an altogether different section of the class, but otherwise its limits are those now adopted. The name Edentata is so generally used, and its meaning so well understood that it would be undesirable to change it now. In fact, similar reasons might be assigned for ceasing to use nearly all the other current ordinal designations, for it might be equally well objected that all carnivora are not flesh-eaters, many of the marsupialia have not pouches, and so forth. If the teeth are not always absent, they invariably exhibit certain imperfections, which are indeed almost the only common characters binding together the various extinct and existing members of the order. These are, that they are homodont and, with the remarkable exceptions of Titusia and Orycterapus, monophyodont, they are never rooted, but have persistent pulps. Except in some fossil forms, they are always deficient in one of the constituents which enter into the formation of the complete mammalian tooth, the enamel, and, at least among living forms, are never present either in the upper or lower jaw and the forepart of the mouth, the situation occupied by the incisors of other mammals. 89. The peculiar nature of the dentition in the aberrant Orycterapus will be noticed under the heading of that genus. As a rule, the coracoid process of the scapula of the edentates is more developed than in other Eutheria. The degree of development of the brain varies considerably in the different families, the hemispheres being in some cases almost or quite smooth, figure 57, with a small corpus callosum, and large anterior commissure, while in other instances the hemispheres are convoluted, and the corpus callosum is larger. Figure 57. Upper surface of the brain of the broad-banded armadillo, Xenurus unicinctus. The large olfactory lobes are seen at the anterior extremity, left of figure. The hemispheres have only 3 sulci. From Garrod, Proc. Zoll. SOC 1878, page 230. There is so great a difference in structure and habits between some of the existing animals assigned to this order that, beyond the negative characters just mentioned, there seems little to connect them. The sloths and anteaters, for instance, in mode of life, general conformation of limbs, structure of digestive organs, etc., appear at first sight almost as widely separated as any mammals. Paleontology has, however, thrown great light upon their relations, and proved their real affinities. Perfectly intermediate forms have been discovered in the great ground sloths of America, which have the dentition and general form of the head of the sloths, combined with the limbs and trunk of the anteaters. It is, indeed, highly probable that the existing members of this order are very much differentiated representatives of a large group, the greater number of which are now extinct, and have become so without ever attaining a high grade of organization. The great diversity of structure in the existing families, the high degree of specialization to which many have attained, the paucity of species and even of individuals, their limited area of distribution, and their small size compared with known ancestral forms, all show that this is an ancient and a waning group, the members of which seem still to hold their own either by the remoteness and seclusion of their dwelling places, by their remarkable adaptation of structure to special conditions of life, or by aid of the peculiar defensive armature with which they are invested. Their former history can, however, only be thus surmised, rather than read, at present, for, though we have ample evidence of the abundance and superior magnitude of certain forms in the most recent or Pleistocene geological age, yet we have at present no definite evidence as to their origin, or relationship to other orders of mammals. The existing members of the order readily group themselves into 5 distinct families, the limits of which are perfectly clear. These are, 1. Bradipodidae, or sloths, 2. Myrmecophagidae, or anteaters, 3. Dasypodidae, or armadillos, 4. Manadeae, pangolins or scaly anteaters, and 5. Orycteropodidae, aardvarks or African anteaters. The geographical distribution of these families coincides with their structural distinction, the first 3 being inhabitants of the New and the last 2 of the Old World. It has been usual to arrange these families into 2 large groups or suborders, 1. The Philophaga, leaf-eaters, also called tardigrada, containing the Bradipodidae alone, and 2. The Entomophaga, insect-eaters, or vermilingua, containing all the other families, from which sometimes the Orycteropodidae are separated as a 3rd suborder under the name of Aphodientia, or Tubulidendata. Such an arrangement is, however, an artificial one, founded on superficial resemblance. The bonds which unite the Manadeae to the Myrmecophagidae are mainly to be found in the structure of the mouth, especially the extensile character of the tongue, the great development of the submaxillary glands, and the absence of teeth. These characters are exactly analogous to those found in the echidna among monotremes, the woodpeckers among birds, and the chameleon among reptiles, the fact probably being that in countries where termites and similar insects flourish, various distinct forms of vertebrates have become modified in special relation to this abundance of nutritious food, which could only be made available by a peculiar structure of the alimentary organs. A close study of the more essential portions of the anatomy of these animals, 90, leads to the belief that all the American edentates at present known, however diversified in form and habits, belong to a common stock. Thus the Bradipodidae, Megatheridae, and Myrmecophagidae are certainly allied, the modifications seen in the existing families relating only to food and manner of life. The ancestral forms may have been omnivorous, and gradually separated into the purely vegetable and purely animal feeders. From the former are developed the modern sloths, from the latter the anteaters. The armadillos, Dasypodidae, are another modification of the same type, retaining some generalized characters, as those of the alimentary organs, but in other respects, as in their defensive armature, remarkably specialized. The two Old World families Manatee and Orycteropodidae are so essentially distinct, both from the American families and from each other, that it may even be considered doubtful whether they are derived from the same primary branch of mammals, or whether they may not be offsets of some other branch, the remaining members of which have been lost to knowledge. Further remarks on this point are recorded under the description of the Orycteropodidae, 91, family Bradipodidae. Externally clothed with long, coarse, crisp hair. Head short and rounded. External ears inconspicuous. Teeth/4 in each jaw, subcylindrical, of persistent growth, consisting of a central axis of vasodentine, with a thin investment of hard dentine, and a thick outer coating of cement, without, so far as is yet known, any succession. Clavicles present. For limbs greatly longer than the hind limbs. All the extremities terminating in narrow, curved feet, the digits never exceeding 3 in number, encased for nearly their whole length in a common integument, and armed with long strong claws. Tail rudimentary. Stomach complex. No cecum. Uterus simple and globular. Placenta deciduate, dome-like, composed of an aggregation of numerous discoidal lobes. Strictly arboreal in habits, vegetable feeders, and limited geographically to the forest regions of South and Central America. Figure 58. Two-toed sloth, Colepus hoffmanni. The sloths, as the animals of this family are called on account of the habitual sluggishness of their movements, are the most strictly arboreal of all mammals, living entirely among the branches of trees, usually hanging under them, with their backs downwards, figure 58, and clinging to them with the simple hook-like organs to which the terminations of all their limbs are reduced. When they are obliged from any cause to descend to the ground, which they rarely, if ever, do voluntarily, their limbs, owing to their unequal length and the peculiar conformation of the feet, which allows the animals to rest only on the outer edge, are most inefficient for terrestrial progression, and they crawl along a level surface with considerable difficulty. Though generally slow and inactive, even when in their natural haunts, sloths can on occasions travel with considerable rapidity along the branches, and, as they do not leap, like most other arboreal creatures, they avail themselves of the swaying of the boughs by the wind to pass from tree to tree. They feed entirely on leaves and young shoots and fruits, which they gather in their mouth, the four limbs aiding in dragging boughs within reach, but not being used like hands, as they are by monkeys, squirrels, etc. When sleeping they roll themselves up in a ball, and, owing to the dry shaggy character of their hair, are very inconspicuous among the mosses and lichens with which the trees of their native forests abound, the concealment thus afforded being heightened in some species by the peculiar greenish tint of the outer covering, very uncommon in mammals. This is not due to the color of the hair itself, but to the presence upon its surface of an alga, the lodgment of which is facilitated by the fluted or rough surface of the exterior of the hair, and the growth of which is promoted by the dampness of the atmosphere in the gloomy tropical forests, as it soon disappears from the hair of animals kept in captivity in England. Sloths are nocturnal, silent, inoffensive, and solitary animals, and usually produce but one young at birth. They appear to show an almost reptilian tenacity of life, surviving the most severe injuries and large doses of poisons, and exhibiting longer persistence of irritability of muscular tissue after death than other mammals. In the Bradipodidae, as well as in the Myrmecophagidae, the testes are placed close to each other, lying on the rectum between it and the bladder. The penis is quite rudimentary, consisting of a pair of small corpora cavernosa, not directly attached by their crura to the rami of the ischia, and having a gland scarcely larger than that of the clitoris of most mammals, and, as in birds and reptiles, without any true corpus spongiosum. In the females of both families the uterus is simple and globular, and the vagina, at least in the virgin state, is divided into two channels by a strong median partition. The deciduate placenta of Colepus is composed of a number of lobes aggregated into a dome-like mass, and it does not appear that the placenta of the anteaters departs in any important characters from this type. According to the late Professor W. K. Parker, the embryos of the sloths, anteaters, and pangolins have the stapes of the middle ear in the form of a rod, thus showing affinities with a very primitive type of mammalian organization. The sloths were all included in the Linnaean genus Bradipus, but Illiger very properly separated the species with but 2 claws on the 4 feet, under the name of Colepus, leaving Bradipus for those with 3. Bradipus, 92, 3-toed sloths. Teeth usually /4 on each side, no tooth projecting greatly beyond the others, the first in the upper jaw much smaller than any of the rest, the first in the lower jaw broad and compressed, the grinding surfaces of all much cupped. Vertebrae, C9, D and L20, of which 15 to 17 bear ribs, S6, C11. All the known species present the remarkable peculiarity of possessing 9 cervical vertebrae, i.e. 9 vertebrae in front of the one which bears the first thoracic rib, or first rib connected with the sternum, and corresponding in its general relations with the first rib of other mammals, but the 9th, and sometimes the 8th, bears a pair of short movable ribs. The arms or forelimbs are considerably longer than the hind legs. The bones of the forearm are complete, free, and capable of pronation and supination. The hand is long, very narrow, habitually curved, and terminates in 3 pointed curved claws, in close apposition with each other. The claws are, in fact, incapable of being divaricated, so that the hand is reduced to the condition of a triple hook, fit only for the function of suspension from the boughs of trees. The foot closely resembles the hand in its general structure and mode of use, the sole being habitually turned inwards, so that it cannot be applied to the ground in walking. The tongue is short and soft, and the stomach large and complex, bearing some resemblance to that of the ruminating ungulates. The windpipe or trachea has the remarkable peculiarity among mammals, not unfrequent among birds and reptiles, of being folded on itself before it reaches the lungs. The mammae are 2, and pectoral in position. AI is the common name given in books to the 3-toed sloths. They were all comprised by Linnaeus under the species Bradipus tridactylus. More recently Dr. Gray described as many as 11 species, ranged in 2 genera, Bradipus and Arctopithecus, but the distinctions which he assigned both to species and genera do not bear close examination. Some are covered uniformly with a gray or grayish-brown coat, others have a dark collar of elongated hairs around the shoulders, B. torquatus, some have the hair of the face very much shorter than that of the rest of the head and neck, and others have a remarkable-looking patch of soft short hair on the back between the shoulders, consisting, when best marked, of a median stripe of glossy black, bordered on each side by bright orange, yellow, or white. There are also structural differences in the skulls, as in the amount of inflation of the pterygoid bones, which indicate real differences of species, but the materials in our museums are not yet sufficient to correlate these with external characters and geographical distribution. The habits of all are apparently alike. They are natives of Guyana, Brazil, and Peru, and 1 if not 2 species, B. infiscatus and B. castanesops, extend north of the Isthmus of Panama as far as Nicaragua. Of the former of these Dr. Seaman says that, though generally silent, a specimen in captivity uttered a shrill sound like a monkey when forcibly pulled away from the tree to which it was holding. Colepus, 93, teeth/4, the most anterior in both jaws separated by an interval from the others, very large, caniniform, wearing to a sharp, beveled edge against the opposing tooth, the upper shutting in front of the lower when the mouth is closed, figure 59, unlike the true canines of heterodont mammals. Vertebrae, C6 or 7, D23 to 24, L3, S7 to 8, C4 to 6. One species, C. didactylus, has the ordinary number of vertebrae in the neck, but an otherwise closely allied form, C. hoffmanni, has but 6. The tail is very rudimentary. The hand generally resembles that of Bradypus, but there are only 2 functional digits with claws, those answering to the second and third of the typical pentadactylate manus. The structure of the hind limb generally resembles that of Bradypus, the appellation two-toed referring only to the anterior limb, for in the foot the 3 middle toes are functionally developed and of nearly equal size. C. didactylus, which has been longest known, is commonly called by the native name of unau. It inhabits the forests of Brazil. C. hoffmanni, figure 58, has a more northern geographical range, extending from Ecuador through Panama to Costa Rica. Its voice, which is seldom heard, is like the bleat of a sheep, and if the animal is seized it snorts violently. Both species are very variable in external coloration. Figure 59. Skull of two-toed sloth, Colepus didactylus. From Proc. Zoll. SOC 1871, page 432. Nothropus, 94. The only fossil form which has been referred to this family is indicated by a lower jaw, described by Dr. Burmeister, from the Pleistocene of Argentina, which appears to have belonged to an animal of about double the dimensions of Colepus didactylus. Professor Cope states, however, that this jaw really belongs to a glyptodont, while it is referred by Dr. Ameghino to the next family. Family Megatheridae. Figure 60. Section of upper molar teeth of Megatherium americanum. Times 1/3. P. Pulp cavity, the other letters explained in the text. After Owen. The members of this family are all extinct. Their characters, so far as is known from the well-preserved remains of many species found abundantly in deposits of Pleistocene age in both North and South America, were intermediate between those of the existing Bradipodidae and the Myrmecophagidae, combining the head and dentition of the former with the structure of the vertebral column, limbs, and tail of the latter. Almost all the known species are of comparatively gigantic size, the smallest, Nothrotherium escrivenens, exceeding the largest existing anteater, and the Megatherium being larger than a rhinoceros. The femur has no third trochanter, and the odontoid process of the axis vertebra has a peculiar facet on the ventral surface. The dentition is usually /4 on each side, as in the sloths, but /3 in Nothrotherium, 95, this genus, and in a still more marked degree Megatherium, differ from all the others in the details of the structure of the teeth. They are very deeply implanted, of prismatic form, quadrate and transverse section, and the component tissues, hard dentine, figure 60, D, softer vasodentine, V, and cement, C, are so arranged that, as the tooth wears, the surface always presents a pair of transverse ridges, thus producing a triturating apparatus comparable to the bilophodont molar of Dinotherium, Topirus, Menatus, Macropus, and others, though produced in a different manner. In all the other genera the teeth are more or less cylindrical, though sometimes laterally compressed or even longitudinally grooved on the sides, and on the grinding surface the prominent ridge of hard dentine follows the external contour, and is surrounded only by a thin layer of cement, as in the existing sloths. The ground sloths, as the members of this family may be conveniently designated, agree with the sloths and anteaters, and thereby differ from all other mammals, in that the coracoid process of the scapula and the coracoidal border of the same unite over the coracoscapular notch, which is thus converted into a foramen. Large clavicles are present. Megatherium, 96, the typical genus Megatherium, as being the longest known representative of the family, may be noticed in some detail. A nearly complete skeleton, found on the banks of the river Luxon, near Buenos Aires, and sent in 1789 to the Royal Museum at Madrid, long remained the principal if not the only source of information with regard to the species to which it belonged, and furnished the materials for many descriptions, notably that of Cuvier, who determined its affinities with the sloths. 97. In 1832 an important collection of bones of the Megatherium was discovered near the Rio Salado, and secured for the museum of the College of Surgeons of England, and these, with another collection found at Luxon in 1837, and now in the British Museum, supplied the materials for the complete description of the skeleton published by Sir R. Owen in 1861. Other skeletons have subsequently been received by several of the continental museums, as Milan and Paris, and also by those in South America, and consequently our knowledge of the organization of the Megatherium, so far as it can be deduced from the bones and teeth, is as complete as that of any other animal, recent or extinct. Figure 61. Oral surface of mandible of Megatherium americanum. A. Condyle. B. Masseteric process. C. Angle. D. Symphysis. After Owen. The remains hitherto spoken of are all referred to one species, Megatherium americanum of Blumenbach, M. Cuvieri of Desmarest, and are all from the newest or Pleistocene geological formations of the Argentine Republic and Paraguay, or the lands forming the basin of the Rio de la Plata. Dr. Leidy has described, from similar formations in Georgia and South Carolina, bones of a closely allied species, about 1/4 smaller, which he has named M. mirabile. 3 other South American species have been described, but M. laurelardi, of Lund, founded upon remains found in Brazil, has been made the type of the genus Octopus. Figure 62. Skeleton of Megatherium, from the specimen in the Museum of the Royal College of Surgeons. Times superscript 1/25. The following description will apply especially to the best-known South American form, Megatherium americanum. In size it exceeded any existing land animal except the elephant, to which it was inferior only in consequence of the comparative shortness of its limbs, for in length and bulk of body it was its equal, if not superior. The full length of a mounted skeleton, figure 62, from the forepart of the head to the end of the tail, is 18 feet, of which the tail occupies 5 feet. The head, which is small for the size of the animal, presents a general resemblance to that of the sloth. The anterior part of the mouth is, however, more elongated, and the jugal bone, though branched posteriorly in the same way as that of the sloth, meets the zygomatic process of the squamosal, thus completing the arch. The lower jaw has the middle part of its horizontal ramus curiously deepened, so as to admit of implantation of the very long-rooted teeth, the peculiar structure of which has been already described. A skull recently discovered shows that, instead of the wide gap between the extremity of the nasals and the premaxilla exhibited in figure 62, there was a prenasal bone, towards which a process extended upwards and backwards from the extremity of the upper surface of the premaxillae. The vertebral column consists of 7 cervical, 16 dorsal, 3 lumbar, 5 sacral, and 18 caudal vertebrae. The spinous processes are much better developed than in the sloths, and are all directed backwards, there being no reversing of the inclination near the posterior end of the dorsal series, as in most active-bodied mammals. In the lumbar region, the accessory zygapophyses, rudimentary in sloths, are fully developed, as in the anteaters. The tail is large, and its basal vertebrae have strong lateral and spinous processes and chevron bones, indicating great muscular development. The scapula resembles that of the sloths in the union of the acromion with the coracoid, and in the bridging over of the suprascapular notch. The clavicle is complete and very large, much resembling that of man on a large scale. The fore limbs are longer than the hind limbs. The humerus has no antepicondylar foramen. The radius and ulna are both well developed, and have a considerable amount of freedom of movement. The hand is singularly modified. The pollex is represented only by a rudimentary metacarpal, but the next 3 digits are large, and terminate in phalanges adapted for the support of immense claws, the middle one being especially large. The outer or 5th digit has no claw, and it may be considered as certain that the weight of the foot was, in standing and walking, chiefly thrown upon this one, which was protected by a callus pad below, as in the existing great anteater, while the other toes were curved inwards towards the palm, and only came in contact with the ground by their outer surfaces. The mechanical arrangements by which the weight of the body was thrown entirely upon the outer side of the foot are very curious, and are fully described in Owen's memoir. The pelvis is remarkably wide, even more so than that of the elephant, but it is formed on the same principle as in the sloths. The femur is extremely broad and flattened, the tibia and fibula are short and strong, and united together at each end. The hind foot, contrary to the usual rule in the edentata, is even more singularly modified than the hand. Thus the ankle joint is formed upon a peculiar plan, quite unlike that of the sloths, or of any other mammal, except the megatherium's nearest allies, and the calcaneum projects nearly as far backwards as the forepart of the foot does forwards. There is no trace of great toe or hallux, or of its corresponding cuneiform bone. The second toe is rudimentary, while the third has an enormous ungual phalanx, which, as in those of the hand, is remarkable for the immense development of the bony sheath reflected from its proximal end around the base of the claw. The two outer toes have large and very peculiarly shaped metatarsals, but only small phalanges, and no claws. The creature probably walked upon the outer edge of the sole, so that the great falcate claw of the third toe did not come into contact with the ground, and so was kept in a state of sharpness ready for use. The foot was therefore formed upon quite a different principle from that of the anteaters or sloths, though somewhat like the latter in having two of the toes aborted. Taking all the various points of its structure together, they clearly indicate affinities both with the existing sloths and with the anteaters, the skull and teeth more resembling those of the former, and the vertebral column and limbs the latter. It is also not difficult to infer the food and habits of this enormous creature. That it was a leaf-eater there can be little doubt, but the greater size and more complex structure of its teeth might have enabled it to crush the smaller branches as well as the leaves and succulent shoots which form the food of the existing sloths. It is, however, very improbable that it climbed into the branches of the trees like its diminutive congeners, and it is far more likely that it obtained its subsistence by tearing them down with the great hook-like claws of its powerful prehensile forelimbs, being easily enabled to reach them by raising itself up upon the massive tripod formed by the two hind feet, firmly fixed to the ground by the one huge falcate claw, and the stout, muscular tail. The whole conformation of the hinder part of the animal is strongly suggestive of such an action. There can also be little doubt but that all its movements were as slow and deliberate as those of its modern representatives. An idea at one time prevailed that the megatherium was covered externally with a coat of bony armor like that of the armadillos, but this originated in dermal plates belonging to the glyptodon having been accidentally associated with bones of the megatherium. Similar plates, on a smaller scale, have indeed been found in connection with the skeleton of the mylodon, but never yet with the megatherium, which we may therefore imagine with a covering of coarse hair like that of its nearest living allies, the sloths and anteaters. Celidotherium, Mylodon, etc., of the more important remaining genera of this family a briefer notice will suffice. Celidotherium, in which Platyonyx may be included, comprises several species of considerably smaller dimensions than the megatherium, and is in some respects intermediate between that genus and Mylodon. The teeth have an oval cross-section, like those of the sloths, while the skull, in which the length of the nasals is subject to great variation in the different species, approximates more or less closely to that of the Myrmecophagidae. The humerus generally has an entepicondylar foramen, and the form and relations of the bones of the feet differ considerably from those obtaining in the type genus. S. leptocephalum, the type of the genus, occurs in Patagonia and Argentina but other species are found in Brazil and Chile. The genus Mylodon, in its widest sense, may be taken to include a number of comparatively large edentates, some of which have been described under the names of Grypotherium, Lestodon, and Pseudolestodon. The teeth of the upper jaw are generally of an oval or subtriangular section, and in the more typical forms the first and second teeth are separated by a short interval, the former being horizontally worn. In other species, however, like M. Lestodon, armatus, there is a considerable space between the first and second teeth, and the first is worn obliquely. The skull is exceedingly like that of the sloths in general contour, and there is not the descending process at the angle of the mandible found in Megatherium. The humerus has no entepicondylar foramen. The species represented in Figure 63 is from the Pleistocene of South America, but the type of the genus is M. harlani, from beds of corresponding age in Kentucky. The Patagonian M. Grypotherium darwini is a remarkable form, characterized by the presence of a bony arch connecting the premaxilla with the nasals, of which, as already mentioned, there is an incomplete development in Megatherium. Megalonyx, from the Pleistocene of Kentucky, differs from Mylodon by the long interval between the first and second teeth, and also by the presence of an entepicondylar foramen in the humerus. Miltratherium is a smaller form, occurring in the deposits of the Brazilian caves, of which the dental features have been already mentioned. The osteological characters of these and other allied genera have been fully described in the works of Cuvier, Owen, Burmeister, Leidy, Ameghino, Gervais, Reinhardt, and others. Figure 63. Skeleton of Mylodon robustus, Pleistocene, South America. From Owen. Promegatherium. 2 genera from the infrapampian beds of Argentina, described as Promegatherium and Promylodon, are respectively distinguished from Megatherium and Mylodon by the presence of bands of enamel on the teeth, which points to the descent of the edentates from mammals with enameled teeth. The tertiary North American forms described as Moropus and Moratherium, 98, and originally regarded as edentates, would appear to be aberrant ungulates. Family Myrmecophagidae. Externally clothed with hair. No teeth. Head elongated. Mouth tubular, with a small terminal aperture, through which the long, vermiform tongue, covered with the viscid secretion of the enormous submaxillary glands, is rapidly protruded in feeding, and withdrawn again with the adhering particles of aliment, which are then sucked into the pharynx. Clavicles rudimentary. In the Manus, the third toe is greatly developed, and has a long falcate claw, the others are reduced or suppressed. The PES has 4 or 5 subequal digits with claws. Posterior dorsal and lumbar vertebrae, with additional interlocking zygapophyses. Tail long, sometimes prehensile. Uterus simple. Placenta dome-like or discoidal. Brain fairly convoluted, and with a large corpus callosum and anterior commissure. The animals of this family are the anteaters par excellence. They feed exclusively on animal substances, mostly insects. One species is terrestrial, the others are boreal, none burrow in the ground. They are all inhabitants of the neotropical region. The reproductive organs, as noticed on page 181, are of the same general type as in the Bradipodidae. Myrmecophaga, 99, skull greatly elongated and narrow, its upper surface smooth and cylindriform. Anteriorly the face is produced into a long, tubular rostrum, rounded above and flattened below, with terminal nares, and composed of the mesethmoid ossified for more than half its length, the vomer, the maxillae, and the long and narrow nasal bones, the premaxillae being extremely short and confined to the margin of the anterior nares. The zygomatic arch is incomplete, the styliform jugal only articulating with the maxilla in front, and not reaching to the very short zygomatic process of the squamosal. The lacrimal foramen is in front of the margin of the orbit. There are no postorbital processes to the frontals, or any other demarcation between the orbits and the temporal fossae. Palate extremely elongated, and produced backwards as far as the level of the external auditory meatus by the meeting in the middle line of the largely developed pterygoids. The glenoid fossa a shallow oval facet, with its long diameter from before backwards. Mandible very long and slender with an exceedingly short symphysis, no distinct coronoid process, and a slightly elevated, elongated, flattened, condylar articular surface. Vertebrae, C7, D15-16, L3-2, S6, C31. Clavicles rudimentary. In the Manus the first digit is very slender, the second also slender, with compressed phalanges of nearly equal length. The third digit is immensely developed, though its proximal phalanx is extremely short. Its ungual phalanx is so long that the entire length of the digit exceeds that of the second. The fourth has a long and rather slender metacarpal, and 3 phalanges diminishing in size, the ungual phalanx being very small. The fifth has the metacarpal nearly as long, but not so stout, as the fourth, and followed by 2 small phalanges, the last rudimentary and conical. Claws are developed upon all but the fifth. In walking the toes are kept strongly flexed, and have their points turned upwards and inwards, the weight being supported upon a callus pad over the end of the 5th digit, and by the dorsal surfaces of the 3rd and 4th digits. The hind feet are short and rather broad, with 5 subequal claws, the 4th the longest, the 1st shortest. The whole sole is placed on the ground in walking. Body rather compressed, clothed with long, coarse hair. Tail about as long as the body, and covered with very long hair, not prehensile. Ears small, oval, erect. Eyes very small. Stomach consisting of a subglobular, thin-walled, cardiac portion, and a muscular pyloric gizzard with dense epithelial lining. No ileocolic valve, and a short white ill-defined cecum. Mammy 2, pectoral. There is one species, 100 M. jubata, the great anteater, or ant bear, figure 64, measuring 4 feet in length without the tail, and upwards of 2 feet in height at the shoulder. Its prevailing color is gray, with a broad black band, bordered with white, commencing on the chest, and passing obliquely over the shoulder, diminishing gradually in breadth as it approaches the loins, where it ends in a point. It is extensively distributed in the tropical parts of South and Central America, frequenting low swampy savannas along the banks of rivers, and the depths of the humid forests, but is nowhere abundant. Its food consists mainly of termites, to obtain which it opens their nests with its powerful sharp anterior claws, and as the insects swarm to the damaged part of their dwelling, it draws them into its mouth by means of its long, flexible, rapidly moving tongue covered with glutinous saliva. The great anteater is quite terrestrial in its habits, being never known to climb trees, nor does it burrow underground like the armadillos. Though generally an inoffensive animal, when attacked it can defend itself vigorously and effectively with its saber-like anterior claws. The female bears but a single young at a birth. The union of the pterygoids in the middle line to prolong the narial passage is a character found elsewhere among existing mammals only in the next genus, in one armadillo, Tatusia, and in certain cetacea. The contrast in length between the skull of the great anteater and that of the sloth is, as Professor Parker observes, very marked indeed, the one being relatively the longest and the other almost the shortest in the whole class. The small size and incomplete development of the jugal bone in the zygomatic arch affords another striking contrast to the sloths, figure 59. Figure 64. The great anteater, Myrmecophaga jubata. From Sclater, List of Animals in Zoological Society's Gardens, 1883, page 190. Tamandua, 101. This genus closely resembles the last in anatomical structure, but the head is much less elongated, the fur is short and bristly, the tail tapering, prehensile, with the underside throughout and the whole of the terminal portion naked and scaly. The stomach is similar to that of Myrmecophaga, but with the muscular pyloric gizzard not quite so strongly developed. There is a distinct ileocolic valve and a short globular cecum. The forefoot has a very large claw on the third toe, moderate-sized claws on the second and fourth, a very minute one on the first, and none on the fifth, which is entirely concealed within the skin. The hind foot has 5 subequal claws. Vertebrae, C7, D17, L2, S5, C37. There are very rudimentary clavicles. Figure 65. Tamandua anteater, Tamandua tetradactyla. From Proc. Zoll. SOC 1871, PL 43. The tamandua, figure 65, is much smaller than the great anteater, and differs essentially from it in its habits, being mainly arboreal. It is an inhabitant of the dense primeval forests of South and Central America. As different individuals vary much in their coloration, it is possible that there may be more than one species. The usual color is yellowish-white, with a broad black lateral band, covering nearly the whole of the side of the body. Figure 66. Kika of the two-toed anteater, Cycloturus didactylus. I. Ilium, C. Cycloturus, 102. The skull is much shorter even than in Tamandua, and is arched considerably in the longitudinal direction. It differs from that of the other members of the family mainly in the long canal for the posterior nares not being closed by bone below, as the greater part of the palatines and the pterygoids do not meet in the middle line. The mandible has a prominent, narrow, recurved coronoid, and a well-developed angular process. It is strongly decurved in front. Vertebrae, C7, D16, L2, S4, C40. Ribs remarkably broad and flat. Clavicles well developed. Manus remarkably modified, the third digit being greatly developed at the expense of all the others, and having a stout short metacarpal and but 2 phalanges, of which the most distal is large, compressed, pointed, and much curved, and bears a very strong hook-like claw. The second digit has the same number of phalanges, and bears a claw, but is very much more slender than the third. The fourth is represented only by the metacarpal and one nailless phalanx, the first and fifth only by very rudimentary metacarpals. The pes is also completely modified into a climbing organ. The hallux is rudimentary, consisting of a metatarsal and one phalanx, concealed beneath the skin, but the other four toes are subequal and much curved, with long pointed compressed claws. The tuber calcaneae is directed towards the plantar surface, and parallel with it and extending to about double its length is a greatly elongated sesamoid ossicle. These together support a prominent calcarine cushion, to which the nails are opposed in climbing. Stomach piriform, with muscular walls, but no distinct gizzard-like portion, as in the foregoing genera. Commencement of the colon provided with two small ceca, figure 66, resembling those of many birds, narrow at the base, and rather dilated at their terminal blind ends, and communicating with the general cavity by very minute apertures. Tail longer than the body, tapering, bare on the under surface, and very prehensile. Fur soft and silky. This genus has also but one species certainly known, the little or two-toed anteater, C. didactylus, an animal not larger than a rat, of a general yellowish color, and exclusively arboreal in its habits. It is a native of the hottest parts of South and Central America. Family Dasypodidae. The greater part of the skin strongly ossified. On the back and sides the union of numerous quadrate or polygonal scuts forms a hard shield, usually consisting of an anterior, scapular, and posterior, pelvic, solid portion, which overhang on each side the parts of the body they respectively cover, forming chambers into which the limbs are withdrawn, and a variable number of rings between, connected by soft flexible skin so as to allow of curvature of the body. The top of the head has also a similar shield, cephalic, and the tail is usually encased in bony rings or plates. The outer or exposed surfaces of the limbs are protected by irregular bony scuts, not united at their margins, but the skin of the inner surface of the limbs and underside of the body is soft, and more or less clothed with hair. Hairs also in many species project through apertures between the bony scuts of the back. The ossified dermal scuts are everywhere covered by a layer of horny epidermis. Teeth numerous, simple, of persistent growth, and usually monophyodont, but in one genus, Tatusia, a succession of teeth has been observed. Zygomatic arch of skull complete. Cervical vertebrae with extremely short, broad, and depressed bodies. The atlas free, but the second and third, and often several of the others, ankylosed together both by their bodies and arches. Lumbar vertebrae with accessory zygomatic processes, and very large metapophyses, supporting the bony carapace. Clavicles well developed. A third trochanter on the femur. Tibia and fibula ankylosed at their distal extremities. 4 feet with strongly developed, curved claws, adapted for digging and scratching, 3, 4, or 5 in number. Hind feet plantigrade, with 5 toes, all provided with nails. Tongue long, pointed, and extensile, though to a less degree than in the anteaters. Submaxillary glands largely developed. Stomach simple. Uterus simple. Placenta discoidal, deciduate. The brain is generally characterized by the large size of the olfactory lobes, figure 57, and the slight development of sulci on the hemispheres, the sylvian fissure being represented only by a very open and shallow angle. From the earliest stage of development the stapes is stirrup-shaped, thus showing a nearer affinity to the higher mammals than is presented by the sloths. The animals of this family are commonly called armadillos, a word of Spanish origin, having reference to their armor-like covering. The existing species are all of small or moderate size. They are mostly, though not universally, nocturnal in their habits, and are all omnivorous, feeding on roots, insects, worms, reptiles, and carrion. Armadillos are harmless and inoffensive creatures, offering no resistance when caught, their principal means of escape from their enemies being the extraordinary rapidity with which they can burrow in the ground, and the tenacity with which they retain their hold in their subterranean retreats. Notwithstanding the shortness of their limbs, they can run with great rapidity. Most of the species are esteemed good eating by the natives of the countries in which they live. They are all inhabitants of the open plains or the forests of the tropical and temperate parts of South America, with the exception of one species, Tatusia novemcincta, which ranges as far north as Texas. Of the existing genera, Chlamydophorus stands apart from the rest in the formation of its external covering, but in all other respects Titusia is the most aberrant form, exhibiting a peculiar type of structure of the 4 feet, which in all the others show modifications, though in very varying degrees, of a single and different type. The reproductive organs of the Dasypodidae differ from those of the sloths and armadillos in the presence of a largely developed copulating organ in the male, and of a simple vagina of corresponding length in the female. The testes are still abdominal, although not in the same position, and the penis still wants both the glands and bulb. The uterus is nearly or quite as simple as in the sloths and anteaters, and there is no reason to believe that the placentation is essentially different from that obtaining in the other groups. Subfamily Chlamydophorinae. In most anatomical characters, especially the structure of the forefoot, this little group resembles the Dasypodidae, but it differs remarkably from all other known armadillos, living or extinct, in the peculiar modification of the dermal armor. Chlamydophorus, 103, teeth/8-9, subcylindrical, somewhat compressed, moderate in size, smaller at each end, especially in front, than at the middle of the series. Skull broad and rounded behind, pointed in front. Muzzle subcylindrical and depressed. A conspicuous rounded, rough prominence on the frontal bone, just before each orbit. Tympanic prolonged into a tubular auditory meatus, curving upwards round the base of the zygoma. Vertebrae, C7, D11, L3, S10, C15. Upper part of head and trunk covered with 4-sided horny plates, with very small thin ossifications beneath, forming a shield, free, and overhanging the sides of the trunk, and attached only along the middle line of the back. The plates are arranged in a series of distinct transverse bands, about 20 in number between the occiput and the posterior truncated end, and not divided into solid thoracic and pelvic shields with movable bands between. The hinder end of the body is abruptly truncated and covered by a vertically placed, strong, solid, bony shield, of an oval, transversely extended, form, covered by thin epidermic plates. This shield is firmly ankylosed by 5 bony processes to the hinder part of the pelvis. Through a notch in the middle of its lower border the tail passes out. The latter is rather short, cylindrical in its proximal half, and expanded and depressed or spatulate in its terminal portion, and covered with horny plates. The dorsal surfaces of the fore and hind feet are also covered with horny plates. The remainder of the limbs and undersurface and sides of the body beneath the overlapping lateral parts of the dorsal shield are clothed with rather long, very soft, silky hair. Eyes and ears very small, and concealed by the hair. Extremities short. Feet large, each with 5 well-developed claws, those on the 4 feet very long, stout, and subcompressed, the structure of the digits being essentially the same as those of Xenurus and Priodon. Nipples 2, pectoral. Visceral anatomy closely resembling that of Dasypus, the cecum being broad, short, and bifid. The Pichisago, C. truncatus, a small burrowing animal, about 5 inches long, inhabits the sandy plains of the western part of the Argentine Republic, especially the vicinity of Mendoza. Its horny covering is of a pinkish color, and its silky hair snow-white. It is rare, and its habits are but little known. A second species, C. retusa, from Bolivia, has been described by Burmeister. It is of rather larger size, and has the dorsal shield attached to the skin of the back as far as its edge, instead of only along the median line. Subfamily Dasypodinae. 4 feet usually with all 5 digits developed and with nails, though the first and fifth may be suppressed. The first and second long and slender, with the normal number and relative length of phalanges. The others stout, with short broad metacarpals, and the phalanges greatly reduced in length and generally in number by coalescence. The ungual phalanx of the third very large, that of the others gradually diminishing to the fifth. Dasypus, as now restricted, has the most normal form of manus, but the modifications so markedly developed in all the others, and culminating in taliputes, are foreshadowed, as it were, in it. Ears wide apart. Mammy 1 pair, pectoral. Dasypus, 104, teeth/9, of which the anterior in the upper jaw is usually implanted in the premaxillary bone. The series of teeth extends posteriorly some distance behind the anterior root of the zygoma, almost level with the hinder edge of the palate. They are large, subcylindrical, slightly compressed, diminishing in size towards each end of the series, the anterior two in the mandible much smaller, and more compressed than the others. Cranial portion of the skull broad and depressed. Facial portion triangular, broad in front and much depressed. Auditory bulla completely ossified, perforated on the inner side by the carotid canal, and continued externally into an elongated bony meatus auditorius, with its aperture directed upwards and backwards. In all the remaining genera of Dasypodini, the tympanic bone is a mere half ring, loosely attached to the cranium. Mandible with a high ascending ramus, broad transversely placed condyle, and high slender coronoid process. Vertebrae, C7, D11 to 12, L3, S8, C17 to 19. Head broad and flat above. Muzzle obtusely pointed. Ears of moderate size or rather small, placed laterally, far apart. Body broad and depressed. Carapace with 6 or 7 movable bands between the scapular and pelvic shields, each plate, or scute, being marked by a regular ellipse formed of widely separated punctures. Tail shorter than the body, tapering, covered with plates forming distinct rings near the base. 4 feet with 5 toes, the first much more slender than the others, and with a smaller ungual phalanx and nail, the second, though the longest, also slender. The third, fourth, and fifth gradually diminishing in length, all armed with very strong, slightly curved, compressed claws, sloping away from an elevated rounded inner border to a sharp, outer, and inferior edge. The hind foot rather short, with all 5 toes armed with stout, compressed, slightly curved, obtusely pointed claws, the third the longest, the second nearly equal to it, the fourth the next, the first and fifth shorter, and nearly equal. To this genus belongs one of the best-known species of the group, the 6-banded armadillo or incubert, D. succinctus, of Brazil and Paraguay. A very similar species, D. villosus, the hairy armadillo, replaces it south of the Rio Plata. There are also 2 very small species, D. velorosus, from the Argentine Republic and North Patagonia, and D. minutus from La Plata. The latter differs from the other 3 in having no tooth implanted in the premaxillary bone. Remains apparently referable to D. villosus occur in the Pleistocene cavern deposits of Brazil. Zanuarus, 105, teeth/9 or /8, of moderate size and subcylindrical. The most posterior placed a little way behind the anterior root of the zygoma, but far from the hinder margin of the palate. Cranium somewhat elongated, much constricted behind the orbits, and immediately in front of the constriction considerably dilated. Mandible slender, coronoid process very small and sharp-pointed, sometimes obsolete. Vertebrae, C7, D12 to 13, L3, S10, C18. Head broad behind. Ears rather large and rounded, wide apart. Movable bands of carapace 12 to 13, the scuts being marked by an obscurely granular sculpture. Tail considerably shorter than the body, slender, and covered with nearly naked skin, with but a few small, scattered, dermal bony plates, chiefly on the under surface and near the apex. On the 4 feet the first and second toes are long and slender, with small claws and the normal number of phalanges. The other toes have but 2 phalanges, the third has an immense falcate claw, the fourth and fifth similar but smaller claws. The hind feet are comparatively small, with 5 toes, bearing small, triangular, blunt nails, the third longest, the first shortest. The best-known species of this genus, the tatoué or cabasson, X. unicinctus, is, after Priodon gigas, the largest of the group. It is found, though not abundantly, in Suriname, Brazil, and Paraguay, its remains occurring in the Pleistocene cavern deposits of Brazil. Others, X. hispidus and lugubris, have been described, but little is as yet known of them. Priodon, 106, teeth variable in number, and generally differing on the 2 sides of each jaw, usually from 20 to 25 on each side above and below, so that as many as 100 may be present altogether, but as life advances the anterior teeth fall out, and all traces of their alveoli disappear. The series extends as far back as the hinder edge of the anterior root of the zygoma. The teeth are all very small, those in the anterior half of each series being strongly compressed, with flat sides and a straight free edge. The posterior ones are more nearly cylindrical, with flat truncated, free surfaces. Vertebrae: C7, D12, L3, S10, C23. Head small, elongated, conical. Ears moderate, ovate. Carapace with 12 to 13 movable bands. Tail nearly equal to the body in length, gradually tapering, closely covered with quadrangular scales, arranged in a quincunx pattern. 4 feet with 5 toes, formed on the same plan as those of Xenurus, but with the claw of the third of still greater size, and that of each of the others, especially the fifth, proportionately reduced. Hind foot short and rounded, with 5 very short toes, with short, broad, flat, obtuse nails. The only known species, the great armadillo, P. gigas, is by far the largest of existing members of the family, measuring rather more than 3 feet from the tip of the nose to the root of the tail being about 20 inches long. It inhabits the forests of Suriname and Brazil. The powerful falcate claws of its 4 feet enable it to dig with great facility. Its food consists chiefly of termites and other insects, but it is said to attack and uproot newly made graves for the purpose of devouring the flesh of the bodies contained in them. Taliputes, 107, teeth/9 or /9, rather large in proportion to the size of the skull, the hinder end of the series reaching nearly to the posterior margin of the palate. Vertebrae: C7, D11, L3, S12, C13. Ears placed low on the sides of the head, rather large, broadly ovate. Carapace with its scapular and pelvic shields very free at the sides of the body, forming large chambers into which the limbs can be readily withdrawn. Only 3 movable bands, sculpture of scuts in the form of subconcentrically arranged granules. Tail short, conical, covered with large bony tubercles. The 4 feet formed on the same type as in the last genus, but the peculiarities carried out to a still greater extent. The claw of the third toe is very long and falcate, the first and fifth greatly reduced and sometimes wanting. On the hind foot the 3 middle toes have broad, flat, subequal nails, forming together a kind of tripartite hoof, the first and fifth much shorter, with more compressed nails. The armadillos of this genus have the power of rolling themselves up into a perfect ball, the shield on the top of the head and the tuberculated dorsal surface of the tail exactly fitting into and filling up the apertures left by the notches at either end of the carapace. This appears to be their usual means of defense when frightened or surprised, as they do not burrow like the other species. They run very quickly, with a very peculiar gait, only the tips of the claws of the 4 feet touching the ground. 3 species are described: T. tricinctus, the apar, T. canurus, the madico, and T. murrii. Remains apparently referable to T. canurus are of not uncommon occurrence in the Brazilian cavern deposits. Subfamily Tutusionidae. This group contains but one genus, Tutusia, 108, teeth/8 or /7, very small subcylindrical. The first and second subcompressed, the last considerably smaller than the others. They present the remarkable peculiarity, elsewhere found among edentates, so far as is yet known, only in Oricpterapus, of all being, with the exception of the last, preceded by 2-rooted milk teeth, which are not changed until the animal has nearly attained its full size. Vertebrae: C7, D9 to 11, L5, S8, C20 to 27. Head narrow, with a long, narrow, subcylindrical, obliquely truncated snout, pterygoids meeting in the middle line below the nasal passage. Ears rather large, ovate, and erect, placed close together on the occiput. Carapace with 7 to 9 distinct movable bands, sculpture on scuts consisting of pits arranged in a V shape. Body generally elongated and narrow. Tail moderate or long, gradually tapering, its dermal scuts forming very distinct rings for the greater part of its length. 4 feet with 4 visible toes, and a concealed clawless rudiment of the fifth. Claws all long, slightly curved, and very slender, the third and fourth subequal and alike, the first and fourth much shorter. Hind feet with 5 toes, all armed with strong, slightly curved, conical, obtusely pointed nails. The third longest, then the second and fourth, the first and fifth much shorter than the others. Figure 67. The Peba armadillo, Titusia novemcincta. This genus differs from all the other armadillos in having a pair of inguinal mammae, in addition to the usual pectoral pair, and in producing a large number, 4 to 10, of young at a birth, all the others having usually but 1 or 2. The Peba armadillo, T. novemcincta, figure 67, is a well-known species, having an extensive range from Texas to Paraguay. It is replaced in the more southern regions of South America by a smaller species, with shorter tail, the Melita, T. hybrida, so called from the resemblance of its head and ears to those of a mule. T. capleri is a large species from Suriname. A rare armadillo from Peru described under the names of Cryptophractus pilosus and Priapus hirsutus, but which evidently belongs to Titusia, is of some interest owing to the thick coat of hair with which it is covered. This animal appears to be closely allied to T. novemcincta, from which it mainly differs by having the whole of the carapace covered with a thick coating of light brown, fine, but rather stiff hair, about 1.5 inches in length. Similar hair is found on the cheeks, the proximal portions of the limbs, and, although less abundantly and shorter, on the under surface of the body. The cephalic shield, snout, feet, and the tail, with the exception of the root, are bare. The coating of hair on the back and sides completely conceals the carapace, except near the margin of the scapular region, but by separating the hairs the bands and scuts are rendered visible. 109. In the Pleistocene cavern deposits of Brazil have been found remains of T. novemcincta, and also of T. punctata, which appears to be an extinct form nearly allied to T. capleri, but of somewhat larger size. Extinct genera. In addition to remains referable to existing genera, the above-mentioned deposits have also yielded evidence of the former existence of extinct generic types of armadillos, some of which attained very large dimensions. Of these Utatus was a large form distinguished from all existing genera by the circumstance that the whole of the carapace was composed of movable bands, which were 33 in number. Dasypitherium was a still larger form, furnished with 8 teeth, of which the second seems to have been larger than the others. This genus is regarded as connecting the modern armadillos with the next one. The gigantic Chlamyditherium, the scuts of which are common in the Brazilian caves, is considered to have been as large as a rhinoceros. The carapace has several movable bands, but the teeth approximate in structure to those of the next family, so that the genus tends to connect the armadillos with the glyptodonts. Family Glyptodontidae. Figure 68. Tooth of glyptodon from the side, and from the grinding surface. After Owen. In the Pleistocene cavern deposits of Brazil, but still more abundantly in the fluviatile deposits which cover the country in the neighborhood of Buenos Aires, are found the remains of some of the most remarkable forms of mammals yet discovered, the glyptodonts, which may be regarded as forming a separate extinct family. They differ from the existing Dasypodidae in their large size, and in having the carapace composed of a solid piece, formed by the union of a multitude of bony dermal scuts, without any movable rings, and in usually having also a ventral piece or plastron. The facial portion of the skull is very short. A long process of the maxillary bone descends from the anterior part of the zygomatic arch. The ascending ramus of the mandible is remarkably high. The teeth are /8 in the known species, all much alike, having 2 deep grooves or flutings on each side, so as to divide them into 3 nearly distinct lobes, figure 68. The vertebral column is almost entirely ankylosed into a solid tube, and there is a complex joint at the base of the neck, to allow of the head being retracted within the carapace. The limbs are very strong, and the feet short and broad, resembling externally those of an elephant or tortoise. This family is mainly characteristic of the southern half of the American continent, but some species of the type genus ranged into Texas and Mexico. Many species of the family have been described and figured, especially by Burmeister, in the Annals del Museo Público de Buenos Aires, among which the following may be noticed. Hoplophorus is characterized by the sculptured and frequently thin scuts of the carapace, those of the periphery being flat, and not raised into prominences. The caudal sheath has several overlapping movable rings at the base, and ends in a long subcylindrical terminal tube similar to the one represented with the carapace of Glyptodon in figure 69, which in all probability really belongs to the genus under consideration. Each foot has 4 complete digits, and the humerus has an antepicondylar foramen. Most of the species are of medium size. Part of a caudal tube from Uruguay described as Eleutherocercus indicates, however, a much larger allied form, in which the tail appears to have had a number of stout bristles protruding from the joints between the scuts. Panocthus comprises very large glyptodonts, distinguished by the great thickness of the scuts of the carapace, which are ornamented with tubercles. The termination of the caudal sheath forms a tube bearing large radiated tubercles. Euryurus is distinguished by the radiate sculpture of the scuts of the carapace. Doedicurus, of which one species was about 12 feet in length, also has a rugose sculpture on the carapace, but the termination of the caudal tube is expanded into a club-like shape, flattened from above downwards, and covered with tubercles mingled with a few large radiate discs, which, as in Panocthus, probably carried horny spines in the living condition. The typical genus Glyptodon has each scute of the carapace ornamented with a rosette-like sculpture, the peripheral scuts being raised into conical prominences, figure 69. The caudal sheath, instead of being like the one represented in the figure, was entirely composed of a series of movable rings, ornamented with large tubercles. The manus had 5 digits, and the pes 4, and there was an antepicondylar foramen to the humerus. A species of this genus, which attained very large dimensions, was made the type of Schistoplurum, on the supposition that the tail of Glyptodon was of the type represented in figure 69. The genus Thoracophorus, of the Pleistocene of South America, as well as Caryoderma, of the Pliocene of Texas, differ from all the preceding in having the scuts of the carapace in the form of disconnected nodules. Glyptodonts also occur in South American beds of earlier age than the Pleistocene, some of these forms having enamel bands on the teeth. Why such a form as the Glyptodon should have failed to keep his ground is, as the late Professor W. K. Parker remarks, a great mystery. Nature seems to have built him, as Rome was built, for eternity. Figure 69. Glyptodon clavipes, Pleistocene, South America. From Owen. The tail is incorrectly restored, and it is probable that the figured portion belongs to Hoplophorus. The left lower corner shows an upper and a lower view of the skull, and the right a section of the caudal sheath. Family Manatee. Covered externally, except the under surface of the body and inside of the limbs, with large imbricated horny scales, and scattered hairs growing in the intervals. No teeth. Tongue long, vermiform, and protractile. No accessory articular processes to the lumbar vertebrae, but the anterior zygapophyses largely developed and deeply concave, completely embracing the semi-cylindrical surfaces of the posterior zygapophyses. Limbs short, with 5 complete digits on each foot. Scaphoid and lunar bones of carpus united. Uterus bicornuate. Placenta diffused and non-deciduate. All the existing forms belong to the Ethiopian and Oriental regions of the Old World. The absence of additional articular processes to the lumbar vertebrae is a character in which this and the following family differ from all the preceding forms. Manus, 110, skull somewhat of the form of an elongated cone, with the small end turned forwards, very smooth and free from crests and ridges. No distinction between the orbits and temporal fossae. The zygomatic arch usually incomplete, owing to the absence of the jubal bone. No distinct lacrimal bone. Palate long and narrow. The pterygoids extend backwards as far as the tympanics, but do not meet in the middle line below. Tympanic ankylose to the surrounding bones, and more or less bolate, but not produced into a tubular auditory meatus. Rami of mandible very slender and straight, without any angle or coronoid process. From near the anterior extremity of the upper edge a sharp, conical, tooth-like process projects upwards and outwards. No clavicles. No third trochanter to the femur. Ungual phalanges bifid at their terminations. Caudal vertebrae with very long, strong transverse processes and numerous chevron bones. Tongue long, vermiform, flattened towards the tip, its retractor or sternoglossal muscles arising from the hinder extremity of the immensely prolonged ensiform cartilage of the sternum. Stomach with thick lining membrane and muscular walls, and a special gland near the middle of the great curvature, consisting of a mass of complex secreting follicles, the ducts of which terminate in a common orifice. No cecum. A gallbladder. Head small, depressed, narrow, pointed in front, with a very small mouth opening. Eyes and pinna of ear very small. Body elongated, narrow. Tail more or less elongated, convex above, flat underneath. The whole of the upper surface of the head, the upper surface and sides of the body, the whole of the tail, and the outer sides of the extremities covered with large, overlapping, horny scales, but usually with a few stiff hairs growing between and projecting beyond them. The sides and under surface of the head, the under surface of the body, and the inner sides of the limbs without scales, but with a rather scanty covering of hair. Limbs short. In walking, the dorsal surface and outer sides of the phalanges of the two outer digits of the front feet alone rest on the ground, the points of the nails turning upwards and inwards. The third toe the longest, with a powerful compressed curved claw, the second and fourth with similar but smaller claws, that of the pollex often almost rudimentary. Hind feet plantigrade, with the hallux very short, and the four other toes subequal, with moderate, curved, subcompressed nails. The reproductive organs of Manus are of a totally different type from those of the families already noticed. The testes lie in the inguinal canal, and the penis is external and well developed. The uterus is truly bicornuate, the vagina not divided, and the placenta diffused and non-deciduate. All the organs and fetal membranes are, indeed, formed very much on the plan of those of the ungulates, without any trace of the special peculiarities obtaining in the typical American edentates. The animals of this genus, which includes all the existing forms, are called pangolins or scaly anteaters, and are all of small or moderate size, terrestrial and burrowing, and feed mainly on termites. Several of them can climb trees. Their length varies from 1 to 5 feet. They can roll themselves up in a ball when in danger. Their peculiar elongated form, short limbs, long, gradually tapering tail, and scaly covering give them on a superficial inspection more the appearance of reptiles than of mammals. The species are not numerous, and may be divided into two groups distinguished by a few not very important external characters, these groups also coinciding with the present geographical distribution of the genus. These two groups, according to Mr. O. Thomas, may be distinguished as follows. The Asiatic pangolins are characterized by having the central series of body scales continued quite to the extreme end of the tail, by having many isolated hairs growing up between the scales of the back, and by their small external ears. They all have a small naked spot beneath the tip of the tail, which is said to be of service as an organ of touch. There are 3 species, viz. Manus javanica, ranging from Burma, through Malacca and Java, to Borneo, M. morita, found in China, Formosa, and Nepal, and the common Indian pangolin, M. pentadactyla, distributed over the whole of India and Ceylon. The African species have the central series of scales suddenly interrupted and breaking into two at a point about 2 or 3 inches from the tip of the tail. They have no hair between the scales, and no external ear conch. The following are the 4 species belonging to this group: the long-tailed pangolin, M. macrura, which has a tail nearly twice as long as its body, and containing as many as 49 caudal vertebrae, being the largest number known among mammals; the white-bellied pangolin, M. tricuspis, figure 70, closely allied to the last, but with longer and tricuspid scales, and white belly hairs. These two, like the Indian species, have a naked spot beneath the tail tip, a character probably correlated with the power of climbing, and they are, moreover, peculiar in having the outer sides of their 4 legs clothed with hair, all the other species being scaly there as elsewhere. Lastly, the short-tailed and the giant pangolins, M. teminki and gigantea, both of which have their tails covered entirely with scales, and evidently never take to arboreal habits. All the 4 species of the second group are found in the West African region, one only, M. teminki, extending also into South and Eastern Equatorial Africa. Figure 70. The white-bellied pangolin, Manus tricuspis. According to Professor W. K. Parker, 111, who remarks upon the peculiarly aberrant nature of the group, the horny scales of the pangolins really consist of cemented hairs. This writer states that in the early embryo lozenge-shaped tracts of skin are seen all over its body, with lines of thinner cuticle between. Under the microscope, sections of these thicker tracts show that they are composed of fine hairs, cemented together by a copious growth of epidermic cells. Here and there larger hairs are seen, but these fail to reach the surface, turning again towards the inside, like nails driven into wood that is too hard for their points. The same author also observes, 112, that there are occasional instances of the presence of 8 cervical vertebrae in the pangolins, a feature which has been considered to indicate some former genetic connection between this family and the sloths. The following account of the habits of Manus tricuspis is given by Mr. L. Fraser in his Zoologia Typica. During my short residence at Fernando Pa, I succeeded in procuring 2 living specimens of this animal. The individuals, judging from the bones, were evidently not adult. The largest measured 30 inches in length, of which the head and body were 12 inches and the tail 18 inches. I kept them alive for about a week at Fernando Pa, and allowed them the range of a room, where they fed upon a small black ant, which is very abundant and troublesome in the houses and elsewhere. Even when first procured they displayed little or no fear, but continued to climb about the room without noticing my occasional entrance. They would climb up the somewhat roughly hewn square posts which supported the building with great facility, and upon reaching the ceiling would return head foremost. Sometimes they would roll themselves up into a ball and throw themselves down, and apparently without experiencing any inconvenience from the fall, which was in a measure broken upon reaching the ground by the semi-yielding scales, which were thrown into an erect position by the curve of the body of the animal. In climbing, the tail, with its strongly pointed scales beneath, was used to assist the feet, and the grasp of the hind feet, assisted by the tail, was so powerful that the animal would throw the body back, when on the post, into a horizontal position, and sway itself to and fro, apparently taking pleasure in this kind of exercise. It always slept with the body rolled up, and when in this position in a corner of the building, owing to the position and strength of the scales, and the power of the limbs combined, I found it impossible to remove the animal against its will, the points of the scales being inserted into every little notch and hollow of the surrounding objects. The eyes are very dark hazel, and very prominent. The colonial name for this species of Manus is Audadillo, and it is called by the boobies, the natives of the island, Gala. The flesh is said to be exceedingly good eating, and is in great request among the natives. The Indian species is said to live in pairs, and to give birth to 1 or 2 young at a time in the spring. Their burrow reaches a depth of some 12 feet, and terminates in a large chamber, which may be as much as 6 feet in diameter. A faint hiss appears to be the only sound emitted by these animals. Remains of a large species of Manus, which are indistinguishable from the corresponding bones of the existing West African M. gigantea, are found fossil in cave deposits in the Karnal district of Madras. This is one among several instances of the close connection between the Pleistocene and Pliocene mammalian fauna of India with the existing African fauna. Paleomenes, 113, the lower Pliocene deposits of the Isle of Samos, in the Turkish archipelago, have yielded remains of a pangolin fully 3 times the dimensions of M. gigantea, upon the evidence of which the genus Paleomenes has been established. Family Orctopodidae, external surface scantily covered with bristle-like hairs. Teeth numerous, apparently heterodont, diffeodont, and a peculiar and complex structure, being traversed by a number of parallel vertical pulp canals. Lumbar vertebrae with no accessory zygapophyses. Femur with a 3rd trochanter. 4 feet without pollex, but all the other digits well developed, with strong moderate-sized nails, suited to digging, the plantar surfaces of which rest on the ground in walking. Hind feet with 5 subequal toes. Mouth elongated and tubular. Tongue subvermiform. Uterus bicornuate. Placenta broadly zonular. Feeding on animal substances. Terrestrial and fossorial in habits. Now mainly limited to the Ethiopian region. Orycterapus, 114, the total number of permanent teeth appears to be from 8 to 10 in each side of the upper, and 8 in the lower jaw, but they are never all in place at one time, as the small interior teeth are shed before the series is completed behind. In the adult they number usually 5 on each side above and below, of which the first 2 are simple and compressed, the next 2 larger and longitudinally grooved at the sides, the most posterior simple and cylindrical. The last 3 in either jaw, having no milk predecessors, may be regarded as true molars. The structure of all these teeth is quite peculiar among mammals, though resembling that of some fishes. Their summits are rounded before they are worn, Their bases do not taper to a root, but are evenly truncated and continually growing. Each tooth is made up of an aggregation of parallel dental systems, having a slender pulp cavity in the center, from which the dentinal tubes radiate outwards, and being closely packed together. Each system assumes a polygonal outline as seen in transverse section. The small anterior teeth have milk predecessors which are fully noticed below. Skull moderately elongated. The facial portion subcylindrical and slightly tapering. The zygoma complete and slender. The palate ends posteriorly in the thickened transverse border of the palatines, and is not continued back by the pterygoids. The tympanic is annular, and not ankylosed to the surrounding bones. The mandible is slender anteriorly, but rises high posteriorly, with a slender recurved coronoid, and an ascending pointed process on the hinder edge below the condyle, which is small, oval, and looks as much forwards as upwards. Vertebrae, C7, D13, L8, S6, C27. The large number of lumbar vertebrae is peculiar among edentates. Tongue less vermiform than in Myrmecophaga, being thick and fleshy at the base, and gradually tapering to the apex. The salivary apparatus is developed much in the same manner as in that genus, but the duct of the submaxillary gland has no reservoir. The stomach consists of a large subglobular cardiac portion, with a very thick, soft, and corrugated lining membrane, and a smaller muscular, pyloric part, with a comparatively thin and smooth lining. There is a very distinct ileocecal valve, and a considerable sized cecum, also a gallbladder. Head elongated, with a tubular snout, terminal nostrils, and small mouth opening. Ears large, pointed, erect. Tail nearly as long as the body, cylindrical, very thick at the base, tapering to the extremity. The reproductive organs and placentation of Oricterapus are formed upon a principle unknown in the more typical edentates, or, in combination, in any other mammals. Thus the testes, in the one described example, were inguinal, but appeared to descend, at all events temporarily, into a scrotum, but the penis is scarcely larger than that of the great anteater. The uterus is still more fully bicornuate than in Manus, with its two lateral chambers opening separately into the vagina, as in certain rodents. The placenta is broadly zonary, but it is not known whether it is deciduate or not. It might readily be derived from the diffused placenta of Manus by the abortion of the fetal villi at the two poles of the ovum. The Oricteropodidae have long been regarded as widely different from other edentates, their presumed affinity with the Manatee being more or less problematical, but the discovery recently made by Mr. O. Thomas, 115, that they have a milk dentition still further emphasizes their aberrant nature. According to this observer, it appears that there are normally no less than 7 milk teeth in the upper jaw, the hindmost of which is far larger than the others, having a rudimentary crown, and a distinct anterior and posterior root. The other milk teeth are styloform, the 4 anterior ones being very minute, and separated from one another by equal intervals. The foremost of all is situated immediately behind the premaxillomaxillary suture. In the mandible only 4 milk teeth have hitherto been detected, of which the hindmost has the comparatively complex form found in the corresponding upper tooth. None of these milk teeth appear, however, to cut the gum, so that the whole set is entirely functionless. Under the microscope these milk teeth show signs of possessing a commencement of the remarkable histological structure found in the permanent teeth. Mr. Thomas remarks that since the 3 large posterior teeth of Oricterapus, already distinguished by their more molariform shape, do not have milk predecessors, while all the small teeth anterior to them do, and in addition the last milk tooth is markedly different from those in front of it, we ought apparently no longer to look upon this animal as an homodont, but instead to consider it as an originally heterodont form in which the incisors and canines have been suppressed to allow free play to the mobile vermiform tongue. But important as a knowledge of the presence of a milk dentition in Oricterapus is, it does not at present render any easier the difficult questions as to the phylogeny and systematic position of that animal. Although called an edentate, it has always been recognized as possessing many characters exceedingly different from those of the typical American members of the order. It has in fact been placed with them rather on account of the inconvenience of forming a special order for its reception than because of its real relationship to them. Now, as they are either altogether toothless, or else homodont and monophyodont, apart from the remarkable exception of Titusia, it seems more than ever incorrect to unite with them the solitary member of the Tubulidentata, toothed, heterodont, and diffeodont, and differing from them in addition by its placentation, the anatomy of its reproductive organs, the minute structure of its teeth, and the general characters of its skeleton. But if Oricterapus is not genetically a near relation of the edentates, we are wholly in the dark as to what other mammals it is allied to, and I think it would be premature to hazard a guess on the subject. Whether even it has any special connection with Manus is a point about which there is the greatest doubt, and unfortunately we are as yet absolutely without any paleontological knowledge of the extinct allies of either. Macrotherium even, usually supposed from the structure of its phalangeal bones, to be related to Manus, has lately proved to have the teeth and vertebrae of a perissodactyle ungulate, and one could not dare to suggest that ancestors of Manus, or Oricterapus were to be sought in that direction. Lastly, as the numerous fossil American edentates do not show the slightest tendency to an approximation towards the Old World forms, we are furnished with an additional reason for insisting on the radical distinctness of the latter, whose phylogeny must therefore for the present remain one of the many unsolved zoological problems. The aardvarks, earth pigs, as these creatures are commonly termed, from the name bestowed on them by the Dutch Boers of the Cape, are of nocturnal habits, sleeping during the day in their burrows, which are usually found in the neighborhood of the tall hills or mounds made by termites. Indeed, wherever these hills are abundant it is stated there is a good chance of finding an aardvark, the food of these animals consisting almost exclusively of termites and ants. Two existing species are recognized, namely the Cape aardvark, O. afra, from South Africa, and another, O. ethiopicus, from the northeastern parts of Africa, ranging into Egypt. An extinct species has been described from the lower Pliocene of the Isle of Samos, in the Turkish archipelago, differing from the existing forms by the larger proportionate size of the lateral metatarsals. Bibliography of Edentata. No general work on the order has been published since that of Rapp, Anat Untersuchungen über die Identiten, 2d edition 1852. Among numerous memoirs on special groups the following may be cited: Myrmecophagidae, R. Owen, Anatomy of Great Anteater, Trans Zol SOC Volume 4, G. Pouchet, MEM. Sur le Grand Formelier, 1874, W. A. Forbes, Anat of Great Anteater, Proc. Zol SOC 1882, page 287. Megatheridae, R. Owen, Extinct Gigantic Sloth, Mylodon robustus, 1842, ID, On the Megatherium, Phil. Trans 1851-56, J. Leidy, Extinct Sloth Tribe of North America, Smithsonian Contribution to Knowledge, 7. 1855, H. Burmeister, Description de la République Argentine, T3. Mammifers, 1879, which contains full references to various memoirs by Owen, Gervais, Reinhardt, and others. Glyptodontidae, Owen, Catalogue of Fossil Mammals, Muse Roy. Call Surgeons, 1845, T. H. Huxley, Osteole. Of Glyptodon, Phil. Trans 1865, H. Burmeister, Annals del Museo Público de Buenos Aires, and Descript. De la République Argentine, 1879, H. Gervais and F. Amagino, Les Mammifères Fossiles de l'Amérique Méridionale, Paris, 1880, which also contains a list of all the American edentates described at that date. Dasypodidae, J. Murray, Anatomy of Taliputes, Trans Lin. SOC Volume 30. 1874, A. H. Garrod, Proc. Zol SOC 1878. For placentation of edentates C. W. Turner, Trans Roy. SOC Eden. 27, 1873, page 72, and Journ. Anat and Physiol Volumes 8. And X, A. Milne-Edwards, and Sciences Nat. 6, 8. Page 1, and for Brain, P. Gervais, Formes Cerebrales des Dentes, Neuve. Arch du Museum, Tom. V. W. Turner, Jour Anatomy, I. 313, 1867. For the dentition of Oricterapus C. O. Thomas, A Milk Dentition in Oricterapus, Proc. Roy. SOC Volume 47. Page 246, 1890. Fuller observations on the mutual relations of the various families are given by W. H. Flower, On the mutual affinities of the animals composing the order Edentata, Proc. Zoll SOC 1882, page 358. Chapter 8 The Order Sirenia and Cetacea Order Sirenia. The purely aquatic habits and fish-like form of the animals of this order caused them to be formerly confounded with the Cetacea, but a more intimate knowledge of their structure has shown that they really belong to a widely different type of the mammalian class. The head is rounded and not disproportionate in size as compared with the trunk, from which it is scarcely separated by any externally visible constriction or neck. Nostrils valvular, separate, and placed above the forepart of the obtuse truncated muzzle. Eyes very small, with imperfectly formed eyelids, capable, however, of contraction, and with a well-developed nictitating membrane. Ear without any pinna. Mouth of small or moderate size, with tumid lips beset with stiff bristles. General form of the body depressed, fusiform. No dorsal fin. Tail flattened and horizontally expanded. Forelimbs paddle-shaped, the digits being enveloped in a common cutaneous covering, on which rudiments of nails are sometimes present. No trace of hind limbs in existing forms. External surface covered with a tough, finely wrinkled, or very rugose skin, naked, or with fine hair sparsely scattered over it. The skeleton is remarkable for the massiveness and density of most of the bones of which it is composed, especially the skull and ribs, which must add to the specific gravity of these slow-moving animals, and aid in keeping them to the bottom of the shallow waters in which they dwell, while feeding on aquatic vegetables. The skull presents many peculiarities, among which may be indicated the large size and backward position of the anterior narial aperture, a further modification of that met within the tapers among ungulates, and presenting some approach to that so characteristic of the Cetacea. The nasal bones are generally absent in the recent forms, or are only found in a most rudimentary condition, attached to the edge of the frontals, far away from the middle line, but in some at least of the extinct species these bones, though small in size, are normal in situation and relations. In very few other respects does the skull present any resemblance to that of the Cetacea. In the spinal column of existing forms none of the vertebrae are united together to form a sacrum, and the flat ends of the bodies do not ossify separately, so as to form disc-like epiphyses in the young state, as in nearly all other mammals. Traces of epiphyses have, however, been recently detected in Monatus, and they were fully developed in Halotherium and other fossil forms. The anterior caudal vertebrae have well-developed chevron bones. In one genus, Monatus, there are only 6 cervical vertebrae. There are no clavicles. The humerus has a small but distinct trochlear articulation at the elbow joint. The 2 bones of the forearm are about equally developed, and generally ankylosed together at both extremities. The carpus is short and broad, and the digits 5 in number, with moderately elongated and flattened phalanges, which are never increased in number beyond the limit usual in the Mammalia. The pelvis is extremely rudimentary, consisting of a pair of bones suspended at some distance from the vertebral column. In no existing species is there any trace of a hind limb, but in the extinct Halotherium an acetabular depression and rudimentary femur have been discovered. 2 kinds of teeth, incisors and molars, separated by a wide interval, are generally present. The former may be developed into tusks in the upper jaw, or may be quite rudimentary. The molars vary much in character. In one genus, Rhytina, no teeth of any kind are present, at least in the adult. Some fossil forms show a more decidedly heterodont dentition, while Halotherium has milk teeth, of which no traces have been observed in the recent genera. In all recent types the anterior part of the palate, and a corresponding surface on the prolonged symphysis of the lower jaw, are covered with rough horny plates of peculiar structure, which doubtless assist in mastication. The tongue is small and fixed in position, with a surface resembling that of the plates just spoken of. The salivary glands are largely developed. The stomach is compound, being divided by a valvular constriction into 2 principal cavities, the first of which is provided with a singular glandular pouch near the cardiac end, and the second usually with a pair of elongated, conical, caecal sacs or diverticula. The intestinal canal is long, and has very muscular walls. There is a cecum either simple, conical, and with extremely thick walls, as in Halochore, or bifid, as in Monatus. The heart is broad and flat, with its apex deeply cleft between the ventricles. The principal arteries form very extensive and complex rhetia mirabilia. The lungs are remarkably long and narrow, as, owing to the very oblique position of the diaphragm, the thoracic cavity extends far back over the abdomen. The epiglottis and arytenoid cartilages of the larynx do not form a tubular prolongation as in the cetacea, so that the epiglottis is not intranarial. The brain is of comparatively small size, and the convolutions on the surface of the cerebrum are few and shallow. The kidneys are simple. The testes abdominal. The uterus is bicornuate. The placenta, in the dugong, is non-deciduate and zonary. The umbilical vesicle disappears early. The mammæ are two, and pectoral, or rather post-axillary in position. The Sirenia pass their whole life in the water, being denizens of shallow bays, estuaries, lagoons, and large rivers, but, unlike the cetacea, are not met within the high seas, far away from the shore. Their food consists entirely of aquatic plants, either marine algae or freshwater grasses, upon which they browse beneath the surface, as the terrestrial herbivorous mammals do upon the green pastures on shore. They are generally gregarious, slow, and inactive in their movements, mild, inoffensive, and apparently unintelligent in disposition. Though occasionally found stranded by the tide or waves, there is no satisfactory evidence that they voluntarily leave the water to bask or feed on the shore. The habit of the dugong of raising its round head out of the water, and carrying its young under the fore fin, seems to have given rise, among the imaginative early voyagers in the Indian Ocean, to the legendary beings, half human and half fish, in allusion to which the name Sirenia was bestowed by Illiger on the order, though certainly the face of a dugong, when closely inspected, does not bear the slightest resemblance to that of the mermaid of romance. The species now existing are very few, and there is reason to believe that the time is not far distant when they will all become extinct. One species, Rhytnostellari, of the North Pacific, was totally exterminated through the agency of man during the last century, and the others, being valuable for their flesh as food, for their hides, and especially for the oil obtained from the thick layer of fat which lies immediately beneath their skin, rapidly diminish in numbers as civilized populations occupy the regions forming their natural habitat. The surviving species are confined to the tropical regions of the shores of both sides of the Atlantic and the great rivers which empty themselves into that ocean, and to the coasts of the Indian Ocean from the Red Sea to North Australia. In the Miocene and early Pliocene epoch Sirenians abounded in the seas of Europe, and their remains have been found in deposits of corresponding periods in North America. Evidence has also been discovered of the existence of an animal of this group in the seas at the bottom of which the Eocene Nummulitic limestone mountain ranges of Egypt were deposited. The existing genera present such well-marked distinguishing characters that it is on the whole convenient to place them in separate families, although, as in so many similar cases, our knowledge of the extinct forms, imperfect as it is, goes far to bridge over the distinction between them. Family Monadidae. The characters of this and the two following families may be conveniently included under the heading of the single genus by which they are respectively represented. Monadus, 116, incisors superscript 2/2, rudimentary, concealed beneath the horny oral plates, and disappearing before maturity. Molars superscript 1, but rarely more than /6 present at one time, the anterior teeth falling before the posterior come into use, similar in characters from beginning to end of the series, with square, enameled crowns, the grinding surface raised into tuberculated transverse ridges. The upper teeth with 2 ridges and 3 roots, the lower teeth with an additional, posterior, ridge or talon, and 2 roots. The cervical vertebrae present the remarkable anomaly of being reduced to 6 in number, the usual vertebral formula being C6, D17, L2, and C23 to 25. Rostrum of the skull, formed by the union of the premaxilla in front of the anterior narial aperture, shorter than the length of the aperture and scarcely deflected from the basicranial axis, premaxilla and mandibular symphysis not markedly deflected, figure 72. Tail entire, rounded, or shovel-shaped. Rudimentary nails on the forelimbs. Cecum bifid. Habitat the shores of, and the great rivers which empty themselves into, the Atlantic within the tropics. These animals are rather fluviatile than marine, ascending large rivers almost to their sources. The manatee may be selected for a somewhat full description, as being one of the best-known representatives of this very remarkable order. The name manatee was apparently first applied to this animal by the early Spanish colonists of the West Indies, in allusion to the hand-like use which it frequently makes of its four limbs, by English writers from the time of Dampier, who gives a good account of its habits. Downwards it has been generally spelt manatee. It was placed by Linnaeus in his heterogeneous genus Trichicus, but Storr's name Manatus is now generally accepted for it by zoologists. The question of the specific distinction of the African and American manatees will be treated of further on, but it will be chiefly to the latter and better known form that the following description applies. Figure 71. American manatee, Manatus americanus, from life. Proc. Zoll. SOC 1881, page 457. The size of the manatee has been much exaggerated, but there is no trustworthy evidence of its attaining a greater length than 8 feet. Its general external form may be seen in Figure 71, taken from a living example in the Brighton Aquarium. The body is somewhat fish-like, but depressed and ending posteriorly in a broad, flat, shovel-like, horizontal tail, with rounded edges. The head is of moderate size, oblong, with a blunt, truncated muzzle, and divided from the body by a very slight constriction or neck. The four limbs are flattened oval paddles, placed rather low on the sides of the body, and showing externally no signs of division into fingers, but with a tolerably free motion at the shoulder, elbow, and wrist joints, and with 3 diminutive flat nails near their extremities. No traces of hind limbs are discernible either externally or internally, and there is no dorsal fin. The mouth is very peculiar, the tumid upper lip being cleft in the middle line into 2 lobes, each of which is separately movable, as will be described in speaking of its manner of feeding. The nostrils are 2 semilunar valve-like slits, at the apex of the muzzle. The eyes are very minute, placed at the sides of the head, and with a nearly circular aperture with wrinkled margins. The external ear is a minute orifice situated behind the eye, without any trace of pinna. The skin generally is of a dark grayish color, not smooth and glistening, like that of the cetacea, but finely wrinkled. At a little distance it appears naked, but a close inspection, at all events in young animals, shows a scanty covering of very delicate hairs, and both upper and under lips are well supplied with short stiff bristles. Figure 72. Skull of African manatee, Manatus senegalensis. 1/5 natural size. From Muse Roy. Call surgeons. The general form of the skull is seen in Figure 72. The cerebral cavity is rather small as compared with the size of the animal, and of oblong form. Its roof is formed of the parietal bones as in ordinary mammals. The squamosal has an extremely large and massive zygomatic process, which joins the largely developed jugal bone in front. The orbit is small, but prominent and nearly surrounded by bone. The anterior nares taken together form a lozenge-shaped aperture, which looks upwards and extends backwards considerably behind the orbits. Their sides are formed by the ascending processes of the premaxilla below, and by the supraorbital processes of the frontals above, no traces of nasals being found in most skulls, though these bones are occasionally present in a most rudimentary condition, attached to the edges of the frontals, far away from the middle line, in a position quite unique among the mammalia. In front of the narial aperture the face is prolonged into a narrow rostrum, formed by the premaxillae, supported below and at the sides by the maxillae. The undersurface of this is very rugose, and in life covered by a horny plate. The rami of the mandible are firmly united together at the symphysis, which is compressed laterally, slightly deflected, and has a rugose upper surface. To this another horny plate is attached, which, with that of the upper jaw, functionally supplies the place of teeth in the anterior part of the mouth. In the young state there are rudimentary teeth concealed beneath these horny plates, which never penetrate through them, and must therefore be quite functionless, and altogether disappear before the animal is full-grown. There is besides on each side of the hinder part of both upper and lower jaws, a parallel row of molar teeth, similar in characters from the beginning to the end of the series, with square enameled crowns raised into tuberculated transverse ridges, something like those of the tapir and kangaroo. The upper teeth have 2 ridges and 3 roots, the lower teeth have an additional posterior small ridge or talon, and but 2 roots. These teeth succeed each other from before backwards, as in the proboscidea, those at the front of the mouth being worn out and shed before those at the back are fully developed. There are altogether about 11 on either side of each jaw, but rarely more than 6 are present at one time. The brain is remarkably simple in structure, its hemispheres exhibiting none of the richness of convolution so characteristic of the cetacea. The mammary glands of the female are situated just behind and to the inner side of the origin of the pectoral limb. The red corpuscles of the blood are among the largest of those of any members of the class, averaging in diameter, according to Gulliver, superscript 1/24 of an inch. Manatees pass the whole of their life in the water, inhabiting bays, lagoons, estuaries, and large rivers, but the open sea, so congenial to the cetacea, is quite unsuited to their peculiar mode of life. As a general rule they prefer shallow water, in which, when not feeding, they lie near the bottom, supporting themselves on the extremity of the tail, or slowly moving about by the assistance of the 4 limbs, the tips of which are just allowed to touch the ground, and only raising the top of the head above the surface for the purpose of breathing at intervals of 2 or 3 minutes. In deeper water they often float, with the body much arched, the rounded back close to the surface, and the head, limbs, and tail hanging downwards. The air in the lungs obviously assists them to maintain this position, acting in the same manner as that in the air sac of fishes. Their food consists exclusively of aquatic plants, on which they browse beneath the water. They are extremely slow and inactive in their movements, and perfectly harmless and inoffensive. Frequent attempts have been made to keep specimens alive in captivity, and sometimes with considerable success, one having lived in the Brighton Aquarium for upwards of 16 months. It was fed chiefly on lettuce and endive, but would also eat leaves of the dandelion, sow-thistle, cabbage, turnip, and carrot. From this and other captive specimens some interesting observations upon the mode of life of the animal have been made. One of these is the free use it makes of its 4 limbs. From the shoulder joint, they can be moved in all directions, and the elbow and wrist permit of free extension and flexion. In feeding these creatures push the food towards their mouths by means of one of the hands, or both used simultaneously, and anyone who has seen these members thus employed can readily believe the stories of their carrying their young about under their arms. Still more interesting and quite unique among mammals is the action of the peculiar lateral pads formed by the divided upper lip, thus described by the late Professor Garrod. These pads have the power of transversely approaching towards and receding from one another simultaneously, see figure 73, A and B. When the animal is on the point of seizing, say, a leaf of lettuce, the pads are diverged transversely in such a way as to make a median gap of considerable breadth. Directly the leaf is within grasp the lip pads are approximated, the leaf is firmly seized between their contiguous bristly surfaces, and then drawn inwards by a backward movement of the lower margin of the lip as a whole. The animal is thus enabled by the unaided means of the upper lip to introduce food placed before it without the assistance of the comparatively insignificant lower lip, the action greatly recalling to the observer that of the mouth of the silkworm and other caterpillars, in which the mandibles diverge and converge laterally during mastication. When out of water the manatee is an extremely helpless animal, and, although statements are frequently met with in books of its voluntarily leaving the water for the purpose of basking or feeding on shore, all trustworthy observations of those acquainted with it, either in a state of nature or in captivity, indicate that it has not the power of doing so. None of the specimens in confinement have been observed to emit any sound. Figure 73. Front view of head of American manatee, showing the eyes, nostrils, and mouth. A. With the lobes of the upper lip divaricated, B. With the lip contracted. From Muri, Trans-Zol SOC Volume 11. Manatees, though much less numerous than formerly, are still occasionally found in creeks, lagoons, and estuaries in some of the West India Islands, and at various spots on the Atlantic coast of America from Florida as far south as about 20 degrees south lat, and in the great rivers of Brazil, almost as high as their sources. They are also met with in similar situations on the opposite African coast, from about 16 degrees north to 10 degrees south lat, and as far into the interior as Lake Chad. Their range may even extend, if native reports obtained by Schweinfurth are correctly interpreted, to the river Kibele, 27 degrees east long. A considerable number of specific names have been applied to the existing manatees, but according to the researches of Dr. Hartlaub, 117, they may be reduced to 3 species, distinguished from one another, among other features, by the characters of the skull, and more especially the relations of the nasals to the adjacent bones. Of these, the American manatee may be known as M. americanus, although it has been described under the names of M. laterostris and M. australis. The African manatee, M. senegalensis, differs from the American species in the following cranial characters: the anterior part of the rostrum is shorter, shallower, and altogether smaller, the orbit is smaller, the zygomatic process is more deep and massive, the jugal bone is deeper from above downwards, the upper margin of the anterior nares is narrower and with a smooth and rounded, instead of a thin and serrated, edge, the upper surface of the frontal is flat, instead of concave, the foramen. Magnum and occipital condyles are narrower from side to side, and the symphysis of the mandible is smaller and shallower. Finally, M. inunguis is a fluviatile species confined to the Amazon and Orinoco, which has been but recently fully brought under the notice of zoologists. Family Halichoridae. Halichor, 118, in the upper jaw a pair of large, nearly straight, tusk-like incisors, directed downwards and forwards, partially coated with enamel. In the male they have persistent pulps, and beveled cutting edges, which project a short distance from the mouth, but in the female, though they remain through life in the alveolar cavity, they are not exserted, and, the pulp cavity being filled with osteodentine, they soon cease to grow, as in the female narwhal. In the young there is also a second small deciduous incisor on each side above. At this age there are also beneath the horny plate which covers the anterior portion of the mandible 4 pairs of slender conical teeth lodged in wide alveolar depressions. These become absorbed before the animal reaches maturity. The molars are usually /5, sometimes /6, altogether, but not all in place at once, as the first falls before the last rises above the gum. They are more or less nearly cylindrical in section, except the last, which is compressed and grooved laterally, without distinction into crown and root, increasing in size from before backwards, with persistent pulps and no enamel. The summits of the crowns are tuberculated before wearing, afterwards flattened or slightly concave. Skull with rostrum formed by the union of the premaxilla in front of the narial aperture, longer than the aperture itself, bending downwards at a right angle with the basicranial axis, and enclosing the sockets of the large incisor tusks. Anterior part of the lower jaw bent down in a corresponding manner. Vertebrae, C7, D18-19, L and C30. Tail broadly notched in the middle line, and with 2 pointed lateral lobes. No nails on the 4 limbs. Cecum single. The dugongs are more distinctly marine in their habits than the manatees, feeding chiefly on seawater algae. They inhabit the shallow bays and creeks of the Red Sea, east coast of Africa, Ceylon, islands of the Bay of Bengal and the Indo-Malayan archipelago, including the Philippines, and the north coast of Australia, ranging from Barrow Reefs on the west to Moreton Bay on the east. Although the distinctive characters are not very obvious, they have been divided into 3 species, according to the localities which they respectively inhabit: H. tabernaculi from the Red Sea, H. dugong from the Indian Seas, and H. australis from Australia. The last named has lately been the object of a regular fishery, chiefly on account of its oil, which is peculiarly clear, limpid, and free from disagreeable smell, and is said to have the same medicinal properties as cod liver oil. Although often stated in books to attain the length of 20 feet when adult, there does not appear to be any evidence from actual specimens in museums that dugongs ever reach half that size, 8 feet being the common length of adult animals. The placentation of this genus has been recently described by Sir W. Turner, who first indicated its zonary form. Family Rhytinidae. Rhytina, 119, no teeth, their place being supplied functionally by the dense, strongly ridged, horny oral plates. Premaxillary rostrum about as long as the anterior narial aperture, and moderately deflected. Vertebrae, C7, D19, L and C34-37. Head very small in proportion to the body. tail with 2 lateral pointed lobes. Pectoral limbs small and truncated. Skin naked and covered with a very thick, hard, rugged, bark-like epidermis. Stomach without caecal appendages to the pyloric cavity. Cecum simple. Only one species of this genus is known, R. stellari, the northern sea cow, by far the largest animal of the order, attaining the length of 20 to 25 feet. It was formerly an inhabitant of the shores of 2 small islands in the North Pacific, Bering and the adjacent Copper Island, on the former of which it was discovered by the ill-fated navigator whose name the island bears, when, with his accomplished companion, the German naturalist Steller, he was wrecked upon it in 1741. 27 years afterwards, 1768, as is commonly supposed, the last of the race was killed, 120, and its very existence would have been unknown to science but for the interesting account of its anatomy and habits left by Steller, and the few more or less imperfect skeletons which have recently rewarded the researches carried on in the frozen soil of the islands around which it dwelt. There is no evidence at present of its having inhabited any other coasts than those of the islands just named, although it can hardly be supposed that its range was always so restricted. When first discovered it was extremely numerous in the shallow bays round Bering Island, finding abundant nutriment in the large laminaria growing in the sea. Its extirpation is entirely due to the Russian hunters and traders who followed upon the track of the explorers, and, upon Steller's suggestion, lived upon the flesh of the great sea cows. Its restricted distribution, large size, inactive habits, fearlessness of man, and even its affectionate disposition towards its own kind when wounded or in distress, all contributed to accelerate its final extinction. According to Steller's account, the Rhytina had a skin of a dark brown color, sometimes spotted or streaked with white. The forelimb was covered with short brush-like hairs. Extinct Sirenians. Halotherium, 121. The Miocene and early Pliocene seas of Europe abounded in Sirenians, to which the generic name of Halotherium was given by Kopp, but which have also received other names. They had large tusk-like incisors in the upper jaw, as in the existing dugongs, though not so greatly developed. Their molar teeth were /5 or /6, anteriorly simple and single-rooted, posteriorly those above with 3 and those below with 2 roots, and with enameled and tuberculated or ridged crowns, in all which respects they more resemble those of the manatee than of the dugong. The anterior molars were deciduous, and there is evidence of the presence of milk teeth. Germs of inferior incisors were also present. Some species at least had nasal bones, short, broad, but normal in position, whereas in all the existing genera these bones are quite rudimentary. Another and still more important evidence of conformity to the general mammalian type is the better development of the pelvic bone, and the presence of a small styliform femur articulated to the acetabulum, although no traces of any other part of the limb have been discovered. These ancient Sirenians, which may be regarded as representing a distinct family, Halotheridae, were thus, in dental, cranial, and other osteological characters, less specialized than are either of the existing species, and if the intermediate links could be discovered might well be looked upon as the ancestral forms from which the latter have been derived, but at present the transitional conditions have not been detected. So far as is yet known, when changes in the physical conditions of the European seas rendered them unfitted to be the habitation of Sirenians, the Halotherium type still prevailed. If the existing dugongs and manatees are descended from it, their evolution must have taken place during the Pliocene and Pleistocene epochs, the one in seas to the east, the other to the west of the African continent, which has long formed a barrier to their intercommunication. Halotherium remains have been found in many parts of Germany, especially near Darmstadt, also in France, Italy, Belgium, Malta, etc. Until a few years ago none were known from England, probably owing to the absence of beds of an age corresponding to those in which they are found on the European continent, but a skull and several teeth have been detected among the rolled debris of which the Red Crag of Suffolk is partially composed. The species are not yet satisfactorily characterized. Some of them appear to have attained a larger size than the existing manatee or dugong. One of these, from the Pliocene of Italy and France, having but /5 molar teeth, has been separated generically under the name of Felsinitherium by Capellini, by whom it has been fully described, but the difference in the number of the teeth does not afford sufficient grounds for separation from Halotherium. Miocene of the Belgian Miocene differs in that the last upper molar is the smallest, in place of the largest of the whole series of teeth. Figure 74. The penultimate and last right lower molars of Halotherium fossil, from the Miocene of the continent. After de Blainville. Other forms. Remains from the Pliocene of France described as prohalochore are regarded as indicating a Sirenian closely allied to halochore, while a molar from the Tertiary of California has been made the type of Desmodilus, which is likewise referred to the halochoridae. Dioplotherium, from the phosphorites of South Carolina, has been considered to connect halochore with Halotherium, but even its ordinal position is uncertain. A portion of a skull found in the Pliocene of Belgium has been described as Crassitherium by Van Beneden, and some compressed teeth, somewhat similar to but larger than those of the dugong, discovered in the Miocene of the department of Lot-et-Garonne, France, gave origin to the genus Rhytiatus of E. Lartet. Of this genus, which may be identical with Trachytherium of the French Miocene, better preserved remains have subsequently been described by Delfortree. These show that the rostrum is more elongated than in Halotherium, but the skull is otherwise very similar, as are the molar teeth. The incisors are very large, exerted, strongly compressed, almost saber-like, rounded on the upper or anterior surface, sharp below, concave on the external and convex on the inner side, and transversely striated. Pachyacanthus from the Miocene of the Vienna Basin is also, according to Van Beneden, another form of Sirenian, of which, however, the skull is not known. In various Miocene marine formations of the United States of America other remains of Sirenians have been found, but mostly in such a fragmentary condition that they afford at present little evidence of the early history of the group in that country. A more satisfactory discovery is that of a nearly complete skull and some bones from a tertiary limestone formation in Jamaica. It is of smaller size than the manatee, and, so far as the teeth are concerned, of a still more generalized character than Halotherium, the dentition being apparently I superscript 3/3, C superscript 1/P plus M/8 equals 48. The incisors are small, not developed into tusks. The canines, wanting in all existing Sirenians, are rather larger than the incisors, judging by the sockets, and the molars are bilophodont, and covered with enamel. It has been described by Sir R. Owen under the name of Parastomus cyanoides. Some writers regard this genus as the type of a distinct family, the Parastomatidae. Unfortunately, we have no knowledge of the geological antiquity of the formation in which it was embedded. Lastly must be mentioned the Eotherium aegyptiacum, Owen, founded on the cast of a brain, with a small quantity of surrounding bone, discovered in the Nummulitic limestone of Eocene age in the Mokattam Hills, near Cairo. The brain is narrower than in Manatus, and resembles that of Halotherium. This is of interest as the most ancient known evidence of any Sirenian whose age has been geologically determined. Teeth from the same deposits referred to Manatus not improbably belong really to Eotherium. The few facts as yet collected relating to the former history of the Sirenia leave us as much in the dark as to the origin and affinities of this peculiar group of animals as we were when we only knew the living members. They lend no countenance to their association with the Cetacea, and on the other hand their supposed affinity with the Ungulata, so much favored by modern zoologists, receives no very material support from them. Bibliography of Sirenia. J. F. Brandt, Symboli Sirenologicae, St. Petersburg, 3 fasciculi, 1846-61-68, an exhaustive account of the anatomy, affinities, and literature of the group, with copious illustrations of the osteology of Rhytina. Anatomy of Dugong, Everard Home, Phil. Trans 1820, page 315, Owen, Proc. Zol. SOC 1838, page 29. Placenta of Dew, W. Turner, Trans Roy. SOC Eden. Volume 35. 1889, Manatee, W. Vralik, Bijdragen tot de Dierkunde, 1851, J. Murray, On the Form and Structure of the Manatee, Trans Zol. SOC London. Volume 8. Page 127, 1872, and Further Observations on the Manatee, Ibid. Volume 11. Page 19, 1880, A. H. Garrod, Notes on the Manatee recently living in the Zoological Society's Gardens, Ibid. Volume 10, page 137, 1875, H. C. Chapman, Observations on the Structure of the Manatee, Proc. Academic, Nat. Sciences of Philadelphia, 1875, page 452, A. Crane, Notes on the Habits of the Manatees in Captivity in the Brighton Aquarium, Proc. Zoll SOC London. 1881, page 456. Extinct Sirenia, Gervais, Journal de Zoologie, Tom. 1 p. 332, 1872. R. Lydecker, Catalogue of Fossil Mammalia in the British Museum, PTV Order Cetacea. This is perhaps the most distinctly circumscribed and natural of all the larger groups into which the class is divided. The external form is fish-like, the body being fusiform, passing anteriorly into the head without any distinct constriction or neck, and posteriorly tapering off gradually towards the extremity of the tail, which is provided with a pair of lateral, pointed expansions of skin supported by dense fibrous tissue, called flukes, forming together a horizontally placed triangular propelling organ, notched in the middle line behind. The head is generally large, in some species attaining to even more than 1/3 of the entire length of the animal, and the aperture of the mouth is always wide, and bounded by stiff immobile lips. The four limbs are reduced to the condition of flattened ovoid paddles, encased in a continuous integument, showing no external sign of division into arm, forearm, and manus, or of separate digits, and without any trace of nails. There are no traces of hind limbs visible externally. The general surface of the skin is smooth and glistening, and devoid of hair, although in many species there are a few fine bristles in the neighborhood of the mouth, which may either persist through life, or be present only in the young state. Immediately beneath the skin, and intimately connected with it, is a thick layer of fat, held together by a dense mesh of areolar tissue, constituting the blubber, which serves the purpose of the hairy covering of other mammals in retaining the heat of the body. In nearly all species a compressed median dorsal tegumentary fin is present. The eye is small, and is not provided with a nictitating membrane or true lacrimal apparatus. The external auditory meatus is a very minute aperture in the skin situated at a short distance behind the eye, and there is no vestige of a pinna. The nostrils open either separately or by a single crescentic valvular aperture, not at the extremity of the snout, but near the vertex of the head. The bones generally are spongy in texture, the cavities being filled with oil. In the vertebral column the cervical region is remarkably short and immobile, and the vertebrae, originally always 7 in number, are in many species more or less fused together into a solid mass. The odontoid process of the axis, when that bone is free, is usually very obtuse, or even obsolete. None of the vertebrae are united together to form a sacrum. The lumbar and caudal vertebrae are numerous and large, and, as their arches are not connected by any articular processes, zygapophyses, they are capable of a very free motion in all directions. The epiphyses at the ends of the vertebral bodies are very distinct flattened discs, not uniting until after the animal has attained its full dimensions. 122. There are largely developed chevron bones, the presence of which indicates the distinction between the caudal and lumbar vertebrae. The skull, figure 75, is modified in a very peculiar manner. The brain case is short, broad, and high, in fact almost spherical. The supraoccipital bone rises upwards and forwards from the foramen magnum, to meet the frontals at the vertex, thus completely excluding the parietals from the upper region of the cranium. The frontals are expanded laterally to form the roof of the orbits. The anterior narial aperture opens upwards, and has in front of it a more or less horizontally prolonged rostrum, formed of the maxillae, premaxillae, vomer, and mesethmoid cartilage, extending forwards to form the upper jaw or roof of the mouth. There are no clavicles. The humerus is freely movable on the scapula at the shoulder joint, but beyond this the articulations of the limb are imperfect, the flattened ends of the bones coming in contact with each other, with fibrous tissue interposed, allowing of scarcely any motion. The radius and ulna are distinct, about equally developed, and much flattened, as are also all the bones of the manus. There are 4, or more commonly 5 digits, and the number of the phalanges of the second and third digits always exceeds the normal number in mammals, sometimes very considerably. Hyperphalangism. They present the exceptional character of having epiphyses at both ends. 123. The pelvis is represented by a pair of small styloform bones placed longitudinally, suspended below and at some distance from the vertebral column at the commencement of the caudal region. These appear to represent the ischia, as the crura of the corpora cavernosa are attached to them. In some species, to the outer surface of these are fixed other small bones or cartilages, the rudiments of the hind limb. Figure 75. A section of the skull of a young dolphin, Globicephalus malaz, times 1/5. PMX, premaxilla, MX, maxilla, ossified portion of the mesethmoid, and anterior nares, nasal, IP, interparietal, FR, frontal, parietal, superoccipital, exoccipital, baseoccipital, SQ, squamosal, periodic, AS, allosphenoid, PS, presphenoid, point, pterygoid, PN, posterior nares, PL, palatine, vomer, S, symphysis of mandible, ID, inferior dental canal, CP, coronoid process of mandible, CD, condyle, A, angle, SH, stylohyle, BH, basohyal, TH, thyrohyal. From Flower's Osteology of Mammalia. Teeth are generally present, but exceedingly variable in number. In the existing species they are of simple, uniform character, all having conical or compressed crowns and single roots, and are never preceded by milk teeth. They are therefore homodont and monophyodont. In one group, the mysticocetes, the teeth are absent, except, in the fetal condition, and the palate is provided with numerous transversely placed horny laminae or baleen. The salivary glands are rudimentary or absent. The stomach is multilocular, its structure being fully noticed under the genus Phocina. The intestinal canal is simple, and only in some species provided with a small cecum. The liver is very little fissured, and there is no gallbladder. The vascular system is greatly complicated by arterial and venous plexuses, or rhetia mirabilia. The larynx is of peculiar shape, the arytenoid cartilages and the epiglottis being much elongated, and together forming a tubular prolongation, which projects into the posterior nares, and when embraced by the soft palate produces a continuous passage between the nostrils and the trachea, as in ungulates, but in a more perfect manner. The brain is large relatively to the size of the animal, very round in form, and with its surface divided by sulci into very numerous and complex convolutions. The kidneys are deeply lobulated. The testes are abdominal. There are no vesiculae seminals, nor os penis. The uterus is bicornuate, and the placenta nondeciduate and diffuse. The mammae are 2 in number, and the nipples placed in depressions on each side of the vulva. The principal ducts of the gland are dilated during lactation into large reservoirs, into which the milk collects, and from which it is injected by the action of a compressor muscle into the mouth of the young animal, by which means the process of sucking under water is greatly facilitated and expedited. The animals of the order Cetacea abound in all known seas, and some species are inhabitants of the larger rivers of South America and Asia. Their organization necessitates passing their life entirely in the water, as on land they are absolutely helpless. They have, however, to rise very frequently to the surface for the purpose of respiration, and, in relation to the constant upward and downward movement in the water thus necessitated, their principal instrument of motion, the tail, is expanded horizontally, quite unlike that of a fish, whose movements are mainly in straightforward or lateral directions. The position of the respiratory orifice or nostril on the highest part of the head is very important for this mode of life, since it is the only part of the body of which the exposure above the surface is absolutely necessary. Of the numerous erroneous ideas connected with natural history, few are so widespread and still so firmly believed, notwithstanding repeated expositions of its falsity, as that the cetacea spout out through their blowholes water taken in at the mouth. The fact is, the spouting, or more properly blowing, of the whale is nothing more than the ordinary act of expiration, which, taking place at longer intervals than in land animals, is performed with a greater amount of emphasis. The moment the animal rises to the surface it forcibly expels from its lungs the air taken in at the last inspiration, which of course is highly charged with watery vapor in consequence of the natural respiratory changes. This, rapidly condensing in the cold atmosphere in which the phenomenon is generally observed, forms a column of steam or spray, which has been erroneously taken for water. It also often happens, especially when the surface of the ocean is agitated into waves, that the animal commences its expiratory puff before the orifice has quite cleared the top of the water, some of which may thus be driven upwards with the blast, tending to complete the illusion. In hunting whales, the harpoon often pierces the lungs or air passages of the unfortunate victim, and then fountains of blood may be forced high in the air through the blowholes, as commonly depicted in scenes of Arctic adventure, but this is nothing more, allowance being made for the whale's peculiar mode of breathing, than what always follows severe wounds of the respiratory organs of other mammals. All the cetacea are predaceous, subsisting on living animal food of some kind. One genus alone, Orca, eats other warm-blooded animals, as seals, and even members of its own order, both large and small. Some feed on fish, others on small floating crustaceans, pteropods, and medusae, while the principal staple of the food of many is constituted by the various species of cephalopods, loligo, and other Teuthidae, which must abound in certain seas in vast numbers, as they form almost the entire support of some of the largest members of the order. In size the cetacea vary much, some of the smaller dolphins scarcely exceeding 4 feet in length, while others are the most colossal of all animals. It is true that most statements of their bulk found in general and even zoological literature are greatly exaggerated, but even when reduced to their actual dimensions, which will be stated under the respective genera, some of the existing whales exceed in size any animal living either at present or in former times of which we have any certain evidence. With some exceptions, the cetacea generally are timid and inoffensive animals, active in their movements, and very affectionate in their disposition towards one another, especially the mother towards the young, of which there is usually but one, or at most 2 at a time. They are generally gregarious, swimming in herds or schools, so termed by the whalers, sometimes amounting to many thousands in number, though some species have hitherto only been met with either singly or in pairs. Although by their mode of life so far removed from close observation that it is impossible to become as familiar with them in their natural condition as with many other animals, whales are in many respects the most interesting and wonderful of all creatures, and there is much in their structure and habits well worthy of study, much that is difficult to understand, and much that leads to great generalizations and throws light upon far-reaching philosophical speculations. One of the first lessons which a study of these animals affords is that, in the endeavor to discover what a creature really is, from what others it is descended, and to what it is related, the general outward appearance affords little clue, and we must go deep below the surface to find out the essential characteristics of its nature. There was once, and may be still in many places, a common idea that a whale is a fish. To realize the fallacy of this notion we have only to consider what a fish really is, what under all the diversities of form, size, and color known among fishes there is common to them all, and we see that in everything which characterizes a true fish and separates it from other classes, as reptiles, birds, and mammals, the whale resembles the last named and differs from the fish. It is as essentially a mammal as a cow or a horse, and simply resembles a fish externally because it is adapted to inhabit the same element, but it is no more on that account a fish than is a bat, because adapted to pass a great part of its existence on the wing in the air, nearly related to a bird. The whole structure of a whale is a most instructive instance of a type of organization which is common to and characteristic of the class Mammalia, but specially modified or adapted to a peculiar mode of life. We see in every part the result of 2 great principles acting and reacting upon each other, on the one hand, adherence to type, or rather to fundamental inherited structural conditions, and, on the other, adaptation to the peculiar circumstances under which it lives, and to which in all probability it has become gradually more and more fitted. The external fish-like form is perfectly suited for swimming through the water. The tail, however, is not placed vertically as in fishes, but horizontally, a position which accords better with the constant necessity for rising to the surface for the purpose of breathing. The hairy covering characteristic of all mammals, which at present might interfere with rapidity of movement through the water, is reduced to the merest rudiments, a few short bristles about the chin or upper lip, which are often only present in very young animals, and the function of keeping the body warm is supplied by the blubber. The forelimbs, though functionally reduced to mere paddles, with no power of motion except at the shoulder joint, have beneath their smooth and continuous external covering all the bones, joints, and even most of the muscles, nerves, and arteries of the human arm and hand, and the rudiments of hind legs found buried deep in the interior of the animal apparently subserve no useful purpose, but point an instructive lesson to those who are able to read it. As before said, the Cetacea form a perfectly well-defined group, sharply separated from all other mammals, and with no outlying or doubtful forms at present known. Among the existing members of the order, there are two very distinct types, the toothed whales or Odontoceti and the baleen whales or Mysticoceti, which present as many marked distinguishing structural characters as are found between many other divisions of the Mammalia which are reckoned as orders. The extinct Zeuglodon, so far as its characters are known, does not fall into either of these groups, but is in some respects an annectant form, and therefore must be placed, provisionally at least, in a third group by itself. The Mysticocetes appear at first sight to be the most specialized and aberrant of the existing Cetacea, as indicated by the absence of teeth, the presence of baleen, and the form and size of the mouth, but, as we see in other groups, dental characters, and all such as relate to the prehension of food generally, are essentially adaptive and consequently plastic or prone to variation, and hence cannot well be relied upon as tests of affinity. In another character, also adaptive, the laxity of the connection of the ribs with the vertebral column and with the sternum, and the reduction of that bone in size, allowing great freedom of expansion of the thoracic cavity for prolonged immersion beneath the water, the Mysticocetes have passed beyond the Odontocetes in specialization. On the other hand, the greater symmetry of the skull, the more anterior position of the external nostrils and their double external orifice, the form of the nasal bones, the presence of a distinctly developed olfactory organ, the mode of attachment of the periodic bone to the cranium, the presence of a cecum and the regular arrangement of the alimentary canal, the more normal characters of the manus and the better development of the muscles attached to it, and the presence, in many species at least, of parts representing not only the bones but also the ligaments and muscles of a hind limb, 124, all show less deviation from the ordinary mammalian type than is presented by the Odontocetes. Taking all these characters into consideration, it does not appear reasonable to suppose that either type has been derived from the other, at all events in the form in which we see it now, but rather that they are parallel groups, both modified in different fashions from common ancestors. Among the Mysticocetes, in the especially distinguishing characters of the division, the rorquals are less specialized than the right whales, which in the greater size of the head, the length and compression of the rostrum, the development of the baleen, and shortness of the cervical region, are exaggerated forms of the type, and yet they retain more fully some primitive characters, as the better development of the hind limb, the pentadactylous manus, and the absence of a dorsal fin. Both types are found distinct in a fossil state at least as far back as the early Pliocene age, but generally represented by smaller species than those now existing. Some of the Pliocene rorquals, Cetatherium, were, in the elongated flattened form of the nasal bones, the greater distance between the occipital and frontal bone at the top of the head, and the greater length of the cervical vertebrae, more generalized than those now existing. In the shape of the mandible also, Van Beneden, to whose researches we are much indebted for a knowledge of these forms, discerns some approximation to the Odontocetes. Among the last-named group there are several distinct types, of which that represented by Platanista, although in some respects singularly modified, has been considered to present on the whole approximations towards the more normal and general type of mammalian structure. It is therefore interesting to find an apparently allied form well represented among the earliest fossil remains of cetaceans in Europe. Almost all the other members of the suborder range themselves under the two principal heads of Ziphioids, or Physeteroids, and Delphinoids. The former is an ancient and once abounding type, of which the sperm whale, Physeter, is a highly specialized form. Among the latter, Globicephalus is a modified form as regards the structure of its anterior extremity, and Monodon as regards its dentition, while Delphinus, with the various allied genera, may be regarded as the dominating type of cetaceans at the present day, abundant in slightly differentiated species and also in individuals. They are in this respect to the rest of the order much as the hollow-horned ruminants are to the other ungulates. The earliest cetaceans of whose organization we have anything like complete evidence are the Zeuglodonts of the Eocene period, 125, which approach in the structure of the skull and teeth to a much more generalized mammalian type than either of the existing suborders. The smallness of the cerebral cavity compared with the jaws and the rest of the skull they share with the primitive forms of many other types. The forward position of the narial aperture and the length and flatness of the nasal bones, which distinguish them from all existing forms, we must also suppose to be a character at one time common to all cetaceans, though now retained, but to a less degree, only by the mysticocetes. Even Squalodon, which in its heterodont dentition so much resembles Zeuglodon as to have been placed by some zoologists in the same genus, entirely differs from it, and conforms with the ordinary dolphins in its essential cranial characters. The origin of the cetacea is at present involved in much obscurity. They present no signs of closer affinity to any of the lower classes of vertebrates than do many other members of their own class. Indeed, in all that essentially distinguishes a mammal from the oviparous vertebrates, whether in the osseous, nervous, reproductive, or any other system, they are as truly mammalian as any other group. Any supposed marks of inferiority, as absence of limb structure, of hairy covering, of lacrimal apparatus, etc., are obviously modifications, or degradations, as they may be termed, in adaptation to their special mode of life. The characters of the teeth of Zeuglodon and other extinct forms, and also of the fetal mysticocetes, clearly indicate that they have been derived from mammals in which the heterodont type of dentition was fully established. The steps by which a land mammal may have been modified into a purely aquatic one are indicated by the stages which still survive among the carnivora in the Otariidae and in the true seals. A further change in the same direction would produce an animal somewhat resembling a dolphin, and it has been thought that this may have been the route by which the cetacean form has been developed. There are, however, great difficulties in the way of this view. Thus, if the hind limbs had ever been developed into the very efficient aquatic propelling organs they present in the seals, it is not easy to imagine how they could have become completely atrophied and their function transferred to the tail. So that from this point of view it is more likely that whales were derived from animals with long tails, which were used in swimming, eventually with such effect that the hind limbs became no longer necessary. The powerful tail, with its lateral cutaneous flanges, of an American species of otter, Lutra brasiliensis, may give an idea of this member in the primitive cetaceans. But the structure of the cetacea is, in so many essential characters, so unlike that of the carnivora that the probabilities are against these orders being nearly related. Even in the skull of the Zeuglodon, which has been cited as presenting a great resemblance to that of a seal, quite as many likenesses may be traced to one of the primitive pig-like ungulates, except in the purely adaptive character of the form of the teeth, while the elongated larynx, 126, complex stomach, simple liver, reproductive organs both male and female, and fetal membranes of the existing cetacea are far more like those of that group than of the carnivora. Indeed, it appears probable that the old popular idea which affixed the name of sea hog, 127, to the porpoise contains a larger element of truth than the speculations of many accomplished zoologists of modern times. The fact that Platanista, which, as mentioned above, appears to retain more of the primitive characteristics of the group than any other existing form, and also the somewhat related Inia from South America, are both at the present day exclusively fluviatile, may point to the freshwater origin of the whole group, in which case their otherwise rather inexplicable absence from the seas of the Cretaceous period would be accounted for. On the other hand, it should be observed that the teeth of the Zeuglodonts approximate more to a carnivorous than to an ungulate type. It is scarcely necessary to allude to the hypothesis started by some continental writers to the effect that the whales are the most primitive type of mammals with which we are acquainted, and that they are the descendants of the Mesozoic reptilian order Ichthyopterygia, from which their hyperphalangism is a direct inheritance. The Ichthyopterygia have been shown, on very strong evidence, to have been derived from land reptiles, and to have gradually acquired their hyperphalangism as an adaptive character suitable to their peculiar mode of life, and there can be but little doubt that a similar adaptation has taken place in the case of the whales. Suborder Mysticoceti, the Balanoidea, whalebone, or true whales, 128, family Balanidae. Teeth never functionally developed, but always disappearing before the close of intrauterine life. Palate provided with plates of baleen or whalebone. Skull symmetrical. Nasal bones forming a roof to the anterior nasal passages, which are directed upwards and forwards. Maxilla produced in front of, but not over, the orbital process of the frontal. Lacrimal bone small and distinct from the jugal. Tympanic bone involuted, figure 76, and ankylosed with the periotic, which is attached to the base of the cranium by two strong diverging processes. Olfactory organ distinctly developed. Rami of mandible arched outwards, their anterior ends meeting at an angle, and connected by fibrous tissue without any true symphysis. All the ribs at their upper extremities articulating only with the transverse processes of the vertebrae, their capitular processes, when present, not articulating directly with the bodies of the vertebrae. Sternum composed of a single piece, and articulating only with a single pair of ribs. No ossified sternal ribs. External openings of nostrils distinct from each other, longitudinal. A short conical cecum. These animals have, when in the fetal state, numerous minute calcified teeth lying in the dental groove of both upper and lower jaws. They are best developed about the middle of fetal life, after which period they are absorbed, and no trace of them remains at the time of birth. 129. The baleen or whalebone does not make its appearance until after birth. It consists of a series of flattened horny plates, between 300 and 400 in number, on each side of the palate, with a bare interval along the middle line. These plates are placed transversely to the long axis of the palate, with very short intervals between them. Each plate or blade is somewhat triangular in form, with the base attached to the palate and the apex hanging downwards. The outer edge of the blade is hard and smooth, but the inner edge and apex fray out into long bristly fibers, so that the roof of the whale's mouth looks as if covered with hair, as described by Aristotle. At the inner edge of each principal blade are 2 or 3 much smaller or subsidiary blades. The principal blades are longest near the middle of the series, and gradually diminish towards the front and back of the mouth. The horny plates grow from a dense fibrous and highly vascular matrix, covering the palatal surface of the maxillae, and sending out lamellar processes, one of which penetrates the base of each blade. Moreover, the free edge of these processes is covered with very long vascular thread-like papillae, one of which forms the central axis of each of the hair-like epidermic fibers of which the blade is mainly composed. A transverse section of fresh whalebone shows that it is made up of numbers of these soft vascular papillae, circular in outline, each surrounded by concentrically arranged epidermic cells, and the whole bound together by other epidermic cells, that constitute the smooth cortical, so-called enamel, surface of the blade, which, disintegrating at the free edge, allows the individual fibers to become loose and assume the hair-like appearance before spoken of. These fibers differ from hairs in not being formed in depressed follicles in the enderon, but rather resemble the fibers composing the horn of the rhinoceros. The whalebone in fact consists of nothing more than modified papillae of the buccal mucous membrane, with an excessive and cornified epithelial development. The blades are supported and bound together for a certain distance from their base by a mass of less hardened epithelium, secreted by the surface of the palatal membrane or matrix of the whalebone in the intervals of the lamellar processes. This is the intermediate substance of Hunter, the gum of the whalers. Baleen varies much in color in different species. In some it is almost jet black, in others slate color, horn color, yellow, or even creamy white. In some the blades are variegated with longitudinal strips of different hues. Baleen differs also greatly in other respects, being short, thick, coarse, and stiff in some, and greatly elongated and highly elastic in those species in which it has attained its fullest development. Its function is to strain the water from the small marine mollusks, crustaceans, or fish upon which the whales subsist. In feeding, the immense mouth is filled with water containing shoals of these small creatures, and then, on the whale closing the jaws and raising the tongue, so as to diminish the cavity of the mouth, the water streams out through the narrow intervals between the hairy fringe of the whalebone blades, and escapes through the lips, leaving the living prey to be swallowed. 130. Our knowledge of the different structural modifications attained by members of this important group of mammals, though largely increased of late years, is still imperfect. Formerly they were all divided into right whales, Balena, and rorquals or fin whales, Balænoptera, the latter distinguished by their smaller heads, elongated and slender form, free cervical vertebrae, Tetradactylus manus, and the presence of very conspicuous longitudinal furrows or folds in the skin of the throat and chest, and of a small adipose dorsal fin, Recent discoveries have, however, brought to light several forms holding a somewhat intermediate position, and presenting combinations of characters not found in either of the longer-known sections. According to our present knowledge, the group is naturally divided into 5 very distinct genera, of which the leading characters are given below. Balena, 131, skin of throat smooth, not furrowed. No dorsal fin. Cervical vertebrae united into a single mass. Pectoral limb short, broad, and pentadactylous. Head very large. Baleen very long and narrow, highly ellus. Tick, and black. Scapula high, with a distinct coracoid and acromion process. Tympanic, figure 78, deep and angular, its inflation comparatively slight, and the involuted portion not fig-shaped, and frequently without a well-marked depression at the anterior extremity of the superior border of the inner surface for the eustachian canal. Figure 76. Greenland or Arctic right whale, Balena mysticetus. The Greenland, or more properly Arctic, right whale, Balena mysticetus, attains, when full-grown, a length of from 45 to 50 feet. Its usual vertebral formula is C7, D12, L14, C22. The external form is shown in Figure 76 from a careful drawing by Mr. Robert Gray. In this species, all the peculiarities which distinguish the head and mouth of the whales from those of other mammals have attained their greatest development. The head is of enormous size, exceeding 1/3 of the whole length of the creature. The cavity of the mouth is actually larger than that of the body, thorax, and abdomen together. The upper jaw is very narrow, but greatly arched from before backwards, to increase the height of the cavity and allow for the great length of the baleen blades. The rami of the mandible are widely separated posteriorly, and have a still further outward sweep before they meet at the symphysis in front, giving the floor of the mouth the shape of an immense spoon. The baleen blades attain the number of 380 or more on each side, those in the middle of the series having a length of 10 or sometimes 12 feet. They are black in color, fine and highly elastic in texture, and fray out at the inner edge and ends into long, delicate, soft, almost silky, but very tough, hairs. The remarkable development of the mouth and the structures in connection with it, which distinguishes the right whale among all its allies, is entirely in relation to the nature of its food. It is by this apparatus that the animal is enabled to avail itself of the minute but highly nutritious crustaceans and pteropods which swarm in immense shoals in the seas it frequents. The large mouth enables it to take in at one time a sufficient quantity of water filled with these small organisms, and the length and delicate structure of the baleen provide an efficient strainer or hair sieve by which the water can be drained off. If the baleen were rigid, and only as long as is the aperture between the upper and lower jaws when the mouth is shut, a space would be left beneath it when the jaws were separated, through which the water and the minute particles of food would escape together. But instead of this, the long, slender, brush-like, elastic ends of the whalebone blades fold back when the mouth is closed, the front ones passing below the hinder ones in a channel lying between the tongue and the lower jaw. When the mouth is opened, their elasticity causes them to straighten out like a bow unbent, so that at whatever distance the jaws are separated the strainer remains in perfect action, filling the whole of the interval. The mechanical perfection of the arrangement is completed by the great development of the lower lip, which rises stiffly above the jawbone and prevents the long, slender, flexible ends of the baleen from being carried outwards by the rush of water from the mouth, when its cavity is being diminished by the closure of the jaws and raising of the tongue. If, as appears highly probable, the bowhead of the Okhotsk Sea and Bering Strait belongs to this species, its range is circumpolar. Though found in the seas on both sides of Greenland, and passing freely from one to the other, it is never seen so far south as Cape Farewell, but on the Labrador coast, where a cold stream sets down from the north, its range is somewhat farther. In the Bering Sea, according to Scammon, it is seldom seen south of the 55th parallel, which is about the farthest southern extent of the winter ice, while on the Sea of Okhotsk its southern limit is about the latitude of 54 degrees. As has been abundantly shown by Eschricht and Reinhardt in the case of the Greenland seas, everything tends to prove, Scammon says, that the Balena mysticetus is truly an ice whale, for among the scattered floes, or about the borders of the ice fields or barriers, is its home and feeding ground. It is true that these animals are pursued in the open water during the summer months, but in no instance have we learned of their being captured south of where winter ice fields are occasionally met with. The occurrence of this species, therefore, on the British or any European coast is exceedingly unlikely, as when alive and in health the southern limit of its range in the North Sea has been ascertained to be from the east coast of Greenland at 64 degrees north lat. Along the north of Iceland towards Spitsbergen, and a glance at a physical chart will show that there are no currents setting southwards which could bear a disabled animal or a floating carcass to British shores. To this a priori improbability may be added the fact that no authentic instance has been recorded of the capture or stranding of this species upon any European coast, for the cases in which it has been reported as seen in British waters may be explained by the supposition of one of the other species of the genus being mistaken for it. Still, as two other essentially Arctic cetaceans, the narwhal and the beluga, have in a few undoubted instances found their way to British shores, it would be rash absolutely to deny the possibility of the Greenland right whale doing the same. Figure 77. Southern right whale, Balena australis. The southern right whale, B. australis, figure 77, resembles the last in the absence of dorsal fin and of longitudinal furrows in the skin of the throat and chest, but differs in that it possesses a smaller head in proportion to its body, shorter baleen, a different shaped contour of the upper margin of the lower lip, and a greater number, 15, of ribs and dorsal vertebrae. This form inhabits the temperate seas of both northern and southern hemispheres, and is divided into several so-called species, according to their geographical distribution: B. biscayensis of the North Atlantic, B. japonica of the North Pacific, B. australis of the South Atlantic, and B. antipoderum and B. novizelandii of the South Pacific. The differential characters by which they have been separated, external as well as anatomical, are, however, slight and subject to individual variation, and the number of specimens available for comparison in museums is not yet sufficient to afford the necessary data to determine whether these characters can be regarded as specific or not. The most interesting of these is the Atlantic right whale, which was formerly abundant in the North Atlantic, but is now so scarce as to appear verging on extinction. This was the whale the pursuit of which gave occupation to a numerous population on the shores of the Basque provinces of France and Spain in the Middle Ages. From the 10th to the 16th centuries Bayonne, Biarritz, Saint-Jean-de-la-Luz, and San Sebastian, as well as numerous other towns on the north coast of Spain, were the centers of an active whale fishery, which supplied Europe with oil and whalebone. In later times these whales were pursued as far as the coast of Newfoundland. They were, however, already getting scarce when the voyages undertaken towards the close of the 16th century for the discovery of the northeastern route to China and the East Indies opened out the seas around Spitsbergen. Then for the first time the existence of the Greenland whale became known, and henceforth the energies of the European whale fishers were concentrated upon that animal. It is a singular fact that the existence of the Atlantic right whale was quite overlooked by naturalists till lately, all accounts referring to it being attributed to the Greenland whale, supposed once to have had a wider distribution than now, and to have been driven by the persecution of man to its present circumpolar haunts. To the two Danish cetologists Eschricht and Reinhard is due the credit of having proved its existence as a distinct species, from a careful collation of numerous historical notices of its structure, distribution, and habits, and their restoration of the animal, founded upon these documents, has been abundantly confirmed by the capture of various specimens in recent times, showing that it still lingers in some of the localities where it formerly was so abundant. The only known instances of its occurrence on the coasts of Europe in modern times are in the harbor of San Sebastian in January 1854, in the Gulf of Taranto, in the Mediterranean, in February 1877, and on the Spanish coast between Guetaria and Zarauz, Guipuzcoa, in February 1878. The skeletons of these three whales are preserved in the museums of Copenhagen, Naples, and San Sebastian respectively. On the coast of the United States several whales of this species have been taken within the last few years. In the North Pacific a very similar if not identical species is regularly hunted by the Japanese, who tow the carcasses ashore for the purposes of flensing and extracting the whalebone. In the tropical seas, however, according to Captain Maury's whale charts, right whales are never or rarely seen, but the southern temperate ocean, especially the neighborhood of the Cape of Good Hope, Kerguelen's Island, Australia, and New Zealand, is inhabited by black whales, once abundant, but now nearly exterminated through the wanton destruction of the females as they visit the bays and inlets round the coast, their constant habit in the breeding time. The range of these whales southward has not been accurately determined, but no species corresponding with the Arctic right whale has as yet been met within the Antarctic icy seas. Figure 78. The right tympanic bone of an immature individual of the Greenland whale, Balena mysticetus, from the inner, A, and outer, B, aspects. Superscript 1/3 natural size. From the Proc. Zoll SOC. Remains of right whales are of not uncommon occurrence in the Pliocene crag deposits of England and Belgium. The tympanics of B. affinis from these deposits appear to indicate a species closely allied to B. mysticetus, in which this bone is long and angulated anteriorly, figure 78, while the tympanics from the same deposits described as B. primigenia are shorter and more rounded at the antero-inferior angle, thus resembling those of B. australis. A smaller species, having an estimated length of about 20 feet, has been described as Balenula balanopsis, the generic distinction being made on account of the freak condition of the atlas and seventh cervical vertebrae, but it seems scarcely advisable to regard such a feature as indicating more than a less specialized species. Balena, balanotus, insignis is a whale of somewhat larger dimensions, in which the atlas is generally, and the seventh cervical vertebra always, free, while in young individuals the axis vertebra may likewise be separate. Neobalena, 132, head about 1/4 the total length. Skin of the throat not plicated. A small falcate dorsal fin. Vertebrae, C7, D17, L3, C16 is equal to 43. The cervical vertebrae are united. The mane is small, narrow, and tetradactylous, wanting the pollex. The ribs remarkably expanded and flattened. The scapula very low and broad, with completely developed acromion and coracoid processes. Tympanic approximating to that of Balena, but with certain very characteristic peculiarities of shape. Baleen very long, slender, elastic, and white. A single species, at present very rare, and marginata, from the Australian and New Zealand seas is the smallest of the whalebone whales, being not more than 20 feet in length. Rachionectes, 133, this combines the small head, elongated form, and narrow pectoral fin of Balanoptera with the smooth skin of the throat and absence of the dorsal fin of Balena. The baleen is the shortest and coarsest of any of the group. Its osteology is imperfectly known. One species, Archlochus, the gray whale of the North Pacific. Megaptera, 134, head of moderate size. Baleen plates short and broad. Vertebrae, C7, D14, L11, C21 is equal to 53. Cervical vertebrae free. Scapula with acromion and coracoid process absent or rudimentary. Skin of throat plicated. Dorsal fin low. Pectoral limb tetradactylous, very long and narrow, attaining about 1/4 of the length of the entire animal, the metacarpus and phalanges being greatly developed, and the latter very numerous. Tympanic still more inflated than in Balanoptera, with the involuted portion more distinctly piriform, the eustachian part of the aperture well defined, and two well-marked longitudinal ridges on the lower surface of adult specimens. The whale commonly called humpback, Megaptera boops, by whalers, perhaps on account of the low hump-like form of the dorsal fin, is very distinctly characterized from all others of the group, especially by the immense length of the pectoral fins or flippers, which are indented or scalloped along their margins, and are, except at their base, of a white color, nearly all the rest of the body being black. The baleen plates are of a deep black color. Though common in the North Atlantic between Norway and Greenland, this whale does not frequently appear on the coasts of the British Isles. One came ashore at Newcastle in 1839, another, a young one, was taken in the estuary of the Dee in 1863, and its skeleton is preserved in the Liverpool Museum, and a nearly full-grown animal was captured in the mouth of the Tay in the winter of 1883-84, 135. The usual length of the adult ranges from 45 to 50 feet, the female being larger than the male. Whales of the genus Megaptera are found in the South Atlantic and in both the North and the South Pacific. They resemble those of British seas so closely that it is doubtful whether the differences which have been observed, and upon which several species have been founded, may not be individual peculiarities, but zoologists have not yet had the opportunity of examining and comparing such a series of specimens of different ages and sexes from different localities as would be necessary to determine these points satisfactorily. Figure 79. Humpbacked whale, Megaptera boops. Tympanic bones of Megaptera occur in the English and Belgian crags, although somewhat less commonly than those of Balaena and Balanoptera. They have been described under the names of Megapteropsis and Burtonopsis. Figure 80. The common rorqual, Balanoptera musculus. Balanoptera, 136, head small and flat, and pointed in front. Body long and slender. Skin of throat plicated. A small falcate dorsal fin. Baleen short and coarse. Cervical vertebrae free. Scapula low and broad, with a large acromion and coracoid process. Pectoral limb tetradactylous, small, narrow, and pointed. Tympanic, figure 81, long, much inflated, and rounded, with the involuted portion thickened and piriform, and the notch for the eustachian canal sharply defined, inner surface flattened, without the vertical groove found in Megaptera. Figure 81. The right tympanic of Balanoptera musculus from the inner, A, and outer, B, aspects. 1/2 natural size. From the Proc. Zoll SOC. The rorquals, fin whales, finbacks, finners, or razorbacks, as they are variously called, have the plicated skin of the throat like that of Megaptera, the furrows being more numerous and close set, but the pectoral fin is comparatively small, the dorsal fin distinct and falcate, and the tail very much compressed before it expands into the flukes. The rorquals are perhaps the most abundant and widely distributed of all the whales, being found in some of their modifications in all seas, except the extreme Arctic, and probably Antarctic regions. Owing to the small quantity and inferior quality of their whalebone, the comparatively limited amount of blubber, and their great activity and the difficulty of capturing them by the old methods, these whales were not until recently an object of pursuit by whale fishers, but, since the introduction of steam vessels, and especially of explosive harpoons fired from guns in the place of those hurled by the human hand, a regular fishery has been established on the coast of Finnmark. There are 4 distinct species of this genus in British seas. 1. Balanoptera sibbaldii, the blue whale, the largest of all known animals, attains a length of 80 or even sometimes 85 feet. Its color is dark bluish-gray, with small whitish spots on the breast. The baleen is black. The flippers are larger proportionally than in other rorquals, measuring 1/7 of the total length of the body, and the dorsal fin is small and placed very far back. This whale has usually 64 vertebrae, of which 16 bear ribs. Like the others of the genus, this species seems to pass the winter in the open seas, and approaches the coast of Norway at the end of April or beginning of May. At this time its sole food is a small crustacean, Euphausia inermis, which swarms in the fjords. Several specimens have been taken on the British coasts, 2 fine skeletons from the Firth of Forth being preserved in the Edinburgh museums. 2. Balanoptera musculus, the common rorqual, has a length of 65 to 70 feet, is of a grayish slate color above and white underneath, and the baleen is slate color variegated with yellow or brown. It has usually 62 vertebrae, of which 15 bear ribs. This is the commonest of all the large whales on the British coasts, scarcely a winter passing without the body of one being somewhere washed ashore, usually after stormy weather, and more frequently on the south coast, as this species has a more southern range than the last, and frequently enters the Mediterranean. It feeds largely on fish, and is frequently seen feasting among shoals of herring. 3. Balanoptera borealis, often called Rudolphi's whale from its first describer, is a smaller species, scarcely attaining a length of 50 feet. It is bluish-black above, with oblong, light-colored spots, whilst the underparts are more or less white. The whole of the tail and both sides of the flippers are black, the baleen is black, and the bristly ends fine, curling, and white. The flippers are very small, measuring 1/11 of the total length of the body. There are 56 vertebrae, with 14 pairs of ribs. This species, according to Collett, feeds chiefly on minute crustaceans, mainly Calanus finmarchicus and Euphausia inermis, and not on fish. Until lately it was considered the rarest of the whales of European seas, and was only known to science from a few individuals stranded on the coasts of northern Europe at long intervals. the skeletons of which have been preserved in museums. The most southern point at which it has been met with hitherto is Biarritz in France. Since the establishment of the whaling station near the North Cape, it has been shown to be a regular summer visitor, and in 1885, 771 individuals were captured on the coast of Finnmark. 4. Balænoptera rostrata, the lesser fin whale or rorqual, is the smallest species found in the northern seas, rarely exceeding 30 feet in length. Its color is grayish-black above, whilst the underside is white, including the whole of the lower side of the tail. The inner side of the flippers is white, and there is a broad white band across the outer side, which is a very characteristic mark of the species. The baleen is yellowish-white. The dorsal fin in this and the last species is comparatively high, and placed far forwards on the body. This whale has usually 48 vertebrae, 11 of which bear ribs. It is common in summer in the fjords of Norway, and is often seen around the British Isles. It has been taken, though rarely, in the Mediterranean, and ranges as far north as Davis's Straits. Rorquals are met with in almost all seas throughout the world, but further and more accurate observations are required before their specific characters and geographical distribution can be made out. Nearly all the individuals hitherto examined with any care, whether from the North Pacific, the Australian seas, or the Indian Ocean, come very near in structure to one or the other of the Atlantic forms described above, so much so that some zoologists have been induced to believe that there are but 4 species, each of which has a wide, almost cosmopolitan range, while others have described and named almost every individual specimen captured as belonging to a different species. 137. Tympanics. Vertebrae, and other bones of rorquals are among the commonest cetacean remains found in the Pliocene crags of England and Belgium. Several species, varying in dimensions, are known from these deposits, B. definita, Sibaldina, being apparently nearly related to the existing B. sibaldi. A caudal vertebra from the Upper Eocene of Hampshire has been referred to Balænoptera, but does not afford sufficient evidence to prove the existence of the genus at that date. Extinct genera. The extinct genus Cetatherium of the European Pliocene may be taken to include a number of fossil whalebone whales allied to the Balænopterine group, several of which have been described under other names, such as Plesiocetus, Heterocetus, and Amphicetus. They are readily characterized by the form of the tympanic bone, which is much narrower in front than behind, the roughened inferior surface being in the shape of an isosceles triangle, and the notch for the eustachian canal being smaller, and descending nearer to the inferior border of the inner wall than in Balænoptera. The skull is longer than the latter, with a greater interval between the occiput and the frontal, and with longer and more flattened nasals. The relative thickness of the cervical vertebrae is also greater. In the typical forms, e.g. C. bryalmonti and C. dubium, the mandibular condyle is simple, but in C. heterocetus, brevifrons it is furnished with a projecting posterior talon, as in the sperm whale. Herpetocetus is known by a comparatively small species from the Belgian and English crags, characterized by the extreme inflation of the egg-shaped tympanic bone, which approximates to that of Megaptera, but has the greater part of the cavity filled by bone. There is a talon to the condyle of the mandible. Paleocetus, as already mentioned, page 232, is founded upon the ankylosed cervical vertebrae of a small whale originally considered as having been derived from the Kimmeridge clay, but which doubtless came from the Suffolk crag. If it belongs to the Balenidae, it indicates a right whale. Suborder Archaeoceti. Family Zeuglodontidae. This group is formed to include certain extinct cetacean-like animals at present only known by more or less fragmentary portions of their skeleton and teeth, and whose position and affinities are, therefore, still subject to doubt. 138. In the anterior part of both jaws the teeth are simple, conical, or slightly compressed, and sharp-pointed. The first 3 in the upper jaw are distinctly implanted in the premaxillary bone, and so may be reckoned as incisors. The tooth which succeeds, or the canine, is also simple and conical, but it does not exceed the others in size. This is followed by 5 teeth having 2 distinct roots and compressed pointed crowns, with denticulate cutting edges. The dentition is therefore I superscript 3/3, C superscript 1/P and M/5 equals 36, resembling that of some seals. 139, general form of the skull elongated and much depressed. Brain cavity very small, and the skull between it and the orbits elongated and narrow. Temporal fossae very large. A strong sagittal crest. Rostrum long and narrow, differing from that of other cetaceans in the large extent to which the premaxilla form the sides of the anterior extremity. Nasal bones elongated, flat, and narrow, the opening of the anterior nares being over the middle of the elongated compressed rostrum. All the cervical vertebrae free. The characters of the dorsal vertebrae and mode of articulation of the ribs appear to have resembled those of Platanista rather than Balaena, Physeter, or Delphinus. Lumbar vertebrae with elongated bodies, low neural spines, and the transverse processes placed low down on the bodies. Characters of the limbs not known with certainty. 140. All the known fossil remains belonging to the animals of this group may be referred, provisionally at least, to the genus Zeuglodon, so named because the first section of a molar tooth examined was taken from the base of the crown, where it was beginning to divide into the two roots, and looked like two single teeth linked or yoked together. This name was substituted by Owen for the earlier one Basilosaurus of Harlan, with the consent of that author, on the mammalian nature of the animal being demonstrated. 141. The latter name is, however, still generally retained by American zoologists. The remains have hitherto been found chiefly in the Eocene formations of the states of Alabama, Louisiana, Mississippi, and Arkansas, and have been assigned to several species. A portion of a skull is recorded from the Barton Clay, Eocene, of Hampshire, England. Suborder Odontoceti, the Delphinoidea, or toothed whales. Calcified teeth always present after birth, generally numerous, but sometimes a very limited number, in a few cases none, are functionally developed. No baleen. Upper surface of the skull more or less asymmetrical. Nasal bones in the form of nodules or flattened plates, applied closely to the frontals, and not forming any part of the roof to the narial passage, which is directed upwards and backwards. Olfactory organ rudimentary or absent. Hinder end of the maxilla expanded and covering the greater part of the orbital plate of the frontal bone. Lacrimal bone either inseparable from the jugal, or, when distinct, very large, and forming part of the roof of the orbit. Tympanic bone not ankylosed with the periotic, which is usually only attached to the rest of the skull by ligament. Rami of mandible nearly straight, much expanded in height posteriorly, with a wide funnel-shaped aperture to the dental canal, and coming in contact in front by a flat surface of variable length, but always constituting a true symphysis. Several of the anterior ribs with well-developed capitular processes, articulating with the bodies of the vertebrae. Sternum almost always composed of several pieces, placed one behind the other, with which several pairs of ribs are always connected by the intervention of well-developed cartilaginous or ossified sternal ribs. External respiratory aperture single, the two nostrils uniting before they reach the surface, usually in the form of a transverse subcrescentic valvular aperture, situated on the top of the head. Manus always pentadactylous, though the first and fifth digits are usually very little developed. No cecum, except in Platanista. Family Physeteridae. No functional teeth in the upper jaw. Mandibular teeth various, often much reduced in number. Bones of the cranium raised so as to form an elevated prominence or crest behind the nares. Pterygoid bones thick, produced backwards, meeting in the middle line, and not involuted to form the outer wall of the post-palatine air sinuses, but simply hollowed on their outer side. Anterior facet of periodic bone, figure 87, for articulation with the tympanic quite smooth, and the posterior tympanic surface of the former broad, with a median longitudinal ridge. Transverse processes of the arches of the dorsal vertebrae, to which the tubercles of the ribs are attached, ceasing abruptly near the end of the series, and replaced by processes on the body at a much lower level, and not on a line or serially homologous with them, but serially homologous anteriorly with the heads of the ribs, and posteriorly with the transverse processes of the lumbar vertebrae. In some genera, as Physeter, the two processes, upper and lower on each side, are both present and well developed in the same vertebra in the region of transition. In others, as Ziphius and Berardius, they are not both developed on any single vertebra. Costal cartilage is not ossified. Subfamily Physeterinae. Numerous teeth in the mandible, which are not set in distinct bony alveoli, but in a long groove imperfectly divided by partial septa, and held in place by the strong, fibrous gum surrounding them. Now distinct lacrimal bone. Cranium strikingly asymmetrical in the region of the narial apertures, in consequence of the left opening greatly exceeding the right in size. Figure 82. Skull of sperm whale, Physeter macrocephalus. Physeter, 142, upper teeth apparently of uncertain number, rudimentary, and functionless, being embedded in the gum. Lower jaw with from 20 to 25 teeth on each side, stout, conical, recurved, and pointed at the apex until they are worn, without enamel. Upper surface of the cranium concave, its posterior and lateral edges raised into a very high and greatly compressed semicircular crest or wall. Zygomatic processes of jugal bones thick and massive. Rostrum greatly elongated, broad at the base, and gradually tapering to the apex. Upper edge of the mesethmoid forming a rough and irregular projection between the narial apertures, inclining to the left side. Mandible exceedingly long and narrow, the symphysis being more than half the length of the ramus. Vertebrae, C7, D11, L8, C24, total 50. Atlas free, all the other cervical vertebrae united by their bodies and spines into a single mass. 11th pair of ribs rudimentary. Head about 1/3 the length of the body, very massive, high and truncated, and rather compressed in front, owing its huge size and remarkable form mainly to the accumulation of an oily substance secreted by the lining membranes of great cells surrounding the narial passage and filling the large hollow on the upper surface of the cranium and overlying the rostrum. The single blowhole is longitudinal, slightly sigmoid, and placed at the upper and anterior extremity of the head to the left side of the middle line. The opening of the mouth is on the underside of the head, considerably behind the end of the snout. Pectoral fin short, broad, and obliquely truncated. Dorsal fin a mere low protuberance. Figure 83. The sperm whale, Physeter macrocephalus. The only representative of this genus is the cachalot or sperm whale, P. macrocephalus, figure 83, one of the most colossal of animals, quite equaling, if not exceeding, the Greenland whale in bulk. The length of the full-grown male is from 55 to 60 feet, but the female is stated not to reach more than half that size. The general color of the surface is black above and gray below, the colors gradually shading into each other. The sperm whale is one of the most widely distributed of animals, being met with usually in herds or schools in almost all tropical and subtropical seas, but not occurring, except accidentally, in the polar regions. Not unfrequently specimens appear on the coasts of the British Isles, but only as solitary stragglers, or as dead carcasses, floated northwards by the Gulf Stream. It is remarkable that every one of these of which we have an accurate record has been an old male. The food of this whale consists mainly of various species of cephalopods, squid and cuttlefish, but fish of considerable size are also eaten. The substance called ambergris, formerly used in medicine and now in perfumery, is a concretion formed in the intestine of this whale, and is found floating on the surface of the seas it inhabits. Its genuineness is proved by the presence of the horny beaks of the cephalopods on which the whale feeds. The oil contained in the great cavity above the skull, when refined, yields spermaceti, and the thick covering of blubber which everywhere envelopes the body produces the valuable sperm oil of commerce, hence this animal has long been the subject of a regular chase, by which its numbers have been greatly diminished. Kogia, 143, teeth of the upper jaw absent, or reduced to a rudimentary pair in front, in the lower jaw 9 to 12 on each side, rather long, slender, pointed, and curved, with a coating of enamel. Upper surface of the cranium concave, with thick, raised posterior and lateral margins, massive and rounded at their anterior terminations above the orbits. Upper edge of the mesethmoid forming a prominent sinuous ridge, constituting a kind of longitudinal septum to the base of the great supracranial cavity. Rostrum not longer than the cranial portion of the skull, broad at the base, and rapidly tapering to the apex. Zygomatic process of the jugal styloform. Mandible with the symphysis less than half the length of the entire ramus. Vertebrae, C7, D13 or 14, L and C30, total 50 or 51. All the cervical vertebrae united by their bodies and arches. External characters not well known, but, judging by the somewhat conflicting accounts of those that have had an opportunity of observing them. The head is about 1/6 of the length of the body, and obtusely pointed in front, the mouth small, and placed far below the apex of the snout, the spiracle crescentic, and placed obliquely on the top of the head anteriorly to the eyes, and to the left of the middle line. The pectoral fins are obtusely falcate, and there is a triangular dorsal fin. The history of this genus is a good illustration of the difficulties in which the study of the cetacea has been involved by the superficial manner in which it has been investigated. The first known example, a skull from the Cape of Good Hope in the Paris Museum, was described by de Blainville under the name of Physeter breviceps. This was afterwards with good reason generically separated by Gray. Until within a very few years ago only 5 other individuals had been met with, each of which had been described under a different specific name, viz. Grayi, Macleayi, Simus, Flowery, and Pottsii, and which are arranged by Gray in 2 distinct genera. The most careful examination of the description given of these specimens, or of the now numerous osteological remains available, fails to detect any differences beyond those which may be attributed to age or sex, and hence, according to our present knowledge, these 6 supposed species must all be included under one name, C. breviceps. This animal appears to attain the length of 10 feet when adult, and has been met with at various distant localities in the Southern Ocean, and also off the coast of Madras and in the North Pacific. Extinct physeteroids. Teeth of physeteroids are of very common occurrence in the Belgian and English crags, and evidently indicate the former existence of whales more or less closely allied to the sperm whale, but often distinguished by the presence of an enamel cap on the crowns of the teeth. The generic determination of these teeth is, however, exceedingly difficult, owing to the water-worn condition in which they are frequently found, and also on account of the impossibility of knowing whether small and large teeth may not be referable to different parts of the jaws of the same species or to individuals of different ages. Moreover, in the cases of isolated teeth it is impossible to know how many were contained in the jaws, and therefore to distinguish physeteroid from ziphioid teeth. Physeterula is a small form about 1/3 the dimensions of the sperm whale, and distinguished by the length of the mandibular symphysis being only about 1/3 that of the entire ramus. It is identified by Professor Cope with Kogia. Eucetus, Dinoziphius, is founded on teeth which are regarded as closely resembling those of Physeter, but distinguished by their subcylindrical form and the small size of the aperture of the pulp cavity. It does not appear, however, to be certain that these teeth are not worn specimens of those described as Scaldocetus. Physetodon, from the Pliocene of Australia, is founded upon the evidence of similar teeth. The teeth from the Belgian crag described as Scaldocetus are somewhat smaller than those of the sperm whale, and are readily characterized by their cap of grooved enamel. Other teeth with enamel caps have been described as Physedon and Hoploccetus. The genus Balenodon is founded upon a very imperfect large tooth from the English crag, which is not sufficiently well preserved to admit of exact comparison with the other types. Subfamily Zophenidae. Teeth of the mandible, at least in existing forms, quite rudimentary and concealed in the gum, except 1, or very rarely 2, pairs which may be largely developed, especially in the male sex. A distinct lacrimal bone. Externally the mouth is produced into a slender rostrum or beak, from above which the rounded eminence formed by a cushion of fat resting on the cranium in front of the blowhole rises somewhat abruptly. Spiracle or blowhole single, crescentic, median, as in the Delphinidae. Pectoral fin small, ovate, the 5 digits all moderately well developed. A small obtusely falcate dorsal fin situated considerably behind the middle of the back. Longitudinal grooves on each side of the skin of the throat, diverging posteriorly, and nearly meeting in front. In external characters and habits the animals of this group closely resemble each other. They appear to be almost exclusively feeders on various species of cephalopods, and occur either singly, in pairs, or in small herds. By their dental and osteological characters they are easily separated into 4 distinct genera. Hyperoodon, 144, a small conical pointed tooth at the apex of each ramus of the mandible, concealed by the gum during life. Skull with the upper ends of the premaxilla rising suddenly behind the nares to the vertex and expanded laterally, their outer edges curving backwards and their anterior surfaces arching forwards and overhanging the nares, the right larger than the left. Nasal bones lying in the hollow between the upper extremities of the premaxilla, strongly concave in the middle line and in front, their outer edges, especially on the right side, expanded over the front of the inner border of the maxilla. Very high longitudinal crests on the maxillae at the base of the rostrum, extending backwards almost to the nares, approaching each other in the middle line above, sometimes so massive that their inner edges come almost in contact. Anteorbital notch distinct. Mesethmoid but slightly ossified. Vertebrae, C7, D9, L10, C19, total 45. All the cervical vertebrae united. Upper surface of the head in front of the blowhole hole very prominent and rounded, rising abruptly from above the small, distinct snout. Figure 84. Hyperudin rostratus. From a female specimen taken off the coast of Scotland, 1882. The genus is known typically by H. rostratus, figure 84, but an imperfect skull has been made the type of H. planifrons, a species differing considerably in cranial characters from the typical one. The females and young males of the first named species have the contour of the head of the same general form as in figure 84, the premaxillary crests of the cranium being widely separated from one another, and terminating in comparatively sharp edges. In the males, however, as age advances the summits of these crests become gradually expanded and flattened, till they are almost or quite in contact in the middle line. This development of the maxillary crests produces a corresponding elevation and flattening of the front of the head, so that in very old males this aspect presents a flattened disc-like surface rising abruptly from the beak, which thus becomes almost buried, and situated in a plane nearly at right angles to the line of the back. 145, so different, indeed, is the appearance of the skull of an old male from that of a female individual that it was long considered that they belonged to different species, the male form having been described as H. latifrons. The length of an adult male reaches 30 feet, while that of the female does not exceed 24 feet. The hyperudin, sometimes called bottlenose, a name also vaguely given to several species of dolphin, is a regular inhabitant of the North Atlantic, passing the summer in the Spitzbergen seas and going farther south in winter. It resembles the sperm whale in possessing a large store of oil in the upper part of the head, which yields spermaceti when refined, on this account, and also for the sake of the blubber, which supplies an oil almost indistinguishable from sperm oil. This whale has been the object of a regular chase in recent years. The following account of its habits is taken from a paper by Captain D. Gray, published in the Zoological Society's Proceedings for 1882. These whales are occasionally met with immediately after leaving the Shetland Isles in March, and north across the ocean until the ice is reached, near the margin of which they are found in the greatest numbers, but they are seldom seen amongst it. Although it is not in their nature to keep in amongst the ice, they like to frequent the open bays for the shelter it gives them from the sea. Sometimes a point of ice overlaps them, it is then only that they are seen going out again towards the ocean. They are also to be met with from the entrance of Hudson Straits and up Davis's Straits, as far as 70 degrees north lat, and down the east side round Cape Farewell, all round Iceland, north along the Greenland ice to 77 degrees north lat, also along the west coast of Spitzbergen, and east to Cherry Island in lat. 72 degrees north and long. 19 degrees east. Beyond these limits I have never seen them, but doubtless they are to be found as far as the Straits of Belle Isle on the west, and east to Nova Zembla. From the fact that they are not seen in summer farther south than a day's sail from the ice, it would appear that they migrate south in the autumn, and north again in the spring. They are gregarious in their habits, going in herds of from 4 to 10. It is rare to see more than the latter number together, although many different herds are frequently in sight at the same time. The adult males very often go by themselves, but young bulls, cows, and calves, with an old male as a leader, are sometimes seen together. They are very unsuspicious, coming close alongside the ship, round about underneath the boats, until their curiosity is satisfied. They vary in color from black in the young to light brown in the older animals. The very old turn almost yellow, the beak and front of the head being quite white, with a white band round their necks. All of them are grayish-white on the belly. They can leap many feet out of the water, even having time while in the air to turn round their heads and look about them, taking the water head first, and not falling helplessly into it sideways like the larger whales. The full-grown whale is 30 feet long by 20 feet in circumference, and yields 2 tons of oil besides 200 weight of spermaceti. Their ordinary food consists of a bluish-white cuttlefish, 6 inches long by 3 inches in circumference, and pointed towards the tail. They evidently have a great depth to go to find them, judging from the length of time that they remain away, and from the long heavy blasts they make on coming to the surface again. Periodic bones of Hyperidon are found in the Red Crag of Suffolk, presenting no character by which they can be specifically distinguished from those of the common existing species. Xiphias, 146, a single conical tooth of moderate size on each side of the mandible close to the anterior extremity, and directed forwards and upwards. Skull with the premaxilla immediately in front of, and at the sides of the nares expanded, hollowed, and with elevated lateral margins, the posterior ends rising to the vertex and curving forwards, the right being considerably more developed than the left, the conjoint nasals forming a strongly pronounced symmetrical eminence at the top of the cranium, projecting forwards over the nares, flat above, most prominent and rounded in the middle line in front, and separated by a notch on each side. From the premaxillae. Anteorbital notch not distinct. Rostrum, seen from above, triangular, gradually tapering from the base to the apex, upper and outer edges of maxillae at base of rostrum raised into low roughened tuberosities. Mesethmoid cartilage densely ossified in adult age, and coalescing with the surrounding bones of the rostrum. Vertebrae, C7, D10, L10, C22, total 49. The 3 anterior cervical vertebrae united, the rest free. The type of this genus is Z. cavarostris of Cuvier, founded upon an imperfect skull picked up in 1804 on the Mediterranean coast of France, and described and figured in the ossements fossils under the impression that it was that of an extinct species. Many other individuals have, however, been subsequently met with in various parts of the world, from the Shetland Islands to New Zealand, all referable to the same genus, if not to the same species, although, as is usual in such cases, they have mostly been described under different names, the so-called genera Petrorhynchus and Epiodon being probably referable to the type species. It is quite probable that some of the physetoroid teeth from the crag deposits mentioned on page 251 may be referable to Xiphias. Figure 85. Mesoplodon bidens. From Reinhardt. Mesoplodon, 147, a much compressed and pointed tooth in each ramus of the mandible, variously situated, but generally at some distance behind the apex, figure 86, its point directed upwards, and often somewhat backwards, occasionally developed to a great size. Skull with the region around the nares as in Hyperidon, except that the nasals are narrow and more sunk between the upper ends of the premaxillae, like those of Hyperidon, they are concave in the middle line in front and above. No maxillary tuberosities. Anteorbital notch not very distinct. Rostrum long, narrow, and solid throughout. Mesethmoid in adult age ossified in its entire length, coalescing with the surrounding bones, and showing as a narrow band on the upper surface of the rostrum. Vertebrae, C7, D10, L10 or 11, C19 or 20, total 46 to 48. 2 or 3 anterior cervicals united, the rest usually free. Figure 86. Left lateral view of skull of Mesoplodon densorostris. Though varying in form, the mandibular teeth of the different members of this genus agree in their essential structure, having a small and pointed enamel-covered crown, composed of true dentine, which, instead of surmounting a root of the ordinary character, is raised upon a solid mass of osteodentine. The continuous growth of this greatly alters the form and general appearance of the organ as age advances, as seen most strikingly in the case of M. layardi, where the long, narrow, flat, strap-like teeth, curving inwards at their extremities, actually meet over the rostrum, and must greatly interfere with the movements of the jaw. In one species, M. grayi, a row of minute, conical, pointed teeth, like those of ordinary dolphins, 17 to 19 in number, are present even in the adults, on each side of the middle part of the upper jaw, but embedded by their roots only in the gum, and not in bony alveoli. This fact, with the frequent presence of rudimentary teeth in other species of this and the last genus in both upper and lower jaws, suggests the idea that the Xiphioids are derived from ancestral forms which had teeth of normal character in both jaws, the dentition of the living forms having become greatly specialized. The existing species of this genus are widely distributed in both northern and southern hemispheres, but most frequent in the latter. The best established are M. bidens, M. europaeus, M. densorostris, M. layardi, M. grayi, and M. hectori, but there is still much to be learned with regard to their distinctive characters and geographical distribution. They were abundant in the Pliocene age, as attested by the frequency with which the most imperishable and easily recognized portion of their structure, the long, cylindrical rostrum of the skull, of more than ivory denseness, is found among the rolled and water-worn fragments of animal remains which compose the well-known bone bed at the base of the Red Crag of Suffolk. Several species have been founded upon the evidence of these rostra. Periodic bones of this genus, figure 87, are of less common occurrence in the crag. The figure is given to illustrate the characteristic features of this bone in the present family. Figure 87. The left periodic bone of Mesoplodon, from the Red Crag of Suffolk. The smooth concave surface in the right upper corner of the figure forms the anterior articulation with the tympanic. From the cat. Foss. Mam. Brit. Muse PTVP 70. Berardius, 148, two moderate-sized, compressed, pointed teeth on each side of the symphysis of the mandible, with their apices directed forwards, the anterior being the larger of the two and close to the apex. Upper ends of the premaxilla nearly symmetrical, moderately elevated, very slightly expanded, and not curved forward over the nares. Nasals broad, massive, and rounded, of nearly equal size, forming the vertex of the skull, flattened in front, most prominent in the middle line. Anteorbital notch distinct. Rostrum long and narrow. Mesethmoid only partially ossified. Small rugus eminences on the outer edge of the upper surface of the maxillae at base of rostrum. Vertebrae, C7, D10, L12, C19, total 48. The three anterior cervicals ankylost, the rest free and well developed. The only known species, B. arnexi, attains the length of 30 feet, and has hitherto only been met within the seas around New Zealand. Conaziphius, 149, the rostral portions of crania from the Antwerp and Suffolk crags, on the evidence of which this genus has been established, agree with those of Mesoplodon in having the premaxillae in contact with the intervening bones throughout the length of their inner surfaces, and also in showing only a very small portion of the vomer on the inferior surface. They differ, however, in that the mesethmoid cartilage remains unossified, whereby a fistular vacuity remains. In some species the soldering of the inner surfaces of the premaxillae is incomplete. The interorbital region of the skull is flat, and there are two pits in the nasal region, of which the right is the larger. Family Squalodontidae. Numerous extinct forms, chiefly known by teeth and fragments of crania, may be provisionally placed here, until more of their osteological characters shall be brought to light. They differ from all existing cetaceans in having the teeth distinctly differentiated into groups, as in the Archaeocidae, the posterior molars being two-rooted. The cranium has, however, none of the distinguishing characteristics of the zeuglodonts, but essentially resembles that of the Odontocidae, especially in the position of the anterior nares and form of the nasal bones. Squalodon, 150, all the forms may be included in this genus, the so-called rhizoprion not being distinct. Dentition, I superscript 3/3, C superscript 1/, simple teeth of the molar series, premolars. /4, two-rooted molars /7 equals superscript 1/5, total 60. The double-rooted molars differ from those of zeuglodon in having the denticulations of the crown confined to the posterior border, or at all events much less developed on the front edge. Very little is known of the structure of these animals beyond the skull and teeth, fragments of which have been found widely distributed throughout the marine Miocene and early Pliocene formations of Europe, especially in the Vienna Basin, many parts of France, and the Antwerp and Suffolk crags. They have also been found in formations of corresponding age in North America and South Australia. A few isolated teeth have been met within the cave deposits of Italy, which, if contemporaneous with the beds in which they occur, indicate the survival of the genus into the Pleistocene period. Family Platanistidae. Under this heading may be placed three very singular genera, which, though differing considerably from each other, have several points in common, and do not altogether come under the definition either of the physeteridae or the delphinidae, especially in the important character of the mode of articulation of the ribs with the dorsal vertebrae, the tubercular and capitular articulations, distinct at the commencement of the series, gradually blending together, as they do in most ordinary mammals. The cervical vertebrae are all free. The lacrimal bone is not distinct from the jugal. The jaws are long and narrow, with numerous teeth in both. The symphysis of the mandible exceeds half the length of the whole ramus. Externally, the head is divided from the body by a slightly constricted neck. Pectoral limbs broad and truncated. Dorsal fin small or obsolete. Fluviatile or estuarine in habits. There are 3 distinct genera, which might almost be made the types of families, but it is probably more convenient to keep them together, only regarding them as representing 3 subfamilies. Platanista, 151, teeth about superscript 3/3 on each side, set near together, rather large, cylindrical, and sharp-pointed in the young, in old animals acquiring a large laterally compressed base, which in the posterior part of the series becomes irregularly divided into roots. As the conical enamel-covered crown wears away, the teeth of the young and old animals have a totally different appearance. The rostrum and dentigerous portion of the mandible are so narrow that the teeth of the 2 sides are almost in contact. Maxillae supporting very large, incurved, compressed bony crests, which overarch the nares and base of the rostrum, and almost meet in the middle line above. Orbits very small and eyes rudimentary, without crystalline lens. External respiratory aperture longitudinal, linear. Vertebrae, C7, D10, L9, C26, total, 52. A small cecum. No pelvic bones. Dorsal fin represented by a low ridge. Figure 88. Platanista gangetica. From Anderson. One species, P. gangetica, entirely fluviatile, being extensively distributed throughout nearly the whole of the river systems, not only of the Ganges, but of the Brahmaputra and Indus, ascending as high as there is water enough to swim in, but never passing out to sea. It is quite blind, and feeds on small fish and crustaceans, groping for them with its long snout in the muddy water at the bottom of the rivers. It attains the length of 8 feet, 152, Enea, 153, teeth variable, from 26 to 33 on either side of each jaw, those at the posterior part with a distinct tubercle at the inner side of the base of the crown. Vertebrae, C7, D13, L3, C18, total 41. Transverse processes of lumbar vertebrae very broad. Sternum short and broad, and consisting of a single segment only. Dorsal fin a mere ridge. The long cylindrical rostrum externally furnished with scattered, stout, and crisp hairs. One species only is known, I. jeffreyensis, about 7 feet in length, inhabiting the upper Amazon and its tributary streams. Pontoporia, 154, teeth 50 to 60 on either side of each jaw, with a cingulum at the base of the crown. Jaws very long and slender. Vertebrae, C7, D10, L5, C19, total 41. Transverse processes of the lumbar vertebrae extremely broad. Sternum elongated, composed of 2 segments, with 4 sternal ribs attached. Dorsal fin rather small, triangular, pointed. External respiratory aperture transverse, crescentic. This genus connects the last 2 forms with the true delphinidae. The only species, P. blainvillei, is one of the smallest members of the whole order, not exceeding 5 feet in length. It has only been met with at the mouth of the Rio de la Plata, near Buenos Aires, and there is at present no evidence that it ascends into the fresh waters of the river. Figure 89. Pontoporia blainvillei. From Burmeister. Fossil forms. Remains of a cetacean from the Pleistocene of South America were referred by Brevard to Pontoporia, but they have been regarded by other writers as indicating a distinct genus, for which the names Paleopontoporia and Pontistes have been proposed. The upper tertiary European genera Champsodelphus and Schizodelphus are generally referred to the present family. The former has wide transverse processes to the lumbar vertebrae, as in Enea, while the teeth also resemble those of that genus. In Schizodelphis, the form of the rostrum presents a great resemblance to that of the delphinoid genus Steno, but the symphysis of the mandible is relatively longer. A number of fossil cetaceans from the Miocene of the United States, such as Priscodelphinus, Lophocetus, Ixacanthus, Rhabdosteus, etc., are referred by Professor E. D. Cope to this family. Agabelus, from the same deposits, is an apparently allied, but toothless type. Family Delphinidae. Teeth usually numerous in both jaws. Pterygoid bones short, thin, each involuted to form with a process of the palate bone the outer wall of the postpalatine air sinus. Symphysis of mandible short, or moderate, never exceeding 1/3 of the length of the ramus. Lacrimal bone not distinct from the jugal. The anterior facet on the periodic, figure 96, for articulation with the tympanic deeply grooved, and the posterior tympanic surface of the same bone comparatively narrow, with its ridge for articulation with the free border of the tympanic ill-defined, and situated close to one edge. Transverse processes of the dorsal vertebrae gradually transferred from the arches to the bodies of the vertebrae without any sudden break, and becoming posteriorly continuous serially with the transverse processes of the lumbar vertebrae. Anterior ribs attached to the transverse process by the tubercle, and to the body of the vertebra by the head, the latter attachment lost in the posterior ribs. Sternal ribs firmly ossified. External respiratory aperture transverse, crescentic, with the horns of the crescent pointing forwards. A very large group, closely united in essential characters but presenting great modifications in details. The different types are mostly so connected by intermediate or osculant forms that there are great difficulties in grouping them into natural subfamilies. Even the formation of well-defined genera is by no means satisfactory in all cases. They may, however, be divided, perhaps artificially, into two groups. Group A. Head rounded, without distinct rostrum or beak. Rostrum of skull about as long as cranial portion. Monodon, 155, besides some irregular rudimentary teeth, the entire dentition is reduced to a single pair of teeth which lie horizontally in the maxilla, and in the female remain permanently concealed within the alveolus so that this sex is practically toothless, while in the male, see figure 90, the right tooth usually remains similarly concealed and abortive, and the left is immensely developed, attaining a length equal to more than half that of the entire animal, projecting horizontally from the head in the form of a cylindrical, or slightly tapering, pointed tusk, without enamel, and with the surface marked by spiral grooves and ridges, running in a sinistral direction. When, as occasionally happens, both tusks are developed, the spiral grooves have the same direction in each. Pterygoids very small, not meeting in the middle line, but approximating posteriorly. Vertebrae, C7, D11, L6, C26, total 50. Cervical region comparatively long, and all the vertebrae distinct, or with irregular unions towards the middle of the series, the atlas and axis being usually free. Manus small, short, and broad, second and third digits nearly equal, fourth slightly shorter. No dorsal fin. This genus is now represented only by the well-known narwhal, M. monoceros, in which the horn-like tusk of the male often grows to a length of 7 or 8 feet. In very young animals several small additional teeth, irregular in number and position, are present, but these usually disappear soon after birth. The head is rather short and rounded, the four limbs or paddles are small and broad compared with those of most dolphins, and, as in the beluga, the median dorsal fin, found in nearly all other members of the group, is wanting or replaced by a low ridge. The general color of the surface is dark gray above and white below, but variously marbled and spotted with different shades of gray. In the general contour of the body the narwhal resembles the white whale or beluga. Figure 90. Upper surface of the skull of male narwhal, Monodon monoceros, with the whole of both teeth exposed by removal of the upper wall of their alveolar cavities. The narwhal is essentially an Arctic animal, frequenting the icy circumpolar seas, and but rarely seen south of 65 degrees north lat. 3 instances have, however, been recorded of its occurrence on the British coasts, one in the Firth of Forth in 1648, one near Boston in Lincolnshire in 1800, while a third, which entangled itself among the rocks in the Sound of Weasdale, Shetland, in September 1808, is described by Fleming in the Memoirs of the Wernerian Society, Volume 1. Like most other cetaceans, it is gregarious in its habits, being usually met with in schools or herds of 15 or 20 individuals. Its food appears to be various species of cephalopods, small fishes, and crustaceans. The purpose served in the animal's economy by the wonderfully developed asymmetrical tusk, or horn, as it is commonly but erroneously called, is not known. As it is present only in the male sex, no function essential to the well-being of the individual, such as the procuring of sustenance, can be assigned to it, but it must be looked upon as belonging to the same category of organs as the antlers of deer, and perhaps may be applied to similar purposes. Very little is, however, known of the habits of narwhals. Scoresby describes them as extremely playful, frequently elevating their horns and crossing them with each other as in fencing. They have never been known to charge and pierce the bottom of ships with their weapons, as the swordfish often does. The name sea unicorn, sometimes applied to the narwhal, refers to the resemblance of its tusk to the horn represented as projecting from the forehead of the fabled unicorn. The ivory of which the tusk is composed is of very good quality, but, owing to the central cavity, which extends the greater part of its length, is only fitted for the manufacture of objects of small size. The entire tusks are sometimes used for decorative purposes, and are of considerable, though very fluctuating, commercial value. Delphinapterus, 156. This genus is closely allied to the last in external form, as well as anatomical structure, differing mainly in the very distinct character of the dentition. Teeth from /8 to superscript 1/, occupying the anterior 3/4 of the rostrum and corresponding portion of the mandible, rather small, conical, and pointed when unworn, but usually becoming obliquely truncated, separated by intervals considerably wider than the diameter of the tooth, and implanted obliquely, the crowns inclining forwards, especially in the upper jaw. Skull rather narrow and elongated, depressed. Premaxilla convex in front of the nares. Rostrum about equal in length to the cranial portion of the skull, triangular, broad at the base, and gradually contracting towards the apex, where it is somewhat curved downwards. Vertebrae, C7, D11, L9, C23, total 50. Cervical vertebrae free. Manus broad, short, and rounded, all the digits being tolerably well developed, except the first. No dorsal fin, but a low ridge in its place. Figure 91. Beluga or white whale, Delphinapterus lucas. From a specimen taken in the River St. Lawrence, and exhibited in London, 1877. One existing species, D. lucas, figure 91, the beluga or white whale, so called from its pure white color, about 12 feet long, abundant in the Arctic seas, and extending as far south on the American coast as the River St. Lawrence, which it ascends for a considerable distance. On rare occasions it has been seen on the coast of Scotland. Remains of a cetacean from the lower Pliocene of Tuscany have been referred by Brandt to this genus under the name D. brochii. In all the remaining genera of Delphinidae the cervical region of the vertebral column is very short, and the first two, and usually more, of the vertebrae are firmly united. Phocina, 157, teeth superscript 2/25, small, occupying nearly the whole length of the rostrum, with compressed, spade-shaped crowns, separated from the root by a constricted neck, figure 92. Rostrum rather shorter than the cranium proper, broad at the base and tapering towards the apex. Premaxillae raised into tuberosities in front of the nares. The frontal bones forming a somewhat square, elevated protuberance in the middle line of the skull behind the nares, rising altogether above the flattened nasals. Pterygoids very small, and widely separated in the middle line. Symphysis of mandible very short. Vertebrae, C7, D13, L14, C31, total 65, subject to slight individual variations. First to sixth cervical vertebrae, and sometimes the seventh also, coalesced. Manus of moderate size, oval, slightly falcate, second and third digits nearly equal in length, fourth and fifth well developed, but shorter. Dorsal fin near the middle of the back, triangular, its height considerably less than the length of the base, its anterior edge frequently furnished with one or more rows of conical horny tubercles. Figure 92. Teeth of porpoise. twice natural size. The common porpoise, figure 93, P. communis, is the best known of British cetaceans. The word porpoise, sometimes spelled porpoise and porpesse, is apparently derived from the French porc and poisson, or the Italian porco and pesce, and thus corresponds with some of the English vernacular appellations, hogfish, sea hog, herring hog, and the German Meerschwein, whence the usual modern French name of the animal, marsouin. Porpoise is commonly used by sailors to designate all the smaller cetaceans, especially those numerous species which naturalists call dolphins, but in scientific language it is restricted to the genus Phocina of Cuvier, of which the porpoise of the British seas, Phocina communis, Cuvier, Delphinus phocina, Linnaeus, is the type. The common porpoise, when full-grown, attains a length of 5 feet or a little more. The dimensions of an adult female specimen from the English Channel were as follows: length in straight line from nose to median notch between the flukes of the tail, 62.5 inches, from the nose to the anterior edge of the dorsal fin, 29 inches, height of dorsal fin, 4.5 inches, length of base of dorsal fin, 8 inches, length of pectoral fin, 9.25 inches, breadth of pectoral fin, 3.5 inches, breadth of tail flukes, 13 inches. The underjaw projects about half an inch beyond the upper one. The aperture of the mouth is tolerably wide, and is bounded by stiff immobile lips, and curves slightly upwards at the hinder end. The eye is small, and the external ear represented by a minute aperture in the skin, scarcely larger than would be made by the puncture of a pin, situated about 2 inches behind the eye. The pectoral fins are of moderate size, and slightly falcate. The upper parts are dark gray, or nearly black, according to the light in which they are viewed, and the state of moisture or otherwise of the skin. The under parts are pure white. The line of demarcation between these colors is not distinct, washes or splashes of gray encroaching upon the white on the sides, and vary somewhat in different individuals. Usually it passes from the throat, the anterior part of which, with the whole of the under jaw, is dark, above the origin of the pectoral fin, along the middle of the flank, and descends again to the middle line before reaching the tail. Both sides of the pectoral and caudal fins are black. Figure 93. The common porpoise, Phocina communis. The porpoise is sociable and gregarious in its habits, being usually seen in small herds, and frequenting coasts, bays, and estuaries rather than the open ocean. It is the commonest cetacean in the seas around the British Isles, and not unfrequently ascends the River Thames, having been seen as high up as Richmond. It has also been observed in the Seine at Neuilly, near Paris. It frequents the Scandinavian coasts, entering the Baltic in the summer, and is found as far north as Baffin's Bay, and as far west as the coasts of the United States. Southward its range is more limited than that of the common dolphin, as, though very common on the Atlantic coasts of France, it rarely enters the Mediterranean. It feeds on fish, such as mackerel, pilchards, and herrings, of which it devours large quantities, and, following the shoals, is often caught by fishermen in the nets along with its prey. In former times it was a common and esteemed article of food in England and in France, but is now rarely if ever eaten, being commercially valuable when caught only for the oil obtained from its blubber. Its skin is sometimes used for leather and boot thongs, but the so-called porpoise hides are generally obtained from the beluga. A closely similar if not identical species from the American coast of the North Pacific has been described under the name of Phocina vomerina, and another from the mouth of the Rio de la Plata as P. spinapennis. Figure 94. Diagrammatic